Preface of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Anusha Ayyar. The Reason Why by Robert Kemp Philp. Preface. We are all children of one Father, whose works it should be our delight to study. As the intelligent child, standing by his parent's knee, asks explanations alike of the most simple phenomena and of the most profound problems, so should man, turning to his Creator, continually ask for knowledge. Not because the profession of letters has, in these days, become a fashion, and that the man of general proficiency can best work out his success in worldly pursuits, but because knowledge is a treasure which gladdens the heart, dignifies the mind, and ennobles the soul. The occupation of the mind by the pursuit of knowledge is of itself a good, since it diverts from evil, and by elevating and refining the mind and strengthening the judgment, it fortifies us for the hour of temptation, and surrounds us with barriers which the powers of sin cannot successfully assail. It is not contended that the mere acquisition of knowledge will either ensure a good moral nature or convey religious truth, but both religion and morals will find in the diffusion of knowledge a groundwork upon which their loftier temples may discover an acceptable foundation. The man who comprehends the order of nature and the immutability of divine law must of necessity bring himself in some degree into accordance with that order, and under submission to the law. Hence the tendency of knowledge will always be found to harmonize the fragment with the mass, and to subvert the evil to the good. The troubles of the world have arisen from the want of knowledge, not from the possession of it, and in proportion as man becomes an intelligent and reflective being, he will be a better creature in all the relations of life. If these benefits, vast and incalculable as they are, be the real tendency and result of knowledge, why is ignorance allowed to remain, and why is the world still distracted by error? It is because the moral and intellectual qualities of man are, like all creations and gifts of God, the subjects of development, whose law is progression. We can aid human improvement, but we cannot unduly hasten it. Whenever man has sprung too rapidly to a conclusion, he has alighted upon error, and has had to retrace his steps. The greatest philosophers have been those who have clung to the demonstrator sciences, and have held that a simple truth well ascertained is greater than the grandest theory founded upon questionable premises. Newton made more scientific revelations to mankind than any other philosopher, and his discoveries have borne the searching test of time. Because he snatched at nothing, leaped over no chasm to establish a favorite dogma, but by the slowest steps, and by regarding the merest trifles, as well as the highest phenomena, he learnt to read nature correctly. He discovered that her atoms were letters, her blades of grass were words, her phenomena were sentences, and her complete volume a grand poem, teaching on every page the wisdom and the power of an almighty Creator. When he observed an apple fall to the ground, he asked the reason why, and in answer to that inquiry there came one of the grandest discoveries that has ever been recorded upon the book of science. With that discovery a flood of light burst upon the human mind, illustrating in a far higher degree than had ever previously been conceived the vastness of almighty power. Why should not each of us inquire the reason why regarding everything that we observe? Why should we mentally grope about when we may see our way? When addressed in a foreign tongue, we hear a number of articulated sounds, to which we can attach no meaning. They convey nothing to the mind, make no impression upon the indwelling soul. When those sounds are interpreted to us in a language that we can understand, they impart impressions of joy, hope, surprise, or sorrow, because the words convey to us a meaning. In like manner, if we fail to understand nature, its beauties, its teachings are lost. Everything speaks to us, but we do not understand the voices. They come murmuring from the brook, trilling from the bird, or pealing from the thunder. But though they reach the ear of the body, they do not impress the listening spirit. Every flower, every ray of light, every drop of dew, each flake of snow, the curling smoke, the lowering cloud, the bright sun, the pale moon, the twinkling stars, speak to us in eloquent language of the great hand that made them. But millions lose the grand lesson which nature teaches, because they can attach no meaning to what they see or hear. The reason why is offered as an interpreter of many of nature's utterances. Great care has been taken that these interpretations may be consistent with the latest knowledge obtained from the highest sources. If the author finds that his work, if accepted for the good of those who seek not only to know, but to understand, he will make it his constant care to read the book of nature, and to add to the pages of this volume whatever interpretations the progress of inquiry and discovery may demand and supply. End of Preface.
Chapter 1 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne Spiegel. The Reason Why by Robert Kemp Philp. Chapter 1. 1. Why should we seek knowledge? Because it assists us to comprehend the goodness and power of God, and it gives us power over the circumstances and associations by which we are surrounded. The proper exercise of this power will greatly promote our happiness. 2. Why does the possession of knowledge enable us to exercise power over our surrounding circumstances? Knowledge enables us to understand that, in order to live healthily, we require to breathe fresh and pure air. It also tells us that animal and vegetable substances, undergoing decay, poison the air, though we may not be able to see or to smell or otherwise discover the existence of such poison. Knowing this, we become careful to remove from our presence all such matters as would tend to corrupt the atmosphere. This is only one of the countless instances in which knowledge gives us power over surrounding circumstances. 3. Name some other instances in which knowledge gives us power. Knowledge of geography and navigation enables the mariner to guide his ship across the trackless deep, and to reach the sought-for port, though he had never before been on its shores. Knowledge of chemistry enables us to separate or to combine the various substances found in nature. Thus we obtain useful and precious metals from what at first appeared to be useless stones, transparent glass from pebbles, through which no light could pass, soap from oily substances, and gas from solid bodies. Give instruction to a wise man, and he will be yet wiser. Teach a just man, and he will increase in learning. Proverbs chapter 9. Knowledge of medicine enables the physician to overcome the ravages of disease, and to save suffering patients from sinking prematurely to the grave. Knowledge of anatomy and of surgery enables the surgeon to bind up dangerous fractures and wounds, and to remove, even from the internal parts of bodies, ulcers and diseased formations that would otherwise be fatal to life. Knowledge of mechanics enables man to increase his power by the construction of machines. The steamship crossing the ocean in opposition to wind and tide, the railway locomotive traveling at 60 miles an hour, and the steam hammer beating blocks of iron into useful shapes, are evidences of the power which man acquires through a knowledge of mechanics. Knowledge of electricity enables man to stand in comparative safety amid the awful war of the elements. Lightning, the offspring of electricity, has a tendency to strike upon lofty objects by which it may be attracted. By its mighty powers, churches or houses may be instantly leveled with the dust. But man, knowing that electricity is strongly attracted by particular substances, raises over lofty buildings rods of steel communicating with bars that descend into the ground. The lightning, rushing with indescribable force toward the steeple, is attracted by the bar of steel and conducted harmlessly to the earth. Men may thus be said to take even lightning by the hand, and to divert its destroying force by the aid of knowledge. And in countless other instances, knowledge is power. End of chapter 1. Chapter 2 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Reason Why, by Robert Kemp Philp. Chapter 2. 4. Why do we breathe air? Because the air contains oxygen, which is necessary to life. 5. Why is oxygen necessary to life? Because it combines with the carbon of the blood and forms carbonic acid gas. Be not as the horse, or as the mule, which have no understanding, whose mouth must be held with the bit and bridle. Psalm 32. 6. Why is this combination necessary? Because we are so created that the substances of our bodies are constantly undergoing change, and this resolving of solid matter into a gaseous form is the plan appointed by our Creator to remove the matter called carbon from our systems. 7. Why do our bodies feel warm? Because, in the union of oxygen and carbon, heat is developed. 8. What is this union of oxygen and carbon called? It is called combustion, which, in chemistry, means the decomposition of substances and the formation of new combinations, accompanied by heat, and sometimes by light as well as heat. 9. What is formed by the union of oxygen and carbon? Carbonic acid gas. 10. What becomes of this carbonic acid gas? It is sent out of our bodies by the compressure of the lungs and mingles with the air that surrounds us. 11. Is this carbonic acid gas heavier or lighter than the air? Pure carbonic acid gas is the heaviest of all the gases. That which is sent out of the lungs is not pure, because the whole of the air taken into the lungs at the previous inspiration has not been deprived of its oxygen, and the nitrogen is returned. Therefore the breath sent out of the lungs may be said to consist of air, with a larger proportion of carbonic acid gas. 12. What is the composition of air in its natural state? It consists of oxygen, nitrogen, and carbonic acid gas, in the proportion of oxygen 20 volumes, nitrogen 79 volumes, and carbonic acid gas 1 volume. It also contains a slight trace of watery vapor. 13. What is the state of the air after it has once been breathed? It has parted with about 1/6 of its oxygen and taken up an equivalent of carbonic acid. And were the same air to be breathed 6 times successively, it would have parted with all its oxygen and could no longer sustain life. A prudent man foreseeth the evil, and hideth himself, but the simple pass on and are punished. Proverbs chapter 27. 14. Is the impure air sent out of the lungs lighter or heavier than common air? At first, being rarefied by warmth, it is lighter, but, if undisturbed, it would be heavier as it cooled, and would descend. 15. Why is it proper to have beds raised about 2 feet from the ground? Because at night, the bedroom being closed, the breath of the sleeper impregnates the air of the room with carbonic acid gas, which, descending, lies in its greatest density near to the floor. 16. What are the chief sources of carbonic acid gas? The vegetable kingdom, as will be hereafter explained, the combustion of substances composed chiefly of carbon, the breathing of animals, and the decomposition of carbonic compounds. 17. Is breathing a kind of combustion? It is. In the breathing of animals, the burning of coals, or of wood, or candles, etc., similar changes occur. The oxygen of the air combines with the carbon of the substance said to be burnt, and forms carbonic acid gas, which unfits the air for the purpose of either breathing or of burning until it has been renewed by admixture with the air. 18. What is carbon? It is one of the elementary bodies, and is very abundant throughout nature. It abounds mostly in vegetable substances, but is also contained in animal bodies and in minerals. The form in which it is most familiar to us is that of charcoal, which is carbon almost pure. 19. What is meant by an elementary body? An elementary body is one of those substances in which chemistry is unable to discover more than one constituent. For instance, the chemist finds that water is composed of oxygen and hydrogen. Water is therefore a compound body, but carbon consists of carbon only, and therefore is called a simple or elementary body. Where no wood is, there no fire goeth out. So where there is no talebearer, the strife ceaseth. Proverbs chapter 26. 20. Why is it dangerous to burn charcoal in rooms? Because, being composed of carbon that is nearly pure, its combustion gives off a large amount of carbonic acid gas. 21. What is the effect of carbonic acid gas upon the human system? It induces drowsiness and stupor, which, if not relieved by ventilation, would speedily cause death. 22. What is the reason that people feel drowsy in crowded rooms? Because the large amount of carbonic acid gas given off with the breaths of the people makes the air poisonous and oppressive. 23. What other causes of drowsiness are there? The candles, gas, or fires that may be burning in the rooms where people are assembled. 3 candles produce as much carbonic acid gas as 1 human being, and it is probable that 1 gaslight produces as much carbonic acid gas as 2 persons. 24. Have people ever been poisoned by their own breaths? In the reign of George II, the Rajah of Bengal took some English prisoners in Calcutta, and put 146 of them into a place which was called the Black Hole. This place was only 18 feet square by 16 feet high, and ventilation was provided for only by 2 small grated windows. 123 of the prisoners died in the night, and most of the survivors were afterwards carried off by putrid fevers. Many other instances have occurred, but this one is the most remarkable. End of chapter 2. Chapter 3 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Reason Why by Robert Kemp Philp. Chapter 3. 25. What is oxygen? Oxygen is one of the most widely diffused of the elementary substances. It is a gaseous body. Stand in awe and sin not. Commune with your whole heart upon your bed and be still. Psalm 4. 26. Why do persons who are walking or riding upon horseback feel warmer than when they are sitting still? Because as they breathe more rapidly, the combustion of the carbon in the blood is increased by the oxygen inhaled, and greater heat is developed. 27. Why does the fire burn more brightly when blown by a bellows? Because it receives, with every current of air, a fresh supply of oxygen, which unites with the carbon and hydrogen of the coals, causing more rapid combustion and increased heat. 28. Why does not the oxygen of the air sometimes take fire? Because oxygen, by itself, is incombustible. The wick of a candle, which retains the slightest spark, being immersed in oxygen, will instantly burn into a brilliant flame, and even a piece of iron wire made red hot and dipped into oxygen will burn rapidly and brilliantly. Oxygen, though non-combustible of itself, is the most powerful supporter of combustion. 29. Why do we know that oxygen will not burn of itself? Because when we immerse a burning substance into a jar of oxygen, it immediately burns with intense brilliancy, but directly it is withdrawn from the oxygen, the intensity of the flame diminished, and the oxygen which remains is unaffected. 30. Why do we know that oxygen is necessary to our existence? Because animals placed in any kind of gas, or in any combination of gases, where oxygen does not exist, die in a very short time. 31. Where is oxygen found? It is found in the air, mixed with nitrogen, in water combined in hydrogen, in the tissues of vegetables and animals, in our blood, and in various compounds called, from the presence of oxygen, oxides. 32. Why is the oxygen of the air mixed so largely with nitrogen? Because oxygen in any greater proportion than that in which it is found in the atmosphere would be too exciting to the animal system. Animals placed in pure oxygen die in great agony from fever and excitement, amounting to madness. As vinegar is to the teeth, and as smoke to the eyes, so is the sluggard to him that sent him. Proverbs 10. 33. What is nitrogen? Nitrogen is an elementary body in the form of gas. 34. Where is nitrogen found? It is chiefly found in the air, of which it constitutes 79 out of 100 volumes. It may be mixed with oxygen in various proportions, but in the atmosphere it is uniformly diffused. It is found in most animal matter, except fat and bone. It is not a constituent of the vegetable acids, but it is found in most of the vegetable alkalis. 35. What are acids? Acids are a numerous class of chemical bodies. They are generally sour. Usually, though there are exceptions, they have a great affinity for water, and are not easily soluble therein. They unite readily with most alkalis, and with the various oxides. All acids are compounds of two or more substances. Acids are found in all the kingdoms of nature. 36. What are alkalis? Alkalis are a numerous class of substances that have a great affinity for, and readiness to combine with, acids, forming salts. They exercise peculiar influence upon vegetable colors, turning blues green, and yellows reddish brown. But they will restore the colors of vegetable blues which have been reddened by acids, and, on the other hand, the acids restore vegetable colors that have been altered by the alkalis. Alkalis are found in all the kingdoms of nature. 37. Could animals live in nitrogen? No, they would immediately die. But a mixture of oxygen and nitrogen in equal volumes constitutes nitrous oxide, which gives a pleasurable excitement to those who inhale it, causing them to be merry, almost to insanity. It has, therefore, been called laughing gas. 38. Why does nitrous oxide produce this effect? Because it introduces into the body more oxygen than can be consumed. It, therefore, deranges the nervous system, and being a powerful stimulant, gives an unnatural activity to the nervous centers and the brain. Lord, make me to know mine end, and the measure of my days, that I may know how frail I am. Psalm 39. 39. In what proportions are the atmospheric gases found in the blood? The mean quantity of the gases contained in the human blood has been found to be equal to 1/10 of its whole volume. In venous blood, the average quantity of carbonic acid is about 1/18, that of oxygen about 1/85, and that of nitrogen about 1/100 of the volume of the blood. In arterial blood, the quantities have been found to be carbonic acid about 1/14, oxygen about 1/38, and nitrogen about 1/72. 40. Then is nitrogen taken into the blood from the air? Such a supposition is highly improbable. It is probably derived from nitrogenized food, just as carbonic acid is derived from carbonized food. 41. What is venous blood? Venous blood is that which is returning through the veins of the body from the organs to which it has been circulated. 42. What is arterial blood? Arterial blood is that which is flowing from the heart through the arteries to nourish the parts where those arteries are distributed. 43. What is the difference between venous and arterial blood? Venous blood contains more carbonic acid and less oxygen and nitrogen than arterial blood. 44. Will nitrogen burn? It will not burn, nor will it support combustion. 45. What is the difference between burning and supporting combustion? Oxygen gas will not burn of itself, but it aids the decomposition by fire of bodies that are combustible. It is therefore called a supporter of combustion. But hydrogen gas, though it burns of itself, will extinguish a flame immersed in it. It is therefore said to be a body which will burn, but will not support combustion. As coals are to burning coals, and wood to fire, so is a contentious man to kindle strife. Proverbs 26. 46. What becomes of the nitrogen that is inhaled with the air? It is thrown off with the breath, mixed with carbonic acid gas, and flies away to be renewed by a fresh supply of oxygen. 47. Where does nitrogen find a fresh supply of oxygen? In the atmosphere. Nitrogen is said to possess a remarkable tendency to mix with oxygen, without having a positive chemical affinity for it. That is to say, neither the oxygen nor the nitrogen undergoes any change by the union except that of admixture. The oxygen and the nitrogen still possess their own peculiar properties. Oxygen and nitrogen are found in nearly the same proportions in all climates and at all altitudes. 48. In combustion, does any other result take place besides the union of oxygen and carbon forming carbonic acid gas? Yes, usually hydrogen is present, which in burning unites with oxygen and forms water. End of chapter 3.
Chapter 4 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 4. 49. What is hydrogen? Hydrogen is an elementary gas and is the lightest of all known bodies. 50. Will hydrogen support animal life? It will not. It proves speedily fatal to animals. 51. Will hydrogen support combustion? Although it will burn, yielding a feeble bluish light, it will, if pure, extinguish a flame that may be immersed in it. Hydrogen will therefore burn, but will not support combustion. 52. Why will hydrogen explode if it will not support combustion? When hydrogen explodes, it is always in combination with oxygen or with the common air which contains oxygen. 2 measures of hydrogen and 1 of oxygen form a most explosive compound. As smoke is driven away, so drive them away. As wax melteth before the fire, so let the wicked perish at the presence of God. Psalm 46. 53. Why does hydrogen explode when mixed with oxygen upon being brought in contact with fire? Because of its strong affinity for oxygen, with which, upon the application of heat, it unites to form water. 54. Where does hydrogen chiefly exist? In the form of water, where it exists in combination with oxygen. 11 parts of hydrogen and 89 of oxygen form water. 55. Is hydrogen found elsewhere? It is never found but in a state of combination, United with oxygen, it exists in water, with nitrogen in ammonia, with chlorine in hydrochloric acid, with fluorine in hydrofluoric acid, and in numerous other combinations. 56. Is the gas used to illuminate our streets hydrogen gas? It is, but it is combined with carbon, derived from the coals from which it is made. It is therefore called carburetted hydrogen, which means hydrogen with carbon. 57. How is hydrogen gas obtained from coals? It is driven out of the coals by heat in closed vessels which prevent its union with oxygen. 58. What becomes of the water which is formed by the burning of hydrogen and oxygen? It passes into the air in the form of watery vapor. Frequently it condenses and may be seen upon the walls and windows of rooms where many lights or fires are burning. Sometimes also portions of it become condensed in the globes of the glasses that are suspended over the jets of gas. A large volume of these gases forms only a very small volume of water. 59. What becomes of the carbonic acid gas which is produced by combustion? It is diffused in the air, which should be removed by adequate ventilation. I will both lay me down in peace and sleep, for thou, Lord, only makest me dwell in safety. Psalm 4. 60. What proportion of carbonic acid gas is dangerous to life? Any proportion over the natural one of 1% may be regarded as injurious, but toxicologists state that 5% of carbonic acid gas in the atmosphere is dangerous to life. 61. What are toxicologists? Persons who study the nature and effects of poisons and their antidotes. 62. Which kind of combustible used for lighting tends most to vitiate the air? Assuming all the lights to be of the same intensity, the degree in which the substances burnt would vitiate the atmosphere may be gathered from the number of minutes each would take to exhaust a given quantity of air. This has been found to be rape oil, 71 minutes, olive oil, 72, Russian tallow, 75, town tallow, 76, sperm oil, 76, stearic acid, 77, wax candles, 79, spermaceti candles, 83, common coal gas, 98, canal coal gas, 152. Thus it is shown that rape oil is most destructive of the atmosphere, and that coal gas is the least destructive. 63. Is an escape of hydrogen gas from a gas pipe dangerous to life? It is dangerous first by inhalation. There are no less than 6 deaths upon records of persons who were killed by sleeping in rooms near to which there was a leakage of gas. It is dangerous secondly by explosion. In 1848, an explosion of gas occurred in Albany Street, Regent's Park, London. The gas accumulated in a shop for a very short time only. It had been escaping from a crack in the meter for about 1 hour and 20 minutes. The area of the room was about 1,620 cubic feet. When the gas exploded, it blew out the entire front of the premises, carried 2 persons through a window into an adjoining yard, and forced another person on to the pavement on the opposite side of the street, where she was killed. The effect of the explosion was felt more than a quarter of a mile on each side of the house, and most of the windows in the neighborhood were shattered. The iron railings over the area of the house directly opposite were snapped asunder, and a part of the roof and the back windows of another house were carried to a distance of from 200 to 300 yards. The pavement was torn up for a considerable length, and the damage done to 103 houses was afterwards reported to amount to £20,000. Other serious explosions have taken place. The explosions of coal damp, which frequently occur in mines, are of a similar character. O Lord, our Lord, how excellent is thy name in all the earth, who hast set thy glory above the heavens. Psalm 8. 64. What proportion of hydrogen gas with atmospheric air will explode? According to the researches of Sir Humphrey Davy, 7 or 8 parts of air to 1 of gas produce the greatest explosive effect, while larger proportions of gas are less dangerous. A mixture of equal parts of gas and air will burn, but it will not explode. The same is the case with a mixture of 2 of air or 3 of air and 1 of gas. But 4 of air and 1 of gas begin to be explosive, and the explosive tendency increases up to 7 or 8 of air and 1 of gas, after which the increased proportion of gas diminishes the force of the explosion. 65. What is the best method of preventing the explosion of gas? Observe the rule, never to approach a supposed leakage with a light. Fortunately, the gas, which threatens our lives, warns us of the danger by its pungent smell. The first thing to be done is to open windows and doors and to ventilate the apartment. Then turn the gas off at the main and wait a short time until the accumulated gas has been dispersed. 66. Does hydrogen gas rise or fall when it escapes? Being 12 times lighter than common air, it rises, and therefore it would be better for ventilation to open the window at the top than at the bottom. But all gases exhibit a strong tendency to diffuse themselves, and therefore they do not rise or fall in the degree that might be anticipated. 67. What proportion of hydrogen in the air is dangerous to life if inhaled? 1/50th part has been found to have a serious effect upon animals. The effects it produces upon the human system are those of depression, headache, sickness, and general prostration of the vital powers. It is therefore advisable to observe precautions in the use of gas. From the place of his habitation, he looketh upon all the inhabitants of the earth. Psalm 33. 68. What proportion of gas in the air may be recognized by the smell? By persons of acute powers of smelling, it may be recognized when there is 1 part of gas in 500 parts of atmospheric air, but it becomes very perceptible when it forms 1 part in 150. Warning is, therefore, given to us long before the point of danger arrives. 69. What other sources of hydrogen are there in our dwellings? It arises from the decomposition of animal and vegetable substances containing sulfur and hydrogen. These give off a gas called sulphuretted hydrogen, from which the fetid effluvium of drains and water closets chiefly arise. We should, therefore, take every precaution to secure effective drainage and to keep drain traps in proper order. 70. May the use of gas for purposes of illumination be considered highly dangerous? Not if it is intelligently managed. The appliances for the regulation of gas are so very simple and perfect that accidents seldom arise except from neglect. In England, 6 million tons of coal are usually consumed in the manufacture of gas, producing 60 billion cubic feet of gas, and yet accidents are of a very uncommon occurrence. End of Chapter 4.
Chapter 5 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sharon Chimeraden. The Reason Why by Robert Kemp Philp. Chapter 5. 71. What is heat? Heat is a principle in nature which, like light and electricity, is best understood by its effects. We popularly call that heat which raises the temperature of bodies submitted to its influence. 72. What is caloric? Caloric is another term for heat. It is advisable, however, to use the term caloric when speaking of the cause of heat, and of heat as the effect of the presence of caloric. While the earth remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night shall not cease. Genesis 8. 73. What is the source of caloric? The sun is the chief source. but caloric, in some degree, exists in every known substance. 74. What are the effects of caloric? Heat, which in proportion to its intensity acts variously upon all bodies, causing expansion, fusion, evaporation, decomposition, etc. 75. Why is caloric called a repulsive agent? Because its chief effects are to expand, fuse, evaporate, or decompose the substances upon which it acts. 76. What is an attractive agent in contradiction to a repulsive agent? Chemical attraction, or affinity, is an attractive agent, as when bodies seek of their own natures to unite and form some new body. 77. When is a body said to be hot? When it holds so much caloric that it diffuses heat to surrounding objects. 78. When is a body said to be cold? When it holds less caloric than surrounding objects and absorbs heat from them. 79. How may caloric be excited to develop heat? By any means which cause agitation or produce an active change in the condition of bodies, thus friction, percussion, sudden condensation or expansion, chemical combination, and electrical discharges all develop heat. 80. Why do burning glasses appear to set fire to combustible substances? Because they gather into one point, or focus, several rays of caloric as they are traveling from the sun, and the accumulation of caloric develops that intensity of heat which constitutes fire. 81. What is a focus? In optics, it is the point or center at which or around which divergent rays are brought into the closest possible union. Yet man is born to trouble, as the sparks fly upward. I would seek unto God, and unto God would I commit my cause. Job 5. 82. What is fire? It is a violent chemical action attending the combustion of the ingredients of fuel with the oxygen of the air. 83. What are the properties of fire? It imparts heat, which has the effect of expanding both fluids and solids. It cannot exist without the presence of combustible materials. It has a tendency to diffuse itself in every direction. It cannot exist without oxygen or atmospheric air. 84. What elements take part in the maintenance of a fire? Hydrogen, carbon, and oxygen. Hydrogen and carbon exist in the fuel, and oxygen is supplied by the air. 85. How does the combustion of a fire begin? A match made of phosphorus and sulfur, highly inflammable substances, is drawn over a piece of sandpaper. The friction of the match induces the presence of caloric, which develops heat and ignites the match, the burning of which is sustained by the oxygen of the air. The flame is then applied to paper or wood, and the heat of the flame is sufficient to drive out hydrogen gas, which unites with the oxygen of the air and burns, imparting greater heat to the carbon of the coals, which assumes the form of carbonic acid gas by union with oxygen, and in a little while all the conditions of combustion are established. 86. What are the properties of heat? It may exist without fire or light. It is not sensible to vision. It makes an impression upon our feelings. It acts powerfully upon all bodies. It has no weight. It attends, or is connected with, all the operations of nature. It radiates from all bodies in straight lines and in all directions. It strikes most powerfully in direct lines. Its rays may be collected into a focus, just as the rays of the sun. It may be reflected from a polished surface. It is more easily conducted by some substances than by others. For my days are consumed like smoke, and my bones are burned as an hearth. Psalm 102. 87. What is animal heat? Animal heat is derived from the slow combustion of carbon in the blood of animals with the oxygen of the air which the animals breathe. 88. What is latent heat? Latent heat, or more properly latent caloric, is that which exists in some degree in all bodies, though it may be imperceptible to the senses. 89. Is there latent caloric in ice, snow, water, marble, etc.? Yes, there is some amount of caloric in all substances. A blacksmith may hammer a small piece of iron until it becomes red hot. With this he may light a match and kindle the fire of his forge. The iron has become more dense by the hammering, and it cannot again be heated to the same degree by similar means, until it has been exposed in fire to a red heat. Is it not possible that, by hammering, the particles of iron have been driven closer together, and the latent heat driven out? No further hammering will force the atoms nearer, and therefore no further heat can be developed. But when the iron has again absorbed caloric by being plunged in a fire, it is again charged with latent heat. Indians produced sparks by rubbing together 2 pieces of wood. 2 pieces of ice may be rubbed together until sufficient warmth is developed to melt them both. The axles of railway carriages frequently become red hot from friction. 98. Have vegetables heat? Yes. Whenever oxygen combines with carbon to form carbonic acid gas, an extrication of heat takes place, however minute the amount. Such a combination occurs much more extensively during the germination of seeds and the impregnation of flowers than at any other time. In the germination of barley heaped in rooms, previous to being converted into malt, it is well known that a considerable amount of heat is developed. 91. Has any investigation of this subject ever been carefully made? Yes. Lamarck, Senebier, and de Candolle found the flowers of the Arum maculatum between 3 and 7 o'clock in the afternoon, as much as 7 degrees Reaum warmer than the external air. Schultz found a difference of 4 degrees to 5 degrees between the heat of the spath of the Canadian pinnatifolium and the surrounding air at 6 to 7 o'clock p.m. Other observations have established differences of as much as 30 degrees between the temperature of the spath of the Arum cordifolium and that of the surrounding atmosphere. And there are diversities of operations, but it is the same God which worketh in all. Corinthians 12. 92. Have plants sometimes a temperature lower than that of the surrounding air? Yes. It has not only been found that under particular circumstances the heat of certain parts of plants is elevated to a very remarkable degree, but that under nearly all circumstances they have a temperature difference from that of the external air, being warmer in winter and cooler in summer. End of Chapter 5. Recording by Sharon Chimuredan of sharonmedia.net. Chapter 6 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sharon Chimuredan. The Reason Why by Robert Kemp Philp. Chapter 6. 93. How many kinds of combustion are there? There are 3, viz., slow oxidation, when little or no light is evolved; a more rapid combination, when the heat is so great as to become luminous; and a still more energetic action, when it bursts into flame. 94. Why does phosphorus look luminous? Because it is undergoing slow combustion. 95. Why do decayed wood and putrefying fish look luminous? Because they are undergoing slow combustion. In these cases, the heat and light evolved are at no one time very considerable, but the total amount of heat, and probably of light, generated through the lengthy period of this slow oxidation amounts to exactly the same as would be evolved during the most rapid combustion of the same substances. 96. What is flame? It is a gaseous matter burning at a very high temperature. 97. Why, when we put fresh coals upon a fire, do we hear the gas escaping from the coals without taking fire? Because the fire, being slow, the temperature is not high enough to ignite the gas. I will praise thee, O Lord, with my whole heart. I will show forth thy marvelous work. Psalm 9. 98. What is the gas which escapes from the coals? Carburetted hydrogen. 99. Why, if we light a piece of paper and lay it where the gas is escaping from the coals, will it burst into flame? Because the lighted paper gives a heat sufficient to ignite the gas, and because also hydrogen requires the contact of flame to ignite it. 100. Why, when the coals have become heated, will the hydrogen burst into flame? Because the carbon of the coals and the oxygen of the air have begun to combine and have greatly increased the heat and have produced rapid combustion, so nearly allied to flame that it ignites the hydrogen. 101. What temperature is required to produce flame? That depends on the nature of the combustible you desire to burn. Finely divided phosphorus and phosphorated hydrogen will take fire at a temperature of 60 degrees or 70 degrees. Solid phosphorus at 140 degrees. Sulfur at 500 degrees. Hydrogen and carbonic oxide at 1000 degrees. Red heat. Coal gas, ether, turpentine, alcohol, tallow, and wood at about 2000 degrees. Incipient white heat. When once inflamed, they will continue to burn and will maintain a very high temperature. 102. What is smoke? Smoke consists of small particles of carbon, of hydrogen gas, and other volatile matters which are driven off by heat and carried up the chimney. 103. Is it not a waste of fuel to allow this matter to escape? It is, as it might all be burnt up by better management. 104. How may the waste be avoided? By putting on only a little coals at a time, so that the heat of the fire shall be sufficient to consume these volatile matters as they escape. And the strong shall be as tow, and the maker of it as a spark, and they shall both burn together, and none shall quench them. Isaiah 1. 105. Why is there so little smoke when the fire is red? Because the hydrogen and the volatile parts of the coal have already been driven off and consumed, and the combustion that continues is principally caused by the carbon of the coals and the oxygen of the air. 106. Will carbon, burnt in oxygen, produce flame and smoke? It burns brightly, but it produces neither flame nor smoke. 107. Why do not charcoal and coke fires give flame? Because the hydrogen has been driven off by the processes by which charcoal and coke are made. 108. What is a conductor of heat? A conductor of heat is any substance through which heat is readily transmitted. 109. What is a non-conductor of heat? A non-conductor is any substance through which heat will not pass readily. 110. Name a few good conductors. Gold, silver, copper, platinum, iron, zinc, tin, stone, and all dense solid bodies. 111. Name a few non-conductors. Fur, wool, down, wood, cotton, paper, and all substances of a spongy or porous texture. 112. How is heat transmitted from one body to another? By conduction, radiation, reflection, absorption, and convection. 113. What is the conduction of heat? It is the communication of heat from one body to another by contact. If I lay a penny piece upon the hob, it becomes hot by conduction. 114. What is the radiation of heat? The transmission of heat by a series of rays. If I hold my hand before the fire, the rays of heat fall upon it, and my hand receives the heat through radiation. Sing praises to the Lord, which dwelleth in Zion. Declare among the people his doings. Psalm 9. 115. What is the reflection of heat? The reflection of heat is the throwing back of its rays toward the direction whence they came. In a Dutch oven, the rays of heat pass from the fire to the oven and are reflected back again by the bright surface of the tin. There is, therefore, considerable economy of heat in ovens and other cooking utensils constructed upon this plan. 116. What is the absorption of heat? The absorption of heat is the taking of it up by the body to which it is transmitted or conducted. Heat was conveyed to my hand by radiation and taken up by my hand by absorption. 117. What is the convection of heat? The convection of heat is the transmission of it through a body or a number of bodies, or particles of bodies, by those substances which first received it, as when hot water rises from the bottom of a kettle and imparts heat to the cold water lying above it. End of Chapter 6. Recording by Sharon Chimeradan of sharonmedia.net. Chapter 7 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sharon Chimeradan. The Reason Why by Robert Kemp Philp. Chapter 7. 118. Why does not a piece of wood, which is turning at one end, feel hot at the other end? Because wood is a bad conductor of heat. 119. Why is wood a bad conductor of heat? Because the arrangement of the particles of which it is composed do not favor the transmission of caloric. 120. Why do some articles of clothing feel cold and others warm? Because some are bad conductors of heat and do not draw off much of the warmth of our bodies, while others are better conductors and take up a larger portion of our warmth. The fining pot is for silver, and the furnace for gold, but the Lord trieth the hearts. Proverbs 17. 121. Which feels the warmer, the conductor or non-conductor? The non-conductor, as it does not readily absorb the warmth of our bodies. 122. What substances are the best conductors of heat? Gold, silver, copper, and most substances of close and hard formation, etc. 123. What substances are the worst conductors of heat? Fur, eider down, feathers, raw silk, wood, lamp black, cotton, soot, charcoal, etc. 124. Why has the toasting fork a wooden handle? Because wood is not so good a conductor as metal. Therefore, the wood prevents the heat from being transmitted by conduction to our hands. 125. Why has the coffee pot a wooden handle? because the metal of the coffee pot would otherwise conduct the heat to the hand, but wood, being a bad conductor, prevents it. 126. Why does hot water in a metal jug feel hotter than in an earthenware one? Because metal, being a bad conductor, readily delivers heat to the hand, but earthenware, being an indifferent conductor, parts with the heat slowly. 127. How can we ascertain that wood prevents the conduction of heat to the hand? By passing the top of the finger along the wooden handle of the coffee pot until it reaches the point where the wood meets the metal. The wooden handle will be found to be cool, but the metal will feel very hot. 128. Of what use are kettle holders? Being made of bad conductors, such as wood, paper, or woolen cloth, they will not readily conduct the heat from the kettle to the hand. Wisdom is the principal thing. Therefore get wisdom, and with all thy getting, get understanding. Proverbs 4. 129. Will a kettle holder, being a bad conductor, sometimes conduct heat to the hand? Yes, but so slowly that the hand will not feel the inconvenience of too much heat. 130. Why does hot metal feel hotter than heated wool, though they may both be of the same degree of temperature? Because metal gives out heat more rapidly than wool, by which it is made more perceptible to our feelings. 131. Which would become cold first, the metal or the wool? The wool, because although the metal conducts heat more rapidly to a substance in contact with it, it does not radiate heat as well as a black and rough substance. 132. Why do iron articles feel intensely cold in winter? Because iron is one of the best conductors and draws off heat from the hand very rapidly. 133. What is the cause of the sensation called cold? When we feel cold, heat is being drawn off from our bodies. 134. What is the cause of the sensation called heat? When we feel hot, our bodies are absorbing heat from external causes. The condition here implied is that of health and of ordinary circumstances. A person in a condition of fever, suffering from intense heat arising from a diseased state of the blood, could not be said to be absorbing heat, nor could such a description apply to a person who, by a very rapid walk, has raised the temperature of his body considerably above its natural state, by the internal combustion which has already been described. A person feeling hot in bed from excessive clothes feels hot from the development of heat internally, which is not conducted away with sufficient rapidity to maintain the natural temperature of the body. 135. If a person sitting before a fireplace without a fire were to set one foot upon a rug and the other upon the stone hearth, which would feel the colder? The foot on the stone, because stone is a good conductor and would conduct the warmth of the foot away from it. The earth is the Lord's, and the fullness thereof, the world and they that dwell therein. Psalm 24. 136. What does the hearthstone do with the heat that it receives? It delivers it to the surrounding air and to any other bodies with which it may be in contact, and as it parts with heat, it takes up more from any body hotter than itself. 137. When there is no fire in a room, what is the relative temperature of the various things in the room? They are all the same temperature. 138. If all the articles in the room are of the same temperature, why do some feel colder than others? because they differ in their relative powers of conduction. Those that are the best conductors feel coldest, as they convey away the heat of the hand most rapidly. If you lay your hand upon the woolen table cover, or upon the sleeve of your coat or mantle, it will feel neither warm nor cold under ordinary circumstances. But if you raise your hand from the table cover or coat and lay it on the marble mantelpiece, the mantelpiece will feel cold. If now you return your hand from the mantelpiece to the table cover or coat, a sensation of warmth will become distinctly perceptible. This will afford a good conception of the relative powers of conduction of wool and marble. 139. How long does a substance feel cold or hot to the touch? Until it has brought the part touching it to the same temperature as itself. 140. When do substances feel neither hot nor cold? When they are of the same temperature as our bodies. 141. Why, under these circumstances, do they feel neither hot nor cold? Because they neither take heat from, nor supply it to, the body. 142. Which would feel the warmer when the fire was lighted, the hearth rug or the hearth stone? The hearth stone, because it is a good conductor, and would not only receive heat directly, but would part with it as freely, therefore making it heat perceptible. But the hearth rug, being a bad conductor, would part with its heat very slowly, and it would therefore be less perceptible. Fire and hail, snow and vapor, stormy wind fulfilling his word. Psalm 148. 143. Would the hearth stone feel hotter than the hearth rug, though both were of the same temperature? It would feel hotter than the hearth rug, because it would part with its heat so rapidly that it would be the more perceptible. 144. But if the hearthstone and the hearth rug were both colder than the hand, which would feel the colder of the two? Then the hearthstone would feel the colder, because, being a good conductor, it would take heat from the hand more freely than the hearth rug, which is a bad conductor. 145. Why would the hearthstone feel comparatively hotter in the one case and colder in the other? Because, being a good conductor, it would conduct heat rapidly to the hand when hot, and take heat rapidly from the hand when cold. End of Chapter 7. Recording by Sharon Chimeradan of sharonmedia.net.
Chapter 8 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Julia Niedermeyer. The Reason Why by Robert Kemp Philp. Chapter 8. 146. Which are the better conductors of heat, fluids or solids? Generally speaking, solids, especially those of them that are dense in their substance. 147. Why are dense substances the best conductors of heat? Because the heat more readily travels from particle to particle until it pervades the mass. 148. Why are fluids bad conductors of heat? Because of the want of density in their bodies, and because of a portion of the imbibed heat always passes off from fluids by evaporation. He casteth forth his eyes like morsels, who can stand before his world. Psalm 147. 149. Why are woolen fabrics bad conductors of heat? Because there is a considerable amount of air occupying the spaces of the texture. 150. Is air a good or a bad conductor? Air is a bad conductor, and it chiefly transmits heat, as water does, by convection. 151. Is water a good or a bad conductor? Water is an indifferent conductor, but it is a better conductor than air. 152. Why, when we place our hands in water, which may be of the same temperature as the air, does the water feel some degrees colder? Because water, being a better conductor than air, takes up the warmth of the hand more rapidly. 153. Why, when we take our hands out of water, do they feel warmer? Because the air does not abstract the heat of the hand so rapidly as the water did, and the change in the degree of rapidity with which the heat is abstracted produces a sensation of increased warmth. 154. Why do we see blocks of ice wrapped in thick flannel in summer time? Because the flannel, being a non-conductor, prevents the external heat from dissolving the ice. Flannel wrapped around a warm body keeps in its heat, and wrapped around a cold body prevents heat from passing into it. 155. How do we know that air is not a good conductor of heat? Because, in still air, heat would travel to a given point much more rapidly, and in greater intensity, through even an indifferent solid conductor, than it would through the air. 156. How do we know that water is not a good conductor of heat? Because in a deep vessel containing ice, and with heat applied at the top, some portion of the water may be made to boil before the ice, which lies a little under the surface, is melted. As snow in summer, and as rain in harvest, so honor is not seemly for a fool. Proverb 26. 157. Why would you apply the heat at the top in this experiment? Because in heating water it expands and rises. The boiling of water is caused by the heated water ascending from the bottom, and the colder water descending to occupy its place. If the heat were not applied at the top, it would be distributed quickly by convection, but not by conduction. 158. Why are bottles of hot water used as feet warmers, wrapped in flannel? Because the flannel, being a bad conductor, allows the heat to pass only gently from the bottle, and preserves the warmth for a much longer time. 159. Why are hot rolls sent out by the bakers wrapped up in flannel? Because the flannel, being a bad conductor, does not carry off rapidly the heat of the rolls. 160. Why is it said that snow keeps the earth warm? Because snow is a bad conductor, and prevents the frosty air from depriving the earth of its warmth. 161. Why are snow huts which the Eskimo built found to be warm? Because snow, being a bad conductor, keeps in the internal heat of the dwelling, and prevents the cold outer air from taking away its warmth. 162. Why is snow, being composed of congealed water, and water being a better conductor than air, so good a non-conductor? Because in the process of congelation it is frozen into crystalline forms, which, being collected into a mass, form a woolly body, thus proving the truthfulness of the Bible simile, which says, God giveth snow like wool. He giveth snow like wool, he scattereth the hoar frost like ashes. Psalm 147. 163. Why does it frequently feel warmer after frost has set in? Because in the act of congelation a great deal of heat is given out and taken up by the air, and thus the severity of the cold is in some degree moderated. 164. Why is it frequently colder when a thaw takes place? Because in the process of thawing a certain amount of heat is withdrawn from the air and enters the thawed ice. 165. What benefit results from these provisions of nature? They moderate both the severity of frosts and the rapidity of thaws, which, in changeable climates, would be seriously detrimental to life and to vegetation. 166. Why are furs and woolens worn in the winter? Because, being non-conductors, they prevent the warmth of the body from being taken up by the cold air. 167. Why are the skins of animals usually covered with fur, hair, wool, or feathers? Because their coverings, being non-conductors of heat, preserve the warmth of the bodies of the animals. He sendeth out his word, and melteth them. He causeth his wind to blow, and waters to flow. Psalm 147. 186. How is the greater warmth of animals provided for in the winter? It is observed that, as winter approaches, there comes a short woolly or downy growth, which, adding to the non-conducting property of their coats, confines their animal warmth. In small birds during winter, let the external colour of the feathers be what it may, there will be found a kind of black down next their bodies. Black is the warmest colour, and the purpose here is to keep in the heat arising from the respiration of the animal. 169. How is warmth provided for in animals that have no such coats? They are furnished with a layer of fat, which lies underneath the skin. Fat consists chiefly of carbon, and is a non-conductor. 170. Why are summer breezes said to be cool? Because, as they pass over the heated surface of the body, they bear away a part of its heat. 171. Why is a still summer air said to be sultry? Because, being heated by the sun's rays, and being a bad conductor, it does not relieve the body by carrying off its heat. 172. Why does fanning the face make it feel cooler? Because, by inducing currents of air to pass over the face, a part of the excessive heat is taken up and carried away. 173. Why does perspiration cool the body? Because it takes up a part of the heat and, evaporating, carries it into the air. 174. Why does blowing upon hot tea cool it? Because it directs currents of air over the surface of the tea, and these currents take up a part of the heat and bear it away. 175. Why does air in motion feel cooler than air that is still? Because each wave of air carries away a certain portion of heat, and, being followed by another portion of air, a further amount of heat is borne away. Though I walk in the valley of the shadow of death, I will fear no evil, for thou art with me. Psalm 23. 176. Is the atmosphere ever as hot as the human body? Not in this country. On the hottest day it is 10 or 12 degrees cooler than the temperature of our bodies. 177. What is the highest degree of artificial heat which man has been known to bear? A man may be surrounded with air raised to the temperature of 300 degrees, the boiling point being 212, and yet not have the heat of his body raised more than 2 or 3 degrees above its natural temperature of from 97 degrees to 100 degrees. 178. Why may man endure this degree of heat for a short time without injury? Because the skin, and the vessels of fat that lie underneath it, are bad conductors of heat, and because perspiration passing from the skin and evaporating would bear the heat away as fast as it was received. Because, also, the vital principle, life, exercises a mysterious influence in the preservation of living bodies from physical influences. 179. Is the air ever hot enough in any part of the world to destroy life? Yes. The hot winds of the Arabian deserts, which are called simooms, scatter death and desolation in their track, withering trees and shrubs, and burying them under waves of hot sand. When camels see the approach of a simoom, they rush to the nearest tree or bush, or to some projecting rock, where they place their heads in an opposite direction to that from which the wind blows, and endeavour to escape its terrible violence. The traveller throws himself on the ground on the lee side of the camel, and screens his head from the fiery blast within the folds of his robe. But frequently both man and beast fall a prey to the terrible simoom. 180. Why are these hot winds so terrible in their effects? Because, being in motion, they surge their way to every part of the body, and passing over it leave some portion of their heat behind, which is again followed by additional heat from every fresh blast of wind. The fear of the Lord is the beginning of knowledge, but fools despise wisdom and instruction. Proverbs 1. End of chapter 8. Chapter 9 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Julia Niedermeyer. The Reason Why by Robert Kemp Philp. Chapter 9. 181. What is radiation? The radiation of heat is a motion of the particles in a series of rays diverging in every direction from a heated body. 182. What is this phenomena of radiation understood to arise from? From a strongly repulsive power possessed by particles of heat, by which they are excited to recede from each other with great velocity. 183. What is the greatest source of radiation? The sun, which sends forth rays of both light and heat in all directions. 184. When does a body radiate heat? When it is surrounded by a medium which is a bad conductor. 185. When we stand before a fire, does the heat reach us by conduction or by radiation? By radiation. 186. What becomes of the heat that is radiated from one body to another? It is either absorbed by those bodies, or transmitted through them and passed to other bodies by conduction, or diffused by convection, or returned by reflection. 187. How do we know that heat is diffused by radiation? If we set a metal plate, or any other body, though metal is best for the experiment, before the fire, rays of heat will fall upon it. If we turn the plate at a slight angle, and place another object in a line with it, we shall find that the plate will reflect the rays it has received by radiation onto the object so placed. But if we place an object between the fire and the plate, we shall find that the rays of heat will be intercepted, and that the latter can no longer reflect heat. The fear of the Lord is the beginning of wisdom. A good understanding have all they that do his commandments. Psalm 111. 188. Does the agitation of the air interfere with the direction of rays of heat? It has been found that the agitation of the air does not affect the direction of rays of heat. 189. Why, then, if a current of air passes through a space across which heat is radiating, does the air become warmer? Because it takes up some portion of the heat, but it does not alter the direction of the rays. This is clearly illustrated by reference to rays of light, which are seen under many circumstances, but they are never bent, moved, nor in any way affected by the wind. 190. Why will not a current of air disturb the rays of heat, just as it would a spider's web or threads of silk? Because heat is an imponderable agent, that is, something which cannot be acted upon by the ordinary physical agencies. It has no weight, presents no substantial body, and is, in these latter respects, similar to light and electricity. 191. What other sources of radiation of heat are there besides the sun and the fire? The earth and all minor bodies are, in some degree, radiators of heat. 192. What substances are the best radiators? All rough and dark-colored substances and surfaces are the best radiators of heat. 193. What substances are the worst radiators of heat? All smooth, bright and light-colored surfaces are bad radiators of heat. Dr. Stark of Edinburgh has proved by a series of experiments the influence which the colours of bodies have upon the velocity of radiation. He surrounded the bulb of a thermometer successively with equal weights of black, red, and white wool, and placed it in a glass tube, which was heated to the temperature of 180 degrees by immersion in hot water. The tube was then cooled down to 50 degrees by immersion in cold water. The black cooled in 21 minutes, the red in 26 minutes, and the white in 27 minutes. Say unto wisdom, thou art my sister, and call understanding thy kinswoman. Proverbs 7. 194. If you wish to keep water hot for a long time, should you put it into a bright metal jug or into a dark earthenware one? You should put it into a bright metal jug, because, being a bad radiator, it would not part readily with the heat of the water. 195. Why would not the dark earthenware jug keep the water hot as long as the bright metal one? Because the particles of earthenware, being rough and of dark color, they radiate heat freely, and the water would thereby be quickly cooled. End of chapter 9. Chapter 10. Of the Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Julia Niedermeyer. The Reason Why by Robert Kemp Philp. Chapter 10. 196. But if, as stated in the lessons upon conduction, metal is a better conductor of heat than stone or earthenware, why does not the metal jug conduct away the heat of the water sooner than the earthenware jug? It would do so if it were in contact with another conductor, but being surrounded by air, which is a bad conductor, the heat must pass off by radiation, and as bright metal surfaces are bad radiators, the metal jug would retain the heat of the water longer than the earthenware one. 197. Supposing a red-hot cannonball to be suspended by a chain from the ceiling of a room, how would its heat escape? Almost entirely by radiation. But if you were to rest upon the ball a cool bar of iron, a part of the heat would be drawn off by conduction. Warm air would rise from around the ball, and moving upwards, would distribute some of the heat by convection, and some of its rays, falling upon a mirror or any other bright surface, might be diffused by reflection. I will teach you by the hand of God. That which is with the Almighty will I not conceal. Job 27. 198. Do some substances absorb heat? Yes. Those substances which are the best radiators are also the best absorbers of heat. 199. Why does scratching a bright metal surface increase its power of radiation? Because every irregularity of the surface acts as a point of radiation or an outlet by which the heat escapes. 200. Why does a bright metal teapot produce better tea than a brown or black earthenware one? Because bright metal radiates but little heat, therefore the water is kept hot much longer, and the strength of the tea is extracted by the heat. 201. But if the earthenware teapot were set by the fire, why would it then make the best tea? Because the dark earthenware teapot is a good absorber of heat, and the heat it would absorb from the fire would more than counterbalance the loss by radiation. 202. How would the bright metal teapot answer if set upon the hob by the fire? Bright metal teapot would probably absorb less heat than it would radiate. Therefore it would not answer so well being set upon the hob as the earthenware teapot. 203. Why should dish covers be plain in form and have bright surfaces? Because, being bright and smooth, they will not allow heat to escape by radiation. 204. Why should the bottoms and back parts of kettles and saucepans be allowed to remain black? Because a thin coating of soot acts as a good absorber of heat, and overcomes the non-absorbing quality of the bright surface. And the foolish said unto the wise, Give us of your oil, for our lamps are gone out. 205. But why should soot be prevented from accumulating in flakes at the bottom and sides of kettles and saucepans? Because, although soot is a good absorber of heat, it is a very bad conductor. An accumulation of it, therefore, would cause a waste of fuel by retarding the effects of heat. 206. Why should the lids and fronts of kettles and saucepans be kept bright? Because bright metal will not radiate heat. Therefore, the heat which is taken up readily through the absorbing and conducting power of the bottom of the vessel is kept in and economized by the non-radiating property of the bright top and front. 207. Does cold radiate as well as heat? It was once thought that cold radiated as well as heat, but a mass of ice can only be said to radiate cold by its radiating heat in less abundance than that which is emitted from other bodies surrounding it. It is therefore incorrect to speak of the radiation of cold. End of chapter 10.
Chapter 11 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Diana Schmidt. The Reason Why by Robert Kemp Philp. Chapter 11. 208. Why, if you hold a piece of looking glass at an angle towards the sun, will light fall upon an object opposite to the looking glass? Because the rays of the sun are reflected by the looking glass. 209. Why, when we stand before a mirror, do we see our features therein? Because the rays of light that fall upon us are reflected upon the bright surface of the mirror. 210. Why, if a plate of bright metal were held sideways before a fire, would heat fall upon an object opposite to the plate? Because rays of heat may be reflected in the same manner as the rays of light. Excerpt. But the wise answered, saying, Not so, lest there be not enough for us and you. But go ye rather to them that sell, and buy for yourselves. Matthew 25. 211. Why would not the same effect arise if the plate were of a black or dark substance? Because black and dark substances are not good reflectors of heat. 212. What are the best reflectors of heat? Smooth, light-colored, and highly polished surfaces, especially those of metal. 213. Why does meat become cooked more thoroughly and quickly when a tin screen is placed before the fire? Because the bright tin reflects the rays of heat back again to the meat. 214. Why is reflected heat less intense than the primary heat? Because it is impossible to collect all the rays, and also because a portion of the caloric imparting heat to the rays is absorbed by the air and by the various other bodies with which the rays come in contact. 215. Can heat be reflected in any great degree of intensity? Yes, to such a degree that inflammable matters may be ignited by it. If a cannonball be made red hot, and then be placed in an iron stand between two bright reflectors, inflammable materials placed in a proper position to catch the reflected rays will ignite from the heat. There is a curious and an exceptional fact with reference to reflected heat, for which we confess that we are unable to give the reason why. It is found that snow, which lies near the trunks of trees or the base of upright stones, melts before that which is at a distance from them, though the sun may shine equally upon both. If a blackened card is placed upon ice or snow under the sun's rays, the frozen body underneath it will be thawed before that which surrounds it. But if we reflect the sun's rays from a metal surface, the result is directly contrary. The exposed snow is the first to melt, leaving the card standing as upon a pyramid. Snow melts under heat, which is reflected from the trees or stones, while it withstands the effect of the direct solar rays. In passing through a cemetery this winter, 1857, when the snow lay deep, we were struck with the circumstance that the snow in front of the headstones facing the sun was completely dissolved, and in nearly every instance, the space on which the snow had melted assumed a coffin-like shape. This forced itself so much upon our attention that we remained some time to endeavor to analyze the phenomena, and it was not until we remembered the curious effect of reflected heat that we could account for it. It is obvious that the rays falling from the upper part of the headstone onto the foot of the grave would be less powerful than those radiated from the center of the stone to the center of the grave. Hence it was that the heat dissolved at the foot of the grave only a narrow piece of snow, which widened towards the center, and narrowed again as it approached the foot of the headstone, where the lines of radiation would naturally decrease. Such a phenomena would prove sufficient to raise superstition in untutored minds. Excerpt. The light of the righteous rejoiceth, but the lamp of the wicked shall be put out. Proverbs 13. 216. Are good reflectors of heat also good absorbers? No, for reflectors at once send back the heat which they receive, while absorbers retain it. It is obvious, therefore, that reflectors cannot be good absorbers. 217. How do fire screens contribute to keep rooms cool? Because they turn away from the persons in the room rays of heat which would otherwise make the warmth excessive. 218. Why are white and light articles of clothing cool? Because they reflect the rays of heat. White as a color is also a bad absorber and conductor. 219. Why is the air often found excessively hot in chalk districts? Because the soil reflects upon objects near to it the heat of the solar rays. 220. How does the heat of the sun's rays ultimately become diffused? It is first absorbed by the earth. Generally speaking, the earth absorbs heat by day and radiates it by night. In this way, an equilibrium of temperature is maintained, which we should not otherwise have the advantage of. 221. Does not the air derive its heat directly from the sun's rays? Only partially. It is estimated that the air absorbs only 1/3 of the caloric of the sun's rays. That is to say, that a ray of solar heat entering our atmosphere at its most attenuated limit, a height supposed to be about 50 miles, would, in passing through the atmosphere to the earth, part with only 1/3 of its calorific element. Excerpt. As for the earth, out of it cometh bread, and under it is turned up as if it were fire. Job 28. 222. What becomes of the remaining 2/3 of the solar heat? They are absorbed chiefly by the earth, the great medium of calorific absorption. But some portions are taken up by living things, both animal and vegetable. When the rays of heat strike upon the earth's surface, they are passed from particle to particle into the interior of the earth's crust. Other portions are distributed through the air and water by convection, and a third portion is thrown back into space by radiation. These latter phenomena will be duly explained as we proceed. 223. How do we know that heat is absorbed and conducted into the internal earth? It is found that there is a given depth beneath the surface of the globe at which an equal temperature prevails. The depth increases as we travel south or north from the equator, and corresponds with the shape of the earth's surface, sinking under the valleys and rising under the hills. 224. Why may we not understand that this internal heat of the earth arises, as has been supposed by many philosophers, from internal combustion? Because recent investigations have thrown considerable and satisfactory light upon the subject. It has been ascertained that the internal temperature of the earth increases to a certain depth, 1 degree in every 50 feet. But that below that depth the temperature begins to decline, and continues to do so with every increase of depth. 225. Do plants absorb heat? Yes, they both absorb and radiate heat under varying circumstances. The majestic tree, the meek flower, the unpretending grass, all perform a part in the grand alchemy of nature. Excerpt. Consider the lilies of the field, how they grow. They toil not, neither do they spin. When we gaze upon a rose, it is not its beauty alone that should impress us. Every moment of that flower's life is devoted to the fulfillment of its part in the grand scheme of the universe. It decomposes the rays of solar light and sends the red rays only to our eyes. It absorbs or radiates heat according to the temperature of the aerial mantle that wraps alike the flower and the man. It distills the gaseous vapors and restores to man the vital air on which he lives. It takes into its own substance and incorporates with its own frame the carbon and the hydrogen of which man has no immediate need. It drinks the dewdrop or the raindrop and gives forth its sweet odor as a thanksgiving. And when it dies, it preaches eloquently to beauty, pointing to the end that is to come. End of chapter 11. Chapter 12 of The Reason Why by Robert Kemp Philp. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Diana Schmidt. The Reason Why by Robert Kemp Philp. Chapter 12. 226. How do we know that plants operate upon the solar and atmospheric heat? A delicate thermometer placed among the leaves and petals of flowers will at once establish the fact not only that flowers and plants have a temperature differing from that of the external air, but that the temperature varies in different plants according to the hypothetical or supposed requirements of their existences and conditions. 227. What is the chief cause of variation in the temperature of flowers? It is generally supposed that their temperature is affected by their colors. 228. Why is it supposed that the color of a flower influences its temperature? Because it is found by experiment that the colors of bodies bear an important relation to their properties respecting heat, and hold some analogy to the relation of colors to light. If when the ground is covered with snow, pieces of woolen cloth of equal size and thickness, and differing only in color, are laid upon the surface of the snow near to each other, it will be found that the relation of color to temperature will be as follows. In a few hours, the black cloth will have dissolved so much of the snow beneath it as to sink below the surface. The blue will have proved nearly as warm as the black. The brown will have dissolved less of the snow, the red less than the brown, and the white the least, or none at all. Similar experiments may be tried with reference to the condensation of dew, and it will be uniformly found that the color of a body materially affects its powers of absorption and of radiation. Excerpt. And yet I say unto you, that even Solomon in all his glory was not arrayed like one of these. Matthew 6. 229. Why do we know that these effects are not the result of light? Because they would occur in just the same order in the absence of light. 230. Why are dark-colored dresses usually worn in winter and light in summer? Because black absorbs heat and therefore becomes warm, while light colors do not absorb heat in the same degree, and therefore they remain cool. 231. Why do iron articles, even near fire, usually feel cool? Because they are bad absorbers and do not take up heat freely unless they are in contact with a hot body. 232. How is heat diffused through the atmosphere? By convection. The warmth radiating from the surface of the earth warms the air in contact with it. The air expands, and becoming lighter, flies upwards, bearing with it the caloric which it holds, and diffusing it in its course. 233. How do the waters of the ocean become heated? Chiefly by convection. Nearly all the heat which the sun sheds upon the ocean is borne away from its surface by evaporation, or is radiated back into the atmosphere. But the ocean gathers its heat by convection from the earth. It girdles the shores of tropical lands where, being warmed to a high degree of temperature, it sets across the Atlantic from the Gulf of Mexico and exercises an important influence upon the temperature of our latitude. 234. What is the cause of winds? Currents of air and winds are the result of convection. The air, heated by the high temperature of the tropics, ascends, while the colder air of the temperate and the frigid zones blows towards the equator to supply its place. Excerpt. Give unto the Lord the glory due unto his name. Worship the Lord in the beauty of holiness. Psalm 29. 235. What is the cause of sea breezes? Sea breezes are also the result of convection. The land, under the heat of the day's sunshine, becomes of a high temperature, and the expanded air on its surface flies away towards the ocean. As the sun goes down, the earth cools again, and the air flies back to find its equilibrium. Many countries by the sea are subjected to these periodical breezes, known as either land or sea breezes, according to their direction. About 8 o'clock in the morning, an aerial current begins to flow from the sea towards the land, and continues until about 3 o'clock in the day. Then the current takes a reverse direction, flowing from the land to the sea. This it continues to do throughout the night, until the time of sunrise, when a temporary calm ensues. 236. Why does a soap bubble ascend in the air? Because being filled with warm air, it is lighter than the surrounding medium, and therefore ascends. 237. Why does the bubble fall after it has been in the air some time? Because the air contained in it has become cool, and as it contains carbonic acid gas, it is heavier than the air. 238. What became of the warmth at first contained in the bubble? It has been distributed in the air through which the bubble passed. 239. What does this simple illustration of the distribution of warmth explain? It explains the law of convection, or heat distribution, over the surface of the globe. 240. Why does air ascend the chimney? Because being heated, it becomes lighter than the surrounding medium, and therefore flies upwards through the outlet provided for it. 241. Why does air fly from the doors and windows towards the fireplace? Because as the warm air flies away, cold air rushes in to occupy its place. Excerpt. How much better is it to get wisdom than gold, and to get understanding rather than to be chosen than silver. Proverbs 16. 242. What does this example of the motion of the air in our rooms explain? It explains the movement of volumes of air by convection, and illustrates the origin of breezes and winds. 243. What is the chief effect of this law of convection? Under its influence, air and water are the great equalizers of solar heat, rendering the earth agreeable to living things, and suited to the laws of their existence. Owing also to this law of convection, the constituents of the air are equalized. The breath of life, supplied by the purer oxygen of the sunny south, is diffused in salubrious gales over the wintry climes of the north. And the waters, evaporated from the bosom of the central Atlantic Ocean and the Pacific, are borne across vast continents and poured down in fertilizing showers upon distant lands. To the educated mind, nothing is too simple to merit attention. To the ignorant, few things are sufficiently attractive to excite curiosity. Knowledge enables us to estimate the varied phenomena that are hourly arising around us, and to see, even in the most trifling effects, illustrations of those great causes and consequences that govern with mighty power the material world. Man, sitting by his fireside, is enabled to witness the operation of some of nature's grandest laws. Light and heat are around him. Conduction, radiation, reflection, absorption, and convection of heat are all going on before him. Little winds are sweeping by his footstool, and warm currents, with miniature clouds folded in their arms, are passing upward before his view. Chemical changes are going on. The solid rock of coal disappears, flying away as an invisible gas. The little hills are melted, and hard stones have been converted into fervent heat. Although some of these changes are imperceptible to the eye, they are manifest to the educated mind, and the pleasures of philosophical observation are as sweet as a poet's dreams. End of chapter 12.
Chapter 13 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tony Oliva. The Reason Why by Robert Kemp Philp. Chapter 13. Neither do men light a candle and put it under a bushel, but on a candlestick, and it giveth light unto all that are in the house. Matthew 5. 244. Why will a piece of paper, held 3 or 4 inches over the flame of a candle, become scorched? Because the hot air and gas produced by the burning of the candle ascends rapidly. 245. Why will a piece of paper held about an inch below the flame of a candle scarcely become warmed? Because the heat ascends, and only a little of it falls upon the paper, and that by radiation. 246. Why does the lower part of the flame of a candle burn of a blue color? Because the hydrogen of the tallow, having a stronger affinity for the oxygen of the air than carbon has, ignites first. Pure hydrogen burns with a bluish flame. 247. Why does the middle of the flame look dark? Because it is occupied with gaseous vapors, derived from the tallow, which have not yet ignited. 248. Why does the upper part of the flame produce a bright yellow light? Because it is in this part of the flame that the hydrogen of the candle and the oxygen of the air combine, and there is just sufficient carbon mixed with the hydrogen to improve its illuminating power. 249. Why is there a fringe of pale light around the upper part of the flame? Because some of the carbon escapes in a state of incandescence, and as soon as it reaches the air it combines with oxygen, and so forms carbonic acid gas. If any dark body, such as the blade of a knife, be held between the eye and the flame of the candle, so as to shut off the light of the more luminous part, the pale fringe around the flame will be distinctly perceptible. Incandescence means heated to whiteness. How oft is the candle of the wicked put out, and how oft cometh their destruction upon them? Job 21. 250. Why does the flame terminate in a point? Because cold air rushes towards the flame in every direction, and is carried upward. At the point where the flame terminates, the cold currents have so reduced the temperature that combustion can no longer be sustained. 251. Why, if you hold anything immediately over the flame, will the flame lengthen? Because, by preventing the rapid escape of the heated air, you maintain a temperature which increases the combustion at the point of the flame. 252. Why should persons whose clothes take fire throw themselves down? Because flame spreads most rapidly in an upward direction. 253. Why should persons whose clothes are on fire roll slowly about when they are down? Because they thereby press out the fire. 254. Why does pressing a flame or a spark put it out? Because it prevents the contact of the flame or spark with the oxygen of the air. Extinguishers put out the flame of candles in the same manner. A person dies from suffocation through the absence of oxygen, and it is literally practicable to suffocate a fire. 255. Why does the wick turn black as it burns? Because it consists principally of carbon. 256. Why, when the point of the wick turns out and meets the air, does it exhibit a bright spark? Because the carbon of the wick comes into immediate contact with the oxygen of the air. 257. Why does holding a candle upside down put it out? Because the melted grease runs down too rapidly and at too low a temperature to undergo combustion. It therefore reduces the heat and extinguishes the flame. Lord, what is man that thou takest knowledge of him, or the son of man that thou makest account of him? Psalms 144. 258. Why is it more difficult to blow out the flame of a candle with a cotton wick than one with a rush wick? Because the cotton wick imbibes more of the combustible materials and holds in its loose texture the inflammable gases in a state ready for combustion. 259. Why does blowing sharply at a candle flame put it out? Because the breath drives away the vapor of the grease which, becoming gaseous, supports the flame, and because too rapid a flow of cold air reduces the temperature below the point at which combustion can be maintained. 260. Why will a gentle puff of breath, if given speedily after the flame is extinguished, rekindle it? Because the oxygen of the air combines with the carbon and hydrogen that are still escaping from the heated wick and relights it. 261. Why will not a similar puff rekindle the flame of a rushlight? Because its wick retains but little heat and holds a comparatively small amount of combustible matter in a volatile state. 262. Why is a fire, when it is very low, sometimes put out by blowing it? Because the too rapid flow of cold air reduces the temperature of the burning mass. 263. Why will a piece of paper twisted like an extinguisher put out a candle? Because before the flame of the candle can ignite the paper, the oxygen contained within it is consumed, and the flame is suffocated. When his candle shined upon my head, and when by his light I walked through darkness. Job 29. 264. Why do tallow candles require snuffing? Because the oxygen of the air cannot reach the wick through the body of the flame. Therefore the unconsumed carbon accumulates upon the wick. 265. Why do composite and wax candles not require snuffing? Because their wicks are made by a series of plates, by which they are bent to meet the oxygen of the air and consumed. 266. Why does setting a glass upon a lamp increase its brilliancy, though it shortens the flame? Because it conducts an increase of air to the flame, and the greater supply of oxygen causes the escaping vapor of oil to be all rapidly consumed. 267. Why does a candle burn dimly when the wick has become loaded with carbon? Because the carbon radiates the heat and disperses it, and reduces the heat of the flame below that temperature which is essential to its luminosity. 268. What differences characterize the combustion of carbon and of hydrogen? The combustion of carbon takes place without the production of flame. The charcoal, or carbon in any other form, being heated to redness, enters directly into combination with the oxygen of the surrounding air, and the carbonic acid gas, being invisible, passes away unobserved. But in the combustion of hydrogen, the heat developed is so intense as to render the gas itself luminous, just as iron may be heated to a red or white heat. 269. What has become of the candle when it has been burnt? It has been resolved partly into carbonic acid gas, which, though unperceived, has diffused itself through the surrounding air, and partly into water, which escaped in the form of thin vapor. 270. Has any part of the candle been consumed or lost? No. There is no such thing as loss in the operations of nature. Every particle of the candle, now invisible, exists either in the form of gas, vapor, or water, with perhaps a few solid particles that may be called ashes, but which are too minute to excite attention. I know that whatsoever God doeth, it shall be forever. Nothing can be put to it, nor anything taken from it. And God doeth it that men should fear before him. Ecclesiastes 3. The economy of nature should teach us a very impressive lesson. Nothing is suffered to be wasted, not even the slightest atom. As soon as any body has fulfilled its purpose in one state of being, it is passed on to another. The candle, existing no longer as a candle, is flying upon the wings of the air as carbonic acid gas and as water. These probably find their way to the garden or the field, where the carbonic acid gas forms the food of the plant, and the water affords it a refreshing drink. And can it be supposed that the Almighty Being, who has thus economized the existence of the material creation, should be less mindful of the immaterial soul of man? There is an eternity before us, the certainty of which is evidenced even by the laws of the material creation. End of chapter 13. Chapter 14 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tony Oliva. The Reason Why by Robert Kemp Philp. Chapter 14. 271. What is coal? Coal is a vegetable fossil. 272. What is meant by a vegetable fossil? It is a substance originally vegetable, which by pressure and other agencies within the earth has been brought to a condition approaching that of mineral or earthy matter. 273. Why do we know that coal is of vegetable origin? By the chemical components of its substance, and also by the vegetable forms that are found abundantly in coal beds. Professor Buckland, in his Bridgewater Treatise, speaking of the impressions of plants found in the coal mines, says, "The finest example I have ever witnessed is that of the coal mines of Bohemia. The most elaborate imitations of living foliage upon the painted ceilings of Italian palaces bear no comparison with the beauteous profusion of extinct vegetable forms with which the galleries of these instructive coal mines are overhung. The roof is covered as with a canopy of gorgeous tapestry, enriched with festoons of most graceful foliage, flung in wild irregular profusion over every part of its surface. The effect is heightened by the contrast of the coal-black color of these vegetables with the light groundwork of the rock to which they are attached. The spectator feels himself transported as if by enchantment into the forests of another world. He beholds trees of forms and characters now unknown upon the surface of the earth, presented to his senses almost in the beauty and vigor of their primeval life. Their scaly stems and bending branches, with their delicate apparatus of foliage, are all spread forth before him, little impaired by the lapse of countless ages. And bearing faithful records of extinct systems of vegetation which began and terminated in times of which these relics are the infallible historians. Surely every man walketh in a vain show. Surely they are disquieted in vain. He heapeth up riches, and knoweth not who shall gather them. Psalms 39, 274. What are the chemical components of coal? They consist of carbon, hydrogen, oxygen, and nitrogen. The proportions of these elements vary in different kinds of coal. Carbon is the chief component, and the proportions may be stated to be generally carbon 90%, hydrogen from 3 to 6%. The other elements enter into the compound in such small proportions that, for all ordinary purposes, it is sufficient to say that coal consists of carbon and hydrogen, but chiefly of carbon. 275. What is charcoal? Charcoal consists almost entirely of carbon. It is made from wood by the application of heat, without the admission of air. The hydrogen and oxygen of the wood are expelled, and that which remains is charcoal, or carbon, in one of its purest states. 276. What is animal charcoal? Animal charcoal, like vegetable charcoal, consists of carbon in a state approaching purity. It is made from the bones of animals, heated in iron cylinders. It is commonly called ivory black. 277. What is the purest form of carbon known? The purest form of carbon is the diamond, which may be said to be absolutely pure. Hence we derive another of the beautiful lessons of science, a lesson which teaches us to despise nothing that God has given. The soot which blackens the face of a chimney sweep, and the diamond that glistens in the crown of the monarch, consist of the same element in merely a different atomic condition. What a lesson of humility this teaches to pride! The haughty beauty, as she walks the ballroom, inwardly proud of the radiance of her gems as they rise and fall upon her breast, little thinks or knows that every breath that is expired around her wafts away like the element of which her treasures are composed. That even in our own flesh and bones the same abounding substance lies hid, and that the buried tree of the primitive world and the little flower of today are both the instruments of giving this singular element to man. 278. What is coke? Coke is coal, divested of its hydrogen and other volatile parts, by a similar process to that by which charcoal is produced. It forms the residue after hydrogen gas has been made from coals. It consists almost entirely of carbon. Oh, that men would praise the Lord for his goodness and for his wonderful works to the children of men. Psalm 107. 279. Why do burning coals produce yellow flame? Because the hydrogen which they contain is combined with some proportion of carbon, which imparts a bright yellow color to the flames. 280. Why do some of the flames of a fire appear much whiter than others? Because the quality of coals and the conditions under which they are burnt are liable to variation. Some coals yield a heavy hydrogen, called bicarbureted hydrogen, which burns with a much brighter flame than carbureted hydrogen. 281. Why does bicarbureted hydrogen burn with a whiter flame than the common coal gas? Because it is combined with a larger proportion of carbon, to which it owes its increased luminosity. 282. Why do some of the flames of a fire appear blue? Because the hydrogen which is escaping where those flames occur is pure hydrogen, destitute of carbon. 283. Why does the fire sometimes appear red and without flame? because the volatile gases have been driven off and consumed, and combustion is continued by the carbon of the coals and the oxygen of the air. 284. What effect has the burning of a fire upon the composition of the air? It is found that in burning 10 pounds of coal, the oxygen contained in 1,551 cubic feet of air is altogether absorbed. It is therefore necessary to keep the atmosphere of a room in which a coal fire is burning fresh and pure, to supply 155 cubic feet of fresh air for every pound of coal that is consumed. O Lord, how manifold are thy works! In wisdom hast thou made them all. The earth is full of thy riches. Psalm 104. 285. Why does wood which is green hiss and steam when it is burnt? Because it contains a large amount of water, which must be evaporated before combustion can proceed. 286. What is the effect of this evaporation? A great deal of heat is unprofitably expended in driving off the water of the fuel. 287. Why does poking a fire cause it to burn more brightly? Because it opens avenues through which the air may enter to supply oxygen. 288. Why do blowers improve the draft of air through a fire? Because by obstructing the passage of the current of air over the fire, they cause additional air to pass through it, and therefore a greater amount of oxygen is carried to the coals. 289. What is smoke? Unconsumed particles of coal, rendered volatile by heat and driven off. 290. What is soot? Carbon in minute particles driven off with other volatile matters and deposited on the walls of chimneys. 291. Why do fresh coals increase the quantity of smoke? Because they contain volatile matters which are easily driven off, and because also they reduce momentarily the heat, so that those matters that first escape cannot be consumed. 292. Why do charcoal and coke fires burn clearly and without flame? Because the hydrogen has been previously driven off from those substances. 293. Why is it difficult to light charcoal and coke fires? Because they contain no hydrogen to produce flame and assist combustion. He hath made his wonderful works to be remembered. The Lord is precious and full of compassion. Psalm 140. A new plan of kindling fires has lately been recommended. Coals are to be laid in the bottom of the fireplace to a considerable depth. Then the paper and wood are to be laid on, and then a little coals and cinders over them. This plan of laying in the fire is precisely the reverse of that which has been pursued for many years. The theory is that when the coals in the bottom are ignited, a more even combustion is kept up, whilst the smoke and gas which would otherwise escape and become as so much waste fuel is burnt up and produces heat. We have heard the plan strongly recommended by persons who have tried it, and who testify to the great economy of fuel to which it conduces. End of chapter 14. Chapter 15 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tony Oliva. The Reason Why by Robert Kemp Philp. Chapter 15. 294. Why does paper ignite more readily than wood? Because its texture is less dense than that of wood, its particles are therefore more readily heated and decomposed. 295. But if articles of loose texture are bad conductors of heat, why do they so easily ignite? The fact that they are bad conductors assists their ignition. The heat which would pass from particle to particle of the dense substance of iron and be conducted away accumulates in the interspaces of paper and ignites it. 296. Why does wood ignite less readily than paper? Because its substance is denser than that of paper. It therefore requires a higher degree of heat to inflame its substance. 297. Why does wood, when ignited, burn longer than paper? Because, being a denser substance, it submits a larger number of particles, within a given space, to the action of the heat and the formation of gases. 298. Why do we, in lighting a fire, first lay in paper, then wood, and lastly coals? Because the paper is more easily ignited than wood, and wood than coals. Therefore the paper assists the ignition of the wood, and the wood assists the ignition of the coals. It is a good thing to give thanks unto the Lord, and to sing praises unto thy name, O Most High. Psalm 92. 299. Why will not wood ignite by the flame of a match? It will do so unless there is a great disproportion between the size of the wood and the flame of a match. A thin piece of wood will ignite, but a square block will not, because the heat of the flame is insufficient to raise the temperature of a large surface to the point that will drive out its gases. 300. Why do we place the paper under the wood and the wood under the coals? Because heat and flame, when surrounded by air, have a strong tendency to spread themselves upwards. 301. Would it be possible to light the coals by putting the paper and the wood up on the top? It would be possible, but the loss of heat would be so great that a much larger quantity of paper and wood would be required. 302. Why does a poker laid across the top of a dull fire revive it? Because the poker radiates the heat it receives from the fire downward upon the fuel. Because also it divides the ascending air and thereby creates currents. The amount of good which the poker does to the fire is very slight indeed. Generally, the housewife stirs the fire first, and blows or brushes away the ashes that prevent the influx of air. She then places the poker upon the top, and the popular mind supposes that the poker draws the fire. The custom of placing a poker over the fire is of very remote antiquity. It was once believed that forming a cross by placing the poker over the bars protected the fire from the hostility of malignant witches. 303. Why should fireplaces be fixed as low as possible in rooms? Because heat ascends, and when the fireplaces are high, the lower parts of the room are inadequately warmed. Also, as currents of air fly towards the fire, elevated fireplaces cause draughts about the persons of the inmates to a much greater extent than they would if they were lowered down. Unto thee, O God, do we give thanks, for that thy name is near thy wondrous works declare. Psalm 75. 304. Why, if a piece of paper be laid with its flat surface upon the fire, will it char, but not ignite? Because, as in the case of the proper candle extinguisher, the carbonic acid gas accumulating beneath it prevents its igniting. 305. Why, if you direct a current of air towards the paper will it burst into a blaze. Because the carbonic acid gas is displaced by a current of air containing oxygen. 306. Why does water extinguish fire? Because it saturates the fuel and prevents the gases thereof from combining with the oxygen of the air. 307. As water contains oxygen, why does not the oxygen of the water support the fire? Because the affinity between the hydrogen and oxygen of the water is so strong that fire cannot separate them. Water may be decomposed by heat, as will be hereafter explained, but the heat of an ordinary fire is insufficient. There is, however, some reason for believing that in cases of very large fires, such as the accidental burning of houses, etc., and when the supplies of water thrown upon the fire is very deficient, the water does become decomposed and add to the fury of the flames. 308. Why does the blacksmith sprinkle water upon the coals of his forge? The blacksmith uses small coals because the small pieces thereof are more easily ignited than large lumps would be, and they convey heat better by completely surrounding the articles put into the fire. He sprinkles water on the coal dust to hold its particles together by cohesion until the heat forms into a cake. A strong blast of hot air drives the vapor of the water away and leaves a porous mass to the action of the fire. 309. Why, when the blacksmith thrusts a heated iron into a tankard of water, do we recognize a peculiar smell? Because the intense heat disengages a small volume of the gases of which water is formed. Oh, the depth of the riches both of the wisdom and knowledge of God! How unsearchable are his judgments, and his ways past finding out. Romans 11. 310. Which gas do we, in this instance, recognize by the smell? The hydrogen gas. Oxygen gas possesses no odor. 311. What is spontaneous combustion? Spontaneous combustion is that which occurs in various bodies when they become highly heated by chemical changes. 312. Why is heat developed during chemical changes? Because, as all bodies contain latent caloric, the disturbance of the atoms of which these bodies are composed during the new combinations that constitute chemical changes frequently sets the caloric free, and an accumulation of caloric produces spontaneous combustion. 313. Does a match ignite spontaneously when drawn over a rough surface? No, because in this case the combustion arises from heat applied by friction. 314. Does phosphorus ignite spontaneously when held in a warm hand? Phosphorus will ignite when held in a warm hand, but it does not then produce spontaneous combustion because it ignites through the agency of applied heat. 315. But if a piece of dry phosphorus be sprinkled with powdered charcoal, it will ignite without the application of heat. Why is this? Because the carbon, charcoal, absorbs oxygen from the air and conveys it to the phosphorus. Here are chemical changes which develop heat and produce spontaneous combustion. 316. Why do haystacks sometimes take fire? Because the hay, having become damp, decays and passes on to a state of fermentation in which chemical changes occur, during which heat is evolved. Hay, taking fire under these circumstances, would exhibit spontaneous combustion. Who hath woe? Who hath sorrow? Who hath contentions? Who hath babbling? Who hath words without cause? Who hath redness of the eyes? They that tarry long at the wine. Proverbs 23. 317. What substances are liable to produce spontaneous combustion? All substances which contain sugar, starch, and other components liable to fermentation. All bodies that evolve under low degrees of temperature, inflammable gases. And all organic bodies undergoing decay. Grain, cotton, hemp, flax, coals, oily and greasy substances. 318. What is the ignis fatuus, sometimes called will-o'-the-wisp, corpse candles, and jack-o'-lantern? It is a flame produced by spontaneous combustion, caused by the decay of animal or vegetable bodies, which evolve phosphoretted hydrogen gas, under circumstances attended by a low degree of heat, sufficient to ignite the gases. It is mostly seen over marshy places and burial grounds. Many a ghost story has owed its origin to these singular but harmless appearances. People ignorant of the cause have been terrified by the effect. To the fancy of an affrighted mortal, the simple flame of the ignis fatuus has assumed the form of a departed friend, and even found a supernatural voice. If, excited by a momentary daring, the beholder moved towards the light upon which he gazed, it fled from him. If he turned from it and walked away, it followed him step by step. The darkness of a lonely road, or the sacred solitude of a burial place, have been sufficient accessories to authenticate the appearance of a spirit. And yet how simple the phenomenon! Matters so volatile as those which produce the ignis fatuus would naturally be driven back by the motion in the air caused by an advancing body, and on the other hand, a body moving from them would create a current in which the ignis fatuus would follow. Poisonous gases escaping from decaying bodies pass into the air and take fire. They are thereby converted into harmless compounds. Thus we see that the ghost which terrifies the mind of the ignorant becomes a guardian angel to the educated. 319. Has spontaneous combustion ever occurred in living bodies? It has occurred in numerous instances to persons habituated to the excessive use of spirits. 320. Why should spontaneous combustion occur in the case of the drunkard? Because spirituous drinks contain a large proportion of alcohol, one of the constituents of which is hydrogen. The vital energies of the drunkard being destroyed by excess, chemical agencies obtain an ascendancy, and it is supposed that the hydrogen of the alcohol combines with the phosphorus of the body to form phosphorated hydrogen, which ignites spontaneously and literally consumes the living temple. Drought and heat consume the snow waters, so doth the grave those which have sinned. Job 24. Cases of spontaneous combustion are of rare occurrence, but they are sufficiently well authenticated by high medical authority in many parts of the world to present an awful warning to the inveterate drunkard. The cases of which we have read the particulars present details of the most appalling description. How signally the almighty displeasure at intemperance is expressed when the very drink which imparts the mad pleasure of intoxication is made the direct instrument by which the drunkard is destroyed. End of chapter 15. Chapter 16 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tony Oliva. The Reason Why, by Robert Kemp Philp. Chapter 16. 321. Why does friction produce heat? Because all bodies contain latent heat, that is, heat that lies hid in their substance, and the rubbings of two bodies against each other draws the latent heat to the excited surfaces. 322. Why does the rubbing of two surfaces together attract latent heat to those surfaces? Because it is a law of nature that heat shall always attend motion, and it is generally found that the intensity of heat bears a specific relation to the velocity of motion. 323. What are the sources of heat? The rays of the sun, the currents of electricity, the action of chemicals, and the motion of substances. 324. Why does water freeze? Because its latent heat is partly drawn off by the surrounding air. 325. Why does ice melt? Because the heat once latent in the water, but drawn off by the air, has returned to it and restored the water to its former condition. So teach us to number our days, that we may apply our hearts unto wisdom. Psalm 90. 326. Why does water become steam? Because a larger amount of heat has entered into it than can remain latent in water. The water therefore expands and rises in the form of vapor, or water attenuated by heat. 327. How many degrees of heat are latent or hidden in the different states of water? In thawing ice, 140 degrees of caloric become latent, and in converting the water into steam, 1,000 degrees more of caloric are taken up. Therefore, ice requires to take up 1,140 degrees of latent caloric before it becomes steam. 328. What is the most modern theory of heat? It is this, that caloric, which produces heat, is an extremely subtle fluid, of so refined a nature that it possesses no weight, yet is capable of diffusing itself among the particles of the most solid bodies. It is also believed that all bodies are subject to the action of two opposing forces, one, the mutual attraction of their particles, the other, the repulsive force of caloric, and that bodies exist in the aeriform, fluid, or solid state, according to the predominance of either the one or the other of these opposing forces. 329. How do we measure the quantity of caloric in any substance? It is impossible to determine the amount of caloric which any body contains. Our sensations would obviously be deceptive, since, if we dipped the right hand in snow, and held the left hand before the fire, and then immersed both hands in cold water, the water would feel warm to the right hand, and cold to the left hand. But as caloric uniformly expands substances that are under its influence, one of the bodies most sensitive to calorific effects has been selected to be the indicator of the amount of caloric. This substance is quicksilver, and the scale of measurement and the apparatus for exhibiting the rise or fall of the quicksilver constitute the thermometer. 330. If it is impossible to measure the amount of caloric in any substance, how can it be said that ice absorbs 140 degrees in becoming water? Those figures simply record the amount of caloric indicated by the thermometer. The instrument will show, with sufficient accuracy, the relative amount of caloric in various bodies, or in the same bodies under different circumstances, but it can never determine the precise amount of caloric in any one body. Great is the Lord, and greatly to be praised in the city of our God, in the mountain of his holiness. Psalm 48. 331. Why, if a hot and a cold body were placed near to each other, would the cold one become warmer and the hot one cooler? Because free caloric, that is caloric that is not latent, always exhibits a tendency to establish an equilibrium. If 20 bodies of different temperatures were placed in the same atmosphere, they would all soon arrive at the same temperature. The caloric would leave the bodies of those the highest and find its way to those of the lowest temperature. 332. How does caloric travel? It travels in parallel rays in all directions with a velocity approximating to that of light, and it passes through various bodies with a rapidity proportionate to their power of conduction. 333. Why does melted metal run like a stream of fluid? Because caloric has passed into its substance, and repelling its particles has separated them to that degree which produces fluidity. 334. How do we know that it is caloric passing into the substance of the metal which produces this effect? Because as soon as a bar of metal begins to be heated, it expands and lengthens. It continues to do so until the heat arrives at that point which causes the metal to melt. 335. Why does the iron of an ironing box sometimes become too large for the box to receive it? Because caloric has passed into the substance of the iron and repelled its particles, by which it has become expanded. 336. Why does the iron enter the box when it has become partially cooled? Because a portion of the caloric has left the iron, the particles of which have drawn closer together and contracted the mass. Cast thy burden upon the Lord, and he shall sustain thee. He shall never suffer the righteous to be moved. Psalm 55. This effect is frequently observed by females in domestic life who, when they are ironing or using the Italian irons, find that the heated metal has been too much expanded to enter the box or tube. They find it necessary to wait until the cooling of the iron has had the effect of reducing its dimensions. The expansion of bodies by heat is one of the grandest and most important laws of nature. We are indebted to it for some of the most beautiful as well as the most awful phenomena, and science has gained some of its mightiest conquests through its aid. Yet frequently, though quite unthought of, in the hands of the humble laundress will be found a most striking illustration of this wonderful force of caloric. 337. Are there any instances in which the abstraction of latent heat will reduce the hulk of bodies? Yes, there are several, but the most familiar one is that which is exhibited by mixing a pint of the oil of vitriol with a pint of water. A considerable amount of heat will be evolved, and it will be found that the 2 pints of fluid will not afterwards fill a quart measure. 338. Is there any latent heat in air? Yes, a considerable amount. In a pint measure of air, though in no way evident to our perceptions, there lurks sufficient caloric to raise a piece of metal several inches square to glowing redness. 339. How do we know that caloric exists in the air? It has been positively demonstrated by the invention of a small condensing syringe, by which, through the rapid compression of a small volume of air, a spark is emitted which ignites a piece of prepared tinder. 340. What is the cause of the spark when a horse's shoe strikes against a stone? The latent heat of the iron or the stone is set free by the violent percussion. The same effect takes place when flint strikes against steel, as in the old method of obtaining a light with the aid of the tinder box. The waters are laid as with a stone, and the face of the deep is frozen. Job 38. What an eloquent lecture might be delivered upon the old-fashioned tinder box, illustrated by the one experiment of striking a light. In that box lie, cold and motionless, the flint and steel, rude in form and crude in substance. And yet, within the breast of each, there lies a spark of that grand element which influences every atom of the universe, a spark which could invoke the fierce agents of destruction to wrap their blasting flames around a stately forest or a crowded city, and sweep it from the face of the world, or which might kindle the genial blaze upon the homely hearth, and shed a radiant glow upon a group of smiling faces, a spark such as that which rises with the curling smoke from the village blacksmith's forge, or that which leaps with terrific wrath from the troubled breast of a Vesuvius. And then the tinder, the cotton, the carbon. What a tale might be told of the cotton field where it grew, of the black slave who plucked it, of the white toiler who spun it into a garment, and of the village beauty who wore it, until faded and despised, it was cast amongst a heap of old rags, and finally found its way to the tinder box. Then the tinder might tell of its hopes, how, though now a blackened mass, soiling everything that touched it, it would soon be wedded to one of the great ministers of nature, and fly away on transparent wings until, resting upon some alpine tree, it would make its home among the green leaves, and for a while live in freshness and beauty, looking down upon the peaceful vale. Then the steel might tell its story, how for centuries it lay in the deep caverns of the earth, until man, with his unquiet spirit, dug down to the dark depths and dragged it forth, saying, "No longer be at peace." Then would come tales of the fiery furnace, what fire had done for steel, and what steel had done for fire. And then the flint might tell of the time when the weather-bound mariners, lighting their fires upon the Syrian shore, melted silicious stones into gems of glass, and thus led the way to the discovery of the transparent pane that gives a crystal inlet to the light of our homes, of the mirror in whose face the lady contemplates her charms, of the microscope and the telescope by which the invisible are brought to sight, and the distant drawn near, of the prism by which Newton analyzed the rays of light, and of the photographic camera in which the sun prints with his own rays the pictures of his own adorning. And then both flint and steel might relate their adventures in the battlefield, whither they had gone together, and of fights they had seen in which man struck down his fellow man, and, like a fiend, had revelled in his brother's blood. Thus, even from the cold hearts of flint and steel, man might learn a lesson which should make him blush at the glory of war, and the proud who despise the teachings of small things might learn to appreciate the truths that are linked to the story of a tinderbox. End of chapter 16. Chapter 17 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tony Oliva. The Reason Why by Robert Kemp Philp. Chapter 17. 341. Since all bodies expand by heat and contract by cold, why does water, when it reaches the freezing point, expand? Because in freezing, water undergoes crystallization, in which its particles assume a new arrangement, occupying greater space. 342. Why does water never freeze to a great depth? Because the covering of ice which is formed upon the surface of the water prevents the cold air from continuing to draw off the caloric of the water. For he saith to the snow, Be thou on the earth, likewise to the small rain, and to the great rain of his strength. Job 37. 343. Why has this exceptional law of the expansion of water when freezing been ordained? Because, but for this, deep waters might be frozen through their whole depth. This would destroy the myriads of fish and other living things that inhabit the water. Parts of the earth, now clad in verdure, would be lost in eternal winter, and even in the most temperate zones it would take months to effect a thaw, and thawing would be attended with such floods and subterranean commotion as are terrible to contemplate. 344. Why are bedroom windows sometimes covered with crystalline forms on winter mornings? Because the vapor of the breaths of the inmates has condensed upon the window panes and formed water. The water has frozen with the cold and exhibits the beautiful crystalline forms into which its particles are arranged. Here we have another domestic illustration of the great laws of nature. It is the same law which locks the Arctic regions in ice and decorates our window panes. This beautiful phenomenon is usually witnessed by us on frosty mornings when we arise from our beds. It has a story which the observer of nature may read in its sparkling eyes. It tells that, although without the air is biting cold, God has wrapped a mantle around the face of nature to keep it from injury, and that the earth and the waters, though looking chilled and dead, have still the warmth of life preserved in their bosoms. 345. What is dew? Dew is watery vapor diffused in the air, condensed by coming in contact with bodies colder than the atmosphere. 346. Why does the air become charged with watery vapor? Because during the day, under the influence of the sun's rays, vapors are exhaled from all the moist and watery surfaces of the earth. These vapors are held in suspension in the atmosphere until, by a change in the temperature of the earth and of bodies on the surface of the earth, they are condensed and deposited in translucid drops. 347. What causes the decline of temperature that favors the deposition of dew? The earth, which during the day received heat from the solar rays, radiates the heat back into the air, and therefore becomes itself colder. All the various objects upon the face of the earth also radiate heat in a greater or lesser degree, and dew will be found to be deposited upon the surfaces of such bodies in proportion to the fall of their temperature through radiation. The Lord is my shepherd. I shall not want. He maketh me to lie down in green pastures. Psalm 23. 348. Why is there little or no dew when the nights are cloudy? Because clouds act as secondary radiators, and when the earth radiates its heat towards the clouds again radiate it back to the earth. If plates of glass be laid over grass beds, as in the engraving Figure 3, no dew will be deposited on the grass underneath the glass plates, although all around the grass will be completely wetted. The explanation is that the glasses, being radiators of heat, act in the same manner as the clouds, returning the heat to the bodies underneath them, and preventing the formation of dew thereon. 349. Why does dew form most abundantly on cloudless nights? Because the heat which is radiated by the earth does not return to it. The temperature of the earth, and the air immediately upon its surface, is therefore lowered, and dew is formed. It has been observed that sheep that have lain on the grass during the formation of dew have their backs completely saturated with it, but that underneath the line where their bodies turn to the earth, their coats will be dry. In the same manner, glass globes suspended in the air on dew-forming nights will be found loaded with globules of dew upon the top, but there will be no appearance of moisture underneath. Dost thou know the balancings of the clouds, the wondrous works of him which is perfect in knowledge? Job 37, 350. Why are starlit nights usually colder than cloudy nights? Because heat is radiated from the earth and passes away into the utmost regions of the atmosphere. 351. Why is there little dew under branches of thick foliage? Because the foliage acts as a screen, which prevents the radiated heat of the earth from passing away. 352. Why is there no dew formed on windy nights? Because as winds generally consist of dry air, they absorb and bear away the atmospheric moisture. 353. Why are valleys and low places chiefly subject to dew? Because the elevated lands around them prevent the disturbance of the air in which the moisture is held. 354. What bodies are most likely to be covered with dew? All bodies that are good radiators of heat, such as wool, swan's down, grass, leaves of plants, wood, etc. 355. What bodies are likely to receive little dew? All bad radiators of heat, such as polished metal surfaces, smooth stones, and polished surfaces generally. Dew will be found to lie more abundantly upon rough and woolly leaves than upon smooth ones. 356. At what period of the night is the largest amount of dew usually formed? It is generally supposed that dew is formed most copiously in the mornings and evenings, but such is not the case. It is deposited at all hours of the night, but most plentifully after midnight. 357. Why is dew formed most plentifully after midnight? Because as radiation has been going on for some time, the temperature of the earth and of various bodies upon it has been considerably reduced. Out of whose womb came the ice, and the hoary frost of heaven? Who hath gendered it? Job 38. 358. In what parts of the world is the maximum of dew formed? In warm lands near the sea, or in the vicinity of rivers or lakes, as the localities of the Red Sea, the Persian Gulf, the coast of Coromandel in Alexandria, and Chile. 359. In what parts of the world is the minimum of dew formed? It is quite absent in arid regions, in the interior of continents, such as central Brazil, the Sahara, and Nubia. 360. Why is dew seldom formed at sea? Because of the defective radiating quality of the surface of water. 361. Why is a heavy dew regarded as the precursor of rain? Because a heavy formation of dew indicates that the air is saturated with moisture. 362. What is hoarfrost? Hoarfrost is frozen dew. 363. Why is hoarfrost said to foretell rain? Because it shows that the air is saturated with moisture, and the temperature of the air being low, the vapors are likely to condense and produce showers. 364. What is honeydew? Honeydew is the name applied to a sweet and sticky moisture occasionally deposited upon the leaves of plants. It is, however, an error to call it dew, as it is procured by a class of insects termed aphids. 365. What are fogs? Fogs are clouds formed near the earth's surface, but London fogs are distinguished from clouds by the fact that they embrace in their vaporous folds the smoke and volatile matters imparted to the air by the operations of man. This is also the case with fogs generally that arise near large towns. Hath the rain a father? Or who hath begotten the drops of dew? Job 38. 366. Why are certain coasts liable to almost perpetual fogs? Because of local or geographical agencies which contribute to their production. The coasts of California are almost constantly wrapped in fog, and almost as constantly the western coasts of the American continent, as far south as Peru, Newfoundland, Nova Scotia, and Hudson's Bay, are all subject to dense and frequent fogs arising from the condensation of vapor from the water flowing from the hot Gulf Stream coming in contact with the colder air. 367. What are dry fogs? Dry fogs are characterized by a dull, opaque appearance of the atmosphere. They are most common in certain parts of North America, though they sometimes occur in Germany and in England. They are generally referred to the electrical state of the atmosphere, but the theory of them is still a matter of doubt. 368. What is a mist? The term mist is generally applied to vapors that rise over marshy places or the surfaces of water, and roll or move over the land. 369. What is the difference between a mist and a fog? Fogs, as they are known to us, generally arise over the land and are usually mingled with the smoke of large towns. Mists generally arise over water or wet surfaces. 370. Why do mists and fogs disappear at sunrise? Because the condensed vapors are again expanded and dispersed by the heat of the sun's rays. 371. Why do fogs frequently rise in the morning and fall again in the evening? Because, warmed by the sun's rays, they become more rarefied and fly away at an altitude where they appear to be altogether dispelled. But at night, when the earth cools by radiation, the vapors near the earth again condense and settle in the form of fog. 372. Why do fogs sometimes rest upon a given locality for several days together, and then disappear? They are probably kept near to the surface of the earth by a superstratum of cold air. A cold air lying above or a cold air lying below might equally contribute to keep a fog near the surface of a particular part of the earth until a flow of wind or a fall of rain altered the atmospheric condition. He bindeth up the waters in his thick clouds, and the cloud is not rent under them. Job 26. There are many interesting facts connected with the history of dew. It has attracted the attention of natural philosophers in all ages, but its true theory was never understood until recently. The ancients imagined that dews were shed from the stars, and the alchemists and physicians of the Middle Ages believed that the dew distilled by night possessed penetrating and wonder-working powers. The ladies of those times sought to preserve their beauty by washing in dew, which they regarded as a celestial wash. They collected it by placing upon the grass heaps of wool, upon the threads of which the magic drops clustered. End of chapter 17.
Chapter 18 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. The Reason Why by Robert Kemp Philp. Chapter 18. 373. What are clouds? Clouds are volumes of vapor, usually elevated to a considerable height. 374. Whence do clouds arise? From the evaporation of water at the earth's surface. 375. Why do we not see them ascend? We do sometimes in the form of what we call mists, but generally the vapors that rise and contribute to the formation of clouds are so thin that they are invisible. With the clouds he covereth the light, and commandeth it not to shine by the cloud that cometh betwixt. Job 36. 376. Why, if they are invisible when they rise, do they become visible when they have ascended? Because the vapors become cooled in passing through the air and form a denser body. 377. Why, when they are condensed, do they not follow the course of gravitation and descend? Because the vapors form into minute vesicles, which we may call vapor bubbles, and these, being warmed by the sun, are specifically lighter than the air. Because also the lower parts of clouds do partially descend, but again becoming more rarefied by meeting with a warmer atmosphere, they again ascend and are thus poised upon the air. Because also there is always a degree of atmospheric motion upward, caused by the convection of heat from the earth's surface. And although there must also be downward movements of the air to supply the place of that which has ascended, still the heat of the ascending air combined with its upward movement expands and floats the vapor of the clouds. 378. At what height do clouds usually fly? They fly at every degree of altitude, but clouds of specific character are said to fly at given altitudes, or to occupy certain ranges of altitude. We will give their probable altitudes when speaking of the specific clouds. 379. How many descriptions of clouds are there? There are 7. 1. The cirrus, estimated range of altitude from 10,000 to 24,000 feet. 2. The cumulus, from 3,000 to 10,000 feet. 3. The stratus, an extended continuous level sheet of cloud increasing from beneath. They fly very low. 4. The nimbus, from 1,500 to 5,000 feet. 5. The cirrocumulus, from 3,000 to 20,000 feet. 6. The cirrostratus, from 5,000 to 10,000 feet. 7. The cumulostratus, from 3,000 to 10,000 feet. The estimated heights given must be looked upon as very conjectural, although they have been derived from the best existing authorities. It is sufficient to know that the range of the altitude of the various clouds is from that of the nimbus or thunder cloud, 1,500 feet, to that of the cirrus, 24,000 feet, the others being intermediate. The first three of the clouds above enumerated constitute what are called the primary forms. The remaining four are called secondary forms because they arise, as their names generally indicate, out of combinations of the primary forms. Although from the frequent mingling of clouds it is not always practicable to identify them by the adopted classification, still, as there is generally a prevalence of one type of cloud over another, the observer would be able to distinguish a cirrus sky or cirro-cumulus sky, etc. Upon some occasions the typical characters of the clouds are beautifully defined, and the contemplation of their forms and the law of their formation affords infinite pleasure to the observer. The advantages of scientific knowledge are such, that whether you look downwards to the earth or upwards to the sky, you still have the writing of God to read. 380. What produces the various shapes of clouds? 1. The state of the atmosphere. 2. The electrical condition of the clouds. 3. The movements of the atmosphere. 4. The season of the year. Behold, he withholdeth the waters, and they dry up. Also he sendeth them out, and they overturn the earth. Job 12. 381. What are the dimensions of clouds? A single cloud has been estimated to have as many as 20 square miles of surface, and to be above a mile in thickness, while others are no larger than a house or a man's hand. 382. How are clouds affected by winds? If cold winds blow upon the clouds, the cold condenses the vapor, turning the clouds into rain. But if warm, dry winds blow upon the clouds, they rarefy the vapor to a greater degree and temporarily disperse the clouds. 383. How do winds affect the shapes of clouds? When winds are mild and gentle, the clouds break into small patches and rise to a considerable height. But when the winds are cold and blustering, the clouds fly low and roll along in heavy masses. 384. Why are east winds usually dry? Because in coming towards England they pass over vast continents of land and comparatively little ocean, hence they are not loaded with vapors. 385. Why do west winds generally bring rain? Because they come across the Atlantic and are heavily charged with vapor. 386. Why are north winds generally cold and dry? Because they come from the Arctic Ocean, over vast areas of ice and snow. Terrors are turned upon me, they pursue my soul as the wind, and my welfare passeth away as a cloud. Job 30. 387. Why are south winds warm and rainy? Because they come from the southern regions, heated by the hot earth and sands, and as they cross the sea they absorbed a large amount of vapor. 388. Why are clouds said to indicate the changes of the weather? Because as it is the state of the clouds that, to a great extent, determines the state of the weather, the formation of the clouds must predicate approaching changes. 389. What do cirrus clouds foretell? Cirrus clouds foretell fine weather when they fly high and are thin and light. They foretell light rain when, after a long continuance of fine weather, they form fleecy lines stretched across the sky. They foretell a gale of wind when, for some successive days, they gather in the same quarter of the heavens, as if denoting the point from which to expect the coming gale. 390. What do cumulus clouds foretell? Cumulus clouds, when they are well defined and advance with the wind, foretell fine weather. When they are thin and dull and float against the wind, or in opposition to the lower currents, they foretell rain. When they increase in size and become dull and gray at sunset, they predict a thunderstorm. When he made a decree for the rain and a way for the lightning and the thunder. Job 28. 391. What do stratus clouds foretell? Stratus clouds foretell damp and cheerless weather. 392. What do nimbus clouds foretell? Nimbus clouds foretell rain, storm, and thunder. 393. What do cirro-cumulus clouds foretell? Cirro-cumulus clouds in summer foretell increasing heat attended by mild rain and a south wind, but in winter they commonly precede the breaking up of a frost and the setting in of foggy and wet weather. 394. What do cirrostratus clouds foretell? Cirrostratus clouds foretell rain or snow according to the season of the year. These clouds extend in long horizontal streaks, thinning away at their base and in parts becoming wavy or patchy. When they are thus defined in the heavens, they are a certain indication of bad weather. 395. What do cumulostratus clouds foretell? Cumulostratus clouds usually foretell a change of weather, from rain to fine or from fine to rain. Behold, I will put a fleece of wool in the floor, and if the dew be on the fleece only, and it be dry upon all the earth beside, then shall I know that thou wilt save Israel. End of chapter 18. Chapter 19 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kay Hand. The Reason Why by Robert Kemp Philp. Chapter 19. 396. Why are cloudy days colder than sunny days? Because the clouds intercept the solar rays in their course towards the earth. 397. Why are cloudy nights warmer than cloudless nights? Because the clouds radiate back to the earth the heat which the earth evolves. Because also the clouds radiate to the earth the heat they have derived from the solar rays during a cloudy day. 398. Why is the earth warmer than the air during sunshine? Because the earth freely absorbs the heat of the solar rays, but the air derives comparatively little heat from the same source. 399. Why does the earth become colder than the air after sunset? Because the earth parts with its heat freely by radiation, but the air does not. 400. Why do glasses, mats, or screens prevent the frost from hitting plants? Because they prevent the radiation of heat from the plants and also from the earth beneath them. 401. Why are the screens frequently covered with dew on their exposed sides? Because they radiate heat from both their surfaces. A piece of glass laid horizontally over the earth would radiate heat both upwards and downwards. But on its lower surface it would receive the radiated heat of the earth, while from its upper surface it would throw off its own heat and become cool. Therefore dew would be deposited upon the upper, but not on the under surface. 402. Why does dew rest upon the upper surfaces of leaves? Because the under surfaces receive the radiated warmth of the earth. And it was so, for he rose up early on the morrow, and thrust the fleece together, and wringed the dew out of the fleece a bowlful of water. 403. Why are cultivated lands subject to heavier dews than those that are uncultivated? Because cultivation breaks up the hard surface of the earth, and thus its radiating power is increased. 404. Why is the gravel walk through a lawn comparatively dry, while the grass of the lawn is wet with dew? Because gravel is a bad radiator, but grass is a good radiator. 405. What benefit results from this arrangement? In cultivated lands where moisture is required, it is induced by the very necessity which demands it, while in rocky and barren places where it would be of no good, dew does not form. 406. Why does little dew form at the base of hedges and walls and around the trunks of trees? Because those bodies in some degree counteract the radiation of heat from the earth, and they also radiate heat from their own substances. 407. Why do heavy morning dews and mists usually come together? Because they both have their origin in the humidity of the atmosphere. The temperature of the earth having fallen, dew has been deposited, but, at the same time, the condensation of the vapor in the air has formed a screen over the surface of the earth, which has checked the further radiation of heat, and consequently the further formation of dew. The sun rises, therefore, upon an atmosphere charged with visible vapor at the earth's surface, and his first sloping rays, having little power to warm the atmosphere, the mist continues visible for some time. 408. What effect have winds upon the formation of dew? Winds generally, and especially when rapid, prevent the formation of dew. but those winds that are moist and contribute to the formation of clouds indirectly aid the formation of dew through the formation of clouds, and also by the moisture they impart to the air. And Gideon said unto God, Let it now be dry only upon the fleece, and upon all the ground let there be dew. 409. Why does the humidity of the atmosphere sometimes form clouds, and at others forms fogs, mists, dews, etc.? The result depends upon the varying temperature, motion, and direction of the atmosphere. A warm, light atmosphere of a few days' duration will elevate the vapors to the region where they are formed into clouds. A chill air, lying upon the surface of the warmer earth, will occasion mists or fogs. A cold earth, acting upon the vapors contained in a warmer atmosphere, will condense them and occasion dews. 410. Why are frosty mornings usually clear? Because in the cold atmosphere which preceded the frost there was but little evaporation, and now that the frost has set in, the vapors that existed have become frozen in the form of hoar frost. 411. Why are clear nights usually cold? Because the screen afforded by the clouds does not exist, therefore the heat of the earth escapes, while the vapors of the air are abstracted from it by condensation into dew, thereby imparting great clearness to the nights. 412. Why are hoar frosts, or as they are termed, white frosts, so frequent, and black frosts so unusual? Because white or hoar frosts result from the coldness of the earth, which, from its great radiating power, is always varying, but black frosts result from the coldness of the air, which is liable to less variation of temperature than the earth. 413. What is a black frost? A black frost results from the coldness of the atmosphere, which is at the time overshadowed by a dull cloud, giving a darkness to everything, and a leaden appearance to the frozen surface of water. 414. Why are black frosts said to last? Because they result from the temperature of the air, which is less likely to vary than that of the earth. There is a probability that the coldness thereof will last for some time. And God did so that night, for it was dry upon the fleece only, and there was dew on all the ground. Judges 6. 415. What benefits result from the radiation of heat, etc.? 415. What benefits result from the radiation of heat, etc.? But for the radiation of heat, we should be subjected to the most unequal temperatures. The setting of the sun would be like the going out of a mighty fire. The earth would become suddenly cold, and its inhabitants would have to bury themselves in warm covering to wait the return of the day. By the radiation of heat, an equilibrium of temperature is provided for, without which we should require a new order of existence. The amount of heat which our earth receives from the sun, and the economy of that heat by the laws of radiation, reflection, absorption, and convection, are exactly proportionate to the necessities of our planet and the living things that inhabit it. It is held by philosophers that any change in the orbit of our earth, which would either increase or decrease the amount of heat falling upon it, would, of necessity, be followed by the annihilation of all the existing races. The planets Mercury and Venus, which are distant respectively 37 millions of miles and 63 millions of miles from the great source of solar heat, possess a temperature which would melt our solid rocks, while Uranus, 1,800 millions of miles, and Neptune, whose distance from the sun has not been determined, must receive so small an amount of heat that water, such as ours, would become solid as the hardest rock, and our atmosphere would be resolved into a liquid. Yet poised in the mysterious balance of opposing forces, our orb flies unerringly on its course at the rate of 63,000 miles an hour, preserving in its wonderful flight that precise relation to the sun, which takes from his life-inspiring rays the exact degree of heat which, being shared by every atom of matter and every form of organic existence, is just the amount needed to constitute the heat life of the world. End of chapter 19. Chapter 20 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kay Hand. The Reason Why by Robert Kemp Philp. Chapter 20. 416. What is rain? Rain is the vapor of the clouds, which, being condensed by a fall of temperature, forms drops of water that descend to the earth. It is the return to the earth in the form of water of the moisture absorbed by the air in the form of vapor. 417. Does rain ever occur without clouds? It sometimes, but rarely happens, that a sudden transition from warmth to cold will precipitate the moisture of the air without the formation of visible clouds. Canst thou lift up thy voice to the clouds, that abundance of waters may cover thee? Job 38. 418. Why are drops of rain sometimes large and at other times small? Because the drops in falling meet and unite and also gather moisture in their descent. The greater the height from which a raindrop has descended, the larger it is, provided that its whole course lay through a rainy atmosphere. The size of the drops is also influenced by the amount of moisture in the atmosphere, the degree of cold, and the rapidity of the change of temperature by which the drops are produced. 419. In what seasons of the year are rains most prevalent? Throughout Central Europe, rains are most prevalent in summer, but in Southern Europe, the preponderance is on the side of winter rains. 420. In what months of the year does it rain most frequently in this country? It rains more frequently from September to March than from March to September, but the heaviest rains occur from March to September. 421. Why are there more rainy days from September to March? Because the temperature of the air is more frequently lowered to that degree which precipitates its vapors. Months in the order of their comparative wetness: 1 October, 2 February, 3 July, 4 September, 5 January, 6 December. Months in the order of their comparative dryness: 1 March, 2 January, 3 May, 4 August, 5 April, 6 November. 422. In what part of the world does the greatest quantity of rain fall? The greatest quantity of rain falls near the equator, and the amount decreases towards the poles. Who can number the clouds in wisdom, or who can stay the bottles of heaven? Job 38. 423. In what part of the world do the heaviest rains occur? The heaviest rains occur in the tropics during the hot season. The drops of rain in the tropical regions are so large and the force with which they descend so great that their splash upon the skin causes a smarting sensation. 424. In what parts of the world do the least rains occur? There are some parts of the earth which are rainless, such as Egypt, the desert of Sahara, the table lands of Persia and Mongolia, the rocky flat of Arabia Petrae, etc. 425. How many rainy days are there in a year? The frequency of rainy days is greatest in countries near the sea, and their number decreases the further we journey from the sea border towards the inland. In England, it rains on an average 152 to 155 days in the year. 426. In what parts of England does the greatest amount of rain fall? In the town of Keswick in Cumberland, where 63 inches of rain fall in a year, Kendal in Westmoreland, 58 inches, Liverpool, 34 inches, Dublin, 25 inches, Lincoln, 24 inches, London, 21 inches. 427. Why do the heaviest rains occur at the tropics? Because the hot air absorbs a large amount of vapor and rises into the higher regions of the atmosphere, where the vapors are suddenly condensed into heavy rains by cold currents from the poles. 428. Why does the greatest quantity of rain fall at the equator? Because the hot air absorbs a large amount of vapor, and as the atmosphere is usually calm, there is an absence of currents, by which the saturated air would be removed. In this, which is called the region of calms, rain falls almost daily. 429. Why are some parts of the earth rainless? Because, being situated in tropical or torrid latitudes and at a distance from the ocean, the atmosphere above them is always in a dry state. Thou, O God, didst send a plentiful rain, whereby thou didst confirm thine inheritance when it was weary. Psalm 68. 430. When is air said to be saturated with vapor? When it cannot take up a larger quantity than that which it already holds. When common salt is dissolved in water until the water can take up no more, the water is then said to be saturated with salt. 431. What proportion of water is air capable of sustaining in the form of vapor? The amount of water held in suspension by the air averages the following proportion. 1,000 cubic feet of air contain as much vapor as, were it condensed to water, would yield about 2/5 of a pint. But 1,000 cubic feet of air are capable of holding half a pint of water, and this may be regarded as the point of saturation. Thus, in a room 10 feet square and 10 feet high, the air at the point of saturation would hold in the form of vapor half a pint of water. It must not be forgotten, however, that the point of saturation necessarily varies with the temperature of the air. 432. Why are cloudy days and nights not always wet? Because the air has not reached the state of saturation. 433. Why does rain purify the air? Because it produces motion in the particles of the air by which they are intermixed, and it precipitates noxious vapors and cleanses the face of the earth from unhealthy accumulations. 434. Why are mountainous localities more rainy than flat ones? Because the mountains attract the clouds, and because the clouds that are flying low are borne against the sides of the mountains and directed upwards, where they meet with cold currents of air. 435. Why does more rain fall by night than by day? Because by night the temperature of the air heated during the day falls to that degree which condenses its vapors into rain. As the hart panteth after the water brooks, so panteth my soul after thee, O God. Psalm 42. 436. Why do bunches of dry seaweed indicate the probability of coming rain? Because they readily imbibe moisture, and when they become soft and damp, they show that the air is approaching the point of saturation. 437. Why does the weather toy, called the weathercock, foretell the probability of rain? Because it is made with a piece of catgut which swells with moisture, and as it swells, shrinks. The catgut is so applied that when it shrinks, it turns a rod which sends the man out of the house, and when it dries, it sends the woman out. Therefore, when the man appears, it is a sign of wet, and when the woman appears, it is a sign of dry weather. There is another toy, called the capuchin, which is made upon the same principle. The figure lifts a hood over its head when wet is approaching, and takes it off when the weather is becoming dry. In this case, a piece of catgut is also employed. Various weather toys may be made upon this principle, among others a little umbrella, which will open on the approach of wet and close on the return of fine weather. A gentleman once made a wooden horse, which he declared should of itself walk across a room without machinery of any kind. The assertion was discredited, but the horse was placed in a room close to the wall on one side. The room was locked and otherwise fastened, so that no one could interfere with the experiment. After a time the door was opened, and it was found that the horse had actually crossed the floor and stood on the opposite side. The horse was made from wood of a peculiar kind, liable to great expansion in wet weather, and cut in a manner to produce the greatest elongation. The 4 hoofs were so made that where they were set they would remain, so that the contracting parts should draw up from behind. It is easy to understand how, in this way, the wooden horse crossed the apartment. 438. Why does a lady's hair drop out of curl upon the approach of damp weather? Because the hair absorbs moisture, which causes its spirals to relax and unfold. 439. Why is it said in mountainous countries that rain is coming because the mountains are putting their nightcaps on? Because the clouds descend when they are heavy with vapor, and being attracted to the mountain tops, they are said to cap the mountains. Hast thou entered into the treasures of the snow, or hast thou seen the treasures of the hail? Job 38. End of chapter 20. Chapter 21 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kay Hand. The Reason Why by Robert Kemp Philp. Chapter 21. 440. What is snow? Snow is congealed vapor, which would have formed rain, but through the coldness of the air has been frozen in its descent into crystalline forms. 441. Why is snow white? Because it reflects all the component rays of light. 442. Why is snow said to be warm, while white garments are worn for coolness? Snow is warm by virtue of its light and woolly texture, but it is also warm on account of its whiteness. For, had it been black, it would have absorbed the heat of the sun, which would have thawed the snow. Instead of which, it reflects heat, and the reflected heat falls upon bodies above the snow, while the warmth of the earth is preserved beneath it. White clothing is cool because it reflects from the body of the wearer the heat of the sun. White snow is warm because it reflects the sun's heat upon bodies. There are few persons but have felt the effect of the sun's rays reflected by the white snow on a clear wintry day. And as regards the warmth of snow towards the earth, by preventing the radiation of heat, it has been found that a thermometer buried 4 inches deep in snow has shown a temperature of 9 degrees higher than at the surface. 443. Why are lofty mountains always covered with snow? Because the upper regions of the atmosphere are intensely cold. 444. Why are the upper regions of the atmosphere intensely cold? Because the atmosphere retains but little of the heat of the sun's rays as they pass to the earth. Because at high altitudes the air is greatly rarefied. And because the radiation of heat from the earth does not materially affect such high regions. He causeth the vapors to ascend from the ends of the earth. He maketh lightnings for the rain. He bringeth the wind out of his treasuries. Psalm 35. 445. What is meant by the snow line? The snow line is the estimated altitude in all countries where snow would be formed. Even at the equator, at an altitude of 15,000 to 16,000 feet from the level of the sea, snow is found upon the mountain summits, where it perpetually lies. As we proceed north or south from the equator, the snow line lessens in altitude. Had we in England a mountain 6,000 feet high, it would perpetually be crowned with snow. 446. Why do we hear of red snow? Red snow is the name given to the snow in the Arctic regions upon which a minute vegetable, probably the Protococcus nivalis, grows, imparting to the snow a red color. Recent microscopic investigations have shown it to consist of a minute vegetable cell which secretes a red coloring matter. Snow is found to be of greater importance to man than is generally supposed. But although in this country we are enabled to recognize the hand of Providence in the gift, there are latitudes wherein the blessing thus conferred is more deeply felt. In such countries as Canada, Sweden, and Russia, the falling of snow is looked for with glad anticipations, quite equaling those which herald the harvest home of England or the vintage of France. No sooner is the ground covered with snow than cranky old vehicles that had been jolting over rough roads and sticking fast in deep ruts of mud are wheeled aside, and swift sledges take their place. Towns distant from each other find an easy mode of communication, the markets are enlivened, and trade thrives. Snow supplies a kind of railroad covering the entire face of the country, and sledges glide over it almost with the speed of the locomotive. 447. What is sleet? Sleet is snow which, in falling, has met with a warmer current of air than that in which it congealed. It therefore partially melts and forms a kind of wet snow. 448. What is hail? Hail is also the frozen moisture of the clouds. It is probably formed by raindrops in their descent to the earth, meeting with an exceedingly cold current of air by which they suddenly become frozen into hard masses. It is also supposed that the electrical state of the air and of the clouds influences the formation of hail. If the clouds be full of rain, they shall empty themselves upon the earth. Ecclesiastes 11. 449. Why is it supposed that the electrical state of the air and the clouds affects the formation of hail? Because hail is more common in the summer than at other seasons, and is frequently attended by storms of thunder and lightning. 450. Why do hailstorms most frequently occur by day? Because the clouds, being charged with vapor to saturation, favor the formation of hail by sudden electrical or atmospheric changes. In the gradual cooling of night, the clouds would expend themselves in rain. Astonishing facts respecting hailstorms are upon record. In 1719, there fell at Cremo hailstones weighing 6 pounds. In 1828 there was a fall of ice at Horsley in Staffordshire, some of the pieces of which were 3 inches long by 1 inch broad, and other solid pieces were about 3 inches in circumference. Hailstorms are most frequent in June and July and least frequent in April and October. Hail clouds float much lower in the sky than other clouds. Their edges are marked by frequent heavy folds, and their lower edges are streaked with white, the other portions being massive and black. End of chapter 21. Chapter 22 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kay Hand. The Reason Why by Robert Kemp Philp. Chapter 22. 451. What is light? Light, according to Newton, is the effect of luminous particles which dart from the surfaces of bodies in all directions. According to this theory, solar light which we receive would depart from the sun and travel to the earth. According to Huygens, light is caused by an infinitely elastic ether diffused through all space. This ether, existing everywhere, is excited into waves or vibrations by the luminous body. The theory of light is so undetermined that neither the views of Newton nor those of Huygens can be said to be exclusively adopted. Writers upon natural philosophy seize hold of either or both of these theories, as they present themselves more or less favorably in the explanation of natural phenomena. In The Reason Why, as we have to speak of the effects of light rather than of its cause, we shall avoid as far as possible the doubtful points. But let no one be discouraged by the fact that the theory of light, as indeed of all the imponderable agents, is imperfectly understood. Rather let us rejoice that there are vast fields of discovery yet to be explored, and that light, the most glorious and inspiring element in nature, invites us from the sun, the moon, and the stars, and from the face of every green leaf and variegated flower, to search out the wonders of its nature, and further to exemplify the goodness and wisdom of God. And God said, "Let there be light," and there was light. 452. What is the distance of the sun from the earth? 95 millions of miles. 453. At what rate of velocity does light travel? At the rate of 192,000 miles in a second through our atmosphere, and 192,500 miles in a second through a vacuum. 454. How long does it take light to travel from the sun to the earth? 8 minutes and 13 seconds. 455. What is the constitution of the sun? It is a spherical body, 1,384,472 times larger than the earth. 456. From what does the luminosity of the sun arise? From a luminous atmosphere, or as M. Arago named it, photosphere, which completely surrounds the body of the sun and which is probably burning with great intensity. 457. What are the minor sources of light? Light may be produced by chemical action, by electricity, and by phosphorescence, in the latter of which various agencies unite. 458. What is a ray of light? A ray of light is the smallest portion of light which we can recognize. 459. What is a medium? A medium is a body which affords a passage for the rays of light. 460. What is a beam of light? A beam of light is a group of parallel rays. 461. What is a pencil of light? A pencil of light is a body of rays which come from or move towards a point. And God saw the light, that it was good, and God divided the light from the darkness. Genesis 1. 462. What is the radiant point? The radiant point is that from which diverging rays of light are emitted. 463. What is the focus? The focus is the point to which converging rays are directed. Diverging, starting from a point and separating. Converging, drawing together towards a point. 464. What is the constitution of a ray of light? A ray of white light as we receive it from the sun is composed of a number of elementary rays which, with the aid of a triangular piece of glass called a prism, may be separated, and will produce under refraction the following colors. 1. An extreme red ray, a mixture of red and blue, the red predominating. 2. Red. 3. Orange, red passing into and combining with yellow. 4. Yellow, the most luminous of all the rays. 5. Green, yellow passing into and combining with the blue. 6. Blue. 7. Indigo, a dark and intense blue. 8. Violet, blue mingled with red. 9. Lavender gray, a neutral tint. 10. Rays called fluorescent, which are either of a pure silvery blue or a delicate green. 465. Why is a ray of light, which contains these elementary rays, white? Because the color of light is governed by the rapidity of the vibrations of the ether waves. When a ray of light is refracted by or transmitted through a body, its vibrations are frequently disturbed and altered, and thus a different impression is made upon the eye. Light, which gives 37,640 vibrations an inch, or 458 trillion in a second of time, produces that sensation upon the eye which makes the object that directs the vibrations appear red. Yellow light requires 44,000 vibrations in an inch, and 535 trillion in a second of time. And the other colors enumerated all require different velocities of vibration to produce the colors by which they are distinguished. The light of the body is the eye. If, therefore, thine eye be single, thy whole body shall be full of light. Matthew 5. Accepting the theory of vibrations and applying it to the elucidation of the phenomena of light, it is unnecessary, we think, to believe that a ray of white light contains rays in a state of color. It is said that if we divide a circular surface into parts and paint the various colors in the order and proportions on which they occur in the refracted ray, and then spin the circle with great velocity, the colors will blend and appear white. But such is not the case. The result is in some degree an illusion arising out of the sudden removal of the impression made upon the eye by the colors. And if a piece of white paper be held by the side of the colored circle in motion, the latter will be found to be gray. When it is remembered that in coloring a white surface with thin colors, the white materially qualifies the colors, it must be admitted that the experiment fails to support the assertion that the colors of the spectrum produce white. But there can be no difficulty in understanding that a ray of light undergoing refraction becomes divided into minor rays which, differing in their degrees of refrangibility, vary also in the velocity of their vibrations, and produce the several sensations of color. 466. Why is a substance white? Because it reflects the light that falls upon it without altering its vibrations. 467. Why is a substance black? Because it absorbs the light and puts an end to the vibrations. 468. Why is the rose red? Because it imparts to the light that falls upon it that change in its vibratory condition, which produces on our eyes the sensation of redness. 469. Why is the lily white? Because it reflects the light without altering its vibrations. 470. Why is the primrose yellow? Because though it receives white light, it alters its vibrations to 44,000 in an inch and 535 trillion in a second, and this is the velocity of vibration which produces upon the eye a sensation of yellow. But if thine eye be evil, thy whole body shall be full of darkness. If therefore the light that is in thee be darkness, how great is that darkness? Matthew 5. 471. Why are there so many varieties of color and tint in the various objects in nature? Because every surface has a peculiar construction or atomic condition by which the light falling upon it is influenced. In tropical climates, where the brightness of the sun is the most intense, there the colors of natural objects are the richest. The foliage is of the darkest green, the flowers and fruits present the brightest hues, and the plumage of the birds is of the most gaudy description. In the temperate climates, these features are more subdued, still bearing relation to the degree of light. And at a certain depth of the ocean, where light penetrates only in a slight degree, the objects that abound are nearly colorless. It has been held by many philosophers, and the theory is so far conclusive that it cannot be dispensed with, that there is an analogy between the vibratory causes of sound and the vibratory causes of color. Anyone who has seen an Aeolian harp and listened to the wild notes of its music will be aware that the wires of the harp are swept by accidental currents of air, that when those currents have been strong, the notes of the harp have been raised to the highest pitch, and as the intensity of the currents has fallen, the musical sounds have deepened and softened, until, with melodious sighing, they have died away. No finger has touched the strings, no musical genius has presided at the harp to wake its inspiring sounds, but the vibration imparted to the air as it swept the wires has alone produced the chromatic sounds that have charmed the listener. If, then, the varied vibrations of the air are capable of imparting dissimilar sensations of sounds to the ear, is it not only possible but probable that the different vibrations of light may impart the various sensations of colors to the eye? End of chapter 22.
Chapter 23 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Naomi Brewster, Melbourne, Australia. The Reason Why by Robert Kemp Philp. Chapter 23. 472. What is the refraction of light? When rays of light fall obliquely upon the surface of any transparent medium, they are slightly diverted from their course. This alteration of the course of the rays is called refraction, and the degree of the refraction is influenced by the difference between the densities of the mediums through which light is transmitted. Let your light shine before men, that they may see your good works, and glorify your Father which is in heaven. Matthew 5. 473. If a ray of light falls in a straight line upon a transparent surface, is it then refracted? In that case the ray pursues its course, there is no refraction. 474. Is the direction in which the rays are bent or refracted influenced by the relative densities of the media? A ray of light falling slantingly upon a window, in passing through it, is slightly brought to the perpendicular, and if it then falls upon the surface of the water, it is still further brought to the perpendicular in passing through the water. 475. Is light refracted in passing from a dense medium to a thinner one? It is, but the direction of the refraction is just the opposite to the instance just given. A ray of light passing through water into air does not take a more perpendicular course, but becomes oblique. 476. Why, if a rod or a spoon be set in an empty basin, will it appear straight, or of its usual shape? Because the rays of light that are reflected from it all pass through the same medium, air. 477. Why, if water be poured into the basin, will the rod or spoon appear bent? Because the rays of light that pass through the water are reflected in a different degree from those that pass through the air. Evening and morning and at noon I will pray and cry aloud, and he shall hear my voice. Psalms 105. Place in the bottom of an empty basin a shilling. Then stand in such a position at the point B that the line of sight over the edge of the basin just excludes the shilling from view. Then request someone to pour water into the basin until it is filled to C, keeping your eye fixed upon the spot. The shilling will gradually appear and will soon become entirely in view. Not only will the shilling be brought into view, but also portions of the basin before concealed. This is owing to the rays of light passing from the bottom through the water in a direction more perpendicular than they would have done through the air. But on leaving the water they become more oblique. and hence they convey the image of the shilling over the edge of the basin, which would otherwise have been obstructed. 478. Why is it that in cloudy and showery days we see the sun's rays bursting through the clouds in different directions? Because in passing through clouds of different densities, the rays are bent out of their course. 479. Why is the apparent depth of water always deceptive? Because the light reflected from the objects at the bottom is refracted as it leaves the water. 480. How much deeper is water than it appears to be? About 1/3. A person bathing and being unable to swim should calculate before jumping into the water that if it looks 2 feet deep, it is quite 3 feet. 481. Why can we seldom at the first attempt touch anything lying at the bottom of the water with a stick? Because we do not allow for the different refractive powers of water and of air. I do set my bow in the cloud, and it shall be for a token of a covenant between me and the earth. 482. Why do we see the sun before sunrise and after sunset? Because of the refractive effects of the atmosphere. Rays of light passing obliquely from the sun through the air to the earth are refracted 3 or 4 times by the varying density of the medium. Each refraction bends the rays towards the perpendicular, and hence we see the sun before it rises and after it sets. 483. Why do figures viewed through the hot air proceeding from furnaces and from lime kilns appear distorted and tremulous? Because the ever-varying density of the air, which is flying away in hot currents and succeeded by cold, constantly changes the refractive power of the medium through which the figures are viewed. 484. Why do stars twinkle? Because their light reaches us through variously heated and moving currents of air. In this case, the earth is the kiln, and the stars are the object that is viewed through the refractive medium. 485. Why does much twinkling of the stars foretell bad weather? Because it denotes that there are various aerial currents of different temperatures and densities, producing atmospheric disturbance. And it shall come to pass, when I bring a cloud over the earth, that the bow shall be seen in the cloud. Genesis 9. 486. What causes the rainbow? The refraction of the sun's rays by the falling rain. 487. Why does the rainbow exhibit various colours? The colours belong to the elementary rays of light, and these rays having different degrees of refrangibility, some of them are bent more than others. They are therefore separated into distinct rays of different colours. 488. Why are there sometimes 2 rainbows? Because the rays of refracted light, reflected upon other drops of rain, are again refracted, and then reflected again, forming a secondary bow. 489. Why are the colours of the secondary bow arrayed in the reverse order of the primary bow? Because the secondary bow is a reflection of the primary bow, and like all reflections is reversed. 490. Why are reflections reversed? Because those rays which first reach the reflecting surface are the first returned. If you hold your open hand towards the looking glass, the light passing from the point of your finger will reach the reflector and be returned before the rays that pass from the back parts of the hand. Hence the image of the hand will present the reflection of the finger point towards the point of the finger. 491. Why are the colours of the secondary rainbow fainter than those of the primary? because they are derived from the refraction and reflection of rays which have already been refracted and reflected, and thereby their intensity has been diminished. 492. What is a lunar rainbow? A lunar rainbow is caused by the light of the moon in the same manner as the solar rainbow is caused by the light of the sun. I am come a light into the world, that whosoever believeth in me should not abide in darkness. John 13. 493. Why is the lunar rainbow fainter than a solar rainbow? Because the light of the moon is the reflected light of the sun and therefore less intense. 494. What is a halo? A halo is a luminous ring which forms between the eye of the observer and a luminous body. Halos may appear around the disk of the sun, moon or stars, but in this country the lunar halos are the most remarkable and frequent. 495. What is the cause of this luminous ring? The refraction of light as it passes through an intervening cloud or a stratum of moist and cold air. 496. Why are halos sometimes large and at other times small? Because they are sometimes formed very high in the atmosphere, at other times very low. Being high and the farther removed from the spectator and nearer the source of light, they appear smaller, while the nearer they are, the larger they appear. 497. Why do halos foretell wet weather? Because they show that there is a great amount of atmospheric moisture, which will probably form rain. 498. Why do glass lustres and chandeliers exhibit rainbow colours? Because they refract the rays of light in the same manner as the raindrops. 499. Why does a soap bubble show the prismatic colours? Because, like a large raindrop, it refracts the rays of light and shows the elementary rays. 500. What causes the rich tints displayed by mother of pearl? The refraction of the light that falls upon the surface of the pearl. Light is sown for the righteous and gladness for the upright in heart. Psalm 97. 501. What causes the brilliant colours of the diamond? The refraction of the rays of light by the various facets of the diamond. The refraction of light and the production of prismatic colours surrounds us with most interesting phenomena. The laundress, whose active labours raise over the wash-tub a soapy froth, performs inadvertently one of the most delicate operations of chemistry, the chemistry of the imponderable agents, and the result of her manipulations manifests itself in the delicate colours that dance like a fairy light over the glassy films that follow the motion of her arms. The laughing child, throwing a bubble from a bowl of tobacco pipe into the air, performs the same experiment, and produces a result such as that which filled the philosophic Newton with unbounded joy. The foam of the seashore, the plumage of birds, the various films that float upon the surface of the waters, the delicate tints of flowers, and the rich hues of luscious fruits, all combine to remind us that every ray of light comes like an angelic artist sent from heaven, bearing upon his palette the most celestial tints with which to beautify the earth and show the inimitable joy of God. End of chapter 23.
Chapter 24 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 24. 502. What is the difference between the refraction and the reflection of light? Refraction is the deviation of rays of light from their course through the interference of a different medium. Reflection is the return of rays of light which, having fallen upon a surface, are repelled by it. 503. What is the radiation of light? The radiation of light is its emission in rays from the surface of a luminous body. 504. Do all bodies radiate light? All bodies radiate light, but those that are not in themselves primary sources of light are said to reflect it. 505. Do black bodies reflect any light? Black bodies absorb the light that falls upon them, but they reflect a very small degree of light. 506. Why is glass transparent? Because its atoms are so arranged that they allow the vibrations of light to continue through their substance. As in water face answereth to face, so the heart of man to man. Proverbs 27. 507. Does glass obstruct the passage of any portion of light? Glass reflects, sends back, a very small portion of light. This may be observed by holding a piece of paper or a hand a few inches from a window, when a faint reflection of it will be visible. Probably the small amount of light reflected by transparent glass, which gives a passage to the greater part of the rays, may serve to illustrate the small amount of light reflected from black surfaces, which absorbs the greater portion of light. Instead of a piece of white paper, hold a piece of black cloth 2 or 3 inches from the window pane, and you will have 2 reflections so weak that the image of the cloth will be almost lost. The first reflection is that of the very small amount of light from the black surface onto the glass, and the second reflection is that of the inconceivably small amount returned by the glass, and by which the faint image of the black cloth is produced. But put the black cloth outside of the window pane, and then hold an object before them, and you will find that the 2 weak reflectors acting together produce an improved image or reflection. 508. Why, if a book is held between a candlelight and the wall, does a shadow fall upon the wall? Because the rays of light are intercepted by the book. 509. Why do the rays pass over the edges of the book in a direct line with the flame of the candle? Because light always travels in straight lines. 510. Why is there some amount of light even where shadows fall? Because as all objects reflect light, some of them throw their light into the field of the shadow. 511. Why are some substances opaque to light? Because the arrangement of their particles will not admit of the vibrations of the luminous ether passing through them. Opaque, impervious to rays of light. 512. Why do we see our faces reflected in mirrors? Because the rays of light from our faces are reflected by the surface of the quicksilver at the back of the glass. The day is thine, the night also is thine. Thou hast prepared the light and the sun. Psalm 74. 513. Why does the quicksilver reflect the rays of light? Because being densely opaque to light, and presenting also a bright surface, it is a good reflector, and it throws back the whole of the rays. 514. What has the glass to do with the reflection? The glass has nothing to do with the reflection, except that it affords a field upon which the reflecting surface of the quicksilver is spread, and it keeps the air and dirt from dulling the quicksilver. The parts of a mirror from which the quicksilver is rubbed away give no reflection that could assist the reflecting power of the quicksilver. That the surface of the glass does not reflect the image is shown by the fact that if you put the point of any object against the glass, the thickness between the point and the place where the reflection of it begins will show the exact thickness of the glass. 515. Why does a compound mirror, a multiplying mirror, exhibit a large number of images of one object? Because all objects reflect rays of light in every direction, and therefore the different mirrors, being at various angles, receive each a reflection of the same object. 516. Why does a window pane appear to be a better reflector by candlelight than by daylight? The reflecting power of glass is precisely the same by night as by day, and is always very feeble, but it appears to be greater by night because the surrounding darkness increases the apparent strength of the reflection. 517. How do we know that objects reflect light in every direction? Because if we prick a hole in a card with a pin, and then look through that small hole upon a landscape, we can see some miles of country and some thousands of objects. Every part of every object throughout the whole scene must have sent rays of light the small hole pricked in the card. Such knowledge is too wonderful for me. It is high, I cannot attain unto it. Psalm 139. At one extremity of the landscape, viewed through the hole in the card, there may be a forest of trees. In the distance there may be hills bathed in golden light, and overhung with glittering clouds. In the mid-distance there may be a river winding its course along, as though it loved the earth through which it ran, and wished, by wandering to and fro, to refresh the thirsty soil. In the foreground may be a church, covered by 1,000,000 ivy leaves, and grouping towards the sacred edifice may be hundreds of intending worshippers, old and young, rich and poor. Flowers may adorn the pathways, and butterflies spangle the air with their beauties. Yet every one of those objects, the forest, the hills, the clouds, the river, the church, the ivy, the people, the flowers, the butterflies, must have sent rays of light, which found their way through the little hole in the card and entered to paint the picture upon the curtain of the eye. This is one of the most striking instances that can be afforded of the wonderful properties of light, and of the infinitude of those luminous rays that attend the majestic rising of the sun. Not only does light fly from the grand ruler of the day, with a velocity which is 1,500,000 times greater than the speed of a cannon ball, but it darts from every reflecting surface with a like velocity, and reaches the tender structure of the eye so gently that as it falls upon the little curtain of nerves which is there spread to receive it, it imparts the most pleasing sensations, and tells its story of the outer world with a minuteness of detail and a holiness of truth. Philosophers once sought to weigh the sunbeam. They constructed a most delicate balance, and suddenly let in upon it a beam of light. The lever of the balance was so delicately hung that the fluttering of a fly would have disturbed it. Everything prepared, the grave men took their places, and with keen eyes watched the result. The sunbeam that was to decide the experiment had left the sun 8 minutes prior to pass the ordeal. It had flown through 95 millions of miles of space in that short measure of time, and it shot upon the balance with unabated velocity, but the lever never moved, and the philosophers were mute. End of chapter 24. Chapter 25 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 25. 518. Why, when we move before a mirror, does the image draw near to the reflecting surface as we draw near to it, and retire when we retire? Because the lines and angles of reflection are always equal to the lines and angles of incidence. 519. What is the line of incidence? If a person stands in a direct line before a mirror, the line through which the light travels from him to the mirror is the line of incidence. Incidence, falling on. Blessed be the Lord, who daily loadeth us with benefits, even the God of our salvation. Psalm 68. 520. What is the line of reflection? The line of reflection is the line in which the rays of light are returned from the image formed in the glass to the eye of the observer. Reflection, a turning back. 521. What is the angle of incidence? The angle of incidence is the angle which rays of light, falling on a reflecting surface, make with a line perpendicular to that surface. 522. What is the angle of reflection? The angle of reflection is the angle which is formed by the returning rays of light and a line perpendicular to the reflecting surface. It is always equivalent to the angle of incidence. Take a marble and roll it across the floor, so that it shall strike the wainscot obliquely. Let A in the diagram represent the point from which the marble is sent. The marble will not return to the hand, nor will it travel to the line B, but will bound off, or be reflected, to C. Now B is an imaginary line, perpendicular to the reflecting surface, and it will be found that the path described by the marble in rolling to the surface and rebounding from it form, with the line B, two angles that are equal. These represent the angles of incidence and of reflection, and explain why the reflection of a person standing at A before a mirror would be seen by another person standing at C. This simple law in optics explains a great many interesting phenomena, and therefore it should be clearly impressed upon the memory. And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also. Genesis 1. 523. Why do windows reflect the sun in the evening? Because the eye of the observer is in the line of the reflection. 524. Why do windows not reflect the sun at noon? They do, but our eyes are not then in the line of the reflection. It is obvious from the foregoing diagram that the evening rays of reflection fall upon the eyes of spectators, while the reflections at noon are so perpendicular that they are lost. 525. Why do the sun and moon appear smaller when near the meridian than when near the horizon? Because when near the horizon they are brought into comparison with the sizes of terrestrial objects, but when near the meridian they occupy the center of a vast field of sky, and as there are no objects of comparison surrounding them, they appear smaller. This is one reason why, assigned by some observers. But there is also another reason to be found in the fact that, when the sun or moon is near the horizon, we view it through a greater depth of atmosphere than we do when at the meridian. A straight line passed upward through the air would not be so long as that which passes to S. Consequently, as the air is generally impregnated with moisture at the time when these effects are observed, the rays of light are caused to diverge more, and the disk of the sun or moon appears magnified. Probably both of these reasons contribute to the effect. This latter reason also explains why the disk of the sun or moon may sometimes appear oval in shape, the lower stratum of air being more loaded with moisture than that through which we view the upper part of the disk. There is no darkness, nor shadow of death, where the workers of iniquity may hide themselves. Job 34. 526. Why do our shadows lengthen as the sun goes down? Because light travels only in straight lines, and as the sun descends, the direction of his rays become more oblique, thereby causing longer shadows. 527. What is the cause of the optical illusions frequently observed in nature? There are various kinds of natural optical illusions. The mirage, in which landscapes are seen reflecting in burning sands. The fata morgana, in which 2 or 3 reflections of objects occur at the same time. The aerial spectra, or aerial reflections, etc. The optical illusions above enumerated owe their origin to various atmospheric conditions, in which refractions and reflections are multiplied by the different densities of atmospheric layers. They chiefly occur in hot countries, where, from the varying effects of heat, the conditions of atmospheric refraction and reflection frequently prevail in their highest degree. In the morning ye say, it will be foul weather today, for the sky is red and lowering. Matthew 16. 528. Why do we have twilight mornings and evenings? Because the coming and the departing rays of the sun are refracted and reflected by the upper portions of the atmosphere. 529. How long before the sun appears above the horizon does the reflection of his light reach us? The time varies with the refracting and reflecting power of the atmosphere, from 20 minutes to 60 minutes. but the sun's position is usually 18 degrees below the horizon when twilight begins or ends. 530. Why is the sky blue? The white light of the sun falls upon the earth without change. It is then reflected back by the earth, and as it passes through the atmosphere, portions of it are again returned to us, and this double reflection produces a polarized condition of light, which imparts to vision the sensation of a delicate blue. 531. Why do the clouds appear white? Because they reflect back to us the solar beam unchanged. 532. Why does the sky appear red at sunset? Because the light vapors of the air, which are condensed as the sun sets, refract the rays of light and produce red rays. The refraction which produces red requires only a moderate degree of density. 533. Why do the clouds sometimes appear yellow? Because there is a larger amount of vapor in the air, which produces a different degree of refraction, resulting in yellow. 534. Why does a yellow sunset foretell wet weather? Because it shows that the air is heavy with vapors. The refraction that produces yellow requires a greater degree of density. When it is evening, ye say it will be fair weather, for the sky is red. Matthew 16. 535. Why does a red sunset foretell fine weather? Because the redness shows that the vapors in the air towards the west, or wet quarter, are light, as is evidenced by the degree of refraction of the sun's rays. 536. Why does a red sunrise foretell wet? Because it shows that towards the east, or dry quarter, the air is charged with vapor, and therefore probably at other points the air has reached saturation. 537. Why does a gray sunrise foretell a dry day? Because it shows that the vapors in the air are not very dense. 538. Why is a rainbow in the morning the shepherd's warning? Because it shows that in the west, or wet quarter, the air is saturated to the rain point. 539. Why is a rainbow at night the shepherd's delight? Because it shows that the rain is falling in the east, and as that is a dry quarter, it will soon be over. Rainbows are always seen in opposition to the sun. End of chapter 25.
Chapter number 26 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Naomi Brewster, Melbourne, Australia. The Reason Why, by Robert Kemp Philp. Chapter 26. 540. What is the difference between light and heat? The most obvious distinction is that light acts upon vision and heat upon sensation or feeling. Another distinction is that heat expands all bodies and alters their atomic condition, while light, though usually attended by heat, does not display the same expansive force, but produces various effects which are peculiar to itself. Ye are the light of the world. A city that is set on a hill cannot be hid. Matthew 5. 541. Are light and heat combined in the solar array? Yes. A ray of light, as well as containing elementary rays that produce colours under refraction, contains also chemical rays and heat rays. 542. How do we know that light and heat are separate elements? Because we have heat rays, as from dark hot iron, from various chemical actions, and from friction, which are unattended by the development of light. And we have light or luminosity, such as that of phosphorescence, which is unaccompanied by any appreciable degree of heat. But, besides this confirmation, further proof is afforded by the fact that in passing rays of solar light through media that are transparent to heat, but not to light, The heat rays may be separated from the luminous rays, and vice versa. Black glass and black mica, which are nearly opaque to light, are transparent to heat to the extent of 90 degrees out of 100, while pale green glass, coloured by oxide of copper and covered with a coating of water or a thin coating of alum, will be perfectly transparent to light, but will be almost quite opaque to heat. These remarks apply, in a greater or less degree, to various other substances. 543. In what respects are light and heat similar? Both heat and light have been referred to minute vibratory motions which occur under exciting causes in a very subtle elastic medium. They are both united in the sun's rays. They are both subject to laws of absorption, radiation, reflection and refraction. They are both essential to life, whether animal or vegetable. Both may be developed in their greatest intensity by electricity. They are both imponderable. When I consider thy heavens, the work of thy fingers, the moon and the stars, which thou hast ordained. 544. In what respects are light and heat dissimilar? Heat frequently exists without light. Light is usually attended with heat. Light may be instantly extinguished, but heat can only be more gradually reduced by diffusion. The solar rays deliver heat to the earth by day, and the heat remains with the earth when the light has departed. Heat diffuses itself in all directions. Light travels only in straight lines. The colours that absorb and radiate both light and heat do not act in the same degree upon them. Black, which does not radiate light, is a good radiator of heat, etc., etc. The oxyhydrogen light emits a most intense heat, but glass, which will transmit the rays of light, will afford no passage to the rays of the heat. Heat is latent in all bodies, but no satisfactory proof has been found that light is latent in substances. These are only a few of the analogies and distinctions that exist between the two mysterious agents, light and heat, but they are sufficient to supply the starting points of investigation. The importance of the heat that attends the solar rays may be illustrated by the experiments performed a few years ago by Mr. Baker of Fleet Street, London, who made a large burning lens, 3 feet and a half in diameter, and employed another lens to reduce the rays of the first to a focus of half an inch in diameter. The heat produced was so great that iron plates, gold and stones were instantly melted. The sulphur, pitch and resinous bodies were melted under water. 545. What is the point of heat at which bodies become luminous? The point of heat at which the eye begins to discover luminosity has been estimated at 1000 degrees. 546. What is the velocity of artificial light? The light of a fire or of a candle or gas travels with the same velocity as the light of the sun, a velocity which would convey light 8 times around the world, while a person could count 1. 547. At what rate of velocity does the light of the stars travel? At the same velocity as all other light. And yet there are stars so distant that although the light of the sun reaches the earth in 8 minutes and a half, it requires hundreds of years to bring their light to us. What is man that thou art mindful of him, and the Son of Man that thou visitest him? Psalm 8. 548. What is the relative intensity of primary and reflected light? The intensity of a reflection depends on the power of the reflecting surface, but taking the sun and moon as the great examples of primary and reflected light, The intensity of the sun's light is 801,072 times greater than that of the moon. 549. What is polarized light? Polarized light is light which has been subjected to compound refraction, and which, after polarization, exhibits a new series of phenomena differing materially from those that pertain to the primary conditions of light. 550. What are the chief deductions from the phenomena observed under the polarization of light? The polarization of light appears to confirm in a high degree the vibratory theory of light, and to show that the vibrations of light have two planes or directions of motion. The mast of a ship, for instance, has two motions. It progresses vertically as the ship is impelled forward, and it rolls laterally through the motion of the billows. Something like this occurs in the vibration of light, only the vertical vibration is the condition of one ray, and the lateral vibration is the condition of another ray, and the vibrations of these two rays intersect each other in the solar ray. When these vibrations occur together, the ray has certain properties and powers, but by polarization the rays may be separated, and the result is two distinct rays having different vibrations. It then appears that various bodies are transparent to these polarized rays only in certain directions, and this fact is supposed to show that bodies are made up of their atoms arranged in certain planes, through or between which the lateral or the vertical waves of light, together or singly, can or cannot pass, and that the transparency or the opacity of the body is determined by the relation of its atomic planes to the planes of the vibration of light. Ordinary light, passing through transparent media, produces no very remarkable effect on its course, but polarized light appears to illuminate every atom of the permeated substance, and by surrounding it with a prismatic clothing, to afford an illustration of its molecular arrangement. A man that is called Jesus made clay, and appointed mine eyes, and said unto me, Go to the pool of Siloam, and wash. And I went and washed, and I received sight. John 9. 551. Why are two persons able to see each other? Because rays of light flow from their bodies to each other's eyes, and convey an impression of their respective conditions. In some popular works that have come under our notice, we find that the student is told that we cannot absolutely see each other, we only see the rays of light reflected from each other. The statement is erroneous as expressed. We do not see the rays of light, for if we did so, the effect of vision would be destroyed, and all bodies would appear to be in a state of incandescence or phosphorescence. Rays of light, which are in themselves invisible, radiate from the objects we look upon, enter the pupil of the eye, and impress the seat of vision in a manner which conveys to the mind a knowledge of the form, colour, and relative size and position of the figure we look upon. If this is not seeing the object, what is? It would be just as reasonable to say that we cannot hear a person speak, that we only hear the vibrations of the air. But as the vibrations are imparted to the air by the organs of voice of the speaker, as he sets the air in motion and makes the air his messenger to us, we certainly hear him, and can dispense with any logical myths that confound the understanding and contribute to no good result. 552. What is actinism? Actinism is the chemical property of light. Actinism equals ray power. 553. Why does silver tarnish when exposed to light? Because of the actinic, or chemical power of the rays of the sun. 554. Why do some colours fade and others darken when exposed to the sun? Because of the chemical power of the sun's rays. 555. Why can pictures be taken by the sun's rays? Because of the actinic powers that accompany the solar light. 556. What is the particular chemical effect of light exhibited in the production of photographic pictures? Simply, the darkening of preparations of silver by the actinic rays. 557. Why are photographic studios usually glazed with blue glass? Because blue glass obstructs many of the luminous rays, but it is perfectly transparent to actinism. The hay appeareth, and the tender grass showeth itself, and herbs of the mountain are gathered. Proverbs 27. 558. Why do plants become scorched under the unclouded sun? Because the heat rays are in excess. The clouds shut off the scorching light, but, like the blue glass of the photographer's studio, they transmit actinism. 559. What effect has actinism upon vegetation? It quickens the germination of seeds and assists in the formation of the colouring matter of leaves. Seeds and cuttings, which are required to germinate quickly, will do so under the effect of blue glass, which is the equivalent of saying the effect of an increased proportion of actinism in half the time they would otherwise require. 560. In what season of the year is the actinic power of light the greatest? In the spring, when the germination of plants demands its vitalizing aid. In summer, when the maturing process advances, light and heat increase, and actinism relatively declines. In the autumn, when the ripening period arrives, light and actinism give way to a greater ratio of heat. But as it is written, eye hath not seen, nor ear heard, neither have entered into the heart of man, the thing which God hath prepared for them that love him. Corinthians, Book 1, 2. We shall have frequently, in the progress of our lessons, to refer to light in its connection with the chemistry of nature and with organic life. But let us now invite the student to pause and for a moment contemplate the wonders of a sunbeam. How great is its velocity, how vast its power, how varied its parts, yet how ethereal. First, let us contemplate it as a simple beam in which light and heat are associated. How deep the darkness of the night, and how that darkness clings to the recesses of the earth. But the day beams, and darkness flies before it, until every atom that meets the face of day is lit up with radiance. That which before lay buried in the shade of night is itself now a radiator of the luminous fluid. Mark the genial warmth that comes as the sister of light. Then stand by the side of the experimentalist and watch the point on which he directs a shining focus, and in an instant see iron melt and stones run like water under the fervent heat. Now look upward to the heavens, where the falling drops of rain have formed a natural prism in the rainbow, and shown that the beam of pure whiteness, refracted into various rays, glows with all the tints that adorn the garden of nature. These are the visible effects of light. But follow it into the crust of the earth, where it is, by another power, which is neither light nor heat, quickening the seed into life. Watch it as the germ springs up, and the plant puts forth its tender parts, touching them from day to day with deeper dyes, until the floral picture is complete. Follow it unto the sea, where it gives prismatic tints to the anemone, and imparts the richest colours to the various algae. Think of the millions of pictures that it paints daily upon the eyes of living things. Contemplate the people of a vast city, when, attracted by some floating toy in the air, 1,000,000 eyes look up to watch its progress. The sun paints 1,000,000 images of the same object, and each observer has a perfect picture. It makes common to all mankind the beauties of nature, and paints as richly for the peasant as for the king. The Siamese twins were united by a living cord which joined their systems, and gave unity and sympathy to their sensations. In the great flood of light that daily bathes the world, we have a bond of union, giving the like pleasures and inspirations to millions of people at the same instant, and that which floods the world with beauty should no less be a bond of unity and love. End of chapter 26.
Chapter 27 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Joseph Tabler. The Reason Why by Robert Kemp Philp. Chapter 27. 561. What is electricity? Electricity is a property of force which resides in all matter and which constantly seeks to establish an equilibrium. 562. Why is it called electricity? Because it first revealed itself to human observation through a substance called, in the Greek language, electrum. This substance is known to us as amber. 563. In what way did electrum induce attention to this property of force in matter? Thales, a Greek philosopher, observed that by briskly rubbing electrum, it acquired the property of attracting light particles of matter, which moved towards the amber and attached themselves to its surface, evidently under the influence of a force excited in the amber. 564. What is amber? It is a resinous substance, hard, bitter, tasteless, and glossy. It has been variously supposed to be a vegetable gum, a fossil, and an animal product. It is probably formed by a species of ant that inhabit pine forests. The bodies of ants are frequently found in its substance. He made darkness his secret place. His pavilion round about him were dark waters and thick clouds of the skies. 565. Why does the rubbing of a stick of sealing wax cause it to attract small particles of matter? Because it excites in the sealing wax that force which was first observed in the amber. Sealing wax, therefore, is called an electric, amber-like body. 566. Why do we hear of the electric fluid? Simply because the term fluid is the most convenient that can be found to express our ideas when speaking of the phenomena of electric force. But of the nature of electricity, except through its observed effects, nothing is known. 567. What substances are electric? All substances in nature, from the metals to the gases, but they differ very widely in their electrical qualities. 568. What is positive electricity? Electricity, when it exists or is excited in any body to an amount which is in excess of the amount natural to that body, is called positive, called also vitreous. 569. What is negative electricity? Electricity, when it exists or is excited in any body in an amount which is less than is the amount natural to that body, is called negative, called also resinous. 570. Why is positive electricity called also vitreous, and negative electricity called also resinous? Because some philosophers believe that there is but one electricity, but that it is liable to variations of quantity or state, which they distinguish by positive and negative, while other philosophers believe that there are two electricities, which they name vitreous and resinous, because they may be induced respectively from vitreous and resinous substances, and they display forces of attraction and repulsion. 571. Upon what do the electrical phenomena of nature depend? Upon the tendency of electricity to find an equilibrium between its positive and negative states, assuming there to be but one fluid, or upon the tendency of vitreous electricity to seek out and combine with resinous electricity, assuming that there are two fluids. The Lord also thundered in the heavens, and the highest gave his voice, hailstones and coals of fire. 572. How does the equilibrium of electricity become disturbed? By changes in the condition of matter. As electricity resides in all substances, and is perhaps an essential ingredient in their condition, so every change in the state of matter, whether from heat to cold or from cold to heat, from a state of rest to that of motion, from the solid to the liquid or the aeriform condition, or vice versa, or whether substances combine chemically and produce new compounds, in every change the electrical equilibrium is disturbed, and in proportion to the degree of disturbance is the force exerted by electricity to resume its balance in the scale of nature. 573. How does electricity seek to regain equilibrium? By passing through substances that are favorable to its diffusion. Therefore they are called conducting or non-conducting bodies, according as they favor or oppose the transmission of the electrical current. 574. What substances are conductors of electricity? Metals, charcoal, animal fluids, water, vegetable bodies, animal bodies, flame, smoke, vapor, etc. 575. What substances are non-conductors? Rust, oils, phosphorus, lime, chalk, caoutchouc, gutta percha, camphor, marble, porcelain, dry gases and air, feathers, hair, wool, silk, glass, transparent stones, vitrefactions, wax, amber, etc. These bodies are also called insulators. Some of these substances, as chalk, feathers, hair, wool, silk, etc., though non-conductors when dry, become conductors when wetted. Insulating, preventing from escaping. 576. Why are amber and wax classed among the non-conductors when they have been pointed out as electrics and used to illustrate electrical force? It is because they are non-conductors that they have displayed under excitement the attractive force shown in respect to the particles of matter which were drawn towards their substances. If a bar of iron were excited instead of a stick of wax, electricity would be equally developed. But the iron, being a good conductor, would pass the electricity to the hand of the operator as fast as it accumulated, and the equilibrium would be undisturbed. Yea, he sent out arrows and scattered them, and he shot out lightnings and discomfited them. Psalm 18. 577. What is the effect when electricity in considerable force seeks its equilibrium, but meets with insulating bodies? The result is a violent action in which intense heat and light are developed, and in the evolution of which the electric force becomes expended. 578. What is the cause of electric sparks? The electric force passing through a conducting body to find its equilibrium is checked in its course by an insulator and emits a spark. 579. What produces the electric light? Currents of electricity pass towards each other along wires at the ends of which 2 charcoal points are placed. As long as the charcoal points remain in contact, the electric communication is complete and no light is emitted, but when they are drawn apart, intense heat and light are evolved. 580. What is the cause of lightning? Lightning is the result of electrical discharges from the clouds. 581. What develops electricity in the clouds? Evaporations from the surface of the earth, changes of temperature in the atmospheric vapor, chemical action upon the earth's surface, and the friction of volumes of air of different densities against each other. His lightnings enlightened the world. The earth saw and trembled. Psalm 47. 582. Why do these phenomena produce electricity? Because they disturb the equilibrium of the electric force and produce positive and negative states of electricity. 583. When does lightning occur? When clouds charged with the opposite electricities approach, the forces rush to each other and combine in a state of equilibrium. 584. Why does lightning attend this movement of the forces of electricity? Because the atmosphere, being unable to convey the great charges of electricity as they rush towards each other, acts as an insulator, and lightning is caused by the violence of the electricity in forcing its passage. 585. Does lightning ever occur when the conducting power is equal to the force of the electricity? No. Electricity passes invisibly, noiselessly, and harmlessly whenever it finds a sufficient source of conduction. End of chapter 27.
Chapter 28 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 28. 586. Why does lightning sometimes travel through a zigzag course? Because the electricity, being resisted in its progress by the air, flies from side to side to find the readiest passage. 587. Why does lightning sometimes appear forked? Because, being resisted in its progress by the air, the electricity divides into 2 or more points and seeks a passage in different directions. 588. Why is lightning sometimes like a lurid sheet? Because the flash is so distant, and therefore we see only the reflection. He directeth it under the whole heavens, and his lightning unto the ends of the earth. 589. When is the flash of lightning straight? When the distance between the clouds whose electricities are meeting is small. 590. What is the cause of the aurora borealis? The mingling of the electricities of the higher regions of the atmosphere. 591. When does the flash of lightning appear blue? When the degree of electrical excitement is intense and general throughout the atmosphere. 592. Why does lightning sometimes appear red, at others yellow, and at others white? Because of the varying humidity, which affects the refracting power of the atmosphere. 593. Does lightning ever pass upwards from the earth to the clouds? Yes, when the earth is charged with a different electricity to that which is in the clouds. 594. Does lightning ever pass directly from the clouds to earth? Yes, when the electricity of the clouds seeks to combine with the different electricity of the earth. The mingling of the electricities of the earth and the air must be continually going on, but lightning does not attend the phenomena, because all natural bodies, vapors, trees, animals, mountains, houses, rocks, etc., act more or less as conductors between the earth and air. It is only when there is a great disturbance of the electrical forces that terrestrial lightning is developed. When lightning strikes the earth with great force, it sometimes produces what are called fulgurites in sandy soils. These are hollow tubes produced by the melting of the soil. 595. What is the extent of mechanical force of lightning? Lightning has been proved in one instance to have struck a church with a force equal to more than 12,000 horsepower. A single horsepower in mechanical calculations is equivalent to raising a weight of 32,000 pounds 1 foot in a minute. The force of lightning, therefore, has been proved to be equal to the raising of 384 million pounds 1 foot in a minute. This is equal to the united power of 12 of our largest steamers, having collectively 24 engines of 500 horsepower each. The velocity of electricity is so great that it would travel round the world 8 times in a minute. After it a voice roareth. He thundereth with the voice of his excellency, and he will not stay them when his voice is heard. Job 37. The church alluded to was St. George's Church, Leicester, a new edifice which was completely destroyed on the 1st of August, 1846, by a thunderstorm. The steeple was rent asunder, and massive stones were hurled to a distance of 30 feet. The vane rod and top part of the spire fell down perpendicularly and carried with it all the floors of the tower. A similar disaster occurred to St. Bride's Church, Fleet Street, London, about 100 years ago. The lightning first struck upon the metal vane of the steeple, and then ran down the rod and attacked the iron cramps, smashing the large stones that lay between them. The church was nearly destroyed. By the same wonderful force, ships have been disabled, trees split asunder, houses thrown down, and animals struck dead. 596. Why is it dangerous to stand near a tree during an electric storm? Because the tree is a better conductor than air, and electricity would probably strike the tree and then pass to the person standing near. 597. If trees are good conductors, why do they not convey the electricity to the ground? Trees are only indifferent conductors, and the electricity would quit the tree to pass through any better conductor. 598. Why is it dangerous to sit near a fire during an electric storm? Because the chimney, being a tall object, and smoke a good conductor, would probably attract the electricity and convey it to the body of a person sitting near the fire. 599. Why is it dangerous to be near water during an electric storm? Because water is a good conductor, and the vapor arising from it might attract the electricity. Man, being elevated over the water, might form the first point attacked by the electricity. 600. Are iron houses dangerous during an electric storm? No, they are very safe, because their entire surface is a good conductor, and would convey the electricity harmlessly to the earth. To him that rideth upon the heavens of heavens, which were of old, lo, he doth send out his voice, and that a mighty voice. Psalm 68. 601. Why does electricity seize upon bell wires and iron fastenings? Because copper wires are the very best conductors of electricity, and iron articles are also good conductors. 602. Supposing electricity to attack a bell wire, where would the point of danger exist? At the extremities of the wire, where the conducting power of the wire would cease, and the electricity would seek to find another conductor. 603. Are umbrellas with steel frames dangerous in an electric storm? They are dangerous in some degree because they might convey electricity to the hand and then transfer it to the body. But generally speaking, when it rains, the rain itself, being a good conductor, relieves the disturbance of electricity by conveying it to the ground. 604. Are iron bedsteads dangerous in electric storms? No, they are safe, because the iron frame, completely surrounding the body and having a great capacity for conduction, would keep the electricity away from the body. 605. Why is it safe to be in bed during an electric storm? Because feathers, hair, wool, cotton, etc., especially when dry, are good insulators or non-conductors. 606. What is the safest situation to be in during an electric storm? In the center of a room, isolated as far as possible from surrounding objects, sitting on a chair and avoiding handling any of the conducting substances. The windows and doors should be closed to prevent drafts of air. 607. In the open air, what is the safest situation? To keep aloof, as far as possible, from elevated structures, and regard the rain, though it might saturate our clothes, as a protection against the lightning stroke, for wet clothes would supply so good a conductor that a large amount of electricity would pass over man's body through wet garments, and he would be quite unconscious of it. God thundereth marvelously with his voice. Great things doeth he, which we cannot comprehend. Job 36. During a violent electric storm in the Shetland Islands, a fishing boat was attacked by the electric fluid, which tore the mast to shivers. A fisherman was sitting by the side of the mast at the time, but he felt no shock. Upon taking out his watch, however, he found that the electric current had actually fused his watch into a mass. In this case, it is more than probable that the man was saved through the saturation of his clothes with rain. 608. Do lightning conductors attract electricity? Not unless the electric current lies in their vicinity. 609. Why have lightning conductors sometimes been found ineffective? Because they have been unskillfully constructed, have been too small in their dimensions, and have not been properly laid to convey the electricity harmlessly away. 610. What is the best material for a lightning conductor? Copper, the conducting power of which is 5 times greater than that of iron. 611. Why should a large building have several conductors? Because the influence of a conductor over the electricity of the surrounding air does not extend to more than a radius of double the height of the conductor above the building. For instance, a conductor rising 10 feet high above the building would influence the electricity 20 feet all round the conductor. 612. Why should conductors have at their base several branches penetrating the earth? To facilitate the discharge of the accumulated electricity into the earth. 613. Why does electricity affect the shapes of clouds? Because electricity does not penetrate the mass of bodies, but affects generally their surfaces. Hence, electricity exists in the surfaces of clouds, and in its efforts to find an equilibrium, it causes the clouds to roll in heavy masses, having dark outlines. All ye inhabitants of the world, and dwellers on the earth, see ye, when he lifteth up an ensign on the mountains, and when he bloweth the trumpet, hear ye. Isaiah 18. The fact that electricity resides in, and is conducted by, the surfaces of bodies is well established, and should receive due attention in the protective measures adopted to secure life and property against the effects of lightning. A practical suggestion that arises out of this fact is that tubes of copper would form far more efficient conductors than bars of the same metal. A copper tube of half an inch diameter would conduct nearly double the amount of electricity which could be conveyed away by a bar of copper wire of the same diameter. The upper extremity of the tube should be open obliquely, that the electric current might be induced to pass over both the inner and outer surfaces. End of chapter 28. Chapter 29 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 29. 614. What is thunder? Thunder is the noise which succeeds the rush of the electrical fluid through the air. 615. Why does noise follow the commotion caused by electricity? Because, by the violence of the electric force, vast fields of air are divided, great volumes of air are rarefied, and vapors are condensed, and thrown down as rain. Thunder is therefore caused by the vibrations of the air as it collapses and seeks to restore its own equilibrium. 616. Why is the thunder peal sometimes loud and continuous? Because the electrical discharge takes place at a considerable distance, and the vibrations are affected in their course by mountains and valleys. Because also the forked arms of the lightning strike out in different directions, causing the sounds of thunder to reach us from varying distances. Lo, these are parts of his ways, but how little a portion is heard of him, but the thunder of his power, who can understand? Job 25. 618. Why is the thunder peal sometimes a low grumbling noise? Because the electrical discharges, though violent, take place far away, and the vibrations of the air become subdued. 619. Why does the thunder peal sometimes follow immediately after the flash of lightning? Because the discharge of electricity takes place near the hearer. 620. Why does the thunder peal sometimes occur several seconds after the flash? Because the discharge takes place far away, and light travels with a much greater velocity than sound. 621. Through what distance will the sound of thunder travel? Some 20 or 30 miles, according to the direction of the wind and the violence of the peal. 622. Through what distance will the light of lightning travel? The light of lightning and its reflections will penetrate through a distance of from 150 to 200 miles. 623. How may we calculate the distance at which the electrical discharge takes place? Sound travels at a rate of 1/4 of a mile in a second. If, therefore, the peal of thunder is heard 4 seconds after the flash of lightning, the discharge took place about a mile off. The pulse of an adult person beats about once in a second. Therefore, guided by the pulse, any person may calculate the probable distance of the storm. 2 beats, 1/2 mile. 3 beats, 3/4 of a mile. 4 beats, 1 mile. 5 beats, 1 1/4 miles. 6 beats, 1 1/2 miles. 7 beats, 1 3/4 miles. 8 beats, 2 miles, etc. Attention should be paid to the direction and speed of the wind, and some modifications of the calculation be made accordingly. Persons between 20 and 40 years of age should count 5 beats of the pulse to a mile. Under 20, 6 beats. The clouds poured out water, the skies sent out a sound, thine arrows also went abroad. 624. Why are electric storms more frequent in hot than in cold weather? Because of the greater evaporation, as the effect of heat, and also of the effect of heat upon the particles of all bodies. 625. Why do electric storms frequently occur after a duration of dry weather? Because dry air, being a bad conductor, prevents the opposite electricities from finding their equilibrium. 626. Why is a flash of lightning generally succeeded by heavy rain? Because the electrical discharge destroys the vesicles of the vapors. If a number of small soap bubbles floating in the air were suddenly broken by a violent commotion of the atmosphere, the thin films of the bubbles would form drops of water and fall like rain. 627. Why is an electrical discharge usually followed by a gust of wind? Because the equilibrium of the atmosphere is disturbed by the heat and velocity of lightning and the condensation of vapor. Air, therefore, rushes towards those parts where a degree of vacuity or rarefaction has been produced. 628. What is a thunderbolt? The name thunderbolt is applied to an electrical discharge when the lightning appears to be developed with the greatest intensity around a nucleus or center, as though it contained a burning body. But there is, in reality, no such thing as a thunderbolt. The voice of the Lord is upon the waters. The God of glory thundereth. The Lord is upon many waters. Psalm 29. 629. Why do electrical storms purify the air? Because they restore the equilibrium of electricity, which is essential to the salubrity of the atmosphere. They intermix the gases of the atmosphere by agitation. They precipitate the vapors of the atmosphere, and with the precipitation of vapors, noxious exhalations are taken to the earth, where they become absorbed. They also contribute largely to the formation of ozone, which imparts to the air corrective and restorative properties. 630. What is ozone? Ozone is an atmospheric element recently discovered, and respecting which differences of opinion prevail. It is generally supposed to be oxygen in a state of great strength, constituting a variety of form or condition. 631. Why do we know that electricity contributes to the formation of ozone? Because careful observations have established the fact that the proportion of ozone in the atmosphere is relative to the amount of electricity. 632. What are the properties of ozone? It displays an extraordinary power in the neutralization of putrefactions, rapidly and thoroughly counteracting noxious exhalations. It is the most powerful of all disinfectants. Schonbeum, the discoverer of ozone, inclines to the opinion that it is a new chemical element. Whatever it may be, there can be no doubt that it plays an important part in the economy of nature. Its absence has been marked by pestilential ravages, as in the cholera visitations, and to its excess are attributed epidemics, such as influenza. It was found during the last visitation of cholera that the fumigation of houses with sulfur had a remarkable efficacy in preventing the spread of the contagion. The combustion of sulfur ozonized the atmosphere. The same result occurs through the emission of phosphoric vapors. Ozone is also developed by the electricity evolved by the electrical machine, and in the greater electrical phenomena of nature. The smell imparted to the air during an electric storm is identical with that which occurs in the vicinity of an electrical apparatus. It is a fresh and sulphurous odor. The opinion is gaining ground that the respiration of animals and the combustion of matter are sources of ozone, and that plants produce it when under the influence of the direct rays of the sun. It is also believed to be produced by water when the sun's rays fall upon it. The most recent opinion respecting ozone is that it is electrized oxygen. The subject is of vast importance and opens another field of discovery to the pioneers of scientific truth. The voice of thy thunder was in the heaven. The lightnings lightened the world. The earth trembled and shook. Psalm 67. 633. What is magnetism? Magnetism is the electricity of the earth, and is characterized by the circulation of currents of electricity passing through the earth's surface. 634. What are magnetic bodies? Magnetic bodies are those that exhibit phenomena which show that they are under the influence of terrestrial electricity, and which indicate the direction of the poles or extreme points of magnetic force. 635. What is galvanism? Galvanism is the action of electricity upon animal bodies, and is so called from the name of its first discoverer, Galvani. 636. What is voltaic electricity? Voltaic electricity is the electricity that is developed during chemical changes, and is so called after Volta, who enlarged upon the theory of Galvani. 637. What are the differences between mechanical or frictional electricity, voltaic electricity, galvanism, and magnetism? Frictional electricity is electricity suddenly liberated under the effects of the motion or the mechanical disturbance of bodies. Voltaic electricity is a steady flow of an electric current, arising from the gradual changes of chemical phenomena. Galvanism and voltaism are almost identical, since the latter is founded upon, and is a development of, the former, but the term galvanism is frequently used when speaking of the development of electricity in animal bodies. Magnetism is the electricity of the earth, and is understood to imply the fixed electricity of terrestrial bodies. And I heard, as it were, the voice of a great multitude, and as the voice of many waters, and as the voice of mighty thunderings, saying, Alleluia, for the Lord God omnipotent reigneth. Revelations 19. Man knows not what electricity is, yet by an attentive observance of its effects, he avails himself of the power existing in an unknown source, and produces marvelous results. When the Grecian philosopher Thales sat rubbing a piece of amber and watching the attraction of small particles of matter to its surface, he little knew of the mighty power that was then whispering to him its offer to serve mankind. And when Franklin, with the aid of a boy's plaything, drew down an electric current from the clouds, and caught a spark upon the knuckles of his hand, even he little conjectured that the time was so near when that strange element, which sent its messenger to him along the string of a kite, would become one of man's most submissive servants. So many great results have sprung from the careful observation of the simplest phenomena, that we should never pass over inattentively the most trifling thing that offers itself to our examination. Nature, in her revelations, never seeks to startle mankind. The formation of a rock and the elaboration of a truth are alike the work of ages. It was the simple blackening of silver by the sun's rays which led to the discovery of the chemical agency of light. It was the falling of an apple which pointed Newton to the discovery of the laws of gravitation. It was the force of steam, observed as it issued from beneath the lid of a kettle, that led to the invention of the steam engine. And it is said of Jacquard that he invented the loom which so materially aided the commerce of nations while watching the motions of his wife's fingers as she plied her knitting. As great discoveries spring from such small beginnings, who among us may not be the herald of some great truth, the founder of some world-wide benefaction? That the area of discovery has not perceptibly narrowed its limits is evident from the fact that the greatest elements in nature are still mysteries to man. And, though it may not be within the power of a finite being to unravel the chain of wonders that enfolds the works of an infinite God, still it is evident, from the progress which discovery has made, and from the good which discovery has done, that God does invite and encourage the human mind to contemplate the workings of divine power, and to pursue its manifestations in every element and in every direction. The wonderful force of electricity astonishes us all the more when we view it in contrast with that equally wonderful element, light. We have seen that light travels with a velocity of 192,000 miles in a second, but that it falls upon a delicate balance so gently that it produces no perceptible effect. As far as we know the nature of electricity, it is even more ethereal than light. Yet while the ether of light falls harmlessly and imperceptibly, even with the momentum of a flight of 95 millions of miles, the ether of electricity, bursting from a cloud, only 500 yards distant, will split massive stones, level tall towers with the dust, strike majestic trees to the ground, and instantly extinguish the life of man. Why does the one ether come divested of all mechanical force, while that which seems to be even more ethereal than it is capable of exerting the mightiest force over material things? Does it not appear that the Creator of the universe has established these paradoxes of power to testify his omnipotence, to show to man that with him all things are possible, and that, in the grand cosmicism of the universe, every attribute of omnipotence has been fulfilled? And the seventh angel poured out his vial into the air, and there came a great voice out of the temple of heaven, from the throne, saying, "It is done." Revelations 16. Let us now consider man's relation to this omnipotence. He sees that electricity smites the tall edifice, and observes that in doing so it displays a choice of a certain substance through which it passes harmlessly, and that its violence is manifested only when its path is interrupted. Man, taking advantage of this preference of electricity for a particular conductor, stretches out an arm of that substance and points it upwards to the clouds. Electricity accepts the invitation, and passes harmlessly to the earth. But this is not all. Man learns by observation that electricity resides in all nature, that it may be collected or dispersed, that it travels along a good conductor at the rate of 500,000 miles in a second of time. He constructs a battery, a kind of scientific fortress, in which he encamps the great warrior of nature, and then, laying down a conducting wire, he liberates the mighty force. But its flight must be on the path which man has defined, and its journey must cease at the terminus which man has decreed, where, by a simple contrivance of his ingenuity, the movements of a magnetic needle, the electric current is made to deliver whatever message of importance he desires to convey. Thus, the element which in an instant might deprive man of life is subdued by him and made the obedient messenger of his will. End of chapter 29. Chapter 30 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 30. 638. What is the atmosphere? The atmosphere is the transparent and elastic body of mixed gases and vapors which envelopes our globe, and which derives its name from Greek words signifying sphere of vapor. 639. To what height does the atmosphere extend? It is estimated to extend from 40 to 50 miles above the surface of the earth. 640. Why is it supposed that the atmosphere does not extend beyond that height? Because it is found by experiment and observation that the air becomes less dense in proportion to its altitude from the earth's surface. The gradual decrease of atmospheric density observed in ascending a mountain or in a balloon supplies sufficient data to enable us to calculate the height at which the atmosphere would probably altogether cease. At an altitude of 18,000 feet, the air is indicated by the barometer to be only half as dense as at the surface of the earth. And as the densities of the atmosphere decrease in a geometrical progression, the density will be reduced to 1/4 at the height of 36,000 feet and to 1/8 at 54,000 feet. The effects of the decreasing density of the atmosphere are that the intensity of light and sound are diminished, and the temperature is lowered. Persons who have reached a very high elevation state that the sky above them began to assume the appearance of darkness, and there can be no doubt that, if it were possible to reach an altitude of some 50 to 60 miles, there would be perfect blackness, although the sun's rays might be pouring through the darkened space to illuminate the atmosphere. Upon the summit of Mont Blanc, the report of a pistol at a short distance can scarcely be heard. When Gay-Lussac reached the height of 23,000 feet, he breathed with great pain and difficulty, and felt distressing sensations in his ears, as though they were about to burst. Upon the high tablelands of Peru, the lips of Dr. Ischuti cracked and burst, the blood flowed from his eyelids. For he looketh to the ends of the earth, and see under the whole heaven, to make the weight of the winds. Job 28. 641. What is the amount of atmospheric pressure at the earth's surface? The pressure of the atmosphere at the earth's surface is 15 pounds to every square inch of surface. That is to say that the column of air extending 50 miles over a square inch of the earth presses upon that square inch with a weight equal to 15 pounds. 642. Is that the weight of dry or moist air? That is the weight of air at what is called the point of saturation, when it is fully charged with watery vapor. 643. What is the proportion of watery vapor in the atmosphere? The proportion constantly varies. Evaporation is not a result of accident. It seems an established law that the air shall constantly absorb vapor until it has reached the maximum it can hold. Experiments have been tried, in which dry air has been pressed upon the surface of water with great force, but no degree of pressure could prevent the formation of vapor. 644. What is the total amount of atmospheric pressure on the Earth's surface? The total amount of atmospheric pressure on the Earth's surface, at 15 pounds to the square inch amounts to 12 quintillion, 42 quadrillion, 604 trillion, 800 billion pounds. This pressure is equal to that of a globe of lead of 60 miles in diameter. 645. What is the pressure of the atmosphere upon the human body? Estimating the surface of a man's body to be equal to 15 square feet, he sustains an atmospheric pressure of 32,400 pounds, or nearly 14 tons and a half. The mere variation of weight arising out of the changes in the state of the atmosphere may amount to as much as a ton and a half. I therefore so run, not as uncertainly, so I fight, not as one that beateth the air. Corinth 9. 646. Why does not man feel this pressure? Because the diffusion of air, which, surrounding him in every direction, and acting upon the internal as well as the external surfaces of his body, and probably surrounding every atom of his frame, establishes an equilibrium, in which every degree of pressure counteracts and sustains itself. 647. What is the weight of air relative to that of water? A cubic foot of air weighs only 523 grains, a little more than an ounce. A cubic foot of water weighs 1,000 ounces. 648. What is the greatest height in the atmosphere which any human being has ever reached? Monsieur Gay-Lussac, in the year 1804, ascended to the height of 23,000 feet. 649. What is a vacuum? A vacuum is a space devoid of matter. The term is generally applied to those instances in which air is drawn from within an airtight vessel. 650. Is it possible to form a perfect vacuum? It is probably impossible to do so, even with the most powerful instruments. Some portion of air would remain, but in so thin a form that it would be imperceptible. 651. Why does the depression of a pump handle cause the water to flow? Because the putting down of the handle lifts up the piston with its valve closed, thereby tending to produce a vacuum. But the pressure of the air upon the water not contained in the pump forces more water up into the part where a vacuum would otherwise be formed. Then when the handle is raised and the piston forced downwards, the valve opens and the water rushes through. There is a second valve below the piston which closes with the downward movement to prevent the water from rushing back again. The wind bloweth where it listeth, and thou hearest the sound thereof, but canst not tell whence it cometh, and whither it goeth. So is every one that is born of spirit. John 2:3. 652. How high will atmospheric pressure raise water in the bore of a pump? It will raise water to an elevation of 30 feet above its level. 653. Why will it raise water to an elevation of 30 feet? Because a column of water 30 feet high nearly balances the weight of a column of air of equal surface, extending to the whole height of the atmosphere. When, therefore, water is elevated to the height of 30 feet, the power of the pump is enfeebled, as the air and the water balance each other. 654. How is water raised to a greater elevation when it is required? By mechanical contrivances, by which the water is forced to a greater elevation. 655. Why does water run through the bent tube called a siphon? Because the atmospheric pressure upon the water on the outside of the siphon forces it into the tube as fast as the siphon empties itself through its longer arm. 656. Why does water run through the longer arm of the siphon? Because the weight of the water in the longer arm of the siphon is greater than that in the shorter. Therefore it runs out by its own gravity, and, as in running out, it creates a tendency towards a vacuum. The pressure of the outer air comes into operation and forces the water through the tube. 657. Why does water issue from the earth in springs? Some springs are caused by natural siphons formed in the fissures of rocks, which, communicating with bodies of water, are continually filled by atmospheric pressure, and therefore convey streams of water to the point where they are set free. Ascribe ye strength unto God. His excellency is over Israel, and his strength is in the clouds. Psalm 68. 658. Why, if a wineglass is filled with water, and a card laid upon it, and the whole inverted, will the water remain in the glass? Because the pressure of the atmosphere upon the surface of the card counteracts the weight of the water. 659. What has the card to do with the experiment? It forms a base upon which the water may rest, while the glass is being inverted, and it prevents the air from acting upon the fluidity of the water and forcing it out of the glass. 660. Why will not beer run out of the tap of a cask until a spile has been driven in at the top? Because the pressure of the air upon the opening of the tap counteracts the weight of the beer, but when the spile is driven in, the air enters at the top and counteracts its own pressure at the bottom. 661. Why does a cup in a pie become filled with juice? Because the heat expands the air and drives nearly all of it out of the cup. When the pie is taken out of the oven and begins to cool, air cannot get into the cup again because its edges are surrounded by juice. A partial vacuum, therefore, exists within the cup, and the pressure of the external air forces the juice into it. 662. Does the cup prevent the juice from boiling over? No. So long as the heat exists, the cup remains empty, and as it occupies space, the air is driven out of it into the pie. It rather tends to force the juice over the sides of the dish. It is only when cooling that the juice enters the cup. 663. Why can flies walk on the ceiling? Because their feet are so formed that they can form a vacuum under them. Their bodies are therefore sustained in opposition to gravitation by atmospheric pressure. 664. How did Mr. Sands perform the feat of walking across the ceiling? By having large discs of wet leather attached to his feet, so that when they were placed upon a smooth surface, the air was excluded, and when he allowed his weight to act upon one of the discs, it formed a hollow cup and a vacuum. By forming a vacuum of only 12 square inches, he gained a pressure of 180 pounds. This being more than his weight, he could accomplish the feat with no other difficulty than that of remaining in an inverted position. The air was admitted underneath the discs by valves, which were closed by springs, which, being pressed by the heels of the performer, let in the air and set the foot free. And God made a wind to pass over the earth. Genesis 8. 665. Why is it difficult to strike limpets from rocks? Because they have the means of forming a vacuum under their shells, and are pressed on to the rocks by the weight of the atmosphere. 666. Why can snails move over plants in an inverted position? Because they form a vacuum with the smooth and moist surfaces of their bodies and are supported by atmospheric pressure. End of chapter 30.
Chapter 31 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Reason Why by Robert Kemp Philp. Chapter 31. Wind. 666. What is wind? Wind is air in motion. 667. What are the velocities of the winds? A breeze travels at 10 feet in a second. A light gale, 16 feet in a second. A stiff gale, 24 feet in a second. A violent squall, 35 feet in a second. Storm wind, from 43 to 54 in a second. Hurricane of the temperate zone, 60 feet in a second. Hurricane of the torrid zone, 120 to 300 feet in a second. When wind flies at 1 mile an hour, it is scarcely perceptible. When its velocity is 100 miles an hour, it tears up trees and devastates its track. 668. What are trade winds? Trade winds are vast currents of air which sweep round the globe over a belt of some 12,000 miles in width. They shall be as the morning cloud, and as the early dew that passeth away, as the chaff that is driven with the whirlwind out of the floor, and as the smoke out of the chimney. Hosea chapter 13. 669. What is the cause of trade winds? The air over the tropical regions becomes heated and ascends. It then diverges in two high currents, one toward the north and the other towards the South Pole, where, being cooled, it again descends and returns toward the equator to replace the air as it ascends therefrom. There is, therefore, a constant revolution of vast currents of air between the tropics and the poles, producing north and south winds. 670. Why do the trade winds blow from east to west, though in their origin their direction is from north to south and from south to north? Because, as the north and south winds blow towards the equator, they are affected by the revolution of the earth from west to east. As the two winds from the poles approach the equator, they are gradually diverted from their northerly and southerly course into an easterly direction by the revolution of the earth. 671. Why is there a prevalence of calms at the equator? Because, as the north and south winds move towards the equator, they drive before them volumes of atmosphere which, meeting in opposite directions, resist and counterpoise each other and abide in a state of stillness between the north and south easterly winds, one on the north and the other on the south of the equator. 672. What are monsoons? Monsoons are periodical winds which blow at a given period of the year from one quarter of the compass and in another period of the year from the opposite quarter of the compass. 673. What is the cause of monsoons? Monsoons are caused by changes in the position of the sun. When the sun is in the southern hemisphere, it produces northeast wind, and when it is in the northern hemisphere, a northwest wind. The northeast monsoon blows from November to March, and the southwest monsoon from the end of April to the middle of October. The region of monsoons lies a little to the north of the northern border of the trade wind, and they blow with the greatest force and with most regularity between the eastern coast of Africa and Hindustan. He shall blow upon them, and they shall wither, and the whirlwind shall take them away as stubble. Isaiah chapter 40. 674. What determines the character of winds? The character of winds is influenced by the condition of the surfaces over which they blow. Winds blowing over dry and arid plains and deserts are dry and hot. Winds blowing across snow-capped mountains and regions of ice are cold. Winds that cross oceans are wet, and those that cross extensive continents are dry. 675. What winds are most prevalent in England? In England, out of 1,000 days, north winds prevail in 82, northeast 111, east 99, southeast 81, south 111, southwest 225, west 171, northwest 120. 676. What is the cause of storms? Storms result from violent commotions of the atmosphere and are chiefly the result of extreme changes of temperature. The magnetic state of the earth and the electrical state of the atmosphere also materially influence the phenomena of storms. By some persons the theory is entertained that storms result from various winds rushing into a center in which the atmosphere has become extremely condensed. According to this theory, a storm is a mighty whirlwind. A most violent hurricane occurred in 1780, which destroyed Lord Rodney's fleet and a vast number of merchant ships. It is said to have killed 9,000 persons in Martinique alone, and 6,000 in St. Lucia. The town of Saint-Pierre in Martinique was totally destroyed, and only 14 houses in the town of Kingston in St. Vincent were left uninjured. 677. Why do the most violent storms occur in and near the tropics? Because there the temperature is very high and the cold currents of air rushing towards the equator from the poles cause great atmospheric disturbance. 678. What are whirlwinds? Whirlwinds are produced by violent and contrary currents meeting and striking upon each other, producing a circular motion. They generally occur after long calms, attended by much heat. Whirlwinds occurring at sea or over the surface of water sometimes put the water in motion, and as the wind rises upwards, it lifts with it a whirling mass of water, producing a waterspout. Out of the south cometh the whirlwind, and cold out of the north. Job chapter 37. 679. Why does the chimney smoke when the fire is first lighted? Because the air in the chimney is of the same temperature as that of the room, and therefore will not ascend. 680. Why does the smoking into the room cease after the fire has been lighted a little while? Because the air in the chimney, being warmed by the fire beneath, becomes lighter and ascends rapidly. 681. Why does a long chimney create a greater draught than a short one? Because the shorter chimney contains less air than the long one. There is consequently less difference of weight between the warm air of the short chimney and the external air. It therefore has not so great an ascensive power. And, lo, the smoke of the country went up as the smoke of a furnace. Genesis chapter 19. 682. Why does smoke issue in folds and curls? Because it is pressed upon by the cold air which always rushes towards a rarer atmosphere. It thus illustrates the development of storms. 683. Why do some chimneys smoke when the doors and windows are closed? Because the draught of air is not sufficient to supply the wants of the fire and enable it to create an upward current. 684. What is the best method of conveying air to fires? Tubes built in the walls, communicating with the outer air and terminating underneath the grates. 685. Why is this the best method of ventilation? Because doors and windows may then be made airtight, and drafts across rooms be prevented. 686. Why do chimneys that stand under elevated objects, such as hills, trees, and high buildings, smoke? Because the wind, striking against the elevated object, flies back, and part of it rushes downward. 687. Why do sooty chimneys smoke? Because the accumulation of the soot diminishes the size of the flue and lessens the ascensive power of the draft by reducing the quantity of warm air. It also obstructs the motion of the air by the roughness of its surface. 688. Why do chimneys smoke in damp and gusty weather? Because the ascending air is suddenly chilled by gusts of damp and cold air and driven down the chimney. Remember that thou magnify his work, which men behold. Every man may see it, man may behold it afar off. Job chapter 36. 689. Why does smoke ascend in a straight line in mild and fine weather? Because the air is still, and being dry and warm, it does not chill the smoke, nor drive it out of its course. 690. Why do the wings of windmills turn round? because the wind, striking at an angle upon the wings, forces them aside, and as there are 4 wings all upon the same angle and fixed upon the same center, the oblique pressure of the wind causes the center to rotate. There is a world of miniature phenomena which has never been fully recognized, in which we may see the mightier works of nature pleasingly and truthfully illustrated. When the wind blows into the corner of a street, and whirling around catches straw, dust, and feathers in its arms, and then wheels away, flinging the troubled atoms in all direction, it is a miniature of the mightier whirlwind which wrecks ships, uproots trees, and levels houses with the earth. When a cloud of dust, on a hot summer's day, rises and flies along the thirsty road, making the passenger close his eyelids and dusting the leaves of wayside vegetation, it is a miniature of the terrible simoom, which blows from the desert sands, scattering death and devastation in its track. When steam issues from the tea urn and becomes condensed in minute drops upon the window pane, the miniature is of the earth's heat evaporating the waters and the cool air of night condensing the vapors into dew. When grass and corn bend before the wind and are beaten down by its force, when the pond forgets its calm and rises in troubled waves, casting the flotilla of natural boats that move upon its surface in rude disorder upon its windward shore, the little storm is but a miniature of those great hurricanes which wrecked a fleet in the Black Sea and leveled the encampments of a mighty army. When the snow that has gathered upon the housetop, warming beneath the smiles of the sun, slips from its bed and drops in accumulated heaps from the roof, it is a miniature of those terrible avalanches which in the Pyrenees bury villages in their icy pall and doom man and beast to death. When the rivulet hurries on its course and meeting with obstructions, leaps over them in mimic wrath, overturning some little raft upon which, perchance, a weary fly has alighted, it is a miniature of those rapids on whose banks the hippopotamus and the alligator yet live, and where, though rarely, man may be seen directing his raft over the troubled current amid the rush of debris from forests unexplored. And when, in a basin of the rivulet, 2 opposing currents meet and form a little vortex into which insect life and vegetable fragments coming within the sphere of its influence are drawn, it is a miniature of the roaring whirlpool, or the wilder maelstrom of the Norwegian seas. Nature rehearses all her parts in mild whispers, and for every picture that she paints, she places a first study upon the canvas. Man need not go into the heart of her terrors to understand their laws. Many an unknown Humboldt, sitting by the river's side, may rejoice in the aspects of nature and share the bliss of knowledge with the great philosopher. Can any understand the spreadings of the clouds or the noise of his tabernacle? Job chapter 36. End of chapter 31. Chapter 32 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Reason Why by Robert Kemp Philp. Chapter 32. A Barometer. 691. What is a barometer? A barometer is an instrument which indicates the pressure of the atmosphere and which takes its name from 2 Greek words signifying measurer of weight. 692. Why does a barometer indicate the pressure of the atmosphere? Because it consists of a tube containing quicksilver, closed at one end and open at the other, so that the pressure of the air upon the open end balances the weight of the column of mercury, quicksilver, and when the pressure of the air upon the open surface of the mercury increases or decreases, the mercury rises or falls in response thereto. 693. Why is a barometer also called a weather glass? Because changes in the weather are generally preceded by alterations in the atmospheric pressure. But we cannot perceive these changes, as they gradually occur. The atmosphere in the height of the column of mercury, therefore, enables us to know that atmospheric changes are taking place, and, by observation, we are enabled to determine certain rules by which the state of the weather may be foretold, with considerable probability. 694. Why are barometers constructed with circular dials and an index to denote changes? Because that is a convenient mechanical arrangement by which the alterations of the relative pressures of the air and the mercury are more clearly denoted than by an inspection of the mercury itself. Fair weather cometh out of the north, with God is terrible majesty. Job chapter 37. 695. Why does the hand of the weather dial change its position when the column of mercury rises or falls? Because a weight, which floats upon the open surface of the mercury, is attached to a string, having a nearly equal weight at the other extremity. The string is laid over a revolving pivot to which the hand is fixed, and the friction of the string turns the hand as the mercury rises or falls. Thou visitest the earth and waterest it. Thou greatly enrichest it with the river of God, which is full of water. Thou preparest them corn, when thou hast so provided for it. Psalm 65. 696. Why does tapping the face of the barometer sometimes cause the hand to move? Because the weight on the surface of the mercury frequently leans against the sides of the tube and does not move freely. And, also, the mercury clings to the sides of the tube by capillary attraction. Therefore, tapping on the face of the barometer sets the weight free and overcomes the attraction which impedes the rise or fall of the mercury. Figure 21 illustrates the mechanism at the back of the barometer. A is a glass tube. Between A and E there exists a vacuum, caused by the weight of the mercury pressing downwards. This space being a vacuum makes the barometrical column more sensitive, as there is no internal force to resist or modify the effects of the external pressure. E represents the height of the column of mercury, C the open end of the tube, F the weight resting on the surface of the mercury, P the pivot over which the string passes and upon which the hand turns, W the weight which forms the pulley with the weight of F. 697. Which is heavier, dry or vaporized air? Dry air is heavier than air impregnated with vapors. 698. Why is dry air heavier than moist air? Because of the extreme tenuity of water vapors, the density of which is less than that of atmospheric air. 699. Why does the fall of the barometer denote the approach of rain? Because it shows that as the air cannot support the full weight of the column of mercury, the atmosphere must be thin with watery vapors. The fall of the mercury in the long arm of the tube would cause the weight F to be pressed upwards. This would release the string to which the weight W is attached, and would, therefore, fall and turn the hand down to rain or much rain. 700. Why does the rise of the barometer denote the approach of fine weather? Because the external air becoming dense and free from highly elastic vapors presses with increased force upon the mercury upon which the weight F floats. That weight, therefore, sinks in the short tube as the mercury rises in the long one, and in sinking turns the hand to change, fair, etc. He caused an east wind to blow in the heaven, and by his power he brought in the south wind. Psalm 78. 701. Why does the barometer enable us to calculate the height of mountains? Because as the barometer is carried up a mountain, there is a less depth of atmosphere above to press upon the mercury. It therefore falls, and by comparing various observations, it has been found practicable to calculate the height of mountains by the fall of the mercury in a barometer. 702. To what extent of variation is the weight of the atmosphere liable? It may vary as much as 1.5 pounds to the square inch at the level of the sea. 703. When does the barometer stand highest? When there is a duration of frost or when northeasterly winds prevail. 704. Why does the barometer stand highest at these times? Because the atmosphere is exceedingly dry and dense and fully balances the weight of the column of mercury. 705. When does the barometer stand lowest? When a thaw follows a long frost or when southwest winds prevail. 706. Why does the barometer stand lowest at these times? Because much moisture exists in the air by which it is rendered less dense and heavy. 707. What effect has heat upon the barometer? It causes the mercury to fall by evaporating moisture into the air. 708. What effect has cold upon the barometer? It causes the mercury to rise by checking evaporation and increasing the density of the air. For so the Lord said unto me, I will take my rest, and I will consider in my dwelling place like a clear heat upon herbs, and like a cloud of dew in the heat of harvest. Isaiah chapter 18. In noting barometrical indications, more attention should be paid to the tendency of the mercury at the time of the observation than to the actual state of the column, whether it stands high or low. The following rules of barometric reading are given as generally accurate, but liable to exceptions. Fair weather, indicated by the rise of the mercury. Foul weather, by the fall of the mercury. Thunder, indicated by the fall of the mercury in sultry weather. Cold, indicated by the rise of the mercury in spring, autumn, and winter. Heat, by the fall of the mercury in summer and autumn. Frost, indicated by the rise of the mercury in winter. Thaw, by the fall of the mercury during a frost. Continued bad weather, when the fall of the mercury has been gradual through several fine days. Continued fine weather, when the rise of the mercury has been gradual through several foul days. Bad weather of short duration, when it sets in quickly. Fine weather of short duration, when it sets in quickly. Changeable weather, when an extreme change has suddenly set in. Wind, indicated by a rapid rise or fall unattended by a change of temperature. The mercury rising and the air becoming cooler promises fine weather, but the mercury rising and the air becoming warmer, the weather will be changeable. If the top of the column of mercury appears convex or curved upwards, it is an additional proof that the mercury is rising. Expect fine weather. If the top of the column is concave or curved downwards, it is an additional proof that the mercury is falling. Expect bad weather. End of chapter 32. Chapter 33 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Reason Why by Robert Kemp Philp. Chapter 33. The Thermometer. 709. What is the thermometer? The thermometer is an instrument in which mercury is employed to indicate degrees of heat. Its name is derived from two Greek words meaning heat measurer. 710. Why does mercury indicate the degrees of heat? Because it expands readily with heat and contracts with cold, and as it passes freely through small tubes, it is the most convenient medium for indicating changes of temperature. When ye see a cloud rise out of the west, straightway ye say, There cometh a shower, and so it is. And when ye see the south wind blow, ye say, There will be heat, and it cometh to pass. Luke chapter 13. 711. Why are there Reaumur's thermometers and Fahrenheit's thermometers? Because their inventors, after whom they are named, adopted a different system of notation, or thermometrical marks, and as their thermometers have been adopted by various countries and authors, it is now difficult to dispense with either of them. We have combined the two. See Figure 22. The diagram will, as we have no doubt, prove exceedingly useful to scientific readers and experimentalists. There is also another system of notation, adopted by the French, called the centigrade, but it is not much referred to in Great Britain. In the centigrade thermometer, 0 is the freezing point and 100 the boiling point. Fahrenheit's scale is generally preferred. Reaumur's is mostly used in Germany. Of Fahrenheit's scale, 32 is the freezing point, 55 is moderate heat, 76 summer heat in Great Britain, 98 is blood heat, and 212 is the boiling point. Mr. Wedgwood has invented a thermometer for testing high temperatures, each degree of which answers to 130 degrees of Fahrenheit. According to his scale, cast iron melts at 2,786 degrees, fine gold at 2,016 degrees, fine silver 1,873 degrees, brass melts at 1,869 degrees. Red heat is visible by day at 980 degrees. Lead melts at 612 degrees. Bismuth melts at 476 degrees. Tin melts at 412 degrees. And there is a curious fact with regard to the three metals, lead, bismuth, and tin, that if they are mixed in proportions of 5, 8, and 3 parts respectively, the mixture, after previous fusion, will melt at a heat below that of boiling water. 712. What is the difference between the thermometer and the barometer? In the thermometer, the column of mercury is much smaller than in the barometer, and is sealed from the air, while in the barometer the column of mercury is open at one end to atmospheric influence. 713. Why does the mercury in the thermometer, being sealed up, indicate the external temperature? Because the heat passes through the glass, in which the mercury is enclosed, and expanding or contracting the metal within the bulb causes the small column above it to rise or fall. Blessed is the people that know the joyful sound. They shall walk, O Lord, in the light of thy countenance. Psalm 89. 714. When does the thermometer vary most in its indication of natural temperature? It varies more in the winter than in the summer season. 715. Why does it vary more in the winter than in the summer? Because the temperature of our climate differs more from the temperature of the torrid zones in the winter than it does in the summer, and the inequalities of temperature cause frequent changes in the degree of prevailing heat. The same remarks, 714 and 715, apply to the barometer. End of chapter 33.
Chapter 34 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Doodles555. The Reason Why by Robert Kemp Philp. 716. What is sound? Sound is an impression produced upon the air by vibrations of the air. 717. What causes the air to vibrate and produce sound? The atoms of elastic bodies being caused to vibrate by the application of some kind of force, the vibrations of those atoms are imparted to the air, and sound is produced. 718. How do we know that sounds are produced by the vibrations of the air, induced by the vibrations of the atoms of bodies? If we take a tuning fork and hold it to the ear, we hear no sound. If we move it rapidly through the air, or if we blow upon it, it produces no sound. But if we strike it, a sound immediately occurs. The vibration of the fork may be seen and felt by the hand that holds it, and as those vibrations cease, the sound dies away. 719. How do we know that without air there would be no sound? Because if a tuning fork were to be struck in a vacuum, as under the receiver of an air pump, no sound would be heard, although the vibrations of the fork could be distinctly seen. And even without life-giving sound, whether pipe or harp, except they give a distinction in the sounds, how shall it be known what is piped or harped? By Corinth the 14th. 720. How are the vibrations of sonorous bodies imparted to the air? When a bell is struck, the force of the blow gives an instant agitation to all its particles. The air around the bell is driven back by the impulse of the force, and thus a vibration of compression is imparted to the air. But the air returns to the bell by its own natural elasticity, thus producing a vibration of expansion. When it is again struck, and thus successive vibrations of compression and expansion are transmitted through the air. 721. How rapid are these vibrations transmitted through the air? They travel at a rate of rather more than 1/4 mile a second, or 12 miles and 3/4 in a minute. 722. Do all sounds travel at the same rate? All sounds, whether strong or weak, high or low, musical or discordant, travel with the same velocity. Why are bells and glasses stopped from ringing by touching them with the finger? Because the contact of the finger stops the vibration of the atoms of the metal in the glass, which therefore cease to impart vibrations to the air. 724. Why does a cracked bell give discordant sounds? Because the connection between the atoms of the bell being broken, their vibrations are not uniform. Some of the atoms vibrate more intensely than the others, and the vibrations imparted to the air are therefore jarring and discordant. 725. Why, when we see a gun fired at a distance, do we see the flash and smoke before we hear the report? Because light, which enables us to see, travels at a velocity of 192,000 miles in a second, while sound, by which we hear, travels only at the rate of 1/4 mile in a second. My heart maketh a noise in me. I cannot hold my peace, because thou hast heard, O my soul, the sound of the trumpet, the alarm of war. By Jared IV. 726. Why does the tread of soldiers, when marching in long ranks, appear to be irregular? Because the sound proceeds from different distances, reach our ears in varying periods of time. 727. What are the numbers of vibrations in a second that produce the various musical sounds? C or Do, 480 vibrations in a second. B or C, 450 vibrations. A or La, 400 vibrations. G or Sol, 360 vibrations. It is thus seen that the more rapid the vibrations, the higher the note, and vice versa. 728. Why does the length of a wire or string determine the sound that it produces? Because the shorter the string, the more rapid are its vibrations when struck. 729. Why does the tension of a wire or string affect its vibrations? Because when the string or wire is tight, a touch communicates vibrations to all its particles, but when it is loose, the vibrations are imperfectly communicated. 730. Why are some notes low and solemn, and others high and quick? Because the vibrations of musical strings vary from 32 vibrations in a second, which produces a soft and deep bass, to 15,000 vibrations in a second, which produces the sharpest treble note. 731. Why can our voices be heard at a greater distance when we speak through tubes? Because the vibrations are confined to the air within the tube, and are not interfered with by other vibrations or movements in the air. The tube itself is also a very good conductor of sound. And I will cause the noise of thy songs to cease, and the sound of thy harps shall no more be heard. Ezekiel the 26th. 732. Is air a good conductor of sound? Air is a good conductor, but water is a better conductor than air. Wood, metals, the earth, etc. are all also good conductors. 733. Why can we hear sounds at a greater distance on water than on land? For various reasons, because a smoother surface of the water is a good conductor, because there are fewer noises or counter-vibrations to interfere with the transmission of sound, and because there are no elevated objects to impede the progress of the vibrations. 734. Why do seashells give a murmuring noise when held to the ear? Because what may be called expended vibrations always exist in the air where various sounds are occurring. These tremblings of the air are received upon a thin covering of the shell, thus being collected into a focus, are transmitted to the ear. 735. Why can people in the Arctic regions converse when more than a mile apart? Because there, the air being cold and dense is a very good conductor, and the smooth surface of the ice also favors the transmission of sound. 736. Why do savages lay their heads upon the earth to hear the sounds of wild beasts, etc.? Because the earth is a good conductor of sound. For this reason, also persons working underground in mines can hear other digging at considerable distances. 737. Why can church clocks be heard striking much more clearly at some times than at others? Because the density of dry air improves the sound conducting power of the atmosphere. The transmission of sounds is also assisted by the direction of the winds. The morning is come unto thee, O thou that dwellest in the land. The time is come, the day of trouble is near, and not the sounding again of the mountains. Ezekiel the 7th. 738. Why may the scratching of a pin at one extremity of a long pole be heard by applying the ear to the opposite extremity? Because wood is a good conductor of sound, and its atoms are susceptible of considerable vibration. It is therefore chosen in numerous instances for the construction of musical instruments. Deaf persons have been known to derive pleasure from music by placing their hands upon the woodwork of musical instruments while being played upon. 739. Why is the hearing of deaf persons assisted by ear trumpets? Because ear trumpets collect the vibrations of the air into a focus, and make the sounds produced thereby more intense. 740. Why are sounding horns used to improve the hearing of congregations? Because being suspended over and a little behind the speaker, they collect the vibrations of the air and reflect them towards the congregation. 741. What are echoes? Echoes are sounds reflected by the objects in which they strike. 742. Why do some echoes occur immediately after a sound? Because the reflecting surface is very near, therefore the sound returns immediately. 743. Why do some echoes occur a considerable time after a sound? Because they are not at a considerable distance, and the sound takes time to travel to it, and an equal amount of time to return. 744. Why do some echoes change the tone and quality of sound? Because a reflecting surface, having vibratory qualities of its own, mingles its own vibrations with that of a sound. 745. Why are there sometimes several echoes to one sound? Because there are various reflecting surfaces at different distances, each of which returns an echo. And God said, "Let the waters under the heaven be gathered together unto one place, and let the dry land appear." And it was so. Genesis the first. 746. Are sounds reflected only by distant objects? Sounds are doubtless reflected by walls and ceilings around us, but we do not perceive the echoes because they are so near that they occur at the same moment with the sound. In lofty buildings, however, there is frequently a double sound, making the utterance of a speaker indistinct. This arises from the echo following very closely upon the sound. 747. Why, when we are walking under an archway or a tunnel, do our voices appear louder? Because the sound of our voices are immediately reflected, and as a gas reflector increases the intensity of light, so a sound reflector will increase the apparent strength of our voices. There are many places where remarkable echoes occur. On the banks of the Rhine, at Lurley, if the weather be favorable, the report of a rifle or the sound of the trumpet, and will be repeated at different periods with varying degrees of strength, from crag to crag, on opposite sides of the river alternatively. A similar effect is heard in the neighbourhood of some of the lochs in Scotland. There is a place at Woodstock, in Gloucestershire, which is said to echo a sound 50 times. Near Rossneath, a few miles from Glasgow, there is a spot where if a person plays a bar of music upon a bugle, the notes will be repeated by an echo, but a third lower, and after a short pause, another echo is heard, again in a lower tone. Then follows another pause, and a third repetition follows in still lower key. The effect is very enchanting. The whispering galleries of St. Paul's, of the Cathedral Church of Gloucester, and of the Observatory of Paris, owe their curious effects to those laws of the reflection of sound by which echoes are produced. But in these cases the effect is assisted by the elliptical form of the edifice, each person being in the focus of an ellipse. End of chapter 7. Recording by Doodles 555. Chapter 35 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why, by Robert Kemp Philp. 35. Chapter 35. What is water? Chapter 35. 740. What is water? Water is a fluid composed of 2 volumes of hydrogen to 1 of oxygen, or 8 parts by weight of oxygen to 1 of hydrogen. It is nearly colorless and transparent. 749. Why, if a saucer of water be exposed to the air, will it gradually disappear? Because water is highly expansive and rises in thin vapor when in contact with warm and dry air. Behold, there ariseth a little cloud from the sea, of the bigness of man's hand. And it came to pass in the meantime that the heaven was black with clouds and wind, and there was a great rain. 1 Kings 38. 750. Why does steam issue from the spout of a kettle? Because the heat of the fire passes into the water and drives its atoms apart, making those of them that rise quickly to the surface lighter than air, upon which they consequently rise. 751. Why does water become solid when it freezes? Because the latent heat of the water passes away from between its atoms into the air. The atoms, therefore, draw closer together. 752. Why, if the atoms of water draw closer together when freezing, does ice expand and occupy greater space than water? Because, when the atoms of water are congealing, they do not form a compact mass, but arrange themselves in a group of crystal points, which occupy greater space. Water contracts when freezing until it sinks to 40 degrees, and then it expands as ice is formed. 32 degrees is said to be the freezing point, but it should be called the frozen point. 753. Why does water boil? Because heat, entering into the lower portions of the water, expands it, The heated portions are then specifically lighter than those that are cooler. The hot water therefore rises upward and forces the cooler water down. 754. What proportion of the Earth's surface is covered with water? There are about 147 millions of square miles of water to 49.5 millions of square miles of land. 755. What is the amount of water pressure? The pressure of the sea at the depth of 1,100 yards is equal to 15,000 pounds to the square inch. But the land, whither ye go to possess it, is a land of hills and valleys, and drinketh water of the rain of heaven. 756. What element is the most abundant in nature? Oxygen, which forms so large a part of water. Of animal substances, oxygen forms 3/4. Of vegetable substances, it forms 4/4. Of mineral substances, it forms 1/2. It forms 8/9 of the waters and 1/5 of the atmosphere, and aggregating the whole creation from 1/2 to 2/3 consists of oxygen. 757. In what ways does man use oxygen? Man eats, drinks, breathes, burns it in various proportions and combinations. It is estimated that the human race consume in those various ways 1 billion pounds daily, that the lower animals consume double that amount, and that in the varied works of nature, no less than 8 billion pounds of oxygen are used daily. 758. Why does water dissolve various substances? Because the atoms of water are very minute. They therefore permeate the pores or spaces between the atoms of those bodies, and overcoming their attraction for each other, cause them to separate. 759. Why does hot water dissolve substances more readily than cold? Because the heat assists to repel the particles of the substance undergoing solution, and gives the water a freer passage between the atoms. Why is pump water sometimes hard? Because, in passing through the earth, it has become impregnated with mineral matters, usually the sulfate and carbonate of lime. 761. Why is rainwater soft? Because it is derived from vapors which, in ascending to the clouds, could not bear up the mineral waters with them. It therefore became purified and distilled. 762. Why do kettles become encrusted with stony deposits? Because a portion of the water which is driven off in steam leaves the mineral matters behind. They therefore form a crust around the sides of the kettle. It is said that if a child's marble be placed in a kettle, it will attract the earthy particles and prevent the encrusting of the sides of the vessel. He gathereth the water of the seas together as in an heap. He layeth up in the storehouses. Psalm 33. 763. Why is it difficult to wash in hard water? Because the soap unites with the mineral matters in the water, and being neutralized, therefore cannot dissolve the dirt with which we desire to cleanse away. 764. Why is the sea salt? Because salt is a mineral that prevails largely in the earth, and which, being very soluble in water, is taken up by the ocean, lakes, and rivers. Also, even those that are considered fresh hold in solution some degree of saline matters, which they contribute to the ocean. As in the evaporations from the sea, the salt remains in it, while the vapors fall as rain and again wash the earth and carry some of its mineral properties to the ocean. The greater saltness of the sea, as compared with the rivers, is accounted for. By some persons, the opinion is entertained that the sea is gradually getting saltier, ever since the creation of the world. This, they say, arises the evaporation of water free from salt, and the returns of the water to the sea, taking with it salt from the land. 765. What is the estimated amount of salt in the sea? The common amount of salt in the various oceans is estimated at 3,051,342 cubic geographical miles, or about 5 times more than the mass of the mountains of the Alps. 766. What is the depth of the sea? The extreme depth has not probably been ascertained, but Sir James Ross took soundings about 900 miles west of St. Helena, whence he found the sea to be nearly 6 miles in depth. Now, if we take the height of the mountains to be 5 miles, the distance from that extreme rise of the earth to the known depths of the sea will be no less than 11 miles. 767. Why are the waters of some springs impregnated with mineral matters? Because the water passes through beds of soda, lime, magnesia, carbonic acid, oxides of iron, sulfate of iron, etc., etc., and takes up in some slight degree the particles of those minerals according to the proportions in which they abound. Who hath measured the waters in the hollow of his hand, and meted out heaven with the span, and comprehended the dust of the earth in a measure, and weighed the mountains and scales and the hills in a balance? Isaiah. 768. Why does iron rust rapidly when wetted? Because the water contains a large proportion of oxygen, some of which combines with the iron and forms an oxide of iron, which is rust. 769. Why does stagnant water become putrid? Because a large amount of oxygen which it contains accelerates the decomposition of the dead animal and vegetable substances that accumulate in it. 770. Is there danger in drinking water on account of the living animalcules which it contains? No danger arises from the living creatures in water, but putrefactive matters may produce serious diseases. 771. What is the best method of guarding against impurities? By obtaining water from the pure sources, and by filtering it before drinking, by which nearly all extraneous matters would be separated from it. End of chapter 35. Chapter 36 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Doodles555. The Reason Why, by Robert Kemp Philp. 36. 772. What is attraction? Attraction is the tendency of bodies to draw near to each other. It is called attraction, from two Latin words signifying drawing towards. 773. How many kinds of attraction are there? There are 5 principal kinds of attraction. 1. The attraction of gravitation. 2. The attraction of cohesion. 3. The attraction of chemical affinity. 4. The attraction of electricity. 5. And capillary attraction. Behold, the nations are as a drop of a bucket, and are counting as a small dust of the balance. Behold, he taketh up the isles as a very little thing. Isaiah. 774. Why do all bodies heavier than the air fall to the earth? Because they are influenced by the attraction of gravitation, by which all bodies are drawn towards the center of the earth. 775. Why do bodies lighter than the air ascend? Because the air, being a denser body, obeys the law of attraction, and in doing so displaces lighter bodies that interfere with its gravitation. 776. Why do fragments of tea and bubbles floating upon the surface of tea draw towards each other and attach themselves to the sides of the cup? Because they are influenced by the attraction of cohesion. Cohesion, the act of sticking together. 777. Why will a drop of water upon the blade of a knife leave a dark spot? Because the iron of the knife attracts the oxygen of the water by chemical affinity, and the two substances form a thin coating of oxide of iron. Affinity, the attraction between dissimilar particles through which they form new compounds. 778. Why do clouds sometimes move towards each other from opposite directions? And 779. Why do light particles of matter attach themselves to sealing wax, excited by friction? Because they are moved by the attraction of electricity. 780. Why will a towel, the corner of which is dipped in water, become wet far above the water? Because the water is conveyed up through the towel by capillary attraction. The atoms of the water are attracted by the threads of the towel and drawn up into small spaces between the threads. Capillary, resembling a hair, small in diameter. He stretcheth out the north over the empty place, and hangeth the earth upon nothing. Job. 781. Why do small bodies floating upon water move towards larger ones? Because the attractive power of a large body is greater than that of a small one. As each atom of matter has inherent power of attraction, it follows that a large aggregation of particles must attract in proportion to the number of those particles. 782. Why do clouds gather around mountain tops? Because they are attracted by the mountains. 783. Why would a piece of lead tied to a string and let down from a church steeple incline a little from the perpendicular towards the church? Because the masses of stone of which the church is built would attract the lead. 784. How can man weigh the earth? By observing what is called the deflection of small bodies when brought within given distances of larger bodies, the degree of attraction exercised by the large body upon the smaller ones becomes known. This attraction of the large body exercised over the smaller body is an opposing influence, acting against the Earth's attraction of the small body, which is drawn out of its course. It constitutes a natural balance between the influence of the Earth and another body, acting in opposition to it. Founded upon these and some other data, man can weigh the Earth and give a morally certain result. Deflection, the act of turning aside. 785. How can man weigh the planets? The planets exercise a certain influence upon each other, as do two pieces of wood floating upon a basin of water. As the planetary bodies fly through their prescribed orbits, and approach nearer to, or travel further from, each other, they are observed to deviate from that course which they must have pursued, but for the increase or the decrease of some influence of attraction. By making observations at various times, and by comparing a number of results, it is possible to weigh any planetary body, however vast or however distant. Is not God in the height of the heaven, and behold the height of the stars? How high are they? Job the 7th. 786. How can man measure the distances of the planets? By making observations at different seasons of the year when the Earth is in the opposite positions in her orbit, and by recording, by instruments constructed with the greatest nicety, the angle of sight at which the planetary body is viewed, by noticing, also, the various eclipses and estimating how long the first light after an eclipse has ceased reaches the Earth, it is possible to estimate the distances of heavenly bodies, no matter how far in the depths of the universe those orbs may be. 787. What are the opinions founded upon estimates respecting the magnitude of the sun? The diameter of the sun is 770,800 geographical miles, or 112 times greater than the diameter of the Earth. Its volume is 1,407,124 times that of the Earth, and 600 times greater than all of the planets together. Its mass is 359,551 times greater than the Earth, and 738 times greater than that of all the planets. A single spot seen upon its surface has been estimated to extend over 77,000 miles in diameter, and a cluster of spots has been estimated to include an area of 3,780,000 miles. 788. What is the weight of the Earth? The Earth has a circumference of 25,000 miles, and it is estimated to weigh 256,195,670,000 plus 12 zeros tons. 789. What is the specific gravity of a body? It is the weight estimated relatively to the weights of other bodies. 790. What determines the force with which bodies fall to the Earth? Generally speaking, their specific gravity, which is proportionate to the density or compactness of the atoms which they are composed. 791. Why does a feather fall to the earth more gradually than a shilling? Because the specific gravity of the feather and of the shilling is relative to that of the air, the medium through which the feather and the shilling pass. If there is no air, a shilling and a feather dropped at the same time from a height of 40 miles would reach the earth at the same moment. End of chapter 36.
Chapter 37 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 37. Where wast thou when I laid the foundations of the earth? Declare if thou hast understanding. 792. What is repulsion? Repulsion is that property in matter by which it repels or recedes from those bodies for which it has no attraction or affinity. 793. Why does dew form into round drops upon the leaves of plants? Because it repels the air and the substances of the leaves upon which it rests, because also its own particles cohere. 794. Why do drops of water roll over dusty surfaces? because they repel the particles of dust, and also because their own particles have a stronger attraction for each other than for the particles of dust. 795. Why does a needle float when carefully laid upon the surface of water? Because the needle and the water mutually repel each other. 796. Why does water, when dropped upon hot iron, move about in agitated globules? Because the caloric repels the particles of the water. 797. Why does oil float upon the surface of water? Because, besides being specially lighter than water, the particles of the oil and the water mutually repel each other. 798. What is carbonic acid? Carbonic acid is a mixture of carbon and oxygen in the proportion of 3 pounds of carbon to 8 pounds of oxygen. Who hath laid the measures thereof, if thou knowest, or who hath stretched the line upon it? 799. Where does carbonic acid chiefly exist? It exists in various natural bodies in which carbon and oxygen are combined. It is evolved by the decomposition of numerous bodies called carbonates, in which carbon is united with a particular base, such as the carbonate of lime, the carbonate of iron, the carbonate of copper, etc. It is also evolved by the processes of fermentation, by the breathing of animals, the combustion of fuel, and the function of plants. Carbonic acid also exists in various waters. Carbonic acid is found most largely in solid combinations with other bodies. It forms 44/100ths of all limestones and marbles, and it exists in smaller quantity combined with other earths and with metallic oxides. 800. What are the states in which pure carbonic acid exists? Pure carbonic acid may exist in the solid, the liquid, or the aeriform state. In the solid state it is produced only by artificial means, and it is then a white crystallized body in appearance like snow. In the liquid state it is a heavy, colorless fluid. In the aeriform state it is pungent, heavy, colorless gas, and is known as carbonic acid gas. 801. Why does bottled porter produce large volumes of froth, much more than the bottle could contain? Because by the fermentive process, carbonic acid has been developed in the porter, and is held in liquid solution, but it always has a strong tendency to escape, and directly the pressure is removed, it evolves into gas, by which it occupies much greater space and forces the porter in millions of small bubbles out of the bottle. 802. Why does soda water effervesce? Because carbonic acid gas is forced into the water by pressure. Pressure alters the gas into a liquid, and directly the pressure ceases, the liquid again evolves into gas. 803. Why does spring water taste fresh and invigorating? Because it contains carbonic acid. Whereupon are the foundations thereof fastened? Or who laid the cornerstone thereof? Job 38. 804. Why does boiled water taste flat and insipid? Because the carbonic acid has been driven off by boiling. 805. Why does beer which has been standing in a glass taste flat? Because its carbonic acid has escaped as carbonic acid gas. 806. Why, when we look into a glass of champagne, do we see bubbles spontaneously appear at the bottom and then rise to the top? Because, in the places where the bubbles are formed, the liquid carbonic acid is evolving into carbonic acid gas. 807. Why do the bubbles arise from 2 or 3 points in columns rapidly succeeding each other? Because when the formation of gas once begins and bubbles ascend, there is less pressure in the line of the column of bubbles. The carbonic acid, therefore, draws toward those points as the easiest channel of escape. These explanations equally apply to the working of beer, by which yeast is produced, to the effervescence of various waters, acidulated drinks, ginger beer, etc., and also to the sponging of bread, etc. 808. Why does gunpowder explode? Gunpowder is made of a very intimate mechanical mixture of nitrate of potash, charcoal, and sulfur. When these substances are heated to a certain degree, the nitrate of potash is decomposed, and its oxygen combines with the charcoal and sulfur, instantaneously forming large volumes of carbonic acid gas and nitrogen, which, seeking an escape, produce an explosion. Thus saith the Lord, Let not the wise man glory in his wisdom, neither let the mighty man glory in his might. Let not the rich man glory in his riches. Jeremiah 9. 809. Why does charcoal act as a powerful disinfectant? Because the carbon readily absorbs and combines with various gases, neutralizing their offensive odors and destroying their unhealthy properties. Let us now pause for a few moments to consider the importance of those two great divisions of nature, air and water, and to reflect upon the wisdom of some of those laws which are connected with the phenomena thereof, and which have not yet been sufficiently explained. We have seen that the air is a thin, elastic body surrounding the globe, that it consists of certain gases essential to the life of animals, and to the growth of plants, and that it takes part in most of those chemical changes which mark the transformations of the inorganic creation. Whether it be the burning of a piece of wood, the evaporation of a drop of water, the breathing of an animal, the respiration of a plant, or the fermentation of bodies, the air, in almost every instance, gives or receives, and in most of the operations in which it engages, it does both. But there is one point of view which we must add to those which have already been considered. The order of nature consists of generation, life, and death. Every beat of the watch signals the birth of millions of living things, and the same beat proclaims that as many living organisms have yielded up their vital spark, and that forthwith the elements of which they are composed must be dissolved, and restored to the great laboratory of nature. The air is the vast receptacle of those organic matters which are undergoing dissolution. The body of the shipwrecked mariner, cast upon the shore of a desolate island, blackens in the sun, and the full round form gradually dwindles to skin and bone, until at last the few atoms that remain crumble into dust and are scattered to the wind. The same process occurs, with some modifications, whether bodies are buried in the earth or dissolve upon its surface. The leaves of forests fall and accumulate in heaps, where they ferment and dissolve, leaving only their more earthy particles behind. The amount of matter which day by day passes from the state of the living to that of the dead must be enormous, but from the difficulties of acquiring data beyond the possibility of calculation. Such statistics as we have, however, enable us to form conclusions as to the mighty agencies in which the air is constantly engaged. There are on the earth 1 billion inhabitants, of whom nearly 35 million die every year, 91,824 every day, 3,730 every hour, and 60 every minute. But even the living die daily, and undergo an invisible change of substance, as we shall hereafter explain. The bodies of those many millions are dissolved in the air, in vapors and gases which, before the dissolution of each corporeal organism is complete, begin to live again in the various forms of vegetable and animal life. Of the number of animals living and dying upon the face of the earth, we can form no adequate estimate. Of mammals there are about 2,000 a certain species, of birds 8,000 species, of reptiles 2,000 species, of fishes some 8 or 10,000 species, of mollusks some 15,000 species, of shellfish 8,000 species, of insects 70,000 species, and including others not specified here, the total number of species of animals probably amounts to no less than 250,000, each species consisting of many millions of living creatures. In the area of London alone, no less than 200,000 tons of fuel are annually cast into the air in the form of smoke. And if we take into account the vast operations of nature in evaporation, fermentation, and putrefactive decomposition, we may be enabled to form a conception of the mighty part which that thin air, of which we think so little, plays in the grand alchemy of nature. I will praise thee, for I am fearfully and wonderfully made. Marvelous are thy works, and that my soul knoweth right well. Psalm 139. In addition also to the facts already communicated respecting the sound-bearing and light-refracting properties of air, it must be remarked that but for the atmosphere, and the general refraction of light by its particles, each atom as it were catching a fairy taper and dancing with it before our view, the condition of vision would be widely opposite to that which exists, and totally unsuited to our wants. The various objects upon which the illuminating rays of the sun fell would be lighted up with an intense glare, but all around would be darkness, just as when a single ray of light is passed into a dark chamber and directed upon a solitary object. The air, without becoming itself visible, diffuses luminous rays, in modified intensity, in every direction. If the air reflected so much light as to render itself visible, it would appear like the glittering surface of the water reflecting the solar rays, and we should then be unable to see the various objects which surround us. Of the importance of water in the scheme of creation, man generally entertains an imperfect conception. It is simply supposed to afford moisture to plants, drink to animals, and to promote salubrity by its cleansing properties. Let us, however, contemplate man as he stands before us, noble in form, erect in position, full of strength, joy, ambition. How much of that noble form is composed of water? Suppose that it could all be instantaneously withdrawn, not the oxygen and the hydrogen, which might combine to form water, but the fluid that exists in his body as water, unchanged, except by mechanical admixture with the secretions of the body. Why then that beautiful temple would collapse and become a mere shred, so thin that it would seem but a shadow of the body as it existed before, and the beholder might doubt whether life ever inhabited a frame whose structure was so frail. It is said that 3/4 by weight of the human body consist of water. Thus, if a man weigh 120 pounds, 90 pounds consist of water, and this subtracted, only 30 pounds of solid matter remain. This statement is rather under than over the fact. The assertion is startling, but so true that it can be verified by simple experiment. A piece of lean flesh, say of beef, cut an inch thick and placed in a slow oven and allowed to remain until all of its water was driven off in vapor, would become as thin as a wafer and as light as a cork. With a more scientific arrangement, it would be possible to collect the water, and the weights of the condensed vapor and of the solid residue would together make up the weight of the beef. If the piece weighed 16 ounces, the weight of the water would be about 14 ounces, and the solid matter about 2 ounces. Water holds a similar proportion in the bodies of all animals and of vegetables. It is evident, therefore, that it occupies a more important place in the scale of creation than is generally accorded to it by the unobservant mind. We are indebted to it for those atmospheric changes which constitute the peculiar feature of our varying climate. Rising in invisible vapors, it builds palaces of glory in the skies, and often presents to the view of man the imagery of heaven. Persons who have ascended above the altitude of the clouds have described the scene upon looking down towards them as the most celestial that the mind can conceive. Fields of fleecy radiance, majestically rolling like a sea of gold, occupied the whole range of vision, and seemed to embellish an eternity of space. Those golden clouds that at one time are decked in the richest splendor and occupy the upper chambers of the court of nature, become grave counselors when the earth grows thirsty and the plant droops with languor. They roll in their heavy brows together as in consultation upon some grave necessity. Down come the refreshing showers, the mighty tongue of thunder rocks the air, the earth is drenched, and becomes fresh with the salubrity of her toilette. Obnoxious substances, with their offensive exhalations, are swept away. Living things rejoice, and beautiful flowers throw their incense in thanksgiving into the air. The broad blue heavens for a time look down and smile upon the blessed work, and then the clouds again gather in a golden train, and one by one fill the high arches of the atmosphere, until the earth once more grows thirsty, and the flower supplicates for drink. How mighty are his wonders! His kingdom is an everlasting kingdom, and his dominion is from generation to generation. Daniel 4. With reference to light, its wonders, and the curious but imperfect theories respecting it, we have little to add, except with regard to its physiological action upon the eyes of man and of animals, which will be given in another place, but of its sister, darkness, for it would not do to call darkness the antagonist of light, since it will be seen that they work harmoniously for good. We have to say that recent discoveries indicate that darkness is as necessary to the health of nature as light. Not only is it necessary to compose man and animals to sleep, to give rest to the overwrought nerves of the industrious, but light is the quickening power of vegetation, and although plants grow by night, they grow as man does when stretched upon his bed, but some of their functions, which are actively excited in the presence of light, are at rest in darkness. Nor is this all. There is not an atom upon the face of the earth which is not affected by the rays of the sun, their light, their heat, their actinism. Colors change, some are bleached, others are darkened. All bodies are expanded. The hardest rock sustains an effect from the sun's rays, and an unceasing sun shining upon the hardest granite, would in time produce such a disturbance of its atomic condition that adamant would crumble away to dust. The going down of the sun, therefore, marks the period when not only does the birds fly to her resting place, and man turn to his couch, but when every atom of a vast hemisphere subsides into a state of quietude, and when homogeneous particles of matter return to their mutual rest. In a few succeeding lessons, we intend to point out some of the scientific truths that are illustrated in the use of toys. We think we shall be able to show to our young readers that even the hours of play may be made the periods of delightful instruction, and that there is no reason why the acquirement of knowledge should not sweetly accord with the occasional pursuit of those pastimes by which health of body and vigor of mind are induced. But before we commence the discharge of that pleasant duty, let us say a few words respecting carbon, that important agent in the world's history. It is doubtless perplexing to the minds of many persons to understand how the diamond can be pure carbon, how charcoal can be carbon a little less pure than the diamond, and how coal and sugar can also be carbon, less pure than the charcoal. The statement that in the diamond carbon exists in a different atomic condition is almost as instructive to the inquiring mind as to say, it is so because it is. Diamonds are expensive things, and so difficult to experiment upon, even if they were not expensive, that the doors of inquiry seem locked. To turn diamonds into charcoal or into carbonic acid gas is a very costly formula of experiment. Charcoal fires, thus sustained, would soon burn a man out of his house, and soda water, impregnated with carbonic acid gas, produced from diamonds, would be a very expensive beverage. If we could only turn charcoal into diamonds, and carbonic acid gas into brilliance, that would be quite another affair. A new El Dorado would be discovered, and there would be so many experimenters that, when they all succeeded, they would find the diamonds had lost their value. However, as a fact for the encouragement of those who would like to be early in the race, we may state that the atoms of charcoal which are repulsed from the charcoal points during the electric agitation which produces the electric light, acquire a hardness and a sharpness almost equal to that of the diamond, only there is still the awkward obstacle in the way, that they happen to be black. He delivereth and rescueth, and he worketh signs and wonders in heaven and in earth. Daniel 7. We must see, therefore, whether there is anything in nature that we can experiment upon, theoretically or practically, to give us a clear conception of this difficult matter. There is a large dewdrop resting upon a luxurious cabbage leaf, one of those great leaves that have flourished in defiance of the snail, and now spreads out like the gigantic frond of the Victoria Regina. That dewdrop is one of the beautiful diamonds which nature sprinkles about on cloudless nights, as if to show the stars, in answer to their twinkling, that we have something that will glisten and twinkle too. The dewdrop is a very good imitation of a diamond, and to the lover of God's works, quite as precious as the stone set in gold. It does not consist of carbon. It probably may have a mite of carbonic acid in its embrace, but that is not necessary to our purpose. All we want to know is the different atomic conditions of which bodies are susceptible, and the very dissimilar appearances they exhibit under the variations of atomic states. It doesn't glisten so much as the diamond because it is round. If we could cut it into a number of facets, it would refract light almost as perfectly as the diamond. It is not solid, but we can freeze it, and we shall at once exhibit two different atomic conditions that will represent nearly enough the diamond and the liquid carbonic acid. Then, if we evaporate the dewdrop, we shall produce a volume of vapor nearly 2,000 times as large as the dewdrop. The steam will be white, but we have only to imagine it black, and then we get an analogy of the differences of the atomic conditions that prevail in the diamond, carbonic acid, and charcoal, tinder, lampblack, or any light form of carbon. Of course, we have been illustrating atomic conditions only, and not chemical composition. There are a few other facts connected with carbon that merit consideration. Carbonic acid gas, entering the lungs, is a deadly poison, but entering the stomach, which lies close under the lungs and is overlapped by them, it is a refreshing beverage. Although charcoal, when burnt, gives off the most poisonous gas, it seems to be very jealous of other gaseous poisons, for if it be powdered and set about in pans where there is a poisonous atmosphere, it will seize hold of poisonous gases, and, by absorbing, imprison them. Even in a drop of toast and water, the charred bread seizes hold of whatever impurities exist in the water, and water passed through the beds of charcoal becomes filtered and made beautifully pure, being compelled to give up to the charcoal whatever is obnoxious. If a piece of meat that has already commenced putrefying be sprinkled with charcoal, it will not only object to the meat putrefying any further, but it will sweeten that which has already undergone putrefaction. Although in the form of gas, it will poison the blood and cause speedy stupefaction and death. If it be powdered and stitched into a piece of silk and worn before the mouth as a respirator, it will say to all poisonous gases that come to the mouth with the air, "I have taken this post to defend the lungs, and I arrest you on a charge of murderous intention." Such are the various facts connected with carbon, and they forcibly indicate that those who understand nature's works are likely to receive her best protection. The father of the righteous shall greatly rejoice, and he that begetteth a wise child shall have joy of him. Proverbs 23. End of chapter 37.
Chapter 38 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jamila. The Reason Why by Robert Kemp Philp. Chapter 38. 810. Why does a humming top make a humming noise? Because the hollow wood of the top vibrates, and the edges of the hole in its sides strike against the air as it spins. The air is thereby set in vibration. 811. Why does a peg top hum less than a humming top? Because, being a solid body of wood, and having no hole in its sides, its particles are not so easily thrown into vibration. Consequently, it does not so readily impart vibrations to the air. 812. Why does a peg top sometimes hum, and at other times not? Because, if it is spun with great force, and its peg is struck sharply against the pavement, the wood is set in vibration, and the surface of the top, repelling the air by its rapid motion, causes vibratory waves. But if it is spun with insufficient force, the wood is not set in vibration. 813. Why do we see the figures painted upon the humming top before it spins, but not while it is spinning? Because the rapid whirling of the top brings the images of its different parts so quickly in succession upon the retina of the eye that they deface each other and impart an impression of colored rings instead of definite objects. Train up a child in the way he should go, and when he is old he will not depart from it. Proverbs 22. 814. Why does the top stand erect when it spins, but fall when it stops? Because the top is under the influence of and is balanced between opposing forces. The rapid rotation of the top gives to all its particles a tendency to fly from the center. If the atoms of the wood were not held together by the attraction of cohesion, they would fly away in a circle outward from the top, just as drops of water fly off from a mop while it is being twirled. If you take a spoonful of sand, salt or dust, and drop it upon the top, it will be scattered in a circle, just as the atoms of the top would be if they were free to separate. But not with the same force, because the atoms of the salt, not being in an active state of rotation, would only be influenced by momentary contact with the rotating body. This tendency of the particles of a rotating body to fly outward from the center is called the centrifugal force. Centrifugal, from the two Latin words meaning receding from the center. The other force influencing the top is the attraction of gravitation, the attraction which, were the top not spinning, would draw it towards the earth. The spill, projecting from the bottom of the top, stands in the line in which the top is drawn towards the earth, and keeps it from obeying the law of gravitation. Therefore, the rotary motion given to the top by the rapid unwinding of the string and the tendency of its atoms to fly outward balance the top upon the line in which it is drawn to the earth, and which is occupied by the spill, which prevents it falling to the ground. 815. Why does the top first reel upon the spill, then become upright, and sleep, and then reel again and fall? Because in being thrown from the hand, the top is delivered a little out of the perpendicular, but the spill is rounded off at the point, and when the top is rotating rapidly, the gravitative force, which attracts the top of the ground continually acting upon it, draws the weight of the top onto the extreme center of the round point. When the rotation subsides and the centrifugal force is weakened, then the top is no longer balanced upon the extreme point of the spill, but falls upon its sides until the force of gravitation is exerted beyond the line of the spill upon the body of the top and then falls to the ground. Even a child is known by his doings, whether his work be pure and whether it be right. Proverbs 20. 816. Why does the top sleep? Because at that period of its spinning, which is called sleeping, the centrifugal and gravitative forces acting upon the top are nearly balanced, and the top, obeying chiefly the rotary force, appears to be in a state of comparative rest. 817. Why does the top cease to spin? Because the friction of the air against its sides and the friction of the spill against the ground act in opposition to the rotatory force, which is a temporary impulse applied by external means, the hand of the person who spins it, and as soon as the applied force is expended, the top yields to the law of gravitation, which is a permanent and ever-prevailing force. 818. Why does a marble revolve as it is propelled along the ground? Because in propelling the marble, the thumb impels the upper surface forward, and the finger draws the under surface backward. This gives a tendency to the upper and lower hemispheres of the marble to separate, which they would do, but for the cohesion of the atoms of the marble. The upper part of the marble therefore rolls forward, drawing after it the under part, which acquires a forward motion by the force with which it is drawn upward, and in this way the opposite portions of the marble act upon each other in successive revolutions. When the marble strikes upon the earth, a new influence is exerted upon it, which is the friction of the earth upon the surface that comes in contact with it. But the upper part of the marble, being free, overcomes the friction acting upon the lower part, and thus the marble continues to progress until the applied force which projected it is expended. Better is a poor and wise child than an old, foolish king who will no more be admonished. Ecclesiastes 4. 819. Why does a striped marble appear to have a greater number of stripes when rolling than when at rest? Because the stripes are presented in rapid succession to the eye, and as the eye receives fresh impressions of stripes before the previous impressions have passed away, the stripes appear multiplied. 820. Why does the marble rebound when dropped upon the pavement? Because the force of its fall to the earth compresses the atoms of which the marble is composed, and the atoms then exert the force of elasticity to restore themselves to their former condition. And by the exercise of this force the marble is repelled or thrown upward from the pavement. Although a marble may be made of very hard stone, yet that stone may be elastic and possess, though in a much less degree, the same kind of elasticity which causes the India rubber ball to rebound from the earth. 821. Why does a marble, assuming it to be impelled with equal force, roll further on ice than on pavement, and further on pavement than on a pebble walk? Because the friction is greater upon pavement than upon ice, and greater upon a pebble walk than upon pavement. 822. How many forces contribute to stay the progress of a rolling marble? The friction of the air, the friction of the earth, and the attraction of gravitation, which tends to bring all bodies to the state of rest. He shall turn the head of the fathers toward the children, and the heart of the children to their fathers. Malachi 4. 823. Why do the stripes upon a marble disappear when it is spun with great velocity? Because, as in the case of the humming top, the different parts of the surface are brought so rapidly in succession to the sight that they deface or confuse the impressions upon the retina. 824. Why are rings most perceptible at the opposite points or poles of the marble? Because the point or pole upon which the marble spins, and that which corresponds to it, on the upper surface, travels less rapidly than the central portions, which, being on a larger circumference, pass through a greater amount of space in the same period of time. The stripes at the poles of the marble are therefore visible, while those at the equator are imperceptible. End of chapter 38. Recording by Jamila. Chapter 39 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jamila. The Reason Why by Robert Kemp Philp. Chapter 39. 825. Why are soap bubbles round? Because they are equally pressed upon all parts of their surface by the atmosphere. 826. Why are bubbles elongated when being blown? Because the unequal pressure of the current of breath by which they are being filled alters the relative pressure upon the outer surfaces. 827. Why does the bubble close and become a perfect sphere when shaken from the pipe? Because the attraction of cohesion draws the particles of soap together directly the bubble is set free from the bowl. Children's children are the crown of old men, and the glory of children are their fathers. Proverbs 17. 828. Why do bubbles blown in the sunshine change their colors? Because the films of the bubbles constantly change in thickness through the atoms from the upper part, descending towards the bottom, and therefore the varying thicknesses of film refracts in different degrees the rays of light. 829. Why do bubbles burst? Because the atoms that compose their films fall towards the earth by gravitation. The upper portion of the bubbles then becomes very thin, and as the denser air of the atmosphere presses towards the warm breath within the bubble, it bursts the film. 830. Why do balloons ascend in air? Because the air or gas which they contain is specifically lighter than the atmosphere. The atmosphere, therefore, forces itself underneath the balloon by its own tendency towards the earth, and the balloon is thereby raised upwards. A balloon is but a larger kind of bubble made of stronger materials. 831. Why does an air balloon become inflated when the spirit set upon the sponge is lit? Because the heat of the flame and the burning of the spirit create a volume of rarefied or thin air, which inflates the balloon and makes it specifically lighter than the surrounding medium. A wise son heareth his father's instruction. Proverbs 13. 832. Why do balloons sometimes burst when they ascend very high? Because as they get into the thinner air which exists at high altitudes, the gas within them expands, and the coating of the balloon is burst asunder. 833. Why does the gas of balloons expand in thin air? Because the air exerts a less amount of pressure upon the air or gas contained in the balloons. 834. Why do parachutes fall very gradually to the ground? Because the air coming in contact with the undersurface of the expanded head of the parachute resists its downward progress. 835. Why does a shuttlecock travel slowly through the air? Because the air acts upon the feathers of the shuttlecock in the same manner as it does upon the parachute. It strikes against their expanded surface and resists their progress through the air. 836. Why does the shuttlecock spin in the air? Because the surfaces of the feathers fall upon the air obliquely or slantingly, and therefore, as the shuttlecock descends, it turns in the air. Come ye children, hearken unto me, I will teach you the fear of the Lord. Psalms 35. 837. Why do we hear a noise when we strike the shuttlecock with the battledore? Because the percussion of the shuttlecock upon the parchment of the battledore causes it to vibrate, and the vibrations are imparted into the air. 838. Why is the sound a dull and short one? Because the vibrations of the parchment are not very rapid, and therefore there is little intensity in the vibrations of the air. 839. Why does the exercise afforded by playing battledore and shuttlecock make us feel warm? Because it makes us breathe more freely and causes the blood to flow faster. We therefore inhale more oxygen, which produces heat by combining with the carbon of our blood. 840. Why does a kite rise in the air? A kite rises in the air by the force of the wind, which strikes obliquely upon its undersurface. The string is attached to the belly band in such a manner that it is nearer the top than the bottom of the band. This causes the bottom of the kite, when its surface is met by the wind, to recede in the direction of the wind. The top is accordingly thrown forward, and the kite is made to lie obliquely upon the current of the air moving against it. The kite then being drawn upon the string in one direction, and pressed by the air in another direction, moves in a line, which describes a medium between the two forces acting upon it. Be ye therefore followers of God as dear children, and walk in love, as Christ also hath loved us. Ephesians 5. 841. Why does the kite string feel hot when running through the hand? because the rapid friction sets free the latent heat of the string, attracts the heat of the hand to the spot where the friction occurs, and sets free the latent heat of the air, which follows the string through the hand and is compressed by the friction. 842. Why does running with a kite cause it to rise higher? Because it increases the force with which the wind strikes upon the surface of the kite. If a person were to run with a kite at the rate of 5 miles an hour through a still air, the effect would be equal to a wind flying at the rate of 5 miles an hour against a kite held by a stationary string. 843. Why does the flying top rise in the air? Because its wings meet the air obliquely, just as the surface of the kite does, and the twirling of the top, causing the oblique surfaces of its wings to strike the air, produces the equivalent effect of a wind from the earth blowing the top upwards. Children, obey your parents in the Lord, for this is right. 844. Why does the flying top return to the earth when its rotations are expended? Because the reaction produced by its wings striking upon the air is insufficient to counteract the attraction of gravitation. End of chapter 39. Recording by Jamila.
Chapter 40 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 40. 846. Why does a mouse painted upon one side of a card and a trap upon the other represent to the eye a mouse in a trap when the card is rapidly twirled upon a string? Because the image of the mouse is brought to the retina of the eye before the image of the trap has passed away. The two impressions, therefore, unite upon the retina and produce the image of a mouse in a trap. Honor thy father and thy mother, that it may be well with thee, and thou mayest be long on the earth. Ephesians 6. 847. Why will a bow stretched out of its natural position propel an arrow through the air? Because its substance, being highly elastic, the particles thereof seek to restore themselves to their former state, as soon as the resisting power is withdrawn. The force derived from this elasticity is communicated to the arrow by the string against which it is placed. 848. Why is the arrow propelled forward? Because the elasticity of the bow, acting equally upon its two ends, to which the string is fastened, produce a line of force in a diagonal direction. It thus illustrates the law that when a body is acted upon by two forces at the same time, whose directions are inclined to each other, it will not follow either of them, but will describe a line between the two. 849. What forces tend to arrest the flight of the arrow? The friction of the air and the attraction of gravitation. My son, give, I pray thee, glory to the Lord God of Israel, and make confession unto him. Joshua 7. 850. Why are feathers usually fastened to the ends of arrows? Because the greater friction of air acting upon them opposes the progress of that part of the arrow in a greater degree than it does the other portion. The effect is to keep the point of the arrow forward, and in a straight line with its opposite extremity. If the arrow were shot the reverse way from the bow, it would turn round in the course of its flight in consequence of the friction of the air, offering greater resistance to its progress of the feathered end. 851. Why does a Jew's harp give musical sounds? Because the vibrations of the metal tongue are communicated to the ear. 852. Why will not the Jew's harp produce loud sounds unless it is applied to the mouth? Because the vibrations are not very intense, but when it is blown upon by the breath, the air is pressed upon it, and the vibrations are thereby rendered more powerful. 853. Why does the alteration of the arrangement of the mouth affect the formation of the sounds? Because it sends the air to the tongue of the harp in a greater or lesser degree of compression. Hear, ye children, the instruction of a father, and attend to no understanding. Proverbs 4. 854. Why does the pressure applied to the handle of an air pistol propel the cork? Because between the cork A and the airtight piston C, there is a closed chamber of air B. When the handle D, which moves the piston C, is rapidly pushed in, it compresses the air until it is so much condensed that it forces out the cork A. 855. Why must the handle be drawn out before the cork is placed in? Because otherwise a partial vacuum would be formed between A and C, and there would be not sufficient air to force out the cork by the return of the piston CD. 856. Why does water rise in a syringe when the handle is drawn out? Because the pressure of the air on the water outside of the syringe forces it into the space vacated by the drawing up of the handle, and where otherwise a vacuum would be formed. 857. Why does not the water run out when the syringe is raised? Because the pressure of the air upon the small orifice resists the weight of the water. 858. Why does the water leak out, but not run? Because water has a tendency always to move to the lowest point, but as the air does not enter freely, the water cannot escape. It therefore drops as small portions of the air enter. Remember now thy Creator in the days of thy youth. Ecclesiastes 11. 859. Why cannot the handle be pressed in if the finger is applied to the orifice? Because water is not compressible like air. It must therefore escape before the handle can be pressed in. Air may be forced into a much smaller compass than is natural to it, but it is impossible to compress water in any great degree. 860. Why does the sucker raise a stone? Because underneath the sucker a vacuum is formed, and the external air, pressing on all sides against the vacuum, lifts the stone. The term sucker is founded upon the mistaken notion that the leather sucks or draws the stone. That such is not the case is evident. If, when the stone is suspended, a pin's point be passed under the leather, so as to open a small passage for the air, the stone will drop instantly. 861. Why does a hoop roll without falling to the ground? Because the centrifugal force gives it a motion which is called the tangent to a circle, that is, a tendency in all of its parts to fly off in a straight line. When a piece of clay adhering to the hoop flies off, it leaves the hoop in a line which is straight with the part of the surface from which it was propelled. This line is the tangent to the circle of the hoop, and the tendency of all the parts of the hoop to fly off in this manner counteracts the attraction of the earth, so long as the hoop is kept in motion. Children, obey your parents in all things, for this is well-pleasing unto the Lord. Colossians 3. 862. Why does the hoop, in falling, make several side revolutions? Because its onward movement, not being quite expended, influences the center of gravity of the hoop, and changes its line of direction. The hoop is also elastic, and when its sides strike the earth, they spring up again, and continue turning until the opposing forces are overcome by the attraction of gravitation. 863. Why will a little boy balance a large boy on a seesaw? Because the seesaw may be placed so that its ends are at unequal distances from the center. This gives the little boy the power of leverage, by which is meant the increase of power or weight by mechanical means. 864. Why does the little boy sink to the ground when the larger boy slightly kicks the earth? Because the larger boy, by kicking against the earth, opposes by mechanical force the attraction of gravitation acting upon him, and he becomes temporarily less attracted to the earth than the little boy. Little children, let no man deceive you. He that doeth righteousness is righteous, even as he is righteous. 1 John 3. 865. Why can the little boy, if he choose, keep the big boy up when once he is up? Because, as the big boy is then on an inclined plane with the fulcrum, or center upon which the seesaw moves, the arm of the lever, upon which the big boy sits, is relatively shortened, and he has then less mechanical power. Also, a portion of the weight of the larger boy is transmitted along the lever to the arm upon which the little boy sits. 866. Why is the ball propelled upward in the game of trap and ball when the trigger is struck? Because when the trigger is struck at A, it is forced downwards, turning upon the fulcrum B, the opposite end, forming the spoon. It is thereby forced upwards, describing a small arc or curved line, but directly the ball is set free from the spoon, it rises in a straight line with the direction it was taking at the moment it was set free. 867. What principles of natural philosophy are illustrated by the results of bat and ball? Percussion, when the bat strikes the ball; rotary motion, when the ball is sent whirling away; momentum, which it acquires by velocity; elasticity, when it rebounds from an object against which it strikes; reflected motion, when it is turned by a body upon which it impinges; friction, as it rolls along the ground; the communication of force, when it sets another body in motion against which it strikes; gravitation, when it falls to the earth; and inertia, when it lies in a state of rest. A wise son makes a glad father, but a foolish son is the heaviness of his mother. Proverbs 10. 868. Why do pith tumblers always pitch upon one end? Because the lead, B, is specifically heavier than the pith to which it is attached. It therefore always falls undermost, and as the lead is rounded off, just like the spill of a top, after the head has oscillated a little and expended the force of the momentum of its fall, it will settle upon its center of gravity, or the point through which it is attracted to the earth. 869. Why do the figures upon the thaumatrope appear to dance when they are made to revolve before a mirror? Because the eye, in looking through the holes in the card towards the reflections in the mirror, receives a rapid succession of impressions. As the figures upon the card are represented in a graduated series of positions, the first one standing upright, the second with his knees a little bent, the third a little more bent, as in the act of springing, and so on, the figure being in each case the same, but the position slightly altered, imparts an impression to the mind through the eye that one figure is passing through a series of motions. Thaumatrope, from two Greek words meaning wonder and to turn. We have said enough, we hope, to show that even the play hours of children may be made instructive to them, and that the simplest toys may be used to illustrate some of the grandest laws of nature. Nor may this kind of instruction be confined to children alone. Grown-up people, whether participators in the sports of youth or simple observers of their games, may gain instruction for themselves and be the better teachers of their children by taking an interest in their enjoyments and giving to their minds, through the attractiveness of pastime, a taste for observing and estimating the varied phenomena which present themselves. Moreover, we think that parental government acquires a greater power when it leans toward the natural desires of childhood, and wins those desires into a proper direction. Love existing between parent and child is the best tie to home, and the strongest incentive to duty. There is also something in the gentleness of childish nature which may influence for good the sterner mold of man, too often warped and clouded by the cares of life. Jesus said, "Suffer the little children, and forbid them not to come unto me, for of such is the kingdom of heaven." Matthew 19. In Kay's Life of Sir John Malcolm, we find an admirable and apt passage. Sir John says, "I have been employed these last few hours with John Eliot and other boys in trying how long we could keep up 2 cricket balls. Lord Minton caught us. He says he must send me on a commission to some very young monarch, for I shall never have the gravity of an ambassador for a prince turned of 12. He, however, added the well-known and admirable story of Henry IV of France, who, when caught on all fours carrying one of his children by the Spanish envoy, looked up and said, 'Is your excellency married?' 'I am, and have a family,' was the reply. 'Well then,' said the monarch, 'I am satisfied, and shall take another turn round the room,' and off he galloped, with his son on his back, flogging and spurring him. I have sometimes thought of breaking myself of what are termed boyish habits, but reflection has satisfied me that it would be very foolish, and that I should esteem it a blessing that I can find amusement in everything, from tossing a cricket ball to negotiating a treaty with the Emperor of China. Men who will give themselves entirely to business, and despise, which is the term, trifles, are very able in their general conception of the great outlines of a plan, but they feel a want of knowledge, which is only to be gained by mixing with all classes in the world, when they come to those lesser points upon which its successful execution may depend. Whether therefore ye eat or drink, or whatsoever ye do, do all to the glory of God. Corinthians 10. End of chapter 40.
Chapter 41 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Ashton Ruby. The Reason Why by Robert Kemp Philp. Chapter 41. 869. Why do we eat food? Because the atoms of which our bodies are composed are continually changing. Those atoms that have fulfilled the purpose of nature are removed from the system, and, therefore, new matter must be introduced to supply their place. 870. Why do we eat animal and vegetable food? Because their substances are composed of oxygen, hydrogen, carbon, and nitrogen, the 4 chemical elements of which the human system is formed. They are, therefore, capable of nourishing the body after undergoing digestion. 871. Why do we masticate our food? Because mastication is the first process towards the digestion of food. Before animal or vegetable substances can nourish us, their condition must be entirely changed, their organic states must be dissolved, and they must become simple matter, in a homogeneous mass, consisting of the 4 chemical elements necessary to nutrition, and they must again be restored to an organic condition. 872. Why does saliva enter the mouth when we are eating? Because, in addition to the mechanical grinding of the food by the action of the teeth, it is necessary that it should undergo certain chemical modifications to adapt it to our use. There are placed, therefore, in various parts of the body, glands which secrete peculiar fluids that have a chemical influence upon the food. The first of these glands are the salivary glands of the mouth, which pour out a clear, watery fluid upon the food we eat, and which fluid has been found to possess a property which contributes to the digestion of food. The moisture afforded by the salivary secretion is also necessary to enable us to swallow the food. And the Lord said unto him, Who hath made man's mouth? Or who hath made the dumb, the seeing, or the blind? Have not I the Lord? Exodus 4. 873. Why does the salivary juice enter the mouth just at the moment that we are eating? Because the glands which are buried in the muscles of the mouth, and which in their form are much like bunches of currants, are always full of salivary secretion. There are nerves which are distributed from the brain to these glands, and when other nerves which belong to the sense of taste, of sight, or of feeling are excited by the presence of food, a stimulus is imparted to the salivary glands through the nerves that surround them. Their cells collapse, and the juice which they contain is poured out through their stems, or ducts, into the mouth. 874. How do we know that impressions imparted to one set of nerves may be imparted to another set, so as to put any particular organ in action? Because very frequently the mere sight of rich fruit or acid substances will cause the saliva to flow freely. In this case, it is evident that the salivary glands could not see or know that such substances were present. An impression must, therefore, be made upon the brain through the organ of vision, and the desire of taste to the substances being awakened, a nervous stimulus is imparted to the glands of the mouth, and they at once commence their action, as if food were present. 875. Why does food descend into the stomach? Because, after the teeth, the tongue, and the muscles of the mouth generally have rolled the food into a soft bolus, it is conveyed to the back of the mouth, where it is set upon the opening of the throat, esophagus. It does not then descend through the throat by its own gravity, because the throat is generally in a compressed or collapsed state, like an empty tube, and we know that persons can eat or drink when their heads downwards. The esophagus is formed like a number of muscular threads or rings, and each little thread is like a hand ready to grasp at the morsel that is coming. As soon as the bulbus is presented at the top of the throat, these little muscular hands lay hold of it and transmit it downward, passing it from one to another, until it is conveyed through the long passage to the door of the stomach which it enters. Remove far from me poverty and lies. Give me neither poverty nor riches. Feed me with food convenient for me. Proverbs 30. 876. Why do we not feel the food being transmitted through the throat? Because the nerves of the body differ in their powers. Some are nerves of feeling, some of motion, and others are nerves of the senses. The nerves of feeling are most abundantly distributed to those parts which feeling is most useful and necessary to us. But the faculty of feeling our food undergoing digestion would be no service to us whatsoever. Therefore, the nerves of motion are plentifully distributed to the throat and stomach, but very few of the nerves of feeling, just as many as will tell us when we eat anything too hot or too cold, or that the stomach is out of order. 877. Why do we feel uneasy after eating in excess? Because the stomach is distended, and presses upon the other organs by which it is surrounded. Who satisfieth thy mouth with good things, so that thy youth is renewed like the eagles. Psalm 103. 878. Why do we feel drowsy after eating heartily? Because while the stomach is in action, a great proportion of the blood of the body is drawn towards it, and as the blood is withdrawn from other parts of the body, they fall into a state of languor. 879. Why does blood flow more freely to the stomach during digestion? Because the energy of an organ is increased by the flow of blood, which supplies the material of which our organs are composed, and in which the vital essence supporting life resides. 880. Why does excess of eating bring on indigestion? Because the power of the stomach to digest food is governed by the amount of food required by the system. It seems to be an instinct of the stomach to hold back food which is in excess, and by indications of pain or disturbance to warn its master that excess has been committed. 881. Why is food digested in the stomach? Because it enters the stomach in the form of a paste, produced by the action of the mouth, and directly food enters. The gastric juice, which is formed by glands embedded in the coats of the stomach, trickles down its sides. This is a more powerful solvent than the salivary juice. It is like the same kind of fluid, only much stronger, and it soon turns the food from a rough and crude paste into a grayish cream, chyme. The heat of the stomach assists the operation, and the muscular threads of the coats move the cream along, in the same manner that the muscles of the esophagus brought down the food. The cream is passed towards the door which leads outward from the stomach, pylorus. But if, in the midst of the cream, there are any undissolved particles of food, it closes upon them, and they return again to the stomach to be further changed. When thou hast eaten and art full, then thou shalt bless the Lord thy God for the good land which he hath given thee. Deuteronomy 8. 882. Why does indigestion bring on bilious attacks? Because the liver secretes a fluid to assist in the digestion of food. The liver is a gland, a similar organ to the glands of the mouth, and it forms bile in the same manner that they form the salivary juice. Only the liver is a much larger gland, and a much greater quantity of blood passes through it. The liver pours its secretion into the biliary ducts, to mix with the gray cream as it passes onward, and to further dissolve it. But when the stomach is excited by food which it cannot dissolve, and when the owner of the stomach disregards its remonstrances, will persist in overeating, or in things that disagree with the system, then the liver and the stomach sympathize, and the muscular threads or hands that prevail all through the alimentary organs, instead of moving onward, move backward, and throw some bile into the stomach to assist to dissolve and remove the excess or improper food. End of chapter 41.
Chapter 42 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 42. 883. Why does some portion of the food we eat nourish the system, while other portions are useless? Because most food contains some particles that are indigestible, or that, if digested, are innutritious and not necessary for the system. The liver is the organ by whose secretion the useful is separated from the useless, for when the bile enters through the duct and mixes with the gray cream coming from the stomach, it remains no longer a gray cream, but turns into a mass colored by bile, having upon its surface little globules of milk, small but very white. Those minute globules of milk, chyle, are the nutritious particles derived from the food. The other portion, colored with bile, is the useless residue, or rather the bulk from which the nutrition has been extracted. God hath made of one blood all nations of men for to dwell on all the face of the earth. Acts 17. 884. Why does the milky or nutritious matter separate from the innutritious upon admixture with bile? Because the bile contains an oily matter which repels the watery milk of nutrition. The pancreatic juice also enters through the same duct with the bile, but its precise use is not understood. It is a fluid much like the salivary secretion of the glands of the mouth. But now hath God set the members in the body, every one as it pleased him. 1 Corinthians 12. 885. How is the nutrition taken away from the bilious residue? The muscular threads, or hands as we figuratively call them, continue to push forward the digested matter through a long tube called the alimentary canal, or bowels. This canal is some 30 feet in length, and is folded in various layers across the abdomen and tied to the edge of a sort of apron, which is gathered up and fastened to the backbone. All along this alimentary canal, those muscular hands are pushing the digested mass along. But upon the coat or surface of the canal there are millions of little vessels called lacteals, which look out for the minute globules of milk as they pass, and absorb them, which means they pick them up and carry them away. There is an immense number of these little vessels, all busily at work picking up food for the system. Then there is a large vessel called the thoracic duct, which comes down and communicates with those little vessels. It is a sort of overseer, having a large number of workmen, and collects the produce of their toil, and carries it upwards to the part where it passes from the organs of digestion into the vessels of circulation. 886. What becomes of the nutrition when it has entered the vessels of the circulation? It is sent through a large vein to the heart, entering that organ on the right side, from which the heart propels it into the lungs, mixed with venous blood, and the venous or blue blood is sent into the lungs, taking with it the milk, the formation of which we have traced. 887. Why are the venous blood and the chyle sent to the lungs? Because the venous blood, in its circulation through the body, has parted with its oxygen and taken up carbon, and it requires to get rid of the carbon and take up more oxygen. The chyle also, now combined with the blood, requires oxygen, and having obtained it, is converted into bright red blood, and the blue blood of the veins, having got rid of its carbon, which formed the carbonic acid of the breath, has again become bright red blood. We must, therefore, in pursuing our description, cease to speak of blue or venous blood and of white milk or chyle, for the two have now combined, and, with the oxygen of the air, have formed arterial blood. My flesh and my heart fainteth, but God is the strength of my heart, and my portion forever. Psalm 48. 888. What becomes of the arterial blood thus formed? It is sent back from the lungs to the right side of the heart, from which it is sent into the great trunk of the aorta, and from thence it passes into smaller blood vessels, until it finds its way to every part of the system. 889. Why does the chest expand when we breathe? Because the lungs consist of millions of hollow tubes and cells, which, having been emptied by throwing off carbonic acid gas and nitrogen, become compressed, and the atmospheric air flowing into these millions of spaces and filling the lungs, just as water fills and swells a sponge, causes them to expand and occupy greater room. All the while my breath is in me, and the Spirit of God is in my nostrils. My lips shall not speak wickedness, nor my tongue utter deceit. Job 27. 890. How does the blood communicate with the air in the lungs? Through the sides of very minute vessels, of which perhaps a fine hair gives us the best conception. But these vessels are twisted and wound round each other in such a curious manner that they form millions of cells, and by being twisted and wound, a much greater surface of air and blood are brought to act upon each other than could otherwise be accomplished. 891. Why does the blood which is thus formed impart vitality to the parts to which it is sent? because the blood is itself vitalized, is, in fact, alive, and capable of diffusing life and vitality to the organization of which it forms a part. This is a very wonderful fact, but no less true than wonderful, that dead matter which, but a little while ago, was being ground by the teeth, softened by the saliva, and solved by the gastric juice and bile, has now acquired life. Nobody can tell the precise stage or moment when it began to live, but somewhere between the stomach and the lungs, melted by the gastric juice, softened by the secretion of the pancreas, separated by the bile of the liver, macerated by the muscular fibers of the bowels, taken up by the absorbents, warmed by the heat of the body, and aerated in the lungs, it has by one, or by all of these processes combined, been changed from the dead to the living state, and now forms part of the vital fluid of the system. End of chapter 42.
Chapter 43 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle Eaton. The Reason Why by Robert Kemp Philp. Chapter 43. 892. Why do we know that the blood has become endowed with vital powers? Because in the course of its formation, it has not only undergone change of condition and colour, but if examined now by the microscope, it will be found to consist of millions of minute cells or discs, which float in a watery fluid. The paste produced by mastication consisted of a crude admixture of the atoms of food. The cream, chyme, formed from this in the stomach, presents to the microscope a heterogeneous mass of matter, exhibiting no appearance whatever of a new organic arrangement. The milk, chyle, which is formed in the intestines, is found to contain a great number of very small molecules, which probably consist of some fatty matter. As the chyle progresses towards the thoracic duct, it appears to contain more of these, and slight indications present themselves of the approach towards a new organic condition. But wherever vitalization begins, no human power can say with confidence. Yet there can be no doubt that the blood is both organized and vitalized, and that it consists of corpuscles, or little cells, enclosing matters essential to life. But they that wait upon the Lord shall renew their strength. They shall mount up with wings as eagles. They shall run and not be weary, and they shall walk and not faint. Isaiah 40. 893. Why does the blood circulate? Because all the bones, muscles, blood vessels, nerves, glands, cartilages, etc., of which the body is composed, are constantly undergoing a change of substance. It is a condition of their life, health, and strength that they shall be renewed, and the blood is the great source of the materials by which the living temple is kept in repair. 894. How is the body renewed by the blood? Every drop of blood is made up of a large number of corpuscles, each of which contains some of the elements essential to the wants of the system. Let us, to simplify the subject, consider the blood vessels of the body to be so many canals, on the banks of which a number of inhabitants live and require constant sustenance. The corpuscles of the blood are the boats which are laden with that sustenance, and when the heart beats, it is a signal for them to start on their journey. Away they go through the arch of the great aorta, and some of the earliest branches which it sends off convey blood to the arms. We will now for a moment dismiss the word artery, and keep up the figure of a system of canals, with a number of towns upon their banks. Though hand join in hand, the wicked shall not be unpunished, but the seed of the righteous shall be delivered. Proverbs 21. Well, away go a fleet of boats through the aorta canal, until they reach a point which approaches Shoulder Town. Some of the boats pass into the Axillary Canal, and Shoulder Town is supplied. The other boats proceed along the Humeral Canal until they approach Elbow Town, when another division of the boats pass into other branch canals and supply the wants of the neighbourhood. The others have passed into the ulnar canals and the radial canals until they have approached Wrist Town and Hand Town, which are respectively supplied. And then the two canals have formed a junction across the Palm and supplied Palm Town, where they have given off branches and boats to supply the Four Finger Towns and Thumb Town. 895. How does the blood return to the lungs after it has reached the extremities? The veins constitute a system of vessels corresponding to the arteries. We may say that the arteries form the down canal and the veins the up canal. The arteries, commencing in the great trunk of the aorta, branch off into large and then into smaller tubes, until they form capillary or hair-like vessels, penetrating everywhere. As for man, his days are as grass. As a flower of the field, so he flourisheth. Psalm 103. The capillary extremities of the arteries unite with the capillary extremities of the veins, and the blood passes from the one set of vessels into the other. As the arteries become smaller from the point where they receive the blood, so the veins grow larger. The venous capillaries pour their contents into small vessels, and these again into larger ones, until the great venous trunks are reached, and the blood is passed again into the heart, as at first described. 896. Why do we see blue marks upon our arms and hands? Because large veins lie underneath the skin, through which the blood of the fingers and hand is conveyed back to the heart. 897. Why are the veins more perceptible than the arteries? Because the arteries are buried deeper in the flesh for protection. It would be more dangerous to life to sever by accident an artery than a vein. A person might bleed longer from a vein than from an artery, without endangering life, because the arteries supply the life-sustaining blood. The Almighty, therefore, has buried the arteries for safety. 898. Why, when we prick the flesh with a needle, does it bleed? Because the capillary arteries and veins are so small, and are so thickly distributed all over the body, that not even the point of a needle can enter the flesh without penetrating the coats of several of these small vessels. Let everything that hath breath praise the Lord. Praise ye the Lord. Psalm 150. 899. What occurs during the circulation of the blood? Not only do the various parts to which the boats are sent take from them whatever they require, but the boats collect all those matters for which those parts have no further use. The bones, the nerves, the muscles, etc., all renew themselves as the boats pass along, and all give something to the boats to bring back. One of the chief exchanges is that of oxygen for carbon, by which a gentle heat is diffused throughout the system. It is for this purpose that fresh air is so constantly necessary. But other exchanges take place. The blood, in addition to oxygen and carbon, contains hydrogen and nitrogen, but it contains its four elements in various forms of combination, producing the following materials for the use of the body. Of 1,000 parts of blood, about 779 are water, 141 are red globules, 69 are albumin, 3 are fibrin, 2 are fatty matter, 6 are various salts. Albumin and fibrin are a kind of flesh imperfectly formed, and probably more chiefly used in repairing the muscles. The red corpuscles contain the oxygen which goes to combine with the superabundant carbon and develop heat. The fatty matters probably repair the fatty tissues, and glands that are of a fatty nature, and the various salts contribute to the bones, and to the chemical properties of those secretions which are formed by the glands, etc. while the great proportion of water is employed in cleansing, softening, and cooling the whole or the living edifice, and it is the medium through which all the nutrition of the body is distributed. 900. Why do we feel the pulse beat? Because every time that the heart contracts, it sends a fresh supply of blood to the blood vessels, and the motion thus imparted creates a general pulsation throughout the system. But it is more distinctly perceived at the pulse, because there a rather large artery lies near to the surface. Thy hands have made me and fashioned me. Give me understanding, that I may learn thy commandments. Psalm 119. 901. What becomes of the matter collected by the blood in the course of its circulation? We have already explained that carbon is thrown off from the lungs in the form of carbonic acid gas, but there are many other matters to be separated from the venous blood, and its purification is assisted by the action of the liver, which is supplied with a large vein, called the portal vein, which conveys into the substance of the liver a large proportion of the venous blood, from which that organ draws off those matters which form the bile, and other matters which are transmitted with the bile to the bowels. The liver and lungs, therefore, are the great purifiers of the venous blood, but there are also smaller organs that assist in the same work. End of chapter 43.
Chapter 44 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 44. 902. Why when we cut our flesh does it heal? Because the blood coagulates over the cut and throws out a kind of lymph, which forms an incipient flesh and excludes the air while the blood vessels are engaged in repairing the part. And God said, Let us make man in our own image, after our likeness, and let them have dominion over the fish of the sea, and over the fowl of the air, and over the cattle, and over all the earth, and over every creeping thing. Genesis 1. 903. Why, since all the substance of the body undergoes change, do we preserve the same features throughout our lives? Because our substance changes in the minutest atoms, and each separate atom has a life of itself, the maintenance of which preserves the unity and permanence of the whole. 904. Why do moles upon the skin continue permanent, while bruises and wounds disappear? Because moles are themselves organized formations, and repair themselves just as any other part of the body does, but bruises and wounds are the result of accidental disturbances, which in course of time become removed. 905. Why do the marks of deep cuts sometimes remain? If the cut is so deep and serious as to destroy the system of vessels which supply and repair the part, then it is evident that they cannot work so perfectly as when in their sound condition. Their functions are, therefore, interfered with, and instead of having flesh uniform with the other parts of the system, there results a scar, or a wound imperfectly repaired. 906. Why, when we hold our hands against a candlelight, do we perceive a beautiful crimson color? Because the fluids and vessels of the body are in some degree transparent, and the thin textures of the sides of the fingers allows the light to pass, and shows the beautiful crimson color of the blood. If the web of a frog's foot be brought into the field of a good microscope, and set against a strong light, the blood may be seen in circulation, with the most wonderful effect. Each vessel and every globule of blood can be seen most distinctly, and the junction of the arteries and veins can be clearly traced. The little boats of nutrition may be seen chasing each other in rapid succession, and when the animal exerts itself to escape, the flow of the blood increases, and not unfrequently under these circumstances of agitation have we seen 2 or 3 blood discs struggling together to enter a vessel that was too small for them. Again and again they have endeavored to find a passage, until one of them, happening to slip forward, got away, followed by the others. Know ye that the Lord he is God. It is he that hath made us, and not we ourselves. We are his people, and the sheep of his pasture. Psalm 100. 907. Why does the flesh underneath the nails look red? Because the transparent texture of the nails enables us to see the color of the vascular structure that lies underneath the skin. Vascular, full of vessels, in this instance full of capillary blood vessels. 908. Why have we nails at our fingers' ends? Because they give firmness to the touch and enable us to apply the extremities of the fingers to many useful purposes for which they would otherwise be unfitted. They enable us to press the tips of the fingers, where the highest degree of sensitiveness prevails, so as to bring the largest amount of nervous perception into the sense of touch. 909. Why do white spots occur upon the nails? Because the vascular surface underneath is attached to the horny texture of the nail, but by knocks and other causes, the nail sometimes separates in small patches from the membrane below, and becomes dry and opaque. 910. Why is there a circular line of whitish color at the root of the nail? Because there the nail is newly formed by the vascular substance out of which it grows, and has not yet assumed its proper horny and transparent nature. 911. Why is the eyeball white? Because the blood vessels that supply its surface are so very fine that they do not admit the red corpuscles of the blood. 912. Why does the eyeball sometimes become bloodshot? Because, under exciting causes of inflammation, the blood vessels become distended, and the red corpuscles enter, producing a network of red blood vessels across the white surface of the eye. 913. Why are the lips red? Because the lips are formed of the mucous membrane that lines the body internally, and covers the surface of most of the internal parts. This membrane contains a great number of minute red vessels, which give softness and moisture to the surface. A very beautiful illustration of the softness, moisture, and delicate color of the mucous membrane is afforded by turning up and examining the under surface of the upper eyelid. Hast thou not known, hast thou not heard, that the everlasting God, the Lord, the Creator of the ends of the earth, fainteth not, neither is weary? There is no searching of his understanding. Isaiah 11. 914. Why do delicate persons look pale and languid? Because, generally from the want of exercise and fresh air, their blood is deficient of the healthy proportion of red corpuscles. 915. Why does exercise and fresh air impart to healthy persons a red and fresh appearance? Because the redness of the blood is due to the amount of oxygen which it contains, and air and exercise oxygenize the blood and diffuse it throughout the system. 916. How is the blood propelled through the arteries? By the very powerful contraction and alternate dilation of the thick muscles of the heart, assisted also by the muscular cords of the blood vessels themselves, and in many instances by the compression of the muscles in which the arteries lie embedded. 917. Why are the capillary arteries capable of receiving the great quantity of blood sent out through the larger vessels? because the capillary vessels are so numerous that, though they are infinitely smaller, they are capable of receiving in their minute tubes the whole of the quantity of blood transmitted to them through the larger vessels. 918. Why, when we sit with our legs crossed, do we see the foot that is raised move at regular intervals? Because the pressure upon the muscles of the leg retards the progress of the blood until it forces itself through the compressed vessels, and thereby imparts a pulsation which moves the leg and foot. 919. Why are capillary blood vessels found in every part of the system? Because it is through these small vessels alone that the substances of the body are renewed and changed. Even the larger blood vessels do not sustain themselves upon the blood which they contain, but receive into their coats numerous capillary vessels by which they are nourished. All my bones shall say, Lord, who is like unto thee, which deliverest the poor from him that is too strong for him, yea, the poor and the needy from him that spoileth him. Psalm 35. 920. How much blood does the human body contain? From 25 to 35 pounds. 921. How does the blood ascend in the veins in opposition to gravitation? In addition to the muscular coats of the veins and the influence of muscular action upon them, there are in the veins numerous semicircular valves, which are not found in the arteries. These valves extend from the sides of the veins in such a manner that they allow the free passage of the blood upwards, but a backward motion of the blood would expand the cup-like valves and stop the passage, so that the blood can only move in one direction, and that towards the heart. 922. How frequently does the total amount of blood circulate through the system? The blood circulates once through the body in about 2 minutes. If, therefore, we estimate the amount of blood at 24 pounds, it follows that no less than 12 pounds of blood pass through the heart every minute, and it is estimated that if the blood moved with equal force in a straight line, it would pass through 150 feet in a minute. End of chapter 44. Chapter 45 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 45. 923. How many bones are there in the body? There are 246, and they are apportioned to the various parts of the body in the following numbers. Head, 8. Ears, 6. Face, 14. Teeth, 32. Backbone and its base, 26. Chest, etc., 26. Arms and hands, 64. Legs and feet, 62. Small movable bones, 8. Our bones are scattered at the grave's mouth, as when one cutteth and cleaveth wood upon the earth. Psalm 112. 924. Of what substances are the bones composed? 100 parts of bone consist of cartilage, 32.17, blood vessels, 1.13, carbonate of lime, 1.30, phosphate of lime, 51.04, fluate of lime, 2.00, phosphate of magnesia, 1.16, soda, chloride of sodium, 1.20, equaling 100.00. 925. What are the uses of these bones? They protect soft and delicate organs. They form a framework to which the organs are attached, and by which they are kept in their places, and they supply a mechanism by which the motions of the body are produced, in combination with the muscles. 926. Why is the brain placed within the skull? Because that delicate and vital organ, being the center and the root of the nervous system, requires a position of the greatest safety. 927. Why are the bones that constitute the vertebrae, backbone, hollowed out so as to form a continuous groove? Because through that groove the spinal cord passes out of the brain. Being in the center of that column of bones, the spinal cord receives from them a similar protection to that which the brain obtains from the skull. 928. Why is the head set upon the neck? Because in that position it obtains the freest motion, can turn in any direction, and is placed relatively to the other parts of the body in that situation where it acquires the greatest possible advantage. 929. Why are the eyes placed in the sockets of the skull? Because the bones of the skull afford protection to the delicate and complicated structure of the eyes, and supply points of attachment and grooves by which the muscles are enabled to turn the eyes freely and thereby extend the field of vision. Thus saith the Lord God unto these bones, Behold, I will cause breath to enter into you, and ye shall live. 930. Why are the bones of the skull arched? Because in that form they acquire greater strength, and hence the utmost degree of safety is combined with extreme lightness of material. 931. Why are the bones of the skull divided by sutures, seams, with points which fit into each other like small teeth? Because, by that arrangement, concussions of the skull, which might be fatal to the brain, are deadened, and injuries from accident greatly modified. And I will lay the sinews upon you, and will bring up flesh upon you, and cover you with skin, and put breath in you, and ye shall live, and ye shall know that I am the Lord. Ezekiel 37. 932. Why are the heart, lungs, etc. placed within the chest? Because the functions of these organs require considerable space, while their importance in the system of life renders it essential that they should be securely protected from the probabilities of accident. 933. Why are the heart and lungs enclosed for protection in a series of ribs, and not in a closed case like the brain? Because, by the inflation and contraction of the lungs, their capacity is constantly changing. When man takes a moderate inspiration, he inhales about 30 cubic inches of air, and the lungs increase in size 1/18 of their whole capacity. Consequently, were they enclosed in a frame of fixed dimensions, it must needs be, to that extent at least, larger than is necessary when the frame is made to dilate and contract with the capacity of the lungs. So perfect is the almighty contrivance that not only are the ribs made to protect the lungs, but by their elasticity and the contractions and dilations of the muscles which lie between them, they assist the lungs in their labors, and work with them in perfect harmony. 934. Why are the bones of the arms, legs, etc. made hollow? Because lightness is thereby combined with strength. There is a provision by which, in the extremities of bones, where an enlarged surface is required, lightness is still combined with the necessary degree of strength. The bones are made up of cellular formation, and this generally occurs in parts which are much called into action in the various movements of the body. Again he said unto me, Prophesy upon these bones, and say unto them, O ye dry bones, hear the word of the Lord. Ezekiel 37. 935. Why are the bones of the arms and legs formed in long shafts? Because a considerable leverage is gained by which the advantages of quickness of motion and increase of mechanical power are secured. 936. Why are the bones of the hands and feet numerous and small? Because the motions of the hands and feet are very varied and complicated. There are no less than 28 bones in one hand and wrist, and about as many in a foot and ankle. To these are fastened a great number of ligaments and muscles, by which their varied compound movements are controlled. But for the complexity of the mechanism of our hands and feet, our motions would be extremely awkward, and many of the valuable mechanical inventions which now benefit mankind could never have been introduced. The bones of the hand and feet are in number equal to 1/2 of the whole of the bones of the body. End of chapter 45. Chapter 46 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 46. 937. What are ligaments? Ligaments consist of bands and cords of a tough, fibrous, and smooth substance by which the bones are bound together and held in their places, allowing them freedom to move and supplying smooth surfaces over which they glide. 938. Why are the joints bound with ligaments? Because the bones would otherwise be constantly liable to slip from their places. That which is born of the flesh is flesh, and that which is born of the Spirit is spirit. John 3. 939. What are tendons? Tendons are long cords of a substance similar in nature to cartilage, by which the muscles are attached to the bones. 940. Why are tendons used to attach the muscles to the bones? Because, by this arrangement, the large muscles by which the extremities are moved may be placed at some distance from the bones upon which they act, and thus the extremities, instead of being large and clumsy, are neat and small. 941. How many muscles are there in the human body? There are about 446 muscles that have been dissected and described, and the actions of which are perfectly understood. But there is probably a much larger number of muscles and of compound actions of muscles than the skill of man has been able to recognize. All flesh is not the same flesh, but there is one kind of flesh of men, another flesh of beasts, another of fishes, and another of birds. Corinthians 16. 942. What is the constitution of a muscle? Every muscle is made up of a number of parallel fleshy fibers or threads, which are bound together by a smooth and soft tissue, forming a sheath or case to the muscle, and enabling it to glide freely over the surfaces upon which it moves. The ligaments may be seen enfolding the finger joints and also crossing the wrist underneath the tendons. The muscles are compressed into tendinous cords at their ends by which they are united to the bones. They are arranged in pairs having reciprocal actions, each muscle having a companion muscle by which the part which it moves is restored to its original position, when the influence of the first muscle is withdrawn and the stimulus given to bring back the part. 943. Why can we raise our fingers? Because muscles which lie on the forearm and have their tendons fastened at the ends of the fingers contract, and by becoming shorter, draw the fingers upward and towards the arm. Thou hast clothed me with skin and flesh, and hast fenced me with bones and sinews. Job 11. 944. Why can we throw back the fingers after they have been raised? Because the muscles at the back of the arm, whose tendons are attached to the back of the fingers, contract and restore them to their former position. 945. What degree of strength do the muscles possess? The degree of strength of a muscle depends upon the healthy condition of the muscle, the amount of stimulus which it receives at the time of exertion, and the manner in which its powers are applied. The great muscle of the calf of the leg has been found, when removed from a dead body, to be capable of sustaining a weight equal to 7 times the weight of the entire body. But the contractile power of the living muscles is very great. The thigh bone has frequently been broken by muscular contractions in fits of epilepsy, and in cases where there has been a dislocation of the thigh, the head of the thigh bone being thrown out of its socket, it has been found necessary to employ strong ropes attached to a wheel turned by several hands, in order to overcome the contraction of the excited muscles, and to enable the operator to restore the bone to its place. 946. What is the stimulus which sets the muscles in action? The muscles are excited to action by the nerves, which they receive from the spinal cord. 947. Why does it require the influence of the will to set the arms in motion? Because the muscles which form their mechanism are voluntary muscles, that is, they are subject to the will of man, and influenced by impulses directed to them through the nervous system by the mind, which is the governing power. And he took him by the right hand, and lifted him up, and immediately his feet and ankle bones received strength. Acts 3. 948. Why does the heart beat without any effort of the will? Because the muscles of the heart are involuntary muscles, that is, they are independent of the will, and receive a continuous nervous stimulus which is not under the control of the mind. 949. Why are the muscles of the arms, etc., made subject to the control of the will? Because, as they supply the mechanism through which we adapt ourselves to our varying wants and circumstances, it was necessary that they should be placed under the control of the mental power, and be moved only in accordance with man's necessities. If thou sayest, Behold, we knew it not, doth not he that pondereth the heart consider it? And he that keepeth thy soul, doth not he know it? And shall not he render to every man according to his works? Proverbs 24. 950. Why are the motions of the heart, etc., made independent of the will? Because, as the necessity for the heart's motion is fixed and unalterable, the constant motion of the heart could be best secured by giving it a fixed nervous influence, by which it might be unfailingly prompted to fulfill its functions. If the movements of a man's heart were subject to his will, he would be constantly required to regard the operations of that organ, and so large an amount of mental care and physical exertion would have to be employed in that direction, that man's sole work would be to keep himself alive. Hence we see the goodness of the Creator in giving life to man and in keeping the vital impulses under his divine care. End of chapter 46. Chapter 47 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 47. 951. What are nerves? The nerves are branches of the brain and the spinal cord. They are distributed in great numbers to all the active and sensitive parts of the body. 952. What is the spinal cord? The spinal cord is a long and large cord of nervous matter, which extends from the brain through a continuous tube formed by corresponding hollows in the bones of the back. It serves as a nervous trunk for the distribution of nerves, just as the aorta distributes branches of blood vessels. 953. Why is the spinal cord placed in the grooves formed by the backbone? Being a very vital part of the system, and from the delicacy of its structure liable to injuries, it is set in the backbone for protection, and so great is its security that it is only by force of an unusual kind that it can be injured. A sound heart is the life of the flesh, but envy is the rottenness of the bones. Proverbs 14. 954. How can branches proceed from it if it is so securely encased in bone? Because in the bones on each side of the spinal cord there are smaller grooves for the transmission of the nervous bundles. 955. Of what does the nervous system consist? Of the brain, the spinal cord, and the branches which are called nerves. 956. What is the constitution of a nerve? It consists of a thin membrane or sheath surrounding a grayish oily matter, which forms the nervous marrow. In the center of this marrow is usually found a small fiber, which is supposed to be the essential part of the nerve, and most nerves consist of a number of these sheaths enclosing fibers running in parallel directions. 957. What is the nervous fluid? The term nervous fluid is used to express our ideas of the mode by which the brain and spinal cord influence the remote parts, just as we say the electric fluid without knowing that such a fluid exists. It is the most convenient form of expression. 958. How many classes of nerves are there? There are 1. The nerves of motion, 2. The nerves of sensation, 3. The nerves of special sense, 4. The nerves of sympathy. Having many things to write unto you, I would not write with paper and ink, but I trust to come unto you, and speak face to face, that our joy may be full. 2 John. 959. What are the nerves of motion? The nerves of motion are those which, in obedience to the will, stimulate the muscles to act, and apportion the amount of stimulation they convey to the degree of exertion required. 960. What are the nerves of sensation? The nerves of sensation are those which impart a consciousness to the brain that its commands to the nerves of motion have been obeyed, and how far they have been fulfilled. Oh, that men would praise the Lord for his goodness, and for his wonderful works to the children of men. Psalm 107. Let us perform a simple experiment, which will more clearly illustrate the phenomena of motion and of sensation, which we are now describing, than a great deal of writing upon the subject. You hold in your hand this book. Close it and set it upon the table. Lay your hands passively upon your lap, and then will your hand to take up the book, which is the same as to say, command your hand to take up the book. What occurs? The hand, immediately obeying your desire, stretches forward to the book, and takes hold of it. How do you know that you have hold of it? You see that you have, but were your eyes closed, you would be equally aware that the hand had reached the book, and fulfilled your wishes. It is by the nerves of sensation that you are made aware that the hand has fulfilled your instructions. Consider what took place in the simple action. In the first instance, a desire arose in your mind to take up the book. The brain is the organ of the mind, and having branches either proceeding from itself or from the spinal cord to every part of the body, branches that traverse like telegraphic wires throughout every part of the system, it transmitted instructions along the nerves that proceed to the muscles of the arm and hand, directing them to take up the book. This was done instantly, and as soon as it was done, you became conscious that your will had been obeyed, because the nerves sent back a sensation to the brain acquainting it that the book had been taken up, and that at the moment of the dispatch it was in the firm hold of the hand. In all the varied motions of the body, this double action of the nerves takes place. It is obvious that without an outward impulse from the brain, upon which the desire of the mind first made an impression, no motion of the muscles of the arm and the hand could have taken place. And it is also obvious that without an inward impulse from the nerves to the brain, you would not have known that the muscles had fulfilled your instructions. The hand might have dropped by the side of the book, or have gone too far, or not far enough, and you would not have been aware of the result but for an inward communication through the nerves. We are not now speaking of the nerves which endow us with the sense of feeling, because they are regarded as separate and distinct from those nerves that produce in us consciousness of muscular response. When we walk, rise, or sit, we are made conscious, without any special feeling being exerted, that the muscles have placed the limb or the body in the desired position, that it is set down safely and firmly, and that we may repose upon it securely without further attention. We refer the impressions made by the book upon the nerves of the hand, and which enable us to tell whether it feels hot or cold, whether its surface is rough or smooth, and so on, to the special sense of feeling. The consciousness of muscular action is a separate and distinct function, and it is generally believed that the same nerves that convey the command of the will outward bring back the information that the will has been obeyed, but that different fibers of the nerves convey the outward and the inward impulses. A single nerve may therefore be likened to a double wire connected with the electric telegraph, one transmitting dispatches in one direction and the other in the opposite direction. 961. What are the nerves of special sense? The nerves of special sense are those through which we hear, see, feel, smell, and taste. For the Lord seeth not as man seeth, for man looketh on the outward appearance, but the Lord looketh on the heart. Samuel 16. 962. What are the nerves of sympathy? The nerves of sympathy, or the system of sympathetic nerves, are those which are distributed to the internal organs, and which are independent of the will. They regulate the motions of the heart, the lungs, the stomach, etc., and stimulate the organs of secretion, so that those organs work in harmony with each other. As the internal organs are all more or less dependent upon each other, and unite their functions for similar ends, it is obvious that there should prevail among them a mutual consciousness of their state. Otherwise, when the stomach had formed chyme, the liver might have no bile ready to fulfill its office. The absorbents might be in a state of rest at the moment when nutrition was set before them, and the heart might beat slowly while the lungs were in active exertion to obtain additional blood to support an active exercise. The sympathetic system of nerves therefore regulates and harmonizes these internal functions. End of chapter 47.
Chapter 48 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 48. 963. Why do we see objects? Because the light which is reflected from them enters our eyes and produces images of their forms upon a membrane of nerves called the retina, just as images are produced upon a mirror. 964. Why does this enable us to see? Because the membrane which receives the images of objects is connected with the optic nerve, which transmits to the brain impressions made by the reflections of light, just as other nerves convey the effects of feeling, hearing, tasting, etc. 965. Why are we enabled to move our eyes? Because various muscles are so placed in relation to the eyeball that their contraction draws the eye in the direction required. We are thus enabled to adjust the direction of the eye to the position of the objects we desire to see, in other words, to set the mirror in such a position that it will receive the reflection. Quote, "Truly the light is sweet, and a pleasant thing it is for the eyes to behold the sun." Ecclesiastes 11. End of quote. 966. Why are we enabled to see large objects upon so small a surface? Because the lenses and humours of the eye collect the rays of light, coming from every direction, and, bringing them into a focus, transmit them to the retina, where each ray impresses upon the nervous surface the qualities it received from the object which reflected it. 967. Why do some persons squint? Because it sometimes happens that a muscle of the eye acts too powerfully for its companion muscle, and draws the eye too much on one side. 968. Why does the pupil of the eye look black? Because the pupil is an opening through which the rays of light pass into the chamber of the eye. There is, therefore, nothing in the pupil of the eye to reflect light. Quote, "Keep me as the apple of thine eye, hide me under the shadow of thy wings." Psalm 17. End of quote. 969. Why is the pupil of the eye larger sometimes than at others? Because the iris, a ring of extremely fine muscles which surround the pupil, contracts when too much light falls upon the retina, and dilates when the light is feeble. It therefore enlarges or diminishes the size of the pupil to regulate the admission of light. 970. Why have we two eyes? Because the field of vision is thereby much extended. The intensity of sight is also increased, the impressions upon the brain being clearer and better defined, just as in a stereoscope. The effect of vision is heightened by a double picture. The sense of sight being more constantly exercised than any other sense during our waking moments, one eye is frequently called upon to give rest to the other, and the important faculty of vision, being endangered by the necessary exposure of some parts of the eye, and the equally necessary delicacy of an organ formed to receive impressions from so ethereal an element as light, is rendered the more secure to us, since though one eye may become enfeebled, diseased, or wholly lost, the other eye will retain the blessing of sight. Quote, "The eyes of the Lord are upon the righteous, and his ears are open unto their cry." Psalm 34. End of quote. 971. Why, having two eyes, and each eye receiving a reflection upon its retina, does the brain experience only one impression of an object? Because, besides those optical laws which bring upon the two retinas the exactly corresponding images of the same objects, the optic nerves meet before they reach the brain and blend the impulses which they convey. 972. Why are the eyes provided with eyelids? Because the eyes require to be defended from floating particles in the air, and to be kept moist and clean. The eyelids form the shutters of the eye, defending it when waking, by closing upon its surface whenever danger is apprehended, moistening its surface when it becomes dry, and covering it securely during the hours of sleep. 973. Why are the eyelids fringed with eyelashes? Because the eyelashes assist to modify the light and to protect the eye without actually closing the eyelids. When the eyelids are partially closed, as in very sunny or dusty weather, the eyelashes cross each other, forming a kind of shady lattice work, from the interspaces of which the eye looks out with advantage, and sees sufficiently for the guidance of the body. 974. Why are we able to see at long or short distances? Because the crystalline lens of the eye is a movable body, and is pushed forward or drawn back by fine muscular fibres, according to the distances of the objects upon which we look. By these means its focus becomes adjusted. 975. Why do we wink? Because, by the repeated action of winking, the eye is kept moist and clean, and the watery fluid secreted by little glands in the eyelids and at the side of the eye is spread equally over the surface instead of being allowed to accumulate, but the action of winking or brightening the eye is so instantaneous that it does not impede the sight. Quote, "And the eye cannot say unto the hand, I have no need of thee, nor again the head to the feet, I have no need of you." Corinthians 12. End of quote. 976. Whence are the humours and secretions of the eye derived? From the blood, which flows abundantly to the eyes and is circulated in capillary vessels that are spread out upon the membranous coats of the eyeballs. 977. Why do tears form in the eyes? Because, under the emotions of the mind, the circulation of blood in the brain and in its nearest branches becomes considerably quickened. The eyes receive a larger amount of blood, and the secretion of the lacrimal glands being increased, the fluid overflows, and tears are formed. The use of tears is probably to keep the eyes cool during the excitement of the brain. They are formed also during laughing, but less frequently. Quote, "If the whole body were an eye, where were hearing? If the whole were hearing, where were smelling?" Corinthians 12. End of quote. 978. Why do we feel inconvenienced by sudden light? Because an excess of light enters the eye before the iris has time to adjust the pupil to the amount of light to be received. 979. Why, if we look upon a very bright light and then turn away, are we unable to see? Because the iris has so reduced the pupil while we were looking at the bright light, that immediately upon turning to a darker object, the pupil is too small to admit sufficient rays to enable us to see. 980. Why do we see better after a short time? Because the iris has relaxed and enlarged the pupil, therefore we receive more rays of light from the comparatively dark object, and are enabled to see it more clearly. 981. Why do cats, bats, owls, etc. see in the dark? Because their eyes are made highly sensitive to small quantities of light. It is also believed that there are certain properties of light which affect their eyes but do not affect ours. In other words, that there are some rays which are luminous to them which are not luminous to us. Hence they find light in what we call darkness. Quote, He that hath ears to hear, let him hear. Matthew 11. End of quote. 982. Why does the pupil of a cat's eye appear nearly closed by day? Because the cat's eye is so sensitive to light that the iris closes the pupil almost entirely to shut out the too powerful light. End of chapter 48. Recording by Julie Niedermeyer. Chapter 49 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 49. 983. Why do we hear? Because the tympanum of the ear receives impressions from sounds, and transmits those impressions to the brain in a similar manner to that in which the retina of the eye transmits the impressions made upon it by light. 984. Why is one part of the ear spread out externally? The external ear is a natural ear trumpet, and serves to collect the vibrations of sound and to conduct them towards the internal ear. 985. Why is the ear allowed to project whilst the eye is carefully enclosed? Because the external ear, being formed of tough cartilaginous substance, and being very simple in its organization, is but little liable to injury. 986. Why do hairs grow across the entrance of the ears? Because they prevent the intrusion of insects and of particles of dust, by which otherwise the faculty of hearing would be impaired. The insect called the earwig is popularly supposed to be so named from its tendency to get into the human ear, and cause pain and madness by penetrating to the brain. An earwig, however, is no more likely to get into the ear than any other insect whose habit it is to penetrate the corollas of flowers. And should an insect enter the ear, it could get no further than the membrane of the tympanum, which spreads all over the auditory passage, just as the parchment of a drum spreads over the entire circumference of that instrument. The fact is that the wing of the insect, when spread, resembles the external ear in shape. It is similar to the wing of the stag beetle. And this fancied resemblance of the wing of the insect to the ear of man may have given rise to the name of ear-wing, which became corrupted to earwig. Quote, Doth not the ear try words, and the mouth taste his meat? Job 12. End of quote. 987. Why is wax secreted at the entrance of the ear? Because, by the peculiar resinous property which it possesses, it improves the sound-conducting power of the auditory canal through which it prevails. 988. Why do we sometimes hear singing noises in the ear? Because the ear is liable to inflammation from various causes, and when the blood flows unduly through the vessels of the ear, it produces a slight sound. Quote, Apply thine heart unto instruction, and thine ears to the words of knowledge. Proverbs 23. End of quote. 989. Why do people become deaf? Because the ear may be injured in various ways. The tympanum may be impaired, the fluid of the ear dried up, or the nerves be pressed upon by swellings in the surrounding parts. When, therefore, the mechanism of hearing is impaired, the sense of hearing becomes weakened or altogether lost. 990. Why do persons accustomed to loud noises feel no inconvenience from them? Because the sensitiveness of the nerves of the ear becomes deadened. They do not convey to the brain such intense impulses when they are frequently acted upon by loud sounds. 991. Why do persons engaged in battle often lose their hearing? Because the vibrations caused by the sounds of artillery are so violent that they overpower the mechanism of the ear, and frequently rupture the connection of the fine nervous filaments with the textures through which they spread. The violent concussions of the air produced by volleys of cannon or by loud peals of thunder have an overpowering effect upon persons nervously constituted, and upon the organ of hearing, which is more especially affected. As persons have been struck blind by intense light, so others have been deafened by intense sounds. In 1697 a butcher's dog was killed by the noise of the firing to celebrate the proclamation of peace. 2 troops of horse were dismounted and drawn up in a line to fire volleys. At the moment of the first volley a large and courageous mastiff belonging to a butcher was lying asleep before the fire. At the noise of the first volley the dog started up, and ran into another room, where it hid itself behind a bed. On the firing of the second volley it ran several times about the room, trembling violently, and when the third volley was fired it ran around once or twice with great violence, and then dropped down dead, with blood flowing from its mouth and nose. Persons who are painfully affected by loud noises should put a little wool in their ears when such noises are occurring. They will thereby save themselves from temporary inconvenience, and probably preserve the sense of hearing from permanent injury. 992. Why do we smell? Because minute particles of matter diffused in the air come in contact with the filaments of the olfactory nerve, which are spread out upon the walls of the nostrils, and those nerves transmit impressions to the brain, constituting what we call the odour of substances. Quote, "And the Lord God formed man of the dust of the ground, and breathed into his nostrils the breath of life, and man became a living soul." Genesis 2. End of quote. 993. Why do hairs grow across the passages of the nostrils? Because they form a defence against the admission of dust and insects, which would otherwise frequently irritate the nervous structure of the nose. 994. Why are the nostrils directed downwards? Because, as odours and effluvia ascend, the nose is directed towards them, and thereby receives the readiest intimation of those bodies floating in the air which may be pleasurable to the sense, or offensive to the smell, and injurious to life. Quote, "Can that which is unsavoury be eaten without salt? Or is there any taste in the white of an egg?" Job 6. End of quote. 995. Why is the nose placed over and near the mouth? Because, as one of the chief duties of that organ is to exercise a watchfulness over the purity of the substances we eat and drink, it is placed in that position which enables it to discharge that duty with the greatest readiness. End of chapter 49. Recording by Julia Niedermeyer. Chapter 50 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 50. 996. Why do we taste? Because the tongue is endowed with gustatory nerves, having the function of taste as their special sense, just as the optic, the auditory, and the olfactory nerves have their special duties in the eyes, ears, and nose. 997. Why do some substances taste sweet, others sour, others salt, etc.? It is believed that the impressions of taste arise from the various forms of the atoms of matter presented to the nerves of the tongue. 998. Why do we taste substances most satisfactorily, after they have remained a little while in the mouth. Because the nerves of taste are most abundantly distributed to the under surface of the tongue, and when solid substances have been in the mouth a little while, they impregnate the saliva of the mouth with their particles and come in contact in a fluid solution with the gustatory nerves. 999. Why, if we put a nub of sugar to the tip of the tongue, has it no taste? Because the gustatory nerves are not distributed to that part of the tongue. Quote, Wine is a mocker, strong drink is raging, and whosoever is deceived thereby is not wise. Proverbs 20. End of quote. 1000. Why, when we draw the tongue in, do we recognize the sweetness of the sugar? Because the dissolved particles of sugar are brought in contact with the nerves of taste. 1001. Through what nerves are we made sensible of the contact of sugar with the tip of the tongue? Through the nerves of feeling, which are abundantly distributed to the tongue to guide it in its control over the mastication of food. 1002. Why do connoisseurs of wines close their mouths and distend their chins for a few seconds when tasting wines? Because they thereby bring the wine in contact with the under surface of the tongue, in which the gustatory nerves chiefly reside. 1003. Why do they also pass the fumes of the wines through their nostrils? Because flavour in its fullest sense comprehends not only the taste, but the odour of a substance, and, therefore, persons of experience attend to both requisites. The various conditions of taste are defined to be: first, where sensations of touch are alone produced, as by glass, ice, pebbles, etc. Second, where, in addition to being felt upon the tongue, the substance excites sensation in the olfactory nerves, as by lead, tin, copper, etc. Third, where, besides being felt, there are peculiar sensations of taste, expressive of the properties of bodies, as salt, sugar, tartaric acid, etc. Fourth, where, besides being felt and tasted, there is an odour characteristic of the substance, and essential to the full development of its flavours, as in cloves, lemon peel, caraway seed, and aromatic substances generally. 1004. Why do we feel? Because there are distributed to various parts of the body fine nervous filaments, which have for their special duty the transmission to the brain of impressions made upon them by contact with substances. Quote, The works of the Lord are great, sought out of all them that have pleasure therein. Psalm 111. End of quote. 1005. In what parts of the body does the sense of touch more especially reside? In the points of the fingers and in the tongue. By laying a piece of paper upon a table, and upon the paper a piece of cloth, on the piece of cloth a bit of silk, and on the bit of silk a piece of leather, so that the edge of each would be exposed to the extent of half an inch, it would be impossible by the touch to tell when the finger passed successively over the leather, silk, cloth, or paper, and arrived on the table. Those impressions of touch must have been communicated with their extremely nice distinctions to the sensitive nerves that lie underneath the skin, and must have been transmitted all the way through the arm to the brain, although the touch itself was so light as scarcely to be appreciable with regard to the force applied. A hair lying on the tongue will be plainly perceptible to the touch of the tongue, and the surface of a broken tooth will often cause the tongue great annoyance by the acute perception it imparts of the roughness of its surface. The toes are also highly sensitive, though their powers of touch are seldom fully developed. Persons who have lost their arms, however, have brought their feet to be almost as sensitive as fingers. blind persons increase, by constant exercise, their powers of touch to such a degree that they are able to read freely by passing their fingers over embossed printing, and they have been known to distinguish colours by differences in their grain, quite unappreciable by other persons. 1006. Why is feeling impaired when the hands are cold? Because, as the blood flows slowly to the nerves, they are less capable of that perception of touch which is their special sense. The skin contracts upon the nervous filaments and impairs the contact between them and the bodies which they touch. 1007. Why do the fingers prick and sting when they again become warm? Because, as the warmth expands the cuticle and the blood begins to flow more freely through the vessels, the nerves are made conscious of the movements of the blood, and continue to be so until the circulation is equally restored to all the parts. Quote, "In the sweat of thy face shalt thou eat bread, till thou return to the ground. For out of it thou wast taken, for dust thou art, and unto dust shalt thou return." Genesis 3. End of quote. 1008. Why do persons whose legs and arms have been amputated fancy they feel the toes or fingers of the amputated limb? Because the nervous trunk which formerly conveyed impressions from those extremities remains in the part of the limb attached to the body. The mind has been accustomed to refer the impulses received through that nervous trunk to the extremity where the sensations arose, and now that the nerve has been cut, the painful sensation caused thereby is referred to the extremity which the nerve supplied, and the sufferers for a time appear to continue to feel the part which they have lost. End of chapter 50. Recording by Julia Niedermeyer.
Chapter 51, Part 1 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle Eaton. The Reason Why by Robert Kemp Philp. Chapter 51, Part 1. 1009. Why do we perspire? Because the skin is filled with very minute pores, which act as outlets for a portion of the water of the blood. That serves to moisten and cool the surface of the body, and to carry away some of the matter no longer needed in the system. 1010. How is the perspiration formed? By very small glands, which lie embedded in the skin. It is estimated that there are about 2,700,000 perspiratory glands distributed over the surface of the body, and that these glands find outlets for their secretion through no less than 7 millions of pores. 1011. What is insensible perspiration? Insensible perspiration is that transmission of watery particles through the skin, which is constantly going on, but which takes place so gently that it cannot be perceived. It is, however, very important in its results, as no less than from 20 to 33 ounces of water may pass imperceptibly through the skin in 24 hours. 1012. What is sensible perspiration? Sensible perspiration is that moisture which exudes upon the skin in drops large enough to be perceptible, when the body is heated by exercise or other means. And Elisha sent a message unto him, saying, Go and wash in Jordan 7 times, and thy flesh shall come again to thee, and thou shalt be clean. 2 Kings 5. 1013. Why does a sudden change from heat to cold bring on illness? Because the effect of cold arrests the action of the vessels of the skin, and suddenly throws upon the internal organs the excretory labour which the skin should have sustained. 1014. Why does a chill upon the skin frequently produce inflammation of the lungs? Because the lungs and the skin together discharge the chief proportion of the watery fluid of the body. When the skin's action is checked, the lungs have to throw off a much greater amount of fluid. The lungs, therefore, become overworked, and inflammatory action sets in. 1015. Why does cleanliness promote health? Because every atom of dirt which lodges upon the surface of the body serves to clog and check the working of those minute pores, by which much of the fluid of the body is changed and purified. In the internal parts of the system, the Creator has made ample provision for cleanliness. Every organ is so constituted that it cleanses and lubricates itself. Every surface of the inner body is perfectly clean and as soft as silk. Nature leaves to man the care of those surfaces which are under his immediate observation and control, and he who from idleness or indifference to nature's laws is guilty of personal neglect, opposes the evident intentions of the Creator, and must sooner or later pay the penalty of disobedience. 1016. Why does exercise promote health? Because it assists all the functions upon which life depended. It quickens the circulation, and thereby nourishes every part of the body, causing the bones to become firm and the muscles to become full and healthy. It promotes breathing, by which oxygen is taken into the system and carbon thrown off, and thereby it produces a higher degree of organic life and strength than would otherwise exist. It promotes perspiration, by which, through the millions of pores of the skin, much of the fluid of the body is changed and purified, and it induces the genial and diffuse warmth, which is one of the chief conditions of a high degree of vitality. Love not sleep, lest thou come to poverty. Open thine eyes, and thou shalt be satisfied with bread. And Proverbs 20. 1017. Why do we feel fatigue? Because those organs which stimulate the mechanism of the body to act, themselves require rest and repair. When the brain and nerves arrive at that state, they make their condition known to the system generally, by indications which we denominate fatigue. 1018. Why after rest do we return invigorated to our labours? Because the nervous system has accumulated, during the hours of rest, a fresh amount of that vital force which we call the nervous fluid, and by which the various organs of the body are excited to perform the duties assigned to them. 1019. What is sleep? Sleep is understood to be that state of the body in which the relation of the brain to some parts of the body is temporarily suspended. There are some parts of the body that never sleep. Such are the heart, the lungs, the organs of circulation, and those parts of the nervous system that direct their operations. But when sleep overtakes the system, it seems as if the relations of those parts under the control of the will were temporarily suspended, as if, for instance, those nerves which move the arms, the legs, the eyes, the tongue, etc., were all at once unfastened, just as the strings of an instrument are relaxed by the turning of a key, or the throwing down of a bridge over which they were stretched. What is meant by the temporary suspension of the relation of the brain to some parts of the body may be thus explained. Notice a man when he sits dozing in a chair. At first his head is held up, the brain controlling the muscles of the neck, and keeping the head erect. But drowsiness comes on, the brain begins to withdraw its influence, and the muscles of the neck becoming, as it were, unstrung. The head drops down upon the breast, but the sleep is unsound and disturbed by surrounding noises. The brain is therefore frequently excited to return its influence to the muscles, and draw up the head of the sleeper. He gives a sudden start, every muscle is tightened in an instant, up goes the head, the eyes open, the ears listen, until a feeling of security and composure returns. The sleep again deepens, the nervous connection is again withdrawn, and then down drops the head as before. Yet a little sleep, a little slumber, a little folding of the hands to sleep. So shall thy poverty come as one that travelleth, and thy want as an armed man. Proverbs 25. 1020. Why do we dream? Dreams appear to arise from the excitement of the brain during those hours when its connection with the other parts of the living organism is suspended. For instance, a man dreams that he is pursued by a furious animal, and the mind passes through all the excitement of flying from danger, but the connection between the moving power and the machinery of motion being suspended, no motion takes place. The same impressions upon the brain, when the nerves were strung to the muscles, would have caused a rapid flight, and a vigorous effort to escape from the apprehended danger. 1021. Why do suppers, when indigestible substances are eaten, produce dreaming? Probably because, as the digestive organs are oppressed, and those parts of the nervous system which stimulate the organs of digestion are excited by excessive action, those portions of the brain which are not immediately employed by the digestive processes are disturbed by that sympathy which is observed to prevail between the relative parts and functions of the body. 1022. Why do we yawn? Because, as we become weary, the nervous impulses which direct the respiratory movements are enfeebled. It has been said that those movements are involuntary, and that the parts engaged in producing them are not subject to fatigue. But the operation of breathing is, to some extent, voluntary, though when we cease to direct it voluntarily, it is involuntarily continued by organs which know no fatigue. When, therefore, we feel weary, still controlling our breathing in our efforts to move or to speak, there frequently arrives a period when, for a few seconds, the respiratory process is suspended. It seems to be the point at which the voluntary nerves of respiration are about to deliver their office over to the involuntary nerves, but the pause in the respiration has caused a momentary deficiency of breath, and the involuntary nerves of respiration, coming suddenly to the aid of the lungs, cause a spasmodic action of the parts involved, and a yawn, attended by a deep inspiration to compensate for the cessation of breathing, are the result. And it shall be, when they say unto thee, Wherefore sighed thou, that thou shalt answer, For the tidings, because it cometh, and every heart shall melt, and all hands shall be feeble. Ezekiel 21. 1023. Why do we cough? Because the respiratory organs are excited by the presence of some body, foreign or unnatural to them. A cough is an effort on the part of the air tubes to free themselves from some source of irritation, and so important are the organs of breathing to the welfare of the body, that the muscles of the chest, back, and abdomen unite in the endeavour to get rid of the exciting substance. 1024. Why do we sneeze? Because particles of matter enter the nostrils and excite the nerves of feeling and of smell. In sneezing, as in coughing, the effort is to free the parts affected from the intrusion of some matters of an objectionable nature, and in this case, as in the former one, there is a very general sympathy of other organs with the part affected, and an energetic effort to get rid of the evil. 1025. Why do we sigh? The action of sighing arises from very similar causes to those of yawning, but in sighing the nervous depression is caused by grief, while in yawning it is the result of fatigue. In sighing, the effect is generally erased by an expiration, in yawning by an inspiration. The mind, wearied and weakened by sorrow, omits for a few seconds to continue the respiratory process, and then suddenly there comes an involuntary expiration of the breath, causing a faint sound as it passes the organs of the voice. 1026. Why do we laugh? Laughing is caused by the very opposite influences that produce sighing. The nervous system is highly excited by some external cause. The impression is so intense, and the mind so fixed upon it, that the respiratory process is irregular and uncontrolled. Persons excited to a fit of laughter generally hold their breath until they can hold it no longer, and then suddenly there is a quick expiration causing eccentric sounds, the mind being too intently fixed upon the cause of the excitement, either to moderate the sounds or to control the breathing. Except ye utter by the tongue words easy to be understood, how shall it be known what is spoken? for ye shall speak into the air. Corinthians 14. 1027. Why do we hiccough? Hiccough is caused by spasmodic twitching of the diaphragm, a thin muscular membrane which divides the chest from the abdomen. It generally arises from sympathy with the stomach, and it is highly probable that the muscular twitches and jerks are so many efforts on the part of the diaphragm to assist the stomach to get rid of some undigested matter. 1028. Why do we snore? Snoring is caused by air sweeping through the passages that lead from the mouth through the nostrils, and which in our waking moments are capable of certain muscular modifications to adapt them to our breathing. But as in sleeping, the nervous control over them is withdrawn. They are left to the action of the air, which in sweeping by them sets them in vibration. End of chapter 51, part 1. Chapter 51, part 2 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle Eaton. The Reason Why by Robert Kemp Philp. Chapter 51, part 2. We have endeavoured by the employment of the simplest language and by reference to some of the most familiar phenomena of nature to impart to the reader a clear conception of those sublime laws which control our being, and afford evidence of the goodness and power of that Almighty God to whom we are indebted for the life that we enjoy, and the varied and beautiful existences which to the rightly constituted mind make the earth a vast aggregation of interesting objects. We will now, before we pass on to the final section of our work, review some of the more important facts that have been communicated, and devote a few pages to meditations upon the formation of the human body, that wonderful temple of which each of us is a tenant. We have described man's organisation. What is that organisation for? It is to make use of the elements upon which man exists. The lungs make use of the air, the eye makes use of the light, the stomach and the system generally make use of water, every part of the body uses heat, and all parts of the system demand food. The hand feeds as constantly as the mouth. The mouth is the receptacle of food by which the body is to be fed. The stomach is the kitchen in which food is prepared for the use of the body, and the blood vessels are the canals through which the food is sent to those members of the body that are in need of it. When we speak of man's organs or members, we speak of those parts of the living machinery by which the elements are used up or employed. For man's benefit, repeat. We speak of those parts of the living machinery by which the elements are used up or employed for man's benefit. And this view of the subject, bearing in mind that the body is held together as the temple of a living spirit, superior to mere flesh and blood, gives us a higher and clearer perception of the distinction between the body and the soul than that which we might otherwise entertain. The body is a machine, working for the spirit which is its owner. While the machine works, the spirit directs and influences its actions. But when the machine stops, the spirit resigns its power over a ruined temple, quits it, and flies to a region where, as a spirit, it becomes subject to a new order of existence, consistent with its severance from earthly things and laws, and there it enters upon its eternal destiny, according to the judgments and appointments of God. It is no longer dependent upon a relation between spiritual and material laws. Not unto us, O Lord, not unto us, but unto thy name give glory, for thy mercy and for thy truth's sake. Psalm 115. Suppose that the air which man breathes, instead of returning from his lungs clear and imperceptible to sight, were tinged with colour, we should see that every time a man breathed, the air would rush in a stream into his mouth, and then return again, and the air which returned would, being warm, be lighter than the outer air, and would rise upward over the man's head, where, cooling and mingling with the outer air, it would descend again. We do, in fact, see this action evidenced. When in winter time the cold condenses the vapour of the breath, we see the little cloud constantly rising before the breather's face, and dispersing in the surrounding air. Is it not a wonderful thing that clear and elastic substance, which you cannot feel, though it touches every part of your body, and which you cannot see, is composed of two distinct bodies, having very different properties, and that the two bodies can easily be separated from each other? Air is of the first importance to life, hence it is provided for us everywhere. We require air every second, water every few hours, and food at intervals considerably apart. Air is therefore provided for us everywhere, whether we stand or sit, whether we dwell in a valley or upon a mountain, whether we go into the cellar under our house, or into the garret at the top of it. Air is there provided for us. God, who made it a law that man should breathe to live, also sent him air abundantly, that he might comply with that law. And all that is required from man in this respect is that he will not shut out God's bounty, but receive it freely. As we have employed the idea that if the air were coloured, we should have the opportunity of marking the process of breathing, let us enlarge upon this, and suppose that every time the air were returned from the lungs, it became of a darker colour, the darkness denoting increased impurity. If we placed a man in a room full of pure air, we should see the air enter his lungs and sent back slightly tinged, but this would disperse itself with the other air in the room and scarcely be perceptible. As the man continued to breathe, however, each measure of air returning from the lungs would serve to pollute that abiding in the room, until at last the whole mass would become cloudy and discoloured, and we should see such a change as occurs when water is turned from a pure and clear state into a muddy condition. The air does become polluted with each respiration, and although it is colourless, it is as impure as if with every breath given off from the lungs it became of a dark colour in proportion to its impurity. Thus we see how important it is that we should provide ourselves with pure air, and that in seeking warmth and comfort in our houses, we should provide an adequate supply of fresh atmosphere, because it is more vital to life than either water or food. Indeed, so constant is our requirement of air, that if we had to fetch it for purposes of breathing, or simply to raise it to our mouths, as we do water when we drink, it would be the sole occupation of our lives. We could do nothing else. For this reason, God has sent the air to us, and not required us to go to the air. And the great error of man is, that in too many instances he shuts off the supply from himself, and brings on disease and pain by inhaling a poisonous compound, instead of air of a healthful kind, which bears an adaptation to the wants of life. There is a natural body, and there is a spiritual body. 1 Corinthians 15. Whilst the rooms of our houses are filled with air, it is otherwise with water, which we require in less degree than air. If we have not the artificial means by which water is brought to our houses, through the pipes of a water company, there is a spring or a pump in the garden, or in the absence of these a good sound cask, standing at the end of our house, forming a receptacle to the water pipes that surround it, provides us with a supply of fresh water distilled from the clouds. If we were to drink a good draught of water once a day, that would be sufficient for all the purposes of life, as far as regards the alimentary use of water. Man is therefore allowed to go to the stream for his drink, and is required to raise it to his lips at those moments when he uses it. Although in breathing man separates the oxygen of the air from the nitrogen thereof, he does not separate the oxygen of the water from the hydrogen. Water, in fact, undergoes no change in the body, excepting that of admixture with the substances of the body, and its uses are to moisten, to cool, to cleanse, and also to nourish the parts with which it comes into contact. But it affords no nourishment of itself. It mixes with the blood, of which it forms a material part, and is the means of conveying the nourishment of the blood to every part of the system. After it has filled this office, and taken up impurities that are required to be removed, it is cast out of the system again without undergoing any chemical change. Man's body is to his soul, in many respects, what a house is to its occupants. But how superior is the dwelling which God erected to that which man has built? Reader, come out of yourself, and in imagination realise the abstraction of the soul from the body. Make an effort of thought, and do not relinquish that effort until you fancy that you see your image seated on a chair before you. And now proceed to ask yourself certain questions respecting your bodily tenement, questions which, perchance, have never occurred to you before, but which will impress themselves the more forcibly upon you, in proportion as you realise for a moment the idea of your soul examining the body which it inhabits. There sits before you a form of exquisite proportions, with reference to the mode of life it has to pursue, the wants of the soul for which it has to care, and which it has to guard, under the direction of that soul, its owner and master. End of chapter 51, part 2. Chapter 51, part 3 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle Eaton. The Reason Why by Robert Kemp Philp. Chapter 51, Part 3. Over the brows that mark the intellectual front of that due form, there fall the auburn locks of youth, or the grey hair of venerable age. Each of those hairs is curiously organised. If you take a branch of a tree and cut it across, you will find curious markings caused by vessels of various structure, all necessary to the existence of the plant. In the centre will be found either a hollow tube or a space occupied by a soft substance called pith. Each hair of your head is as curiously formed as the branch of a tree, and in a manner not dissimilar, though its parts are so minute that the unaided eye cannot discern them. Every hair has a root, just as a tree has, and through this root it receives its nourishment. As the vessels which feed a plant are always proportionate to the size of the plant itself, how fine must be those vessels which form the roots of the hair, being in proportion to the size of the hair, which in itself so small that the eye cannot see its structure. The hair is, in fact, an animal plant, growing upon the body in much the same manner that plants grow upon the surface of the earth. But how does this hair grow? Not alone by the addition of matter at its roots, pushing up and elongating its stem. Nourishment passes up through its whole length and is deposited upon its end, just as the nourishment of a tree is deposited upon its extreme branches. If, after having your hair cut, you were to examine its ends by the microscope, you would discover the abrupt termination left by the scissors. But allow the hair to grow, and then examine it, and you will discover that it grows from its point, which in comparison with its former state, is perfect and fine. The reason why the beard is so hard is that the ends of the hair are continually being shaved off. The hair of the beard, if allowed to grow, would become almost as soft as the hair of the head. The very hairs of your head are all numbered. Matthew 11. But why is man's head thus covered with hair? For precisely the same reason that a house is thatched, to keep the inmates warm. We might add also, to give beauty to the edifice. But as beauty is a conventional quality, and if men were without it they would consider themselves quite as handsome as they do now, we will not enlarge upon the argument. Our bald-headed friends, too, might have reason to complain of such a partial hypothesis. The brain is the great organ upon which the health, the welfare, and the happiness of the system depends. The skull, therefore, may be regarded as analogous to the strong box, the iron chest in which the merchant keeps his treasure. There is no point at which the brain can be touched to its injury, without first doing violence to the skull. Even the spinal cord runs down the back through a tunnel or tube, formed in a number of strong bones, so closely and firmly jointed together that they are commonly termed the backbone. Look at eyebrows. What purpose do they fulfil? Precisely that of a shed or arch placed over a window to shelter it from rain. But for the eyebrows, the perspiration would frequently run from the brow into the eyes and obscure the sight. A man walking in a shower of rain would scarcely be able to see, and a mariner in a storm would find a double difficulty in braving the tempest. Now we come to the eye, which is the window of the soul's abode. And what a window! How curiously constructed, how wisely guarded! In the eyelashes as well as the eyebrows, we see the hair fulfilling a useful purpose, differing from any already described. The eyelashes serve to keep cold winds, dust, and too bright sun from injuring or entering the windows of the body. When we walk against the east wind, we bring the tips of our eyelashes together, and in that way exclude the cold air from the surface of the eye, and in the same manner we exclude the dust and modify the light. The eyelashes, therefore, are like so many sentries, constantly moving to and fro, protecting a most important organ from injury. The eyelids are the shutters by which the windows are opened and closed, but they also cleanse the eye, keeping it bright and moist. There are, moreover, in the lids of each eye or window, little glands or springs, by which a clear fluid is formed and supplied for cleansing the eye. The eye is placed in a socket of the skull, in which it has free motion, turning right or left, up or down, to serve the purpose of the inhabitant of the dwelling. Of the structure of the eye itself we will not say much, for the engravings will afford a clearer understanding than a lengthy written description. But we would have you examine the formation of the iris of the living eye, the ring which surrounds the pupil. Hold a light to it, and you will find that the iris will contract and diminish the pupil. Withdraw the light, and the iris will relax and the pupil expand, thus regulating the amount of light. The images of external objects are formed upon the retina of the eye, a thin membrane, spread out upon the extremity of a large nerve, which proceeds immediately to the brain, and forms the telegraphic cord by which information is given to the mind of everything visible going on within the range of sight. Thou art of purer eyes than to behold evil, and canst not look on iniquity. Habakkuk 1. Now think for a few moments upon the wonderful structure of those windows of the body. Can you fancy in the walls of your house a window which protects itself, cleanses itself, and turns in any direction at the mere will of the tenant, and when that tenant is oppressed by excess of light, draws its own curtain and gives him ease, and when he falls asleep closes its own shutters and protects itself from the cold and dust of night, and the instant he awakes in the morning, opens, cleanses itself with a fluid which it has prepared during the night and kept in readiness, and repeats this routine of duty day after day for half a century without becoming impaired. Such, nevertheless, is the wonderful structure of the window of the body, the eye. In some scientific works that have recently been published, curious investigations have been made known. It has been shown that the eye is impressed momentarily, as a photographic plate is impressed by the rays of the sun. But the photography of the eye has this extraordinary quality, that one image passes away and another takes its place immediately, without confusion or indistinctness. But the most wonderful assertion of all is, that under the excitement of memory, these photographic images are restored, and that when, in our mind's eye, we see the image of some dear departed friend, the retina really revives an image which once fell upon its sensitive surface, and which image has been stored up for many years in the sacred portfolio of its affections. Another extraordinary assertion is one which comes supported by a degree of authenticity that entitles it to consideration. It is said that the eye of a dead man retains an impression of the last picture that fell upon the faithful retina. Dr. Sandford of America examined the eye of a man named Beardley, who had been murdered at Auburn, and he published in the Boston Atlas the following statement. At first we suggested the saturation of the eye in a weak solution of atropine, which evidently produced an enlarged state of the pupil. On observing this, we touched the end of the optic nerve with the extract, when the eye instantly became protuberant. We now applied a powerful lens, and discovered in the pupil the rude, worn-away figure of a man, with a light coat, beside whom was a round stone, standing or suspended in the air, with a small handle stuck in the earth. The remainder was debris, evidently lost from the destruction of the optic nerve, and its separation from the mother brain. Had we performed the operation when the eye was entire in the socket, with all its powerful connection with the brain, there is not the least doubt but that we should have detected the last idea and impression made on the mind and eye of the unfortunate man. The picture would evidently be entire, and perhaps we should have had the contour, or better still the exact figure of the murderer. The last impression on the brain before death is always more terrible from fear than any other cause, and figures impressed on the pupil more distinct, which we attribute to the largeness of the optic nerve, and its free communication with the brain. Whether the supposition, which seems to be supported by the experiment above detailed, be correct or not, it is in no sense more wonderful than the facts which are already known respecting this curious and perfect organ. Be not rash with thy mouth, and let not thine heart be hasty to utter anything before God. For God is in heaven, and thou upon earth, therefore let thy words be few. Ecclesiastes 5. The nose is given us for two purposes, to enable us to respire and to smell. As odours rise from the surface of the earth, the cup or the funnel of the nose is turned down to meet them. In the nostrils, hair again serves a useful purpose. It not only warms the air which enters the nostrils, but it springs out from all sides and forms an intersecting net, closing the nostrils against dust and the intrusion of small insects. If by any means, as when taking a sharp sniff, foreign matters enter the nostrils, the nose is armed with a set of nerves which communicate the fact to certain muscles, and the organs of respiration unite with those muscles to expel the intruding substances. In this action, the diaphragm, or the muscle which divides the abdomen from the chest, is pressed down, the lungs are filled with air, the passage by which that air would otherwise escape through the mouth is closed up, and then all at once, with considerable force, the air is pressed through the nostrils, to free them from the annoying substance. So great is the force with which this action takes place, that the passage into the mouth is generally pushed open, occasioning the person in whom the action takes place to cry, "Ch!" and thus is formed what is termed a sneeze. As with the eye, so with the nose. Innumerable nerves are distributed over the lining membrane, and these nerves are connected with larger nerves passing to the brain, through which everything relating to the sense of smell is communicated. The nose acts like a custom-house officer to the system. It is highly sensitive to the odour of most poisonous substances. It readily detects hemlock, henbane, monk's hood, and the plants containing prussic acid. It recognises the fetid smell of drains, and warns us not to breathe the polluted air. The nose is so sensitive that air containing a 200,000th part of bromine vapour will instantly be detected by it. It will recognise the 1,300,000th part of a grain of otto of roses, or the 13,000,000th part of a grain of musk. It tells us in the mornings that our bedrooms are impure. It catches the first fragrance of the morning air, and conveys to us the invitation of the flowers to go forth into the fields and inhale their sweet breath. To be led by the nose has hitherto been used as a phrase of reproach, but to have had a good nose and to follow its guidance is one of the safest and shortest ways to enjoyment of health. The mouth answers the fourfold purpose of the organ of taste, of sound, of mastication, and of breathing. In all of these operations, except in breathing, the various parts of the mouth are engaged. In eating we use the lips, the tongue, and the teeth. The teeth serve the purpose of grinding the food. The tongue turns it during the process of grinding, and delivers it up to the throat for the purposes of the stomach, when sufficiently masticated. The lips serve to confine the food in the mouth and assist in swallowing it, and there are glands underneath the tongue and in the sides of the mouth, which pour in a fluid to moisten the food, and so watchful are those glands of their duty that the mere imagination frequently causes them to act. Their fluid is required to modify the intensity of different flavours and condiments in which man with his love of eating will indulge. Thus, when we eat anything very acid, as a lemon, or anything very irritating, as cayenne pepper, the effect thereof upon the sensitive nerves of the tongue is greatly modified by a free flow of saliva into the mouth. And if we merely fancy the taste of any such things, those glands are so watchful that they will immediately pour out their fluid to mitigate the supposed effect. I say unto you, swear not at all, neither by heaven, for it is God's throne, nor by the earth, for it is his footstool. Matthew 5. In speaking we use the lips, the teeth, the tongue, and the chest supplies air, which being controlled in its emission by a delicate apparatus at the mouth of the windpipe, causes the various sounds which we have arranged into speech, and by which under certain laws we are enabled to understand each other's wants, participate in each other's emotions, express our loves, our hopes, our fears, and glean those facts, the accumulation of which constitutes knowledge, enhances the happiness of man, and elevates him in its ultimate results above the lower creatures to which the blessing of speech is denied. The curious structure of the tongue and the organs of speech would fill a very interesting volume. The tongue is unfortunately much abused, not only by those who utter foul words and convert the blessing of speech, which should improve and refine, into a source of wicked and profane language, but it constantly remonstrates against the abuse of food, and the use of things which are not only unnecessary for the good of our bodies, but prejudicial to their health. When the body is sufficiently fed, the tongue ceases its relish and derives no more satisfaction from eating, but man contrives a variety of inventions to whip the tongue up to an unnatural performance of its duty, and thus we not only overeat, but eat things that have no more business in our stomachs than have the stones that we walk upon. Can we wonder then that disease is so prevalent, and that death calls for many of us so soon? That wonderful essence, the soul of man, rises above all finite knowledge. Its wonders and powers will never probably be understood until when, in a future state of existence, the grandest of all mysteries shall be explained. When we talk of the brain, we speak of that which 'tis easy to comprehend as the organ or the seat of the mind. When we speak of the mind, we have greater difficulty in comprehending the meaning of the term we employ. But when we speak of the soul, we have reached a point which defies our understanding, because our knowledge is limited. The brain may be injured by a blow, the mind may be pained by a disagreeable sight, or offended by a harsh word, but the soul can only be influenced secondarily through the mind, which is primarily affected by the organs of the material senses. Thus the happiness or the misery of the soul depends to a very great extent upon the proper fulfilment of the duties of the senses, which are the servants of the soul, over which the mind presides, as the steward who meditates between the employer and the employed. The ear, which is taught to delight in sweet sounds and in pure language, is a better servant of the master soul than one which delights not in music, and which listens, with approbation or indifference, to the oaths of the profane. The eye, which rejoices in the beauties of nature, and in scenes of domestic happiness and love, is a more faithful servant than one that delights in witnessing scenes of revelry, dissipation, and strife. The nose, which esteems the sweet odour of flowers, or the life-giving freshness of the pure air, is more dutiful to his master than one that rejects not the polluted atmosphere of neglected dwellings. The mouth, which thirsts for morbid gratification of taste, is more worthless than one which is contented with wholesome viands, and ruled by the proper instincts of its duty. Who that can understand the wonderful structure of the tongue, and the complicated mechanism of the organs of speech and of hearing, could be found to take pleasure in the utterance of oaths, and of words of vulgar meaning? Were those beautiful cords that like threads of silk are woven into the muscular texture of the mouth, and along with the essence of life travels with the quickness of thought, to do the bidding of the will, were they given for no higher use than to sin against God who gave them, and upon whose mercy their existence every moment depends? Out of the same mouth proceedeth blessing and cursing. My brethren, these things ought not so to be. James 3. The actions of the senses must necessarily affect the mind, which is the head steward of the soul, and the soul becomes rich in goodness or poor in sin, in proportion as the stewardship, held by his many servants, is rightly or wrongfully fulfilled. As in an establishment where the servants are not properly directed and ruled, they often gain the ascendancy, and the master has no power over them. So with man, when he gives himself up to sensual indulgences. The soul becomes the slave of the senses, the master is controlled by the servant. With regard to the mechanism of motion, let us take the case of a man who is walking a crowded thoroughfare, and we shall see how active are all the servants of the soul under the influence of the mind. He walks in a given direction, but for the act of volition in the mind not a muscle would stir. The eye is watching his footsteps. There is a stone in his path. The eye informs the mind communicates with the brain, and the nerves stimulate the muscles of the leg to lift the foot a little higher, or turn it on one side, and the stone is avoided. The eye alights on a familiar face, and the mind remembers that the eye has seen that face before. The man goes on thinking of the circumstance under which he saw that person, and partially forgets his walk and the direction of his steps. But the nerves of volition and motion unite to keep the muscles up to their work, and he walks on without having occasion to think continually, I must continue walking. He has not to make an effort to lift his leg along between each interval of meditation. He walks and meditates the while. Presently a danger approaches him from behind. The eye sees it not, knows no more, in fact, than if it were dead, but the ear sounds the alarm, tells the man, by the rumbling of a wheel and the tramp of horses' feet, that he is in danger, and then the nerves, putting forth their utmost strength, whip the muscles up to the quick performance of their duty. The man steps out of the way of danger and is saved. He draws near to a sewer, which is vomiting forth its poisonous exhalations. The eye is again unconscious, it cannot see the poison lurking in the air. The ear too is helpless, it cannot bear witness to the presence of that enemy to life. But the nose detects the noxious agent, and then the eye points out the direction of the sewer, and guides his footsteps to a path where he may escape the injurious consequences. A clock strikes, the ear informs him that it is the hour of an appointment, the nerves stimulate the muscles again, and he is hastened onward. He does not know the residence of his friend, but his tongue asks for him, and his ear makes known the reply. He reaches the spot, sits, rests. The action of the muscles is stayed. The nerves are for a time at rest. The blood which has flown freely to feed the muscles while they were working goes more steadily through the arteries and veins, and the lungs, which had been purifying the blood in its course, partake of the temporary rest. I am but a little child. I know not how to go out or come in. 1 Kings 3. Let us remember that there are two sets of muscles, acting in unison with each other, to produce the various motions. They are known by the general terms of flexors and extensors. The first enable us to bend the limbs, the other to bring the limbs back to their former position. The flexors enable us to close the hand, the extensors to open it again. The flexors enable us to raise the foot from the ground. The extensors set the foot down again in the place desired. Consider for a moment the nicety with which the powers of these muscles must be balanced, and the harmony which must subsist between them in their various operations. When we are closing the hand, if the extensor muscles did not gradually yield to the flexors, if they gave up their hold all at once, the hand, instead of closing with gentleness and ease, would be jerked together in a sudden and most uncomfortable manner. If, in such a case, you were to lay your hand with its back upon the table, and wish to close the hand, the fingers would fall down upon the palm suddenly, like the lid of a box. Again, consider how awkward it would be in such a case. Our walk through the streets would become a series of jumps and jerks, when a man had raised his foot after it had been jerked up. There it would stand fixed for a second before the opposite muscles could put on their power to draw it down again. This case is not at all supposititious. There is a derangement frequently observed in horses, in which one set of muscles becomes injured, and we may see horses suffering from this ailment, trotting along with only one of their legs jerking up much higher than the others, and set down again with difficulty, just in the manner described. It is also to be observed that very nice proportions must exist between the sizes of the muscles and the sizes of the bones. If this were not the case, our motions, instead of being firm and steady, would be all shaky and uncertain. In old persons the muscles become weak and relaxed. Hence there is a tendency in the movements of the aged to fall, as it were, together. The head is no longer erect, the body bends, the knees totter, and the arms lean towards the body as for support. In the child a somewhat similar state of thing exists. The muscles have not been properly developed, nor have they been brought sufficiently under the control of the nervous system. The child therefore totters and tumbles about, and it is not until it has stumbled and tumbled some hundreds of times in its little history that the muscles have become strong enough to fulfil their office, or have been brought sufficiently under the control of the nervous system to perform well the various duties required from them. In all these things we recognise the perfection of the divine works. We are too apt to overlook this perfection, because it prevails in everything, but by speculating upon what inconveniences we might suffer, were not things ordained as they are, we obtain most convincing evidences of divine goodness and wisdom. Watchman, what of the night? The watchman said, The morning cometh, and also the night. If ye will enquire ye. Return, come. Isaiah 21. Having taken this view of the muscular system of the external man, let us turn our attention to the muscles of the internal organs. The muscles of which we have been speaking are called the voluntary muscles, because we have them under our own control. They are subject to the influences of our will. But there is the other set of muscles. What are they? We talk of the beating or of the palpitation of the heart. But what is it that causes the heart to beat? You cannot, if you wish it, make your heart beat more quickly or more slowly. Place your finger on your pulse and notice the degree of rapidity with which its pulsations follow. Now think that you should like to double the frequency of those pulsations. Say to the heart with your inner voice that you wish it to beat 120 times in a minute instead of 60. It does not obey you. It does not appreciate your command. Now place your finger on the table and your watch by the side of your hand, and tell your finger to beat 60 times in a minute, or 100 times, or 150 times, or 200 times, and the finger will obey you, because it is moved by muscles which are subject to the will, while the heart is composed of muscles which are not subject to the will. Why should this be? Why should man have the power to regulate his finger and not to regulate his heart? For the sustentation of our bodies it is needful that the blood should ever be in circulation. If the heart were to cease beating only for 3 or 4 minutes, perhaps less, life would be extinct. In this short time the whole framework of man, beautiful in its proportions, perfect in its parts, would pass into the state of dead matter, and would simply wait the decay that follows death. The eye would become dull and glazed, the lips would turn blue, the skin would acquire the coldness of clay, love, hope, joy would all cease. The sweetest, the fondest ties would be broken. Flowers might bloom and yield their fragrance, but they would be neither seen nor smelt. The sun might rise in its brightest splendour, yet the eye would not be sensitive to its rays. The rosy-cheeked child might climb the paternal knee, but there, stiff, cold, without joy, or pain, or emotion of any kind, unconscious as a block of marble, would sit the man whose heart for a few moments had ceased to beat. How wise then, and how good of God, that he has not placed this vital organ under our own care. How sudden would be our bereavements, how frequent our deaths, how sleepless our nights, and how anxious our days, if we had to keep our own hearts at work, and death the penalty of neglect. And yet before we were born, until we reach life's latest moment, through days of toil and nights of rest, even in the moments of our deepest sin against the God who at the time is sustaining us, our hearts beat on, never stopping, never wearying, never asking rest. This brings us to another reflection. Our arms get weary, our legs falter from fatigue, the mind itself becomes overtaxed, and all our senses fall to sleep. The eye sees not, the ear is deaf to sound, the sentinels that surround the body, the nerves of touch, are all asleep. You may place your hand upon the brow of the sleeping man, and he feels it not. Yet unseen, unheard, without perceptible motion, or the slightest jar to mar the rest of the sleeper, the heart beats on, and on, and on. As his sleep deepens, the heart slackens its speed, that his rest may be the more sound. He has slept for 8 hours, and the time approaches for his awakening. But is the heart weary, that heart which has toiled through the long and sluggard night? No. The moment the waking sleeper moves his arm, the heart is aware that a motion has been made. The effort and exercise are about to begin. The nerves are all arousing to action. The eyes turn in their sockets, the head moves upon the neck. The sleeper leaves his couch, and the legs are once more called upon to bear the weight of the body. Blood is the food of the eye, the food of the ear, of the foot, the hand, and every member of the frame. While they labour they must be fed. That is the condition of their life, the source of their strength. The heart, therefore, so far from seeking rest, is all fresh and vigorous for the labours of the day, and proceeds to discharge its duty so willingly that we do not even know of the movements that are going on within us. Awake up, my glory, awake, psaltery and harp, I myself will wake early. Psalm 57. Thus we have seen the difference between the voluntary and the involuntary muscles, and we have perceived the goodness of our Creator in not entrusting to our keeping the control of an organ so vital to life as the heart. But the heart is not the only organ which thus works unseen and unfelt. There are the lungs and the muscles of the chest, the stomach and other parts occupying the abdomen, together with all those muscular filaments which enter into the structure of the coats and valves of the blood vessels, and which assist to propel the blood through the system. All these are at work at every moment of man's life, and yet, so perfect is this complicated machinery, that we really do not know, except by theory, what is going on within us. During the time that the sleep has been at rest, the stomach has been at work digesting the food which was last eaten. Then the stomach has passed the macerated food into the alimentary canal. The liver has poured out its secretion and produced certain changes in the condition of the dissolved food, and the lacteals, of which there may be many thousands, perhaps millions, have been busy sucking up those portions of the food which they know to be useful to the system, while they have rejected all those useless and noxious materials upon which the liver, like an officer of health, had set his mark as unfitting for the public use. This busy life has gone on uninterruptedly. Every member of that body, every worker in that wonderful factory, has been unremitting in its duty, and yet the owner, the master, has been asleep, and wakes up finding every bodily want supplied. Notwithstanding that much has already been said of the wonders that pertain to the eye, it is not yet being considered as the seat of tears, those mute but eloquent utterers of the sorrows of the heart. Beautiful tear, whether lingering upon the brink of the eyelid, or darting down the furrows of the careworn cheek, thou art sublime in thy simplicity, great because of thy modesty, strong from thy very weakness, offspring of sorrow, who will not own thy claim to sympathy, who can resist thy eloquence, who can deny mercy when thou pleadest. Every tear represents some indwelling sorrow preying upon the mind and destroying its peace. The tear comes forth to declare the inward struggle, and to plead a truth against further strife. How meet that the eye should be the seat of tears, where they cannot occur unobserved, but blending with the beauty of the eye itself, must command attention and sympathy. Whenever we behold a tear, let our kindliest sympathies awake. Let it have a sacred claim upon all that we can do to succour and comfort under affliction. What rivers of tears have flown, excited by the cruel and perverse ways of man. War has spread its carnage and desolation, and the eyes of widows and orphans have been suffused with tears. Intemperance has blighted the homes of millions, and weeping and wailing have been incessant. 1,000 other evils which we may conquer have given birth to tears enough to constitute a flood, a great tide of grief. Suppose we prize this little philosophy, and each one determine never to excite a tear in another. Watching the eye as the telegraph of the mind within, let us observe it with anxious regard, and whether we are moved to complaint by the existence of supposed or real wrongs, let the indication of the coming tear be held as a sacred truce to unkindly feeling, and our efforts be devoted to the substitution of smiles for tears. Who is as the wise man, and who knoweth the interpretation of a thing? A man's wisdom maketh his face to shine, and the boldness of his face shall be changed. Ecclesiastes 8. There is only one other matter to which we think it necessary to allude, before we pass to the concluding section of our work. It has been said that snow which is white keeps the earth warm, that white as a colour is cool, and that black absorbs heat. These assertions may appear to be contradictory, and, taken in connection with the fact of the blackness of the skin of negroes in hot climates, may at a first glance be considered unsatisfactory. They are, however, perfectly reconcilable, and that too without the slightest evasion of the real bearing of the asserted facts. White snow is warm on account of its texture, which, being woolly, forms a layer of non-conducting substance over the surface of the earth, and keeps in its warmth. White clothing worn as a garment consisting of a thin material is cool, because the white colour turns back the rays of the sun that fall upon it. Swan's down, although white, being a non-conductor, would be warm, because though it would reflect the light and heat, it would confine and accumulate the heat of the body. The black skin of the negro is a living texture, and is not subject to the same laws that govern dead matter. The skin of the negro is largely provided with cells which secrete a fatty matter that acts as a non-conductor of the external heat, and also a much larger number of perspiratory glands that exist in the skins of Europeans. The perspiration cools the blood and carries off the internal heat, while the oily matter gives a shining surface to the skin and reflects the heat, to which the fatty matter presents itself as a non-conductor. We see, therefore, that there are two express provisions for the cooling of the negro's skin, independent of the colour. The skin of the Eskimo who inhabits a cold country is white, though it might be supposed that a black skin would best conduce to the warmth of his body. But the Eskimo has, underneath his skin, a thick coating of fat, by which the internal heat of the body is prevented from escaping. The resume of the subjects embodied in the form of question and answer in the previous pages will serve to impress the more important truths upon the mind of the reader, while it has enabled us to fill up many omissions necessitated by the arbitrary form of catechetical composition. Ask now the beasts, and they shall teach thee, and the fowls of the air, and they shall tell thee. Job 12. End of chapter 51, part 3.
Chapter 52 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 52. Ask now the beasts, and they shall teach thee, and the fowls of the air, and they shall tell thee. Job 12. 1029. Why are there so many bodily forms in the animal creation? Because the various creatures which God has created have different modes of life, and the forms of their body will be found to present a perfect adaptation to the lives allotted to them. Because also, the beauty of creation depends upon the variety of objects of which it consists, and the greatness of the Creator's power is shown by the diversity of ends accomplished by different means. 1030. Why are birds covered with feathers? Because they require a high degree of warmth on account of the activity of their muscles, but in providing that warmth it was necessary that their coats should be of the lightest material so as not to impair their powers of flight, and feathers combine the highest warming power with the least amount of weight. 1031. Why have ostriches small wings? Because having long legs, they do not require their wings for flight. They are merely used to steady their bodies while running. 1032. Why are ostrich feathers soft and downy? Because, as the feathers are not employed for flight, the strength of the feather as constructed for flying is unnecessary, and the feathers therefore consist chiefly of a soft down. 1033. Why have water bird feathers of a close and smooth texture? Because such feathers keep the body of the bird warm and dry by repelling the water from their surface. A bird could scarcely move through the water with the downy feathers of the ostrich because of the amount of water the down would absorb. 1034. Why is man born without a covering? Because man is the only animal that can clothe itself. As in the various pursuits of life he wanders to every part of the globe, he can adapt himself to all climates and to any season. Who teacheth us more than the beasts of the earth, and maketh us wiser than the fowls of heaven? Job 35. 1035. Why do the furs of animals become thicker in the winter than in the summer? Because the Creator has thus provided for the preservation of the warmth of the animals during the cold months of winter. 1036. Why does a black down grow under the feather of birds as winter approaches? Because the down is a non-conductor of heat, and black the warmest color. It is therefore best adapted to keep in their bodily warmth during the cold of winter. 1037. Why has man no external appendage to his mouth? Because his hands serve all the purposes of gathering food and conveying it to the mouth. Man's mouth is simply an opening. In other animals, it is a projection. 1038. Why have dogs and other carnivorous animals long pointed teeth projecting above the rest? Because as they have not hands to seize and control their food, the projecting teeth enable them to snap and hold the objects which they pursue for food. 1039. Why is the under jaw of the hog shorter and smaller than the upper one? Because the animal pierces the ground with its long snout, and then the small under jaw works freely in the furrow that has been opened in quest of food. 1040. Why have birds hard beaks? Because having no teeth, the beak enables them to seize, hold, and divide their food. 1041. Why are the beaks of birds generally long and sharp? Because the greater number of birds live by picking up small objects, such as worms, insects, seeds, etc. The sharp beak, therefore, serves as fine pincers, enabling them to take hold of their food conveniently. As the fishes that are taken in an evil net, and as the birds that are caught in the snare, so are the sons of men snared in an evil time when it falleth suddenly upon them. Ecclesiastes 9. 1042. Why have snipes and woodcocks long tapering bills? Because they live upon worms which they find in the soft mud of streams and marshy places. Their long bills, therefore, enable them to dig down into the mud after their prey. 1043. Why have woodcocks, snipes, etc. nerves running down to the extremity of their bills? Because as they dig for their prey in the soft sand and mud, they cannot see the worms upon which they live. Nerves are therefore distributed to the very point of their bills, where in other birds nerves are entirely absent, to enable them to prehend their food. 1044. Why have ducks and geese square-pointed bills? because they not only feed by dabbling in soft and muddy soil, but they consume a considerable quantity of green food, and their square bills enable them to crop off the blades of grass. Let the heaven and earth praise him, the seas, and everything that moveth therein. Psalm 69. 1045. Why has the spoonbill a long expanded bill lined entirely with sharp muscular points? Because the bird lives by suction, dipping its broad bill in search of aquatic worms, mollusks, insects, and the roots of weeds. The bill forms a natural spoon, and the muscular points enable the bird to filter the mud and to retain the nourishment which it finds. 1046. Why has the spoonbill long legs? Because it wades in marshy places to find its food. Its legs are therefore long for the purpose of keeping its body out of the water and above the smaller aquatic plants, while it searches for its prey. 1047. Why have the parrots, etc., crooked and hard bills? Because they live upon nuts, the stones of fruit, and hard seeds. The shape of the bill, therefore, enables them to hold the nut or seed firmly, and the sharp point enables them to split or remove the husks. 1048. Why can a parrot move its upper as well as its lower bill? Because by that means it is enabled to bring the nut or seed nearer the fulcrum or joint of the jaw. It therefore acquires greater power, just as with a pair of nutcrackers we obtain increased power by setting the nut near to the joint. 1049. Why have animals with long necks large throats? Animals that graze or feed from the ground generally have a more powerful muscular formation of the throat than those which feed in other positions, because a greater effort is required to force the food upward than would be needed to convey it down. 1050. Why are the bones of birds hollow? Because they are thereby rendered lighter, and do not interfere with the flight of the bird as they would do if they were solid. Greater strength is also obtained by the cylindrical form of the bone, and a larger surface afforded for the attachment of powerful muscles. And my hand hath found as a nest the riches of the people, and as one gathereth eggs that are left, have I gathered all the earth, and there was none that moved the whip, or opened the mouth, or peeped. Isaiah 10. 1051. Why do all birds lay eggs? Because to bear their young in any other manner would encumber the body and materially interfere with their powers of flight. As soon as an egg becomes large and heavy enough to be cumbersome to the bird, it is removed from the body. A shell, impervious to air, protects the germ of life within until from 2 to 20 eggs have accumulated, and then, although laid at different intervals, their incubation commences together, and the young birds are hatched at the same time. End of chapter 52.
Chapter 53 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 53. 1052. Why have birds with long legs short tails? Because the tails of birds are used to guide them through the air by a kind of steerage. When birds with long legs take to flight, they throw their legs behind, and they then serve the same purpose as a tail. 1053. Why have fishes fins? The fins of fishes are to them what wings and tails are to birds, enabling them to rise in the fluid in which they live by the reaction of the motions of the fins upon its substance. Speak to the earth, and it shall teach thee, and the fishes of the sea shall declare unto thee. Who knoweth not in all these that the hand of the Lord hath wrought this? Job 12. 1054. Why are the fins of fishes proportionately so much smaller than the wings of birds? Because there is less difference between the specific gravity of the body of a fish and the water in which it moves than between the body of a bird and the air in which it flies. The fish, therefore, does not require such an expanded surface to elevate or guide it. 1055. Why have fishes scales? Because scales, while they afford protection to the bodies of fish, are conveniently adapted to their motions, and as the scales present no surface to obstruct their passage through the water, as hair or feathers would do, they evidently form the best covering for the aquatic animal. 1056. Why do fishes float in streams when they are not swimming, with their heads towards the stream? Because they breathe with the transmission of water over the surface of their gills, the water entering at the mouth and passing over the gills behind. When, therefore, they lie motionless with their heads to the stream, they are in that position which naturally assists their breathing process. 1057. Why have fishes air bladders? Because, as the density of water varies greatly at different depths, the enlargement or concentration of the bladder regulates the relation of the specific gravity of the body of the fish to that of the water in which it moves. 1058. Why have whales a very large development of oily matter about their heads? Because their heads are thereby rendered the lighter part of their bodies, and a very slight exertion of the part of the animal will bring its head to the surface to breathe air, which it constantly requires. 1059. Why have birds that swim upon water web feet? Because the spreading out of the toes of the bird brings the membrane between the toes into the form of a fin or water wing, by striking which against the water the bird propels itself along. And Jesus said unto him, The foxes have holes, and the birds of the air have nests, but the Son of Man hath not where to lie his head. Matthew 13. 1060. Why have birds that swim and dive short legs? Because long legs would greatly impede the motions in the water by becoming repeatedly entangled in the weeds and by striking against the bottom. Waders, however, require long legs because they have to move about through the tall vegetation of marshy borders. 1061. Why have the feet of the heron, cormorant, etc. deep rough notches upon their under surface? Because, as those birds live by catching fish, they are enabled by the notches in their feet to hold the slippery creatures upon which they feed. 1062. Why have otters, seals, etc. web feet? Because, while the feet enable them to walk upon the land, they are equally effective in their action upon the water, and hence they are adapted to the amphibious nature of the animals to which they belong. 1063. Why do the external ears of animals of prey, such as cats, tigers, foxes, wolves, hyenas, etc., bend forward? Because they collect the sounds that occur in the direction of the pursuit, and enable the animal to track its prey with greater certainty. Doth the hawk fly by thy wisdom, and stretch her wings toward the south? Doth the eagle mount up at thy command, and make her nest on high? 1064. Why do the ears of animals of flight, such as hares, rabbits, deer, etc., turn backward? Because they thereby catch the sounds that give them warning of the approach of danger. 1065. Why has the stomach of the camel a number of distinct bags, like so many separate stomachs? Because water is stored up in the separate chambers of the stomach, apart from the solid aliment, so that the animal can feed without consuming all its drink. It is thereby able to retain water to satisfy its thirst while traveling across hot deserts, where no water could be obtained. 1066. Why do woodpeckers tap at old trees? Because by boring through the decayed wood with the sharp and hard bills with which they are provided, they get at the haunts of the insects upon which they feed. 1067. Why are woodpeckers' tongues about 3 times longer than their bills? Because if their bills were long, they would not bore the trees so efficiently, and when the trees are bored and the insects alarmed, they endeavor to retreat into the hollows of the wood, but the long, thin tongue of the woodpecker fixes them in its sharp, horny point and draws them into the mouth of the bird. 1068. Why have the Indian hogs large horns growing from their nostrils and turning back towards their eyes? Because the horns serve as a defense to the eyes, while the animal forces its way through the thick underwood in which it lives. 1069. Why have calves and lambs and the young of horned cattle generally no horns while they are young? Because the presence of horns would interfere with the suckling of the young animal. When, however, it is able to feed itself by browsing, then the horns begin to grow. She dwelleth and abideth on the rock, upon the crag of the rock, and the strong place. From thence she seeketh the prey, and her eyes behold afar off. Her young ones also suck up blood, and where the slain are, there she is. Job 39. 1070. Why have infants no teeth? Because the presence of teeth would interfere with their suckling, while the teeth would be of no service until the child could take food requiring mastication. 1071. Why cannot flesh-eating animals live upon vegetables? Because the gastric juice of a flesh-eating animal, being adapted to the duty which it has to perform, will not dissolve vegetable matter. 1072. Why have birds gizzards? Because having no teeth, the tough and fibrous gizzards are employed to grind the food preparatory to digestion. 1073. Why are small particles of sand, stone, etc. found in the gizzards of birds? Because, by the presence of those rough particles which become embedded in the substance of the gizzard, the food of the bird is more effectively ground. When our fowls are abundantly supplied with meat, they soon fill their craw, but it does not immediately pass thence into the gizzard. It always enters in small quantities, in proportion to the progress of trituration. In like manner as in a mill, a receiver is fixed above the two large stones, which serve for grinding the corn, which receiver, although the corn be put into it by bushels, allows the grain to dribble only in small quantities into the central hole in the upper millstone. Paley. End of chapter 53.
Chapter 54 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 54. 1074. Why has the mole hard and flat feet armed with sharp nails? Because the animal is thereby enabled to burrow in the earth in search for worms. Its feet are so many shovels. 1075. Why is the mole's fur exceedingly glossy and smooth? Because its smoothness enables it to work underground without the soil sticking to its coat, by which its progress would be impeded. From soils of all kinds, the little worker emerges shining and clean. I know all the fowls of the mountains, and the wild beasts are mine. Psalm 50. What I have always most admired in the mole is its eyes. This animal occasionally visiting the surface, and wanting, for its safety and direction, to be informed when it does so, or when it approaches, a perception of light was necessary. I do not know that the clearness of sight depends at all upon the size of the organ. What is gained by the largeness or prominence of the globe of the eye is width in the field of vision. Such a capacity would be of no use to an animal which was to seek its food in the dark. The mole did not want to look about it, nor would a large advanced eye have been easily defended from the annoyance to which the life of the animal must constantly expose it. How, indeed, was the mole, working its way underground, to guard its eyes at all? In order to meet this difficulty, the eyes are made scarcely larger than the head of a corking pin, and these minute globules are sunk so deeply in the skull and lie so sheltered within the velvet of its covering, as that any contraction of what may be called the eyebrows not only closes up the apertures which lead to the eyes, but presents a cushion, as it were, to any sharp or protruding substance which might push against them. This aperture, even in its ordinary state, is like a pinhole in a piece of velvet, scarcely pervious to loose particles of earth. Paley. 1076. Why has the elephant a short unbending neck? Because the elephant's head is so heavy that it could not have been supported at the end of a long neck, or lever, without a provision of immense muscular power. Be not afraid, ye beasts of the field, for the pastures of the wilderness do spring, for the tree beareth her fruit, the fig tree and the vine do yield their strength. Joel 2. 1077. Why has the elephant a trunk? The trunk of an elephant serves as a substitute for a neck, enabling the animal to crop the branches of trees or to raise water from the stream. 1078. Why do the hind legs of elephants bend forward? Because the weight of the animal is so great that when it lay down it would rise with great difficulty, if its legs bent outward, as do the legs of other animals. Being bent under the body, they have a great power of pushing directly upward, when the powerful muscles of the thighs straighten them. According to Cuvier, the number of muscles in an elephant's trunk amounts to 40,000, all of which are under the will, and it is to these that the proboscis of this animal owes its flexibility. It can be protruded or contracted at pleasure, raised up or turned to either side, coiled round on itself or twined around any object. With this instrument the elephant collects the herbage on which he feeds and puts it into his mouth. With this he strips the trees of their branches, or grasps his enemy and dashes him to the ground. But this admirable organ is not only adapted for seizing or holding substances of magnitude, it is also capable of plucking a single leaf, or of picking up a straw from the floor. The orifices of the canal of the extremity are encircled by a projecting margin, produced anteriorly into a finger-like process endowed with a high degree of sensibility and exceedingly flexible. It is at once a finger for grasping and a feeler. The division between the two nasal orifices, or their elevated sides, serves as a point against which to press, and thus it can pick up or hold a small coin, a bit of biscuit, or any trifling thing with the greatest ease. Knight's Animal Kingdom. 1079. Why have bats hooked claws in their wings? Because bats are almost destitute of legs and feet, at least those organs are included in their wings. If they alight upon the ground, they have great difficulty in again taking to the wing, as they cannot run or spring to bring their wings in action upon the air. At the angle of each wing there is placed, therefore, a bony hook, by which the bat attaches itself to the sides of rocks, caves, and buildings, laying hold of crevices, joinings, chinks, etc., and when it takes flight, it unhooks itself, and its wings are at once free to strike the air. 1080. Why does the bat fly by night? Because it lives chiefly upon moths, which are night-flying insects. So are the paths of all that forget God, and the hypocrite's hope shall perish, whose hope shall be cut off, and whose trust shall be a spider's web. Job 8. 1081. Why does the bat sleep during the winter? Because, as the winter approaches, the moths and flying insects upon which it feeds disappear. If therefore it did not sleep through the winter, it must have starved. 1082. Why has the spider the power of spinning a web? Because, as it lives upon flies, but is deficient of the power of flying in pursuit of them, it has been endowed with an instinct to spread a snare to entrap them, and with the most wonderful machinery to give that instinct effect. There are few things better suited to remove the disgust into which young people are betrayed on the view of some natural objects than this of the spider. They will find that the most despised creature may become a subject of admiration, and be selected by the naturalist to exhibit the marvelous works of the creation. The terms given to these insects lead us to expect interesting particulars concerning them, since they have been divided into vagrants, hunters, swimmers, and water spiders, sedentary and mason spiders, thus evincing a variety in their condition, activity, and mode of life. And we cannot be surprised to find them varying in the performance of their vital functions, as, for example, in their mode of breathing, as well as in their extremities and instruments. Of these instruments, the most striking is the apparatus for spinning and weaving, by which they not only fabricate webs to entangle their prey, but form cells for their residence and concealment, sometimes living in the ground, sometimes under water, yet breathing the atmosphere. Corresponding with their very singular organization are their instincts. We are familiar with the watchfulness and voracity of some spiders, when their prey is indicated by the vibration of the cords of their network. Others have the eye and disposition of the lynx or tiger, and after couching in concealment, leap upon their victims. Some conceal themselves under a silken hood or tube, 6 eyes only projecting. Some bore a hole in the earth, and line it as finely as if it were done with a trowel and mortar, and then hang it with delicate curtains. A very extraordinary degree of contrivance is exhibited in the trap-door spider. This door, from which it derives its name, has a frame and hinge on the mouth of the cell, and is so provided that the claw of the spider can lay hold of it, and whether she enters or goes out, says Mr. Kirby, the door shuts of itself. But the water spider has a domicile more curious still. It is under water, with an opening at the lower part for her exit and entrance, and although this cell be under water, it contains air like a diving bell, so that the spider breathes the atmosphere. The air is renewed in the cell in a manner not easily explained. The spider comes to the surface, a bubble of air is attracted to its body, with this air she descends and gets under her cell, and when the air is disengaged and rises into the cell, and thus, though under water, she lives in the air. There must be some peculiar property of the surface of this creature by which she can move in the water, surrounded with an atmosphere, and live under the water, breathing the air. The spider taketh hold with her hands, and is in kings' palaces. Proverbs 30. The chief instrument by which the spider performs these wonders is the spinning apparatus. The matter from which the threads are spun is the liquid contained in cells. The ducts from these cells open upon little projecting teats, and the atmosphere has so immediate an effect upon this liquid that upon exposure to it, the secretion becomes a tough and strong thread. 24 of these fine strands form together a thread of the thickness of that of the silkworm. We are assured that there are 3 different sorts of material thus produced, which are indeed required for the various purposes to which they are applied, as, for example, to mix up with the earth to form the cells, to line these cells, as with fine cotton, to make light and floating threads by which they may be conveyed through the air, as well as those meshes which are so geometrically and correctly formed to entrap their prey. Note by Lord Brougham to Paley's Natural Theology. For every beast of the forest is mine, and the cattle upon 1,000 hills. Psalm 50. 1083. Why have many insects a great number of eyes? Because the orb of the eye is fixed, there is therefore placed over the eye a multiple lens, which conducts light to the eye from every direction, so that the insect can see with a fixed eye as readily as it could have done with a movable one. As many as 1,400 eyes, or inlets of light, have been counted in the head of a drone bee. The spider has 8 eyes, mounted upon different parts of the head, 2 in front, 2 in the top of the head, and 2 on each side. 1084. Why have birds of prey no gizzards? Because their food does not require to be ground prior to digestion, as does the food of grain-eating birds. 1085. Why have earthworms no feet? Because the undulatory motion of their muscles serves them fulfill the purpose of progression needed by their mode of life. 1086. Why have mussels strong tendinous threads proceeding from their shells? Because as they live in places that are beaten by the surf of the sea, they moor their shells by those threads to rocks and timbers. 1087. Why have cockles stiff muscular tongues? Because, having no threads to moor themselves as the mussels have, they dig out with their tongues a shelter for themselves in the sand. 1088. Why do oxen, sheep, deer, etc. ruminate? Because they have no front teeth in the upper jaw, the place of which is occupied by a hardened gum. The first process, therefore, consists simply of cropping their food, which is passed into the paunch, to be brought up again and ground by the back teeth when the cropping process is over. Because in a wild state they are constantly exposed to the attacks of carnivorous beasts, and as the mastication of the large amount of vegetable food required for their sustenance would take a considerable time, they are provided with stomachs, by which they are enabled to fill their paunches quickly, and then, retiring to a place of safety, they bring their food up again and chew it at leisure. A righteous man regardeth the life of his beast, but the tender mercies of the wicked are cruel. Proverbs 12. 1089. Why can ruminating animals recover the food from their paunches? Because they have a voluntary power over the muscles of the throat, by which they can bring up the food at will. 1090. Why can they keep the unchewed food in the paunch from the cud they have chewed for nourishment? Because their stomachs are divided into 3 chambers. 1, the paunch, where the unchewed food is stored. 2, the reticulum, where portions of the food are received from the paunch, and moistened and rolled into a cud, to be sent up and chewed. And 3, the saltarium, which receives the masticated food and continues the process of digestion. In quadrupeds, the deficiency of teeth is usually compensated by the faculty of rumination. The sheep, deer, and ox tribe are without 4 teeth in the upper jaw. These ruminate. The horse and ass are furnished with teeth in the upper jaw and do not ruminate. In the former class, the grass and hay descend into the stomachs nearly in the state in which they are cropped from the pasture, or gathered from the bundle. In the stomach, they are softened by the gastric juice, which in these animals is unusually copious. Thus softened and rendered tender, they are returned a second time to the action of the mouth, where the grinding teeth complete at their leisure the trituration which is necessary, but which was before left imperfect. I say the trituration which is necessary, for it appears from experiments that the gastric fluid of sheep, for example, has no effect in digesting plants, unless they have been previously masticated, that it only produces a slight maceration, nearly as common water would do in a like degree of heat, but that when once vegetables are reduced to pieces by mastication, the fluid then exerts upon them its specific operation. Its first effect is to soften them and to destroy their natural consistency. It then goes on to dissolve them, not sparing even the toughest parts, such as the nerves of the leaves. I think it very probable that the gratification also of the animal is renewed and prolonged by this faculty. Sheep, deer, and oxen appear to be in a state of enjoyment whilst they are chewing the cud. It is then, perhaps, that they best relish their food. Paley. I am like a pelican of the wilderness. I am like an owl of the desert. I watch, and am as a sparrow alone upon the housetop. Psalm 102. End of chapter 54.
Chapter 55 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by
Darth Vader
and Catherine. The Reason Why by Robert Kemp Philp. Chapter 55.
1091. Why do quadrupeds that are vegetable eaters feed so continually?
Because their food contains but a small proportion of nutrition, so that it is necessary to digest a large quantity to obtain sufficient nourishment.
1092. Why do flesh-eating animals satisfy themselves with a rapid meal?
Because the food which they eat is rich in nutritious matter and more readily digestible than vegetable food. It does not therefore require the same amount of grinding with the teeth.
1093. Why does the pelican have a large pouch under its bill?
Because it subsists upon fish, generally of the smaller kind, and uses its pouch as a net for catching them. The pouch also serves as a paunch, in which the fish is stored, until the bird ceases from the exertion of fishing and takes its meal at leisure. And God created great whales, and every living creature that moveth, which the waters brought forth abundantly, after their kind, and every winged fowl after his kind. And God saw that it was good. Genesis 1. In their wild state they hover and wheel over the surface of the water, watching the shoals of fish beneath, and suddenly sweeping down, bury themselves in the foaming waves, rising immediately from the water by their own buoyancy. Up they soar, the pouch laden with fish scooped up during their momentary submersion. The number of fish the pouch of this species will contain may be easily imagined when we state that it is so dilatable as to be capable of containing 2 gallons of water. Yet the bird has the power of contracting this membranous expansion by wrinkling it up under the lower mandible until it is scarcely to be seen. In shallow inlets, which the pelicans often frequent, it nets its prey with great adroitness. The pelican chooses remote and solitary islands, isolated rocks in the sea, the borders of lakes and rivers, as its breeding place. The nest, placed on the ground, is made of coarse grasses, and the eggs, which are white, are 2 or 3 in number. While the female is incubating, the male brings fish to her in his pouch, and the young, when hatched, are assiduously attended by the parents, who feed them by pressing the pouch against the breast, so as to transfer the fish from the former into the throats of the young. This action has doubtless given origin to the old fable of the pelican feeding its young with blood drawn from its own breast. Knight's Animal Kingdom.
1094. Why do the smaller animals breed more abundantly than larger ones?
Because the smaller ones are designed to be the food of the larger ones, and are therefore created in numbers adapted to that end. An elephant produces but 1 calf, the whale but 1 young one. A butterfly lays 600 eggs. Silkworms lay from 1,000 to 2,000 eggs. The wasp 5,000. The ant 4,000 to 5,000. The queen bee 5,000 to 6,000, or 40,000 to 50,000 in a season. And a species of white ant, Termes fatalis, produces 86,400 eggs in a day. Birds of prey seldom produce more than 2 eggs. The sparrow and duck tribe frequently sit upon a dozen. In rivers there prevail 1,000 minnows for 1 pike, and in the sea 1,000,000 of herrings for a single shark, while of the animalcules upon which the whale subsists, there must exist hundreds of millions for 1 whale.
1095. Why is the whale feathery like laminae of whalebone extending from its jaws?
Because these feathery bones, lying side by side, form a sieve or strainer for the large volumes of water which the whale receives into its mouth, drawing off therefrom millions of small animals, which form a jelly-like mass upon which the whale feeds. A whale has been known to weigh as much as 249 tons, and its blubber yielded 4,000 gallons of oil. How many millions of living creatures must have gone to make up that enormous mass of animal matter? Hast thou given the horse strength? Hast thou cloaked his neck with thunder? He paveth the valley, and rejoiceth in his strength. He goeth on to meet the armed men. Job 39.
1096. Why have cats and various animals whiskers?
The whiskers of cats and of the cat tribe are exceedingly sensitive, enabling them, when seizing their prey in the dark, to feel its position most acutely. These hairs are supplied through their roots with branches of the same nerves that give sensibility to the lips, and that in insects supply their feelers.
1097. Why has the horse a smaller stomach proportionately than other animals?
Because the horse was created for speed. Had he the ruminating stomach of the ox, he would be quite unfitted for the labor which he now so admirably performs.
1098. Why has the horse no gallbladder?
Because the rapid digestion of the horse, by which its fitness for speed is greatly increased, does not require the storing up of the bile as in other animals, in which the digestive process is a slower operation.
1099. Why do certain butterflies lay their eggs upon cabbage leaves?
Because the cabbage leaves are the food of the young caterpillars. and although the butterfly does not subsist herself upon the leaf, she knows by instinct that the leaf will afford food to her future young. She therefore lays her eggs where her young ones will find food. This explanation applies to many insects that lay their eggs upon other plants.
1100. Why have insects long projections from their heads, like horns or feathers?
Because these organs, the antennae, are those through which some insects hear and others feel, and the projecting of these antennae from their bodies probably enables them to hear and feel more acutely while their wings are in motion, without the interference of the vibrations of their wings. My son, eat thou honey, because it is good, and the honeycomb which is sweet to thy taste. Proverbs 24.
1101. Why have bees stings?
Because they gather and store up honey which would constantly attract other insects, and the bees would be robbed of their food but for the sting, which is given to them for protection.
1102. Why have flies fine hairs growing at the extremities of their legs?
Because they require to cleanse their bodies and wings, and to free them from particles of dust. And as they cannot turn their heads for this purpose, they have hairy feet, which serve as brushes, by which any part of their bodies can be reached and cleaned. End of chapter 55.
Chapter 56 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 56. 1103. Why, when the perfume of flowers is unusually perceptible, may wet weather be anticipated? Because when the air is damp, it conveys the odors of flowers more effectively than it does when dry. 1104. Why, when swallows fly low, may wet weather be expected? Because the insects which the swallows pursue in their flight are flying low to escape the moisture of the upper regions of the atmosphere. 1105. Why do ducks and geese go to the water and dash it over their backs on the approach of rain? Because by wetting the outer coat of their feathers before the rain falls, by sudden dashes of water over the surface, they prevent the drops of rain from penetrating to their bodies through the open and dry feathers. 1106. Why do horses and cattle stretch out their necks and snuff the air on the approach of rain? Because they smell the fragrant perfume which is diffused in the air by its increasing moistness. I will remember the works of the Lord. Surely I will remember thy wonders of old. Psalm 77. 1107. Why may change of weather be anticipated when domestic animals are restless? Because their skins are exceedingly sensitive to atmospheric influences, and they are oppressed and irritated by the changing condition of the atmosphere. 1108. Why may fine weather be expected when spiders are seen busily constructing their webs? Because those insects are highly sensitive to the state of the atmosphere, and when it is setting fine they build their webs because they know instinctively that flies will be abroad. 1109. Why is wet weather to be expected when spiders hide? Because it shows that they are aware that the state of the atmosphere does not favor the flight of insects. 1110. Why, if gnats fly in large numbers, may fine weather be expected? Because it shows that they feel the state of the atmosphere to be favorable, which induces them all to leave their places of shelter. 1111. Why, if owls scream during foul weather, will it change to fine? Because the birds are pleasurably excited by a favorable change in the atmosphere. 1112. Why is it said that the moping of the owl foretells death? Because owls scream when the weather is on the change, and when a patient is lingering on a deathbed, the alteration in the state of the atmosphere frequently induces death, because the faint and expiring flame of life has not strength enough to adapt itself to the change. 1113. Why may wet weather be expected when spiders break off their webs and remove them? Because the insects, anticipating the approach of rain, remove their webs for preservation. There shall the great owl make her nest, and lay and hatch, and gather under her shadow. There shall the vultures also be gathered, every one with her mate. Isaiah 34. 1114. Why may we expect a continuance of fine weather when bees wander far from their hives? Because the bees feel instinctively that from the state of the atmosphere they may wander far in search of honey, without the danger of being overtaken by rain. 1115. Why, if people feel their corns ache and their bones rheumatic, may rain be expected? Because the dampness of the atmosphere affects its pressure upon the body, and causes a temporary disturbance of the system. All general disturbances of the body manifest themselves in those parts which are in a morbid state, as in a corn, a rheumatic bone, or a decayed tooth. 1116. Why, if various flowers close, may rain be expected? Because plants are highly sensitive to atmospheric changes, and close their petals to protect their stamens. 1117. Why, when moles throw up their hills, may rain be expected? Because the moles know instinctively that on the approach of wet, worms move in the ground. The moles therefore become active and form their hills. 1118. Why is a magpie, when seen alone, said to foretell bad weather? Because magpies generally fly in company, but on the approach of wet or cold, one remains in the nest to take care of the young, while the other one wanders alone in search of food. 1119. Why do seagulls appear numerous in fine weather? Because the fishes swim near to the surface of the sea, and the birds assemble over the sea to catch the fish, instead of sitting on rocks or waiting on the shore. 1120. Why do seagulls fly over the land on the approach of stormy weather? Because in stormy weather they cannot catch fish, and the earthworms come up on the land when the rain falls. And I said, Oh, that I had wings like a dove, for then would I fly away and be at rest. Psalm 55. 1121. Why, if birds cease to sing, may wet and probably thunder be expected? Because birds are depressed by an unfavorable change in the atmosphere, and lose their joyful spirits which give rise to their songs. 1122. Why, if cattle run around in meadows, may thunder be expected? Because the electrical state of the atmosphere has the effect of making them feel uneasy and irritable, and they chase each other about to get rid of the irritability. 1123. Why, if birds of passage arrive early, may severe weather be expected? Because it shows that the indications of unfavorable weather have set in the latitudes from which the birds come, and that they have taken an early flight to escape it. 1124. Why, if the webs of the gossamer spider fly about in the autumn, may east winds be anticipated? Because an east wind is a dry and dense wind, and suitable to the flight of the gossamer spider. The spider, feeling instinctively the dryness of the air, throws out its web and finds it more than usually buoyant upon the dense air. The observation of the changing phenomena which attend the various states of the weather is a very interesting study, though no general rules can be laid down that can be relied upon, because there are modifying circumstances which influence the weather in various localities and climates. To observe weather indications accurately, no phenomenon should be taken alone, but several should be regarded together. The character and the duration of the weather of the preceding days, the direction of the wind, the forms of the clouds, the indications of the barometer, the rise or fall of the thermometer, and the instinctive forewarnings of birds, beasts, insects, and flowers should all be taken into account. Although no direct material advantages attend such a study, it induces a habit of observation and develops the inductive faculty of the mind, which, when applied to more significant things, may trace important effects to their greater causes. End of chapter 56. Chapter 57 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 57. 1125. Why can gossamer spiders float through the air? Because, having no wings, and being deficient in the active muscular powers of other spiders, they have been endowed with the power of spinning a web which is so light that it floats in the air and bears the body of the gossamer spider from place to place. Each web acts as a balloon, and the spider attached thereto is a little aeronaut. 1126. Why do crickets make a peculiar chirping sound? Because they have hard wing cases, by the friction of the edges of which they cause their peculiar noise, to make known to each other where they are, in the dark crevices in which they hide. 1127. Why has the glowworm a brush attached to its tail? Because it is necessary to keep its back very clean, that the light which its body emits may not be dimmed. 1128. Why does the glowworm emit a light? Because the female glowworm is without wings, but the male is a winged insect. The female, therefore, is endowed with the power of displaying a phosphorescent light. The light is only visible by night, but it is, nevertheless, beautifully adapted for the purpose stated, because the male is a night-flying insect, and never ventures abroad by day. They that go down to the sea in great ships, that do business in great waters, these see the works of the Lord, and his wonders in the deep. Psalm 107. There exists some differences of opinion between naturalists upon the use of the light of a glowworm. There are some who doubt that it is exhibited to attract the flying insect. The objectors, however, offer no explanation of the luminous properties of the worms. Sir Charles Bell say the preponderance of the argument is decidedly in favor of the explanation we have given. 1129. Why does not the iris of the fish's eye contract? Because the diminished light in water is never too strong for the retina. 1130. Why is the eye of the eel covered with a transparent, horny covering? Because as the eel lives in holes and pushes its head into mud and under stones, etc., it needs such a covering to defend the eye. 1131. Why is the whale provided with an eye, having remarkably thick and strong coats? Because when he is attacked by the swordfish and the shark, he is almost helpless against his enemies, as they fix themselves upon his huge carcass. He therefore dives with them down to a depth where the pressure of the water is so great that they cannot bear it. The eye of the whale is expressly organized to bear the immense pressure of extreme ocean depths, without impairing the sight. 1132. Why have fishes no eyelids? Because the water in which they swim keeps their eyes moist. Eyelids would therefore be useless to them. 1133. Why have fishes the power of giving their eyeballs very sudden motion? Because having no eyelids, such organs being unnecessary to keep their eyes moist, they still need the power of freeing their eyes from the contact of foreign matters, and this is secured to them by the power they have of giving the eyeball a very rapid motion, which causes reaction in the fluid surrounding it and sweeps the surface. This motion may frequently be seen in the eyes of fishes in glass globes. And God made the beast of the earth after his kind, and cattle after their kind, and everything that creepeth upon the earth after his kind. And God saw that it was good. Genesis 1. 1134. Why is the lacrimal secretion of the horse's eye thick and glutinous? Because as his eye is large and constantly exposed to dust on journeys, it is provided with a viscid secretion, which cleanses the eye and more instantly and securely removes the dust than a watery secretion would. 1135. Why does the lower bill of the sea crow project beyond the upper one? Because the bird obtains his food by skimming along the water, into which he dips his bill and lifts his food out. 1136. Why do the mandibles of the crossbill overlap each other? Because the bird requires a peculiar bill to enable it to split seeds into halves and to tear the open cones of the fir tree. 1137. Why are the tails of fishes so much larger than their fins? Because their tails are their chief instruments of motion, while their fins are employed simply to direct their progress and steady their movements. 1138. Why have oxen and other quadrupeds a tough ligament called the pax-wax, running from their backs to their heads? Because their heads are of a considerable weight, and having frequent occasion to lift them, they are provided with an elastic ligament, which is fastened at the middle of their backs, while its other extremity is attached to the head. This enables them to raise their heads easily. Otherwise, the effort to do so would be a work of great labor. To the horse, the pax-wax acts as a natural bearing rein, assisting it to hold its head in that position, which adds to the grace and beauty of the animal. In carving beef, this ligament may be seen passing along the vertebrae of the neck, the chuck, and the foreribs. He shall feed his flock like a shepherd. He shall gather the lambs with his arm, and carry them in his bosom, and shall gently lead those that are with young. Isaiah 11. 1139. Why have the females of the kangaroo and opossum tribes pouches or pockets formed in the skin of their breasts for the reception of their young? Because their young ones are remarkably small and helpless, in fact, more so than those of any other animal of equal proportions. Besides which, the full-grown animals have very long hind legs, and they progress by a series of extraordinary leaps. It would consequently be impossible for their helpless young ones to follow them. God has therefore given to female kangaroos and opossums curious pockets, formed out of their own skin, in which they place their little young ones and bear them, through their surprising leaps, with the greatest ease and safety. End of chapter 57.
Chapter 58 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 58. 1140. What is the difference between an animal, a plant, and a mineral? The great naturalist Linnaeus used to say that animals grow, live, and feel, plants grow and live, and minerals grow. Animals are here defined to enjoy 3 conditions of existence, plants 2 conditions, and minerals 1 condition. This definition has in latter days been held to be unsatisfactory, since there are a few plants that are supposed to feel, and a few animals that are supposed to have even less feeling than the sensitive plants alluded to. The concise definition by Linnaeus, nevertheless, is true, as far as regards a vast majority of the bodies constituting the 3 great kingdoms of nature, and it may be sufficient to say that animals grow, live, feel, and move, plants grow and live, minerals grow by the addition of particles of inorganic matter. If we now state the few exceptions that are admitted to this definition, we shall bring the explanation as near to the truth as the present state of knowledge will permit. And God said, Behold, I have given you every herb bearing seed, which is upon the face of all the earth, and every tree, in the which is the fruit of a tree, yielding seed. To you it shall be for meat. Genesis 1. 1141. Why is it understood that some plants feel? Because a sensitive plant closes its leaves on being touched. The Venus flytrap closes its leaves upon flies that alight upon them. Others close upon the approach of rain, and at sunset, and open at sunrise, and turn towards the sun during its daily transit. 1142. Why is it understood that some plants move? Because certain seaweeds throw off undeveloped young plants, which move through the water by the aid of fine cilia or muscular hairs, until they find a suitable place upon which to attach themselves. The roots of plants will penetrate through the ground in the direction of water and of favorable soil. 1143. Of what elementary substances are plants composed? Of carbon, oxygen, hydrogen, and nitrogen. 1144. Whence do plants derive those substances? From the air, the earth, and water. 1145. How do plants contain carbon? They obtain it chiefly from the air, in the form of carbonic acid gas. The carbon of the carbonic acid gas, which is thrown out by the breath of animals, and by other processes in nature, is absorbed by the leaves of plants, and the oxygen which had united with the carbon to form the carbonic acid gas is again set free for the use of animals. 1146. How do plants obtain oxygen? They obtain it from the atmospheric air. But as they do not require a large amount of oxygen for their own use, they throw off the amount which is in excess, after having separated it from the other elements with which it was combined when taken up by them. From the humble blade of grass to the stately tree of the forest, plants operate to purify the air, and to correct and counteract the corruption of the air by the myriads of animals inhabiting the earth. It has been generally stated that plants in rooms purify the air by absorbing carbonic acid by day and releasing a part of the oxygen, but that, as the presence of light is necessary to produce this action, they do not restore oxygen to the air by night, but on the contrary give off carbonic acid gas. Therefore it has been stated that plants in rooms by night are unhealthy. Mr. Robert Hunt, one of the ablest chemists of the present time, makes the following remarks upon this subject in his Poetry of Science. The heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. Psalm 19. The power of decomposing carbonic acid is a vital function which belongs to the leaves and bark. It has been stated, on the authority of Liebig, that during the night the plants act only as a mere bundle of fibers, that it allows of the circulation of carbonic acid and its evaporation unchanged. In his eagerness to support his chemical hypothesis by respiration, the able chemist neglected to inquire if this was absolutely correct. The healthy plant never ceases to decompose carbonic acid during one moment of its existence, but during the night, when the excitement of light is removed and the plant reposes, its vital powers are at their minimum of action, and a much less quantity is decomposed than when a stimulating sun, by the action of its rays, is compelling the exertion of every vital function. In hot, swampy countries, where vegetation is very rapid, and the soil loaded with decomposing carbonic matter, the plants absorb more carbonic acid than they require, and they then evolve carbonic acid gas from their leaves. Hence, such climates as the West Indies are injurious to life, though favorable to vegetation. 1147. How do plants obtain hydrogen? They obtain hydrogen in combination with oxygen in water, and with nitrogen in the form of ammonia, as which it exists in animal manures. 1148. How do plants obtain nitrogen? From the atmospheric air and from the soil, in which it is combined with other elements. 1149. How do plants apply these elements to the formation of their own structures? When those substances which form the food of plants are absorbed, either by their leaves or their roots, they are converted with the aid of water into a nutritive sap, which answers the same purposes in plants as blood does in animals. 1150. How is the nutritive sap applied to the growth and enlargement of the plant? Every seed contains a small amount of nutrition, sufficient for the sustentation of the germ of the plant, until those vessels are formed by which the nutritive elements can be absorbed and used for the further development of the living structure. The earth, penetrated by the sun's rays, warms the sleeping germ and quickens it into life. For a short time the germ lives upon the seed, which, moistened and warmed by the soil, yields a kind of glutinous sap, out of which the first members of the plant are formed. and then the tender leaf, looking up to the sky, and the slender rootlet penetrating the soil, begin to draw their sustenance from the vast stores of nature. He causeth the grass to grow for the cattle, the herb for the service of man, that he may bring forth food out of the earth. Psalm 104. 1151. Of what do vegetable structures consist? Of membranes or thin tissues, which, being variously arranged, form cells, tubes, air passages, etc. Of fibers, which form a stronger kind of membrane, and which is variously applied to the production of the organs of the plants. And the organs, formed by those elementary substances by which the plants absorb, secrete, and grow, and fulfill the conditions of their existence. 1152. Why are seeds generally enveloped in hard cases? Because the covering of the seed, like the shell of an egg, is designed to preserve the germ within from the influence of external agencies until the time for development has arrived and the conditions of germination are fulfilled. 1153. Why does a seed throw out a root before it forms a leaf? Because moisture, which the root absorbs from the earth, is necessary to enable the germ to use the nutrition which the seed itself contains, and out of which the leaf must be eliminated. Moisture forms a kind of gluten, in which the starch of the seed is dissolved and converted into sugar, the sugar into carbonaceous sap, and the sap into cellular tissue and woody fiber, as the leaves present themselves to the influence of the air and light. 1154. Why does a plant grow? Because as soon as membranes and vessels are organized in the young germ, the nutritive fluid formed by its first organs begins to move through the fine structures, and from that time the plant commences to incorporate with its own substance the elements with which it is surrounded that are suitable to its development. Can the rush grow up without mire? Can the flag grow without water? Whilst it is yet in its greenness, and not cut down, it withereth before any other herb. Job 8. End of chapter 58.
Chapter 59 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Amy Graymore. The Reason Why, by Robert Kemp Philp. Chapter 59. 1155. Why, if we break the stem of a hyacinth, do we see a glutinous fluid exude? Because by breaking the stem, we rupture the vessels of the plant and cause the nutritive fluid to escape. The sap of the plant is analogous to the blood of man, and the vessels to the arteries and veins of the animal body. 1156. Why, if we split the petal of a tulip, do we see cells containing matter of various colors? Because by splitting the petal of the flower, we disclose the anatomy of its structure, and bring to view those cells, or organs, of the vegetable body by which the different coloring matters are secreted. 1157. Why, if we break a pea shell across, do we discover a transparent membrane which may be removed from the green cells underneath? Because we separate from the cellular or fleshy part of the shell the membrane which forms the epidermis and answers to the skin of the animal body. 1158. Why, if we cut through a cabbage stump, do we find an outer coat of woody fiber and an inner substance of cellular matter? Because the woody fiber forms a kind of skeleton which supports the internal structure of the plant and gives form and character to its organization. The woody fiber of plants is analogous to the bony structure of animal bodies. 1159. Why, if we cut across the stem of a plant, do we see numerous tubes arranged in parallel lines? Because we thereby bring to view the vessels formed by the membranes and fibers of the vegetable body for the transmission of the fluids by which the structure is sustained. It was planted in a good soil by great waters, that it might bring forth branches, and that it might bear fruit, that it might be a goodly vine. Ezekiel 17. Skeleton leaves and seed vessels of plants form exceedingly interesting objects, and serve to illustrate the wonderful structure of plants. With patience and care, they may be produced by any person, and will afford an interesting occupation. The leaves should be gathered when they are in perfection, that is, when some of the earliest leaves begin to fall from the trees. Select perfect leaves, taking care that they are not broken or injured by insects. Lay them in pans of rainwater, and expose them to the air to undergo decomposition. Renew the water from time to time, taking care not to damage the leaves. They need not be examined more than once a week, and then only to see that the water is sufficient to cover them. Give them sufficient time for their soft parts to become decomposed, then take them out, and laying them on a white plate with a little water, wash away carefully, with a camel hair pencil, the green matter that clings to the fibers. The chief requirement is patience on the part of the operator, to allow the leaves and seed vessels sufficient time to decompose. Some leaves will take a few weeks, and others a few months. But a large panful may be put to decompose at the same time, and there will always be some ready for the process of cleansing. When they are thoroughly cleaned, they should be bleached by steeping for a short time in a weak solution of chloride of lime. They should then be dried, and either pressed flat or arranged in bouquets for preservation under glass shades. The result will amply reward the perseverance of the operator. 1160. Why are clayey soils unfavorable to vegetation? Because the soil is too close and adhesive to allow of the free passage of air or water to the roots of the plants. It also obstructs the expansion of the fibers of the roots. 1161. Why are sandy soils unfavorable to vegetation? Because they consist of particles that have too little adhesion to each other. They do not retain sufficient moisture for the nourishment of the plants, and they allow too much solar heat to pass to the roots. 1162. Why are chalk soils unfavorable to vegetation? Because they do not absorb the solar rays, and are therefore cold to the roots of plants. 1163. Why are mixed soils favorable to vegetation? Because they contain the elements of nutrition essential to the development of the vegetables, and the plants absorb from them those constituents which are necessary to their growth. 1164. Why do farmers sow different crops in rotation? Because every plant takes something from the soil, and gives something back, but all kinds of plants do not absorb nor restore the elements in the same proportions. Therefore, a succession of crops of one kind would soon impoverish the soil, but a succession of crops of different kinds will compensate the soil, in some degree, for the nourishment withdrawn. He watereth the hills from his chambers. The earth is satisfied with the fruit of thy works. Psalm 104. 1165. Why do farmers manure their lands? Because as soil varies and crops impoverish the soils, the farmer employs manure to restore fertility, and to adapt the soils to the wants of the plants he desires to cultivate. It is remarkable that nature herself points out to man the necessity for changing the succession of vegetable growths. When plants have exhausted the soil upon which they grow, they push their roots far in search of sustenance, and in time migrate to a new soil, while other plants will spring up and thrive upon the area vacated. When a forest in North America is destroyed by fire, the trees that grow afterwards are unlike those that the fire consumed, and evidently arise from seeds that have long lain buried in the earth, waiting the time when the ascendancy of the reigning order of plants should cease. 1166. Why are grasses so widely diffused throughout nature? Because they form the food of a very large portion of the animal kingdom. They have therefore been abundantly provided. No spot of earth is allowed to remain idle long. When the foot of man ceases to tread down the path, grass immediately begins to appear, and by its universality and the hardihood of its nature, it clothes the earth as with a carpet. Many grasses, whose leaves are so dry and withered that the plants appear dead, revive and renew their existence in the spring by pushing forth new leaves from the bosom of the former ones. Withering's Botany. Grasses are nature's care. With these she clothes the earth. With these she sustains its inhabitants. Cattle feed upon their leaves, birds upon their smaller seeds, men upon the larger, for few readers need to be told that the plants which produce our bread, corn, belong to this class. In those tribes which are more generally considered as grasses, their extraordinary means and powers of preservation and increase, their hardiness, their almost unconquerable disposition to spread, their faculties of reviviscence, coincide with the intention of nature concerning them. They thrive under a treatment by which other plants are destroyed. The more their leaves are consumed, the more their roots increase. The more they are trampled upon, the thicker they grow. Many of the seemingly dry and dead leaves of grasses revive and renew their verdure in the spring. In lofty mountains, where the summer heats are not sufficient to ripen the seeds, grasses abound which are viviparous, and consequently able to propagate themselves without seed. It is an observation, likewise, which has often been made, that herbivorous animals attach themselves to the leaves of grasses, and if at liberty in their pastures to range and choose, leave untouched the straws which support the flowers. Paley. For the earth bringeth forth fruit of herself, first the blade, then the ear, after that the full ear in the corn. Mark 5. End of chapter 59.
Chapter 60 of The Reason Why. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Reason Why by Robert Kemp Philp. Chapter 60. 1167. Why do some plants droop and turn to the earth after sunset? Because when the warmth of the sun's rays is withdrawn, they turn downwards and receive the warmth of the earth by radiation. 1167. Why does the young ear of corn first appear enfolded in two green leaves? Because the light and air would act too powerfully for the young ear. Two leaves therefore join and embrace the ear and protect it until it has acquired strength, when they divide and leave the ear to swell and ripen. 1168. Why are the seeds of plants usually formed within the corollas of flowers? Because the petals of the flowers surrounding the seeds afford them protection until they are ripened, when the flower dies and the petals fall to the ground. 1169. Why does the flower of the poppy turn down during the early formation of seed? Because the heat would probably be too great for the seed in its early stage. The plant is therefore provided with a curious curve in its stalk, which turns the flower downward. But when the seeds are prepared for ripening, the stalk erects itself, and the seeds are then presented to the ripening influences of the sun. 1170. Why have plants of the pea tribe a folding blossom called the boat or keel? Because within that blossom the pea is formed, and the shape of the blossom is exactly suited to that of the pea which is formed therein. The blossom is itself protected by external petals, and when the wind blows and threatens to destroy the parts upon which the seeds depend, the plants turn their backs to the wind and shelter the seed. The fruit of the righteous is a tree of life, and he that winneth souls is wise. Proverbs 11. 1171. Why are the leaf buds enclosed in scales
which fall off as the leaf opens. Because the scales serve as a shelter to the tender structure of the young leaf. The scales are rudimentary leaves, formed at the end of the previous season, and which, being undeveloped then, serve to guard the young leaves of the future year. In trees, especially those which are natives of colder climates, this point is taken up earlier. Many of these trees, observe in particular the ash and the horse chestnut, produce the embryos of the leaves and flowers in one year, and bring them to perfection the following. There is a winter, therefore, to be gotten over. Now, what we are to remark is, how nature has prepared for the trials and severities of that season. These tender embryos are, in the first place, wrapped up with a compactness which no art can imitate, in which state they compose what we call the bud. This is not all. The bud itself is enclosed in scales, which scales are formed from the remains of past leaves, and the rudiments of future ones. Neither is this the whole. In the coldest climates, a third preservative is added, by the bud having a coat of gum or resin, which, being congealed, resists the strongest frosts. On the approach of warm weather, this gum is softened, and ceases to be a hindrance to the expansion of the leaves and flowers. All this care is part of that system of provisions which has for its object and consummation the production and perfecting of the seeds. Paley. 1172. Why are the seeds of many plants enclosed in a rich juice or pulp? Because the matter by which the seed is surrounded, as well as being intended for the nourishment and care of the seed, is designed for the use of man and of animals, by whom the seed is set free to take its place in the earth. By virtue of this process, so necessary but so diversified, we have the seed, at length, in stone fruits and nuts, encased in a strong shell, the shell itself enclosed in a pulp or husk, by which the seed within is, or hath been, fed. Or, more generally, as in grapes, oranges, and the numerous kinds of berries, plunged overhead in a glutinous syrup, contained within a skin or bladder. At other times, as in apples and pears, embedded in the heart of a firm fleshy substance, or, as in strawberries, pricked into the surface of a soft pulp. These and many more varieties exist in what we call fruits. In pulse and grain and grasses, seeds, as in the pea tribe, regularly disposed in parchment pods, which, though soft and membranous, completely exclude the wet even in the heaviest rains. The pod also, not seldom, as in the bean, lined with a fine down, and at other times, as in senna, distended like a blown bladder. Or we have the seed enveloped in wool, as in the cotton plant, lodged, as in pines, between the hard and compact scales of a cone, or barricadoed, as in the artichoke and thistle, with spikes and prickles. In mushrooms, placed under a penthouse, in ferns, within slits in the back part of the leaf, or, which is the most general organization of all, we find them covered by strong, close tunicles, and attached to the stem according to an order appropriated to each plant, as is seen in the several kinds of grains and grasses. And I will send grass in thy fields for thy cattle, that thou mayest eat and be full. Deuteronomy 11. In which enumeration, what we have first to notice is unity of purpose under variety of expedients. Nothing can be more single than the design, more diversified than the means. Pellicles, shells, pulps, pods, husks, skin, scales armed with thorns, are all employed in prosecuting the same intention. Secondly, we may observe that in all these cases the purpose is fulfilled within a just and limited degree. We can perceive that if the seeds of plants were more strongly guarded than they are, their greater security would interfere with other uses. Many species of animals would suffer, and many perish, if they could not obtain access to them. The plant would overrun the soil, or the seed be wasted for want of room to sow itself. It is, sometimes, as necessary to destroy particular species of plants as it is at other times to encourage their growth. Here, as in many cases, a balance is to be maintained between opposite uses. The provisions for the presentation of seeds appear to be directed chiefly against the inconstancy of the elements, or the sweeping destruction of inclement seasons. The depredation of animals and the injuries of accidental violence are allowed for in the abundance of the increase. The result is that out of the many thousand different plants which cover the earth, not a single species, perhaps, has been lost since the creation. When nature has perfected her seeds, her next care is to disperse them. The seed cannot answer its purpose while it remains confined in the capsule. After the seeds, therefore, are ripened, the pericarpium opens to let them out, and the opening is not like an accidental bursting, but, for the most part, is according to a certain rule in each plant. What I have always thought very extraordinary, nuts and shells, which we can hardly crack with our teeth, divide and make way for the little tender sprout which proceeds from the kernel. Handling the nut, I could hardly conceive how the plantule was ever to get out of it. There are cases, it is said, in which the seed vessel, by an elastic jerk, at the moment of its explosion, casts the seeds to a distance. We all, however, know that many seeds, those of most composite flowers, as in the thistle, dandelion, etc., are endowed with what are not improperly called wings, that is, downy appendages by which they are enabled to float in the air, and are carried oftentimes by the wind to great distances from the plant which produces them. It is the swelling also of this downy tuft within the seed vessel that seems to overcome the resistance of its coats, and to open a passage for the seed to escape. But the constitution of seeds is still more admirable than either their preservation or their dispersion. In the body of the seed of every species of plant, or nearly of every one, provision is made for two grand purposes. First, for the safety of the germ, secondly, for the temporary support of the future plant. The sprout, as folded up in the seed, is delicate and brittle beyond any other substance. It cannot be touched without being broken. Yet in beans, peas, grass seeds, grain, fruits, it is so fenced on all sides, so shut up and protected, that whilst the seed itself is rudely handled, tossed into sacks, shovelled into heaps, the sacred particle, the miniature plant, remains unhurt. It is wonderful also how long many kinds of seeds, by the help of their integuments and perhaps of their oils, stand out against decay. A grain of mustard seed has been known to lie in the earth for 100 years, and as soon as it had acquired a favorable situation, to shoot as vigorously as if just gathered from the plant. Then, as to the second point, the temporary support of the future plant, the matter stands thus. In grain and pulse and kernels and pipins, the germ composes a very small part of the seed. The rest consists of a nutritious substance, from which the sprout draws its aliment for some considerable time after it is put forth, viz., until the fibres, shot out from the other end of the seed, are able to imbibe juices from the earth in a sufficient quantity for its demand. It is owing to this constitution that we see seeds sprout, and the sprouts make a considerable progress without any earth at all. Say not ye, there are 4 months, and then cometh harvest? Behold, I say unto you, lift up your eyes, and look on the fields, for they are white already to harvest. John 4. From the confirmation of fruits alone, one might be led, even without experience, to suppose that part of this provision was destined for the utilities of animals. As limited to the plant, the provision itself seems to go beyond its object. The flesh of an apple, the pulp of an orange, the meat of a plum, the fatness of the olive, appear to be more than sufficient for the nourishing of the seed or kernel. The event shows that this redundancy, if it be one, ministers to the support and gratification of animal natures, and when we observe a provision to be more than sufficient for one purpose, yet wanted for another purpose, it is not unfair to conclude that both purposes were contemplated together. Paley. 1173. Why have climbing plants tough, curly tendrils? Because, having no woody stalks of their own to support them, they require to take hold of surrounding objects, and raise themselves from the ground by climbing. Their spiral tendrils are, therefore, so many hands, assisting them to rise from the earth. 1174. Why does the pea put forth tendrils and the bean not? Because the bean has in its stalk sufficient woody fiber to support itself, but the pea has not. We do not know a single tree or shrub having a firm, strong stem sufficient for its support, which is also supplied with tendrils. 1175. Why do the ears of wheat stand up by day and turn down by night? Because when the ear is becoming ripe, the cold dew falling into the ear might induce blight. The ears therefore turn down to the earth and receive warmth by radiation. 1176. Why have grasses, corn, canes, etc., joints or knots in their stalks? Because a long hollow stem would be liable to bend and break, but the joints are so many points where the fibers are bound together, and the structure greatly strengthened. Then shall the earth yield her increase, and God, even our own God, shall bless us. Psalm 47. 1177. Why have the berries of the mistletoe a thick and viscid juice? Because the mistletoe is a parasitical plant, growing upon the bark of other trees. It will not grow in the ground. Its seeds are therefore filled with an exceedingly sticky substance, which serves to attach them to the bark of trees, to which the berries attach themselves at once by throwing out tough fibers, and the next year the plant grows. 1178. How are the seeds of the mistletoe transferred from its own stem to the bark of trees? Various birds, and particularly the mistle thrush, feed upon the berries. As the bird moves in pursuit of its food, the viscid berries attach themselves to its feathers, and in this way the thrush is the instrument which conveys the seed to the spot to which it adheres, and from which the tree ultimately grows. 1179. What is the circulation of the sap in plants? The circulation of the sap is the movement of the nutritive juices by which the plant is sustained. There is a slow, uninterrupted movement of the sap from the root through the stems to the leaves, and downwards from the leaves through the bark to the root. For the sun is no sooner arisen with the burning heat, but it withereth the grass, and the flower thereof falleth, and the grace of the fashion of it perisheth. So also shall the rich man fade away in his ways. James 1. 1180. Why does the sap of plants thus ascend and descend? Because it conveys upward from the ground some of the matter by which the plant is to be nourished, and which must undergo digestion in the leaves, and it brings downward from the leaves the matter absorbed for the nourishment of the plant, and discharges through the root the substances which the plant cannot use. The movement of the sap is most active in the spring, but in the depths of winter it almost ceases. There are other motions of the sap in plants, which are called special, in distinction from the ascending and descending of the sap, which is called general or common to all plants. The special movements of the sap are peculiar to certain plants, in some of which a fluid full of little green cells is found to have a rotary motion. In other plants, a milky fluid is found to move through particular tissues of the vegetable structure. 1181. Why are the leaves of plants green? Because they secrete a carbonaceous matter named chlorophyll, from which they derive their green color. 1182. Why are the hearts of cabbages, lettuces, etc., of a pale yellow color? Because the action of light is necessary to the formation of chlorophyll, and as the leaves are folded upon each other, they exclude the light, and the green matter is not formed. 1183. Why do leaves turn brown in the autumn? Because when their power of decomposing the air declines, the oxygen absorbed in the carbonic acid gas lodges in the leaf, imparting to it a red or brown color. 1184. Why do succulent fruits, such as gooseberries, plums, etc., taste acid? Because, in the formation of juices, a considerable amount of oxygen is absorbed, and the oxygen imparts acidity to the taste. The earth is full of the goodness of the Lord. Psalm 33. 1185. Why do ripe fruits taste sweet, and unripe fruits taste sour? Because the juices of the ripe fruit contain a large proportion of sugar, which in the unripe fruit has not yet been formed. 1186. Why do some leaves turn yellow? Because they retain an excess of nitrogen. Leaves undergoing decay turn either yellow, red, crimson, or violet. Yellow is due to the excess of nitrogen, red and crimson to various proportions of oxygen, violet to a mixture of carbon, and green to chlorophyll. 1187. Why do leaves fall off in the autumn? Because they have supplied for a season the natural wants of the tree. Every part has received nutrition through the spring and summer months, and the wants of the tree being supplied, the chief use of the leaf ceases, and it falls to the ground to decay and enrich the soil. 1188. Why do plants suffer from the smoke of cities? Because the smoke injures the porous structure of the leaves and interferes with their free respiration. End of chapter 60.